decision tree stump. Okay, decision tree stump. And this decision tree stump basically has a depth of only one when we are constructing the decision tree. Now let's consider this is my data set, and we will try to create this entire ADA boost. So we'll try to understand the entire maths in depth inclusion, and we'll also make sure that we create a decision tree stump over here, and I'll try to show you the example how the entire ADA boost tree is basically constructed. Okay. Now first step, always in ADA boost, like this is my entire data set that is given. I have features like salary, credit, approval. Okay. So this credit is nothing but credit score. It says that if my salary is less than or equal to 50k, and if my credit score is bad, I'm not going to get a credit card approval. Okay. Similarly, if my salary is less than or equal to 50k, if my credit score is good, I'm going to get the credit card approval. So like this, I have all the data set. Here, n basically means normal. The credit score is normal. Okay, I've just created my own feature. Now let's go ahead and let's try to understand the first step. In the first step, we create decision tree stump. Okay, decision tree stump. Obviously, you know how to create decision tree with the help of entropy and information gain. But here, we are focusing on creating a decision tree stump. That is just with respect to one match depth. Okay. Now, first of all, let me consider one feature salary. So this will be my feature salary. Okay. Here, I'm just going to write the condition salary is less than or equal to 50k. Okay. So here, I obviously have salary is less than or equal to 50k. So let me make this circle a little bit bigger so that it will look good. So here, I have salary is less than or equal to 50k. Now, with respect to this, I just have two situations, yes or no, right? Let's say that this is my yes output and this is my no output. Okay. So here I have basically yes and no. This is perfectly fine. Now let's go ahead and see over here. With respect to salary is less than or equal to 50k. If it is, how many of them are yes? So here you can see that less than or equal to 50k. Here I have a specific required. I have one yes, right? So I have two yes, right? So obviously I have two yes. So here I'm going to basically write two yes. Okay. This is fine. But when less than or equal to 50k is there, here I'm also getting no's. In our previous video, we have got a brief understanding about ADA boost, and what is our main aim in ADA boost? We'll try to combine multiple weak learners, and then we'll try to create a strong learner. And the weak learner in case of ADA boost is basically called as decision tree stump. Okay, decision tree stump. And this decision tree stump basically has a depth of only one when we are constructing a decision tree. Now let's consider this is my data set, and we will try to create this entire ADA boost. So we'll try to understand the entire maths in depth inclusion, and we'll also make sure that we create a decision tree stump over here, and I'll try to show you the example how the entire ADA boost tree is basically constructed. Okay. Now first step, always in ADA boost, like this is my entire data set that is given. I have features like salary, credit, approval. Okay. So this credit is nothing but credit score. It says that if my salary is less than or equal to 50k, and if my credit score is bad, I'm not going to get a credit card approval. Okay. Similarly, if my salary is less than or equal to 50k, if my credit score is good, I'm going to get the credit card approval. So like this, I have all the data set. Here, n basically means normal. The credit score is normal. Okay, I've just created my own feature. Now let's go ahead and let's try to understand the first step. In the first step, we create decision tree stump. Okay, decision tree stump. Obviously, you know how to create decision tree with the help of entropy and information gain. But here, we are focusing on creating a decision tree stump. That is just with respect to one match depth. Okay. Now, first of all, let me consider one feature salary. So this will be my feature salary. Okay. Here, I'm just going to write the condition salary is less than or equal to 50k. Okay. So here, I obviously have salary is less than or equal to 50k. So let me make this circle a little bit bigger so that it will look good. So here, I have salary is less than or equal to 50k. Now, with respect to this, I just have two situations, yes or no, right? Let's say that this is my yes output and this is my no output. Okay. So here I have basically yes and no. This is perfectly fine. Now let's go ahead and see over here. With respect to salary is less than or equal to 50k. If it is, how many of them are yes? So here you can see that less than or equal to 50k. Here I have a specific required. I have one yes, right? So I have two yes, right? So obviously I have two yes. So here I'm going to basically write two yes. Okay. This is fine. But when less than or equal to 50k is there, here I'm also getting no's, right? So total number of no's will be how much? One no and one more no is over here. So two no's, right? So here obviously some kind of misclassification has definitely happened. Okay. I'll talk about that as we go ahead. Now, with respect to this, the total number of yes and no's that you have is basically two yes and two no's. Now, what about the other case? When the salary is greater than 50k, right? Over here, you can see I have one no and I have two yes, right? So over here, I'm just going to write two yes and one no's. Okay. So let's say this is my decision tree stump 1. And similarly, I will try to create my decision tree stump 2 with another feature, which is called as credit. Okay. Let's say this feature is basically having credit is equal to good. Okay. And I hope everybody knows how to create a decision tree, right? We can use different less than based on these features that we specifically have. Okay. So here I have to, if the credit score is equal to good, I may have yes and no. So let's go ahead and see. This is my decision tree stump 1. This is my decision tree stump 2. Okay. Now, but out of this, I'll be only selecting one, right? And so in the first instance, because in ADA boost we create weak learners, right? Weak learners we combine it together. And in order to create this weak learner, I can use any of this feature. It can be salary or it can be credit also. Okay. But out of this, how do we select? We basically use entropy. Okay. But that I'll discuss about it. Now let's say if my credit score is good, then how many number of yes I have and how many number of no's I have. So if my credit score is good, I have 1 yes, 2 yes, 3 yes, right? No number of no's are there. So here I have 3 yes and 0 no's. Similarly, in the case of when my credit score is not equal to good, then I have 1 no, 2 no, 3 no's, right? So total 3 no's and how many yes? 1 yes, right? So 1 no is definitely there. So 1 yes and 3 no's I'm actually getting. Okay. Now this is fine. Okay. I can construct this kind of many decision tree stump. Okay. But understand from this two, which one is the decision tree stump that needs to be getting selected as my first decision tree stump in ADA boost. Okay. Because now like this decision tree stump I can create many, right? Because I have a lot of features over here also, right? Let's say that if these two are there, now the next step we will try to understand which decision tree stump needs to get selected. And obviously for this we will be using something called as entropy. Entropy, okay, or Gini index or Gini impurity. Gini index and Gini impurity are one and the same. We can use either of these two and we can understand that which is having an impure split. Now in this particular case, since you have 50% of probability saying yes and 50% of probability saying no, this is completely impure split. At this point of time, if I try to calculate with the help of entropy, what is the number that is going to come? Just guess, just pause for a second and just understand. This particular value will be 1 for entropy and 0.5 for Gini impurity. Similarly, over here 2 yes and 1 no's, obviously this is also impure split. In this particular case, I have a pure split and I have a little bit smaller impure split over here. So obviously, if I try to compare where I'll be getting a better entropy or Gini index, I will be getting for this second decision tree stump, right? So this is how we go ahead and select it. Otherwise, if you just want to think that okay, do I have any math formula? Yes. So entropy can basically be used for calculating like this, right? So this already we know the formula which I have already discussed in my decision tree classifier, right? How to apply entropy. And similarly, Gini index, I think you know the formula, otherwise we can just revise the video with respect to decision tree classifier. So in the first step, what we did is that we created decision tree stump and we selected the best decision tree stump using what technique? Using entropy. entropy or gain index, right, or gain impurity. So this is what we did in the first step. Always remember, our first step is basically to create all the decision tree stump and select the best decision tree stump as we go ahead. Okay, so in this first case we have done that. Now in the second step we are going to do some more amazing thing. But in the first step we understood that okay, fine, we created a decision tree stump and we have selected the best one. So let's go ahead and understand the second step. So now let's go ahead and try to discuss about the second step. In the second step, with respect to the AdaBoost classifier machine learning algorithm, we are basically going to perform two different operations. One is sum of total errors and performance of stump. Okay. Now here you have already seen that I had created two stumps, and out of this got selected. How? Because we used entropy or gain impurity, right? And like this, I can have many number of stumps when I'm creating the first decision tree stump. Out of which, whichever will be having the best entropy, that one we are going to select, because the best entropy will basically say that you're getting a pure leaf node very quickly. Okay. Now coming to the next step, I'm just going to consider the same stump over here, and I'm going to place it over here. Now the first step, in order to calculate the total error and performance of stump, I need to assign some weights. Okay. So here, let's go ahead and assign some sample weights. Now, how do I assign a sample weight with respect to this same data set? Okay. First of all, you go and count that how many records are there. So here you have 1, 2, 3, 4, 5, 6, 7. 7 records. So what you do is that you just assign equal weights to all the records. So this will be 1 by 7, 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 and 1 by 7. I'll tell you why we are assigning this particular weights, because this first component that you see, sum of total errors, right? That is what the sample weights will actually help us to calculate this total errors. Okay. Now, when we took this particular stump, when my credit score was good, I got 3 yes and 0 no's. In the case of no, I got 1 yes and 0 no's, right? But over here, with respect to our data set, I don't have any scenario where my credit score was good and I was getting no as an answer. So this 1 yes is basically my error, right? This is my error, right? Because here you can see when my credit score is good, right? Every time I'm getting yes, I'm nowhere getting no's, right? And if I probably see my credit score is not equal to good, at that time you can see that most of the time I'm getting no's. So this can definitely be considered as an error, right? 1 yes I'm actually getting. Now this is which scenario? Because this is which scenario? You can see that when my credit score is normal, you can see that I'm getting yes. So I can definitely say that with respect to this particular decision tree stump, if I train with this specific data set, I'm going to get an error, and the error will be this record, okay? And the error will be this record. Now, when I have this specific error with respect to this particular record, okay, now we will go ahead and calculate the total error. Okay, so coming to the first step, let's go ahead and calculate the total error. Now, if I really want to compute what exactly is total error, so suppose this is my total error, I'm just going to use the total number of wrong records. Okay, so how many wrong records are there in this particular case? I have just one wrong record. Okay, so this is my wrong record that I'm actually getting. Okay, now in this particular case, let's say that okay, I just consider this is the wrong record that I've got. Let's say in this particular case, the sample weight that you have is 1 by 7. So I'm just going to sum up all the total errors. Okay, sum up all the total errors. Okay, when I say summing up all the total errors, that basically means I'm just going to add up all the sample weights of all the wrong records. Now in this particular case, I just have one wrong record, so my total error will be 1 by 7. Okay, so this is my total error. Okay, because that many number of wrong records I have. I just have one wrong record, so I'm basically going to get 1 by 7. Perfect. Now let's go to the next step. Now in the next step, what we are actually going to do over here is that we are going to calculate something called as performance of stump. Performance of stump. Because we really need to find out how this stump has basically performed, right? How many wrong records it is basically getting created, and based on that, what is this performance of this specific stump? Now in order to calculate the performance of this specific stump, I use a formula which is like 1 by 2 log to the base e 1 minus total error divided by total error. Right? What is my total error over here? My total error is nothing but 1 by 7. So if I probably go and compute, this ln basically means log to the base e. Okay. So if I probably write over here ln of 1 minus 1 by 7 divided by 1 by 7. Right? So if I probably try to calculate this, I've already done the calculation, but I would suggest you do it by yourself. Log n of 6. This is approximately going to be equal to 0.896. Okay. So here you can see that with respect to this particular stump, the performance that I'm actually getting, okay, it is somewhere around 0.896. Now you need to understand what this 0.896 basically specifies. Okay, what this 0.896 specifies. Okay, so I'm just going to write over here the performance of stump is nothing but it is approximately equal to 0.896. Now as we go up, guys, I had created a function, right? Function for AdaBoost, right? What is this function? I'll just write it down over here. Okay, so let's say my function is f is equal to alpha 1. And let's say this is my model 1, that is my decision tree stump 2, alpha 2, m2, like this. I have a lot of different values. Okay, this alpha basically indicates weights, and the performance of this first stump is basically the performance of this particular model. So here, my alpha 1, I'm going to assign it to something called as 0.896. Okay, so this is my alpha 1, or I will be saying this is my weight. And for this model 1, this is my decision tree stump. Okay, so this is basically my m1, or I can also say or decision tree stump. Okay, so I hope you're getting an idea about how we are relating it to. Now, what we have to do is that, see, in a specific, whenever I have a weak learner, let's say this is my weak learner, right? And we have created this weak learner, right? So this is my weak learner that I've actually created, right? Now, this will obviously predict some wrong records. Now, I'm going to make sure that I pass this next records or pass this wrong records to my next decision tree stump. And that is how these are sequentially connected, right? So that is what I'm actually going to do now. Now, I need to understand that what is the next step. Now, you basically need to understand that, okay, fine, Krish, now this is done. If you are able to find out the performance of the stump over here with respect to the first decision tree stump, then how do I construct this particular second model? And how do I set up alpha 2? So that we are going to understand in the next video. So I hope you have understood till here. If not, please make sure that you revise these things, okay? Thank you. Get into the step 3 of basically constructing our AdaBoost classifier, which uses decision stumps as its weak learner. In our second step, we have already computed two amazing things, that is the total errors and the performance of the stump. And we also understood that why this performance of stump is important, because this is basically telling the weight that is needed to be assigned to the first decision tree stump. Okay, so that is what we computed it. Now, in the upcoming steps, we need to make sure that whichever are the wrong records that needs to be sent to the next decision tree stump. Okay, So for that, we need to perform two important steps. First is update the weights for correctly and incorrectly classified points. Now what does this basically mean? Over here, we have understood that our incorrect classified point was this one, right? So over here, right, 50K, normal and yes, this was incorrectly classified point from my decision tree stump 1. Now we need to update these weights. We have to make sure that whichever is the classified points, we have to reduce the weight, and whichever is the incorrectly classified points, we have to increase the weight. Because of that, what will happen is that there will be a high probability of selecting the wrong records by the next decision tree stump. Now you may be thinking how this can basically be done. Okay, so let's go ahead and let's understand the math behind it. Okay, now first statement I'm basically going to write over here. So here, let me write updated weights. Okay, so this will be my updated weights, or let me just write it quickly over here, something like updated weights. Okay, now updated weights, first of all, for correct classified points. Okay, for correct classified points, you know that what we need to do, we need to decrease the weight, because I really want to increase the probability of selecting the wrong records by the next decision tree. So what we need to do is that for the correct records, we will try to decrease this weights. Okay, for this weight, we have to, for this record, we have to increase the weight. Okay, so for correctly classified points, we use a different formula, and for incorrect classified points, we use a different formula. So if I really want to find out what is the formula of the weight updation for correct classified points, I will just give a simple notation that is nothing but weight, the older weight multiplied by e to the power of minus performance of stump. Performance of stump. Okay, so what is my previous weight that we need to compute it over here? So I will be getting 1 by 7 multiplied by e to the power of minus performance of stump, which is the performance of stump before we got somewhere around 0.896. So here I'm going to basically use 0.896. So this output that you are going to get is somewhere around 0.058. I have already done the computation. So whichever are the correctly classified points, all the weights will get updated to 0.058. This will also be 0.058. This will also be 0.058. And this will also be 0.058. This will also be 0.058. This will be 0.058. But what about this? Now, in order to update this specific weights for the incorrect classified points, so weight updation for incorrect classified points, we have a different formula. Okay, and the formula is nothing but older weight multiplied by e to the power of performance of stump. Before it was minus, now it is plus performance of stump, right? Before here you can see it was minus, right? So here I'm just going to apply. Over here it will be 1 by 7 multiplied by e to the power of what is the performance of stump? Performance of stump is nothing but it is 0.896. So here I'm going to basically mention 0.896. So overall, if I go and see it, it will be coming somewhere around 0.349. Okay, so this is my 0.349 will get updated over here. Okay, now this is super important, guys. The third step is the updating the weights for the correctly and incorrectly classified points. So here you can see that now all my correctly classified points we have decreased the value over here by over here you can see that it has decreased, here also decreased, but this has specifically increased. So I'm having 0.349 and this has also decreased. Okay, so this was about the third step. Now in the fourth step we have something called as normalized weight. So let's go ahead and let's see what exactly normalized weight is all about. But I hope you have understood what you have done over here. In short, we have just updated the weights with respect to the classified and unclassified points. Okay, please make sure that you remember the formula. This is nothing but older weight multiplied by e to the power of minus performance of step. And similarly for the incorrect classified points, I have weight multiplied by e to the power of performance of step. Right. So let's go ahead and let's see the fourth step. Thank you. Bye bye. We're going to continue the discussion with respect to AdaBoost, and in this part, we are going to discuss about how to create normalized weights and assigning bins. Okay. Now, in my previous video, we have already seen how the weights needs to get updated. The reason we are updating the weights to make sure that the unclassified points, from the decision tree stump 1, should go towards the decision tree stump 2. So that is the reason we have increased the weights, which was incorrectly classified, for those specific data points, and decreased the weights for the classified, for the correct data points that were classified. Now, in the next step, we will go ahead and try to understand about normalized weights, computation, and assigning bins. Now, what happens is that, guys, when we have this all updated weights, so the same updated weights are written over here, you'll be able to see that if I do the summation of all these weights, it will not be 1. Okay. If you probably go ahead and do the summation, it will be somewhere around. If I probably add this up all the weights, it will be somewhere around 0.697. Okay, but initially when we assigned the sample weights, we could see that all the summation was actually 1, right? So we really need to normalize this to entirely to come as a total computation. If I try to do the total summation, it should be 1, right? So that is the reason we go ahead and do something called as normalized weights. Now, normalized weights, how to basically bring up all this to the scale of 1 itself. All I have to do is that for each and every term that I'm considering over here, I will divide this by 0.697. 0.697 is this specific total value, right? So if I really want to normalize it and bring this entire summation to should be near to 1, I will just go ahead and try to normalize this weight by dividing all this value by 0.697. So after dividing, if you probably divide 0.058 divided by 0.697, you're going to get somewhere like 0.08. So like this, all this value will be 0.08, 0.08, 0.08, 0.08, and this value, which is 0.349, this will probably get converted to something like 0.50, and again, it will be 0.08. All I'm doing is that for every number, I'm just dividing by 0.697. So when you do this, you will be getting normalized weight, and now when you try to find out the summation, it will be equal to 1. Okay. Now this is the first step. Now let's come to the second step. Now see, our main target is that after decision tree stump 1 is created, right? Suppose if these are doing some incorrect classified predictions, right? We need to send that wrong records to my next decision tree stump, right? Now we need to find out a mechanism like how do I make sure that my machine learning algorithm sends only those records or mostly those records that are incorrectly classified. Okay. So for that particular case, we will be assigning some bins. Okay. So here I'm basically going to write bins assignment. Now this bins assignment is super important, guys, because here we are going to create a range of bins. So the first range will be between 0 to 0.08, since this is 0.08, right? Then the second range will be between 0.08 to 0.16, okay? The third range will be 0.16 to 0.24, because we just keep on adding it, right? So from here, 0.16, again, I've added this, so it is this range. Similarly, 0.24, 0.32, 0.32 to 0.40, okay? And over here, now you can see this range will now get increased, 0.40 to 0.50. And finally, here you can see that it is 0.50 to 0.58, right? Now, you can see that the maximum bin size is basically this specific value, right? Which is between 0.40. Sorry, this should be changing a little bit. So this is nothing but 0.40 to 0.90, because here I have 0.50. So here you can definitely see that this is my maximum bin size. Now my target is that whichever are the wrong records. Now here you can see that since this is wrongly predicted by my decision tree stump 1, here my range is quite huge. So I will try to find out a mechanism wherein I will try to send this records more frequently to my next decision tree stump 1. Sorry, next decision tree stump 2, right? That is what we are trying to do. And based on that, my next decision tree stump 2 will be able to train the wrongly predicted records. So that is the reason we have basically done the bin assignment. Now in the next step, we are going to find out a way that what are the records that are going to get captured to go to the next decision tree stump 1. Okay, so again, let me revise it over here. So this was my decision tree stump 1, which I have already created. And you know what is the alpha 1 value that I got? Alpha 1 weight was 0.896. So this is alpha 1 value is 0.896. Now, we did many steps after this. We updated the weights, we assigned the weight, we normalized the weight, and we created a bin. The reason we did it is that because we wanted to send the wrong records to my next decision tree stump. Now, before sending this, I have to prepare my records over here, right? I have to prepare which records needs to be sent, which data points needs to be sent. And that is the reason why we have created this bin size. Okay, now in the next step, what I will do is that in order to send my records to the next decision tree stump 2, how I'm going to select the records from this, we are going to understand. So I hope you're able to understand this. These are the steps, and still one more final step is there so that we prepare our new record, and the entire steps that we have done from step 1 to 4, that all will get repeated. So let's go ahead and let's see the next video where we'll try to create a data set that needs to be sent to our next decision tree stump 2. Thank you. In the step 4, we have created this bins and we have assigned some bin size. Okay, how did we assign? We just kept on doing the summation with respect to this normalized weights. Now, how do I select my new data points to send to the next stump? Okay, so that is what we are going to discuss in this video. So we will continue an iterative process. Let's continue an iterative process. In this iterative process, we will be selecting random values between 0 and 1. Okay, so we'll be creating some random values between 0 and 1. Okay, let's say in the first instance, I'm just going to create all my new records that are going to get selected from here based on this bins assignment. So I'm just going to create a dark division line over here. Let's say these are my features. I have my salary, I have my credit. Okay, I have my credit so that I don't take much space. I have my approval. Okay, and let's say this is my random number that is getting generated. And this random number will be between 0 to 1. Let's say for the first instance in the iteration, and I have to do this iteration till I get all the 7 records over here. Okay, so what I'm actually going to do over here, or let me just write down these columns once again. So here I have salary, credit, approval, and finally my random number. And random number is getting generated between 0 to 1. Now let's say if my random number have got generated as 0.50. Now in this particular case, we'll go and see in the bin assignment where this 0.50 range will come. And here you can clearly see that it is between 0.40 0.90. So here obviously your incorrect predicted records are getting selected. So greater than 50k, normal, and yes has got selected. Okay, and whatever records are getting selected, this will get passed to the next decision. Now let's say that my random number that is getting generated is 10. So 0.10 is somewhere here. So here I have less than 50k, green, sorry, not green, good, and yes, this has got selected. Now similarly, let's consider that my random number that is generated is 0.60 again. So 0.060. Now see over here, since the gap is more, right, there's a high probability this row will get selected again and again. So here I have greater than 50k, normal, yes, right. Now the next weak learner will focus on this kind of records. Let's say after this again, 0.75 is my random number that I got generated. Then where is 0.75 that is coming over here, right? Then again this will get repeated, greater than 50k and yes. Let's say it is again another record that is got generated is 0.24. 0.24 is nothing over here, so this record will get selected, less than 50k, green, and yes. Okay, so how many records? 1, 2, 3, 4, 5. 2 more records will get selected. Let's say that I am going to basically write 0.32 over here. 0.32 is the random number that got selected, so 0.32 is coming over here. So I will this record will get selected, which is greater than 50k, B and no. Okay, and finally let's say again over here 0.90 or 0.87 has got selected. So again you can see over here this incorrect records will again get picked. So greater than 50k, normal, and yes. Now here you can see one thing is that this record that you see, right, is getting picked up again and again. So here I have one record which is my incorrect classified point, and there here I have 2 more records which is incorrectly classified points. And finally, here you'll be able to see one more record that is incorrectly classified points. So these all are getting selected again and again, right? Now what will happen is this entire record will be now sent to my next decision tree stump. And then once this entire record is getting selected, so let me just select this entire thing. This will be my new data set, okay? That is going to get, which will be my step 6. In the step 6, what we are going to do is that this entire these records will be sent for training, sent to the next decision tree stump. So here if I'm pasting it, again the same process will start, wherein we'll start with something called as sample weights. Okay, let's say over here we are going to again create a sample weight. Again, sample weight will be assigned by 1 by 6, 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 1 by 6. Then all the steps that we have done from step 2 to step 6 will keep on repeating. Okay, unless and until we don't finish up all the decision tree stumps sequentially. By default, if we do practically, there are around 100 decision tree stumps that are just selected. It is initialized in the initial state when you're training the model. Okay, then again sample weight will get updated. Then again you will, after creating the sample weight, you'll again try to find out a total error. Then you'll try to find out the performance stump. Okay, and let's say for this particular model you got performance stump as 0.65. Then what will happen? Again, your function which was having alpha 1 model 1, which is my decision tree stump 2, alpha 2 model 2. Model 2 basically means this particular decision tree stump will get selected, and here your alpha 2 value will be 0.65. And before your alpha 1 value is nothing but somewhere around what it is 0.896. So you will probably combine all these values and we'll try to see how the output will be predicted. Okay. So similarly, we keep on continuing creating multiple stumps and we do this particular step again and again. Okay. Now in the next step, we'll try to see how the predictions will basically happen and how the entire prediction will happen with respect to a new test data that we are getting by using this decision tree stump. Okay. So yes, I'll see you all in the next video. So I hope you're able to understand all these things. Okay. So in this step, we have focused on selecting how the next data points need to be selected to send it to the next decision tree stump. Thank you. Now let's understand the final step is that how does the final prediction actually happen with respect to a new test data in AdaBoost, and this is specifically with respect to a classification problem. Now let's say we try to solve this with respect to this particular problem. Let's say that I got a new test data where it is saying the salary is less than 50k and the credit score is good. Then what happens is that let's say this particular decision tree is saying okay fine, here my output is yes, here my output is no. Decision tree stumps. Let's say this is my decision tree stump 1, decision tree stump 2, decision tree stump n. Like this I can have any number of decision tree stump, right? So this we have already. Let's say this is saying yes and let's say this is saying no. Okay. Now here as I said that like random forest we don't focus on majority voting classifier. Here one important parameter that we have discussed with respect to this we have a weight called as alpha 1. This is basically weight alpha 2, alpha 3, similarly alpha n. Let's consider that initially we computed alpha 1 as 0.896, right? 0.896, and this was 0.650. Let's say I'm just considering this was with respect to this is like a 0.24, and let's say this alpha n is basically giving me a weight of it can also be a negative value, so let's say it is minus 0.30, right? So final function that you'll be able to see is nothing but alpha 1 model 1 plus alpha 2 model 2 plus alpha 3 model 3 like this plus alpha 4 model 4, let's say this I'm considering it as alpha 4. Okay, so here you can see that what is alpha 1? Alpha 1 is nothing but 0.9896. Model 1 is basically saying us yes. Okay, let's say alpha 2 is 0.650. Model 2 is basically saying no, and alpha 3 is nothing but 0.244 over here. Model 3 is basically saying yes, and finally alpha 4 is basically minus 3.30, and this model is basically saying no as an output, right? So once we do this, we just need to combine what is the value with respect to yes. Okay, with respect to yes, if I probably add up 0.896, 0.24. So how much is 0.896, 0.240, 613, 11, and this is 1. So here I'm getting 1.136 plus how much is this no? This is nothing but 0.6590 minus 0.30. So here I'm going to get 0.350, and here this will be no. Now here you can see the maximum number, right? Whatever it is saying over here, 1.136 is maximum more than 0.350. So definitely the entire output of this entire weak learners, which is combined as a strong learner, here the maximum output is yes, since I get the performance of say. We also say it as like this: performance of say with respect to yes is high. That is 1.136. Performance of say with respect to no. You also give this particular statement also, or you can also say that the weight with respect to yes is very high when compared to no. It is 0.350. So this is obviously greater than this, right? So finally, our output is that, right? Whenever I get a test data with respect to less than or equal to 50K and the credit score is good, the credit card will definitely get approved. So the final output will be yes with respect to this particular use case. Okay, considering this particular data set. Okay, so this is how the final prediction will basically happen. Okay, and in the next video, I'll also talk about how does the regression problem statement will happen. Only two things will be changing with respect to regression. Here we will not be using entropy. Instead we'll be using mean squared error. Okay, to basically compute which decision tree stump is the best. And at the last, everything will be almost same. Okay, everything will be almost same, but here we'll be having a continuous value with respect to some weights assigned to it. Okay, so that is the difference. But I hope you have got an idea with respect to the classification problem of AdaBoost. So here you can see how many pages I've written. This is how you should definitely practice to get the mathematical intuition in a better way. So yes, this was it. I'll see you on the next video. Thank you. Hello guys, in this video we are going to implement the AdaBoost classification machine learning algorithm implementation with the help of Python and sklearn. And for this I'm taking the same problem statement that we did it for holiday package prediction for random forest. The reason why I'm taking the same problem statement because I really want to combine all the machine learning algorithms and see which machine learning algorithm is performing well. And if you remember till random forest, what all things we have actually implemented, we did all the feature engineering over here. I probably think you can also check out all the feature engineering from the previous video itself and just revise it quickly if you really want to go. But what we will do is that we will just try to apply all the machine learning algorithms over here, right? So here if you see sklearn.ensemble, we tried with random forest classifier. We can also try with gradient boost classifier. Gradient boost classifier will come in the future, but I really want to try with the random forest classifier also. Sorry, AdaBoost classifier, which is today's this specific video, right? And then I also tried with decision tree classifier, logistic regression. So out of this, you could find out that which was the most performing one, right? Over here, you could see definitely random forest was performing well. You would also see gradient boost was not that much performing well, but that is the reason we selected random forest. Now let's see with the help of AdaBoost, can we improve this particular training of this particular machine learning algorithm? So first of all, what I will do, I will just go and search for sklearn AdaBoost classifier, and then we'll also do for regressor. So AdaBoost classifier, here you can see it is basically present in ensemble. So what I'm actually going to do, I'm going to go over here and just import from sklearn.ensemble, import AdaBoost classifier, since this is a classifier problem, right? AdaBoost classifier. Okay, so once I execute this, here you can see that I've executed. Now all I have to do is that add that specific key over here, okay, because we have actually created this generic way of training any number of models that you like, right? So here it is, AdaBoost classifier, I'm initializing it. Then automatically what it will do, it will basically do the predictions for the train data, for the test data, and everything as such. So guys, now after I probably initialize AdaBoost classifier, then again all the steps will be same. We'll be iterating through each and every model. We'll be fitting with the X train, Y train. We'll be doing the prediction for X train. We'll be doing the prediction for X test, and then we'll try to see the accuracy score, precision, recall, ROC, AUC score, and based on that we'll also be seeing the accuracy score for the test set and all, and then we'll display all this particular information which we have probably discussed it, right? So let me go ahead and execute it. Now here you can see logistic regression is giving this much, for test it is giving this much. Obviously logistic will not play a major role over here because it actually creates a straight line to differentiate the points, right? Similarly, I have decision tree. Here you can see decision tree is really creating some good results, but again the recall is less. Let's compare with something else like random forest. So random forest again is performing well with respect to gradient descent. Here you can see the accuracy, F1 precision when compared to decision tree and random forest are less. But let's see with respect to AdaBoost. So AdaBoost also we are getting somewhere around 85% accuracy, 83% F1 score. Again the recall is less. Over here also you can see that recall is less. During the scenario also, right, we can go ahead and select ROC, AUC curve, and we can also select the threshold since it is giving in probability. But anyhow, we really need to try AdaBoost with different parameters. So what I can do is that I can basically also show you how we can select AdaBoost params, okay? And I will define my own params over here. Now how do I define my params? If I go over here, you'll be finding what all parameters I have. First of all, base estimator. Now here you can see the base estimator which the boost ensemble is built. By default it is using decision tree classifier. I'm just going to keep it with respect to that because it is going to get initialized to the max depth of 1, right? In AdaBoost, if you remember, we basically create something called as stumps, right? And then this n number of estimators basically means that how many number of decision trees we have to probably use. That is basically 50. Again, we can play with this as a hyperparameter. I will play with learning algorithm as a hyperparameter. So let's play with a hyperparameter for 2 to 3 parameters, right? So I'll use n estimators over here. I'll just define it. So I'm just going to make this as a list. Let's say this is my n estimator. This will be in the form of key value pairs. I'll write 50, 60, 70, 80, 90. Okay. And then the next parameter that I'm going to probably use is the next one, which is nothing but algorithm. So I'm just going to select this and paste it over here. And this will basically be my algorithm. And in this algorithm, I'm just going to use my other parameters over here, which is called as SAMI and SAMI.R. Right? So here you can use SAMI.R, then use the SAMI.R real boosting algorithm based estimator must support calculation of class probabilities and all. So some information you can also be able to find it over here, right? So I'm just going to paste it over here, and this will also be in the form of list. Very simple. Okay. So we're just going to perform hyperparameter tuning based on the specific 2 parameters. Okay. So I've executed it. Now all I'll do, this is my RF params. Obviously for this, I guess random forest will work well, but I really want to show you how we can also test with other algorithms. So here you can see AdaBoost parameters are there. Now in order to include this, what I'll do, I'll copy like this, and how we did it for hyperparameter tuning in random forest. We're just going to copy this, put a comma, paste it over here. Okay. Give my name as AdaBoost. Okay, or just write AB AdaBoost, and here I'm going to initialize with AdaBoost classifier. Okay, and parameters that I'm actually going to probably give is something but AdaBoost underscore param. AdaBoost underscore param. Okay, so these are all the parameters that I'm going to play with, and obviously I've used these two models. I'm going to perform randomize for CV. So these are all models I'm actually putting inside this particular variable. And again, this is in the form of tuple. I'll get three information. One is my model, one is my model parameter, and one is my model name. And with respect to this, I will train my model and randomize for CV. So if you probably go and see random underscore CV models, here you'll be seeing AdaBoost and random forest. And then from my scalar.model section, I'm import randomize for CV, and then I'm iterating through this random underscore CV models. And with respect to this, I'm using number of iteration is 100, CV is equal to 3, verbose is equal to 2, and we are fitting, and we're getting the best parameters for every algorithm. Okay, so let's execute it. So this will probably take some time because it is just going to do a total number of 300 fits because we have different parameters. Okay, now since it is doing for two machine learning algorithms, here you can definitely see that some amount of time is definitely required. Okay, then whatever best parameters you are getting, go ahead and write it over here with respect to AdaBoost. Okay, with respect to AdaBoost, and just try to initialize AdaBoost classifier, and whatever parameters is selected, you can select it over here. Now here it says cannot clone object. You should provide an instance of scikit-learn estimator instead of a class. Let's see where we have done some mistakes. So params, let's see the params over here. AdaBoost classifier. See, there's a problem. I did not give the brackets, so that is the reason it gave me an error. So anyhow, I'll just execute it. Now my concurrent training will start. So till then, I'm just keeping everything ready. I've also written this as over here. I've not written brackets, and because of that, it is saying that okay, I'm not given an object. But anyhow, you have to give an object for the training purpose. Okay. So here it is. The training is happening. Perfect. I got this as the best parameters with respect to AdaBoost, so that I can get a good performance. And here I'm just going to paste it over here, right? So I'm going to paste it. I'm going to remove this bracket. I'm going to remove this bracket. So remaining all will be same, and then we'll be able to get the model accuracy. So it says okay, invalid syntax. The reason is that I have to write equal to instead of colon, right? So here also equal to. Here also equal to, right? And once I train it, so here you'll be able to, again, I'm getting an error. Let's see. Okay. Perhaps you meant double equal to. Okay, not a problem. I don't have to write this as quotes. Okay, because these all are parameters. I'm not going to edit this video. Whatever mistakes I'm making, I really want you all to see. Okay, so now everything will start. The training will start, and I'll get the output. Now here you can see with random forest. This is what accuracy I'm getting. With AdaBoost, this is what I'm getting. Okay, it may have improved, may have not improved, but clearly you can see random forest is the better one compared to AdaBoost. Because AdaBoost works on stumps. Okay, so finally you can also use your ROC AUC curve score with respect to AdaBoost. Right? What is the AUC score over here? 0.6049. Okay, and try to draw the ROC AUC curve. So here it is. You just try to draw it based on this. Okay, and now if you probably see how your curve will look like, it'll just get displayed. So this is how your curve will look like. Okay. Yes. Model.predict for AUC models. Okay, I've used random forest over here. Instead of using random forest, I'll just use AdaBoost. Okay. I'll just copy this. Okay. Very simple. I'll paste it over here. Okay. This should be my AdaBoost classifier, and this should be removed over here with my AdaBoost classifier. Okay. Perfect. This is it. Now let's go ahead and do it, and probably I will get this kind of thing. And obviously, when your ROC score is 0.60, obviously you're not going to get a better model when compared to the random forest, because in random forest your ROC score was 84%, so it's covering 84% of the entire area. So I hope you understood how to work with AdaBoost classifier, how to perform the hyperparameter tuning. But at the end of the day, we should try each and every hyperparameter tuning before we go ahead. Okay. So this was with respect to AdaBoost classification implementation. Again, go to the problem statement. We're just talking about the same problem statement. The reason why I'm taking up the same problem statement and showing you, because at the end of the day, whatever problem statement you work with, you have to try multiple algorithms. So yes, this was it from my side. I hope you like this particular video. I'll see you on the next video. Thank you. Bye. Hello guys, so in this video we are going to do the model training of AdaBoost regression, and already the same project was implemented in random forest regressor. Why I am taking the same project? Because I really want to show you that how you should basically use all the models, train it, and then try to find out the best model itself, right? And as you go ahead, I have a lot of end-to-end projects created for you. You can definitely refer over there. We have performed EDA, feature engineering, model training, model deployment, and many more things. Okay, so yes, let's go ahead and let's understand this model training and model selection. Right now you can see that I've used random forest regressor, linear, ridge, lasso, k-nearest neighbor, and decision tree regressor. So similarly, what I can do is that I can go ahead and write sklearn AdaBoost regressor. Okay, and I will probably go to my AdaBoost ensemble techniques. So here it is. It is also ensemble techniques. We will hyperparameter tune with this parameters later on. But right now, let's go ahead and use this AdaBoost regressor over here. So to use it, all I have to do is that just go ahead and write from sklearn.ensemble import AdaBoost regressor, right? So here I'm just going to use AdaBoost regressor, and then this AdaBoost regressor we will be using for this particular problem statement. Again, we'll evaluate the model over here. And again, if you did not go through the steps, this video has again been repeated in this particular section. You can watch it. Okay, so all the previous videos you can definitely watch it. Now, what I'm actually going to do over here, this evaluate model, I'll just execute it because here I'll be finding out mean absolute error, mean square error, and RMSE, that is root mean square error, and then other than that is R square also. Now let's go ahead and create our model dictionary. Now I'm going to create my next model dictionary, that is AdaBoost, and this AdaBoost will be initialized with my AdaBoost regressor. So here I'm just going to write AdaBoost regressor, and I also want to train all these particular models like this. See, you can also use pipeline, but I feel still this is the best way to do it because here you'll be getting a clear idea about the performance metrics, and no changes in the other code because we're going to just make the prediction with respect to X test, and then we are going to evaluate the train and test, and I'm going to get the model performance over here. So once I execute, see in linear regression, I'm getting 0.62, R2 score. With respect to test data, I'm getting 0.66, lasso, I'm getting 0.66 again, ridge 0.66, k-nearest neighbor, I'm getting 0.86 and 0.91, which is good. Decision tree, I'm getting 0.99 and 0.87, and you know that if you're using decision tree by default, it may overfit models. Then I have random forest, which is 97 and 93, which is good, and then I also have AdaBoost, that is 78 and 72. So that basically AdaBoost is not performing well when compared to random forest and decision tree, but yes, we are going to use this and we are going to see any kind of hyperparameter tuning will work or not. Now, in order to perform the hyperparameter tuning, I really need to select the parameters. So here I'll just say ADA params, and the params that I'm going to play with, will be all this specific parameters, right? So here are my base estimator n underscore estimator. By default, base estimator will be using decision tree regressor, which will internally use probably MSE. And the max that is probably getting initialized with 3, right? So over here, I'm just going to play with n estimators and loss. So let's select this. And let me make this in the form of key value pairs again, like how we did it for AdaBoost regressor. And this I will be initializing to multiple values like 50, 60, 70, 80. Let's say I'm going to play with all these things. And then also, if you probably go and see, along with this base, I have something called as loss. Okay, loss can be linear, square, or exponential. So I'm going to use this specific thing. So here I'm just going to write loss and initialize with different values. And the values will be nothing but all these values like linear, square, and exponential. So here I am just pasting it. Linear, square, exponential. Okay, so these are all the loss parameters that I'm going to use in AdaParams. So let me just go ahead and execute it. Now all I have to do is that add this in my hyperparameter tuning in this list of models. So I'm just going to make one more cell and probably create one more tuple. I think this step you can basically do like that only. Okay, so here I'm going to write ADA boost, right? And then I'll be initializing to my ADA boost regressor. And then this will basically be my ADA params, right? And finally, these are all the models that I'm going to play with. Okay. And then finally, you can see, okay, one error is there because ADA params. Okay, I've closed over here on ADA boost, right? So because of that. Now, after this, we are just going to perform randomizer CV, while we are iterating through each and every models, doing the fit, finding out the best params, and then with the help of modeling, we'll be able to get it. I'll go and execute it over here. So here you can see the training has actually started. With respect to randomizer CV, obviously this will be very less number of fits when compared to Gradestar CV because it is not going to take all the combination, but it is going to take the most important combination, right? So obviously this will take some amount of time because here now I have also added one more model that is ADA boost along with KNN and random forest. I can also use decision tree if I want since it was overfitting, but it is up to you. Again, the hyperparameter tuning technique is like that. Again, you can just use any number of parameters over here to perform the hyperparameter tuning. So yes, let's wait and then let me do one thing till then. Let me add all the parameters that is required over here. Okay, so let's say I'm going to write ADA boost. Okay, and this will be initialized to my ADA boost regressor. So ADA boost regressor, and I'm just going to assign it to ADA boost regressor. But let me just get all these things over here. I'm just going to copy paste this thing. Okay, ADA boost regressor, and I'll be initializing whatever parameters I get from the above training, right? So here it's still taking time. And finally, for with respect to ADA boost, I've got this parameter. I'm just going to use it over here, paste it over here, and just initialize this parameters, which looks like this is equal to. Also, just make sure that you write it in a proper way, like how we give this parameters over here, right? Perfect. So this looks good. Let's see whether I have comma. Yeah. So these are the list of models that I'm going to try again and again, probably make the prediction for and see the performance, right? So once I execute this, here is it. Now with the help of ADA boost, you can see 74 and 62, which is not better when compared to the previous one which we are getting over here. Like here we got 78 and 72. So definitely ADA boost is also not a model for this specific problem statement, right? But obviously we are able to see k nearest neighbor and random forest is able to perform well when compared to the other one. Again, you can also update all these parameters in k nearest neighbor also over here. And with respect to random forest also you can update it over here. Okay. So you can try both of the things, and I've just shown you how to do ADA boost regression. Again, understand why I'm taking the same problem because I really want you all to understand because in a problem statement you really need to apply all this kind of algorithms. So I hope you like this particular video. The same type of process we'll be doing it for XG boost also and gradient boost also. Yes, I'll see you in the next video. Thank you. In this video, we are going to learn about a new machine learning algorithm which is called as gradient boosting machine learning algorithm. And with the help of this particular algorithm, we can solve both regression and classification use cases. Now, gradient boosting is a part of a boosting ensemble technique wherein we create decision trees sequentially when we combine all the weak learners together, and finally we basically get a strong learner. Already we have discussed about AdaBoost and we have seen the internal working of how the decision tree is basically getting constructed in AdaBoost. So to start with, we'll take up this regression problem statement and we'll try to construct a gradient boosting decision trees on top of this particular dataset. Now, let me talk about this particular dataset. This dataset is a regression dataset. Here I have three features. One is experience, degree, and salary. Experience and degree are my independent features. Okay, this both are my independent features, and this is salary is my output or dependent feature. And here you can see that all my salary output is continuous value. So we are basically considering this as a regression dataset. Okay. Now, what are the steps to start with if you really want to create a gradient boosting machine learning algorithm? So let me note down all the steps over here. So this will be my steps. The first step will be to create a base model. Okay, to create a base model. And whenever we create a base model, we have to make sure that this base model is not biased to any value. So it will be giving you some default value. So in order to find out what default value this base model will give, you just have to go ahead and compute the average of all the salary output, because this is my truth output y, right? So when I compute all the salary, average of the salary output, you can see 50 plus 70 plus 80 plus 100, you will be getting somewhere around 75k. Okay. So this is the first step. So in the first step, what we are doing, we are basically creating our base model, and the output of any base model, if whenever I give any of my data set, the output will be 75. Okay. Now let's go towards the second step. Now in the second step, what we have to basically do, and how did we compute this base model? In short, we have to find out the average, right? Now in order to find out the average, I will just add up 50 plus 70 plus 80. So let me add up over here 50 plus 70 plus 80 plus 100 divided by 4. So in short, I'm actually getting 75. So this is how we have basically constructed our base model, which is giving one output that is 75. The next step that we are going to do is that we are going to compute the residuals or errors. Okay. Now, in order to compute the residual and error, what I'm actually going to do, let's say for my base model, I'm going to get my output as y hat. Let's say this is my predicted output. And you know what is my predicted output? It is nothing but 75k, 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 and 75k. Okay. So what we are going to do in order to find out the residuals and error, all you have to do, I have to find out the difference between the salary and my predicted value. That is my true value and my predicted value. So in order to do this, let's consider that I'm going to write this as R1. Okay. R1 basically means the residual one. And here I'm just going to subtract both of this. So in short, here what I'm actually going to do, I'm going to subtract y and y hat. Okay. So if I subtract 50 minus 75k, I'm going to get minus 25k. Similarly, here I'm going to get 5k minus 5k. Here 5k and here 25k. Okay. So this is my residual. Okay. Now let's go to the next step. Okay. I've computed the residuals over here, or errors. Okay. That is the difference between the truth value and the predicted value. This predicted value I've got it from the base models over here, which was the average of all my salary output. Now coming to the third step, which is a super important step, we are going to construct a decision tree. See, in AdaBoost, we were constructing what kind of tree? It was a stump. But here we are going to construct a decision tree considering inputs x of I and output as R1 or residual R of I. Okay. Now in this particular case, you can see that my inputs will be experience and degree, and I'm going to consider this R of 1 as my output feature, and I'm going to construct the decision tree. So if I really want to construct, initially I have a base model. This base model will basically be taking 75. Next, the next decision tree sequentially that I'm going to construct will be considering the input features as my independent feature and the output feature as R1. Okay, that is what we are going to do. So whatever decision tree we are going to construct over here, this decision tree 1 is going to take all my independent feature, and my output feature is R of I. So here I'm going to take x of I, comma R of I. R of I basically means R of 1. Okay, for the first decision tree. So here I'm just going to write R of 1. This is my residual 1, right? Now, once we construct this decision tree, and I hope everybody knows how to create a regression decision tree, because we have already discussed that in the decision tree, so I'm not going to repeat that. Okay. Again, mean square error you'll be probably taking, you'll be basically splitting it based on different features, and again you can use gain over there to find out which feature should be selected first, along with MSE. There we have also discussed about variance reduction, right? All those things have been basically discussed. Now this is super important in here. Okay. Now. If we construct a decision tree considering x of I and R1 as my output, obviously with respect to this, I will be getting one more output feature, which is called as R2. Let's say when I pass any record to this particular model, it gives me some output. Let's say if the first record, I'm just considering anything over here, it can be any value. The first record is giving minus 23k. The second record probably it is giving minus 3. The third record, let's say, it is giving 3, and this is basically giving 20. Okay. So why did I write R2? R2 basically is after training, right? After training the model with independent features and R of 1, whenever I pass any record to this particular decision tree, I'm getting this outputs. Okay. And obviously the output will be different over here. Okay. So again, what I did after constructing a decision tree, I will again go and compute the residual error. Okay. So that is what, in short, I got the residual error for the once this decision tree is basically getting trained with my previous input and the output feature. Now this step is super important. Now we need to find out, suppose let's say if I give any input, what should be my predicted output? Because this is my residual value. This should not definitely be my predicted output. So in order to compute the predicted output, how should I give it? Now let's say that I'm passing this particular record, and from this particular record, I passed it over here, right? So my first final predicted output will be nothing but predicted output for the first record. Let's say here, first of all, the base model, you go to the base model. So in my base model, my value is 75, right? Then when it goes to the next decision tree 1, for the same record, you know what is the output? It is nothing but minus 23. So what I'm going to do, I'm just going to subtract minus 23 with 75. So 75 minus 23 is nothing but 52. Now here you can see that for the first record, my predicted output is 52k, and the real output is 50k. The difference is very small. Then obviously I can think that okay, my model is performing well. So don't get mistaken by this, guys. Here the model is basically performing overfitting, right? So we will not calculate our predicted output like this. Instead, we will be introducing one more new term. So after my new record passes to 75, so let's say this is my new record that passes to 75 through this base model, and the base model output is 75. I'm going to multiply with one learning rate parameter. So here alpha basically means it is called as learning rate, and this value ranges between 0 to 1. But let's consider that I'm going to consider alpha is equal to 0.1. So here, what happens? Alpha, I'm going to multiply with whatever output of the decision tree 1 I've actually got. Okay, whatever decision tree output I've got along with that. So here you can definitely see that if I probably now multiply, it is nothing but 0.1 multiplied by decision tree, that is minus 23, decision tree 1 for the same record, right? For this particular record, my output is minus 23. So here you can definitely see that I'm going to subtract minus 2.3, and in short, I'm actually going to get somewhere around 72.7. Now, if I get this specific output, obviously this output error is huge, right? So let's say I got this particular output over here. Again, I'm going to write my updated y hat, right? After passing through the decision tree 1. So let's say I got over here as 72.7. Okay, so here I got 72.7. Let's say after this, I'm also going to get something like 60. I'm also going to get somewhere around, let's say 77.7, because when I compare with this somewhat a larger value, then I may get some other values like, probably if I'm computing over here, I may get somewhere like 85. Okay, I may get 110, 105, something like this, right? So let's say after passing all the records, I'm getting this particular output. And if you really also want to compute, all I'll do is that I'll go ahead and compute the predicted output. Now let's say for the second record, how do I compute? 75 multiplied by 0.1. And what is the residual over here? Residual is nothing but -3, right? Over here you can see the residual is -3. So for the second record, this will be -3. So in short, this will nothing be 75 plus minus 0.3. So here you can basically see that it will be 74.7. That basically is my second record. What it will be? It will be nothing but 74.7, right? 74.7. And similarly, I will go ahead and compute this. Then after this, what will happen if I really want to construct my next decision tree? Again, I have to go ahead and compute my R3, that is residual R3. And residual R3 will be giving from the difference of this 50k and this 72.7, right? So here I'm actually going to get minus 22.7 and some other values. So in this particular case, I'm going to get minus 4/7. Some values will also be coming over here. Then what I'll do, again, I will repeat all these particular steps, and I will, after computing the residual, again, I'll construct my next decision tree. Now my next decision tree will have, first of all, my base model 75, right? Along with my, so here you will be able to see that I will be first of all having my base model, and obviously my base model is giving me 75. Then I will construct my first decision tree, which is already constructed, right? Already constructed, and this will be to its complete depth. That will not be a problem. And after this, I will again construct my next decision tree. Now in this next decision tree, what I'm actually going to do, I'm going to take my inputs x of I, comma, my output will be what? In this particular case, it will be R3. So once I take R3, then again I will be getting my, once this model will get trained, then again I will be getting my R4, that is my residual 4, which is the output of that specific decision tree. Again, this process will keep on continuing. So in final, if I probably want to talk about it, my final function of this particular gradient boost, let's say this will be my function that I'm going to basically write. I can definitely write that my function of f of x will be the base model h0 of x, okay, plus alpha 1 h1 of x, okay. Then similarly, this is my first decision tree 1, okay. Then this will be my decision tree 2 h of x plus alpha 3 h of x, okay, like this up to alpha n h of x, okay. So any number of decision tree that I keep on adding sequentially. Here alpha 1, alpha 2, alpha 3 are all my learning rates, okay, learning rate. And if you say, can we assign one simple value like 0.1 to this? Yes, you can definitely apply to this, okay. You can just use one learning rate for all the decision trees that are available. So let's rewrite this something into a different notation. Here instead of writing alpha 1, here I'm going to write alpha 0, okay. So finally I'll be writing alpha 0. So at the end of the day, I can write a summation of I is equal to 0 to n. Here I'm going to write alpha of I, h of I, x. So this is the entire notation of my function f of x for gradient boost. Super important. And this is how we construct all the decision trees sequentially, and we will be able to solve any kind of problem, let it be with respect to regression or classification in the case of gradient boosting. So this is the final function of gradient boosting. Again, guys, don't get confused like how the decision tree will basically get constructed. All the same steps that we have probably applied in the machine, in probably the decision tree with respect to the regression, right? Over here, we do multiple splits, we finally get a leaf node, and based on that, we can also do this. In top of it, here also we can apply pre-pruning. We can play with multiple parameters that I'll show you in the help of coding. Okay, so yes, this was it about gradient boosting regression. I hope you have understood it. Please just go through the video once again in order to understand it properly, because this will be super important when we are doing the practical implementation with Python and Scala. So yes, I will see you all in the next video. Thank you. In this video, we are going to probably train a gradient boost classification algorithm. And again, the problem statement that we have basically taken is with respect to holiday package prediction. Now, all I will be doing is that I'll also be adding gradient boosting and see whether the performance is working good or not. Now, with respect to gradient boosting, I'm going to import it. And here you can see from the scalar, it is basically presented from sklearn.ensemble import gradient boost classifier. So I've imported over here. Let me execute it. And I probably need to add this algorithm over here. I know probably for AdaBoost classifier, the performance was bad when I saw the previous example. But let's try and let's see from logistic decision, random forest, gradient boost, which is performing well. And again, the same thing, you make a prediction with respect to train and test, and you probably see everything like F1 score, precision, recall, and all, right? So once I execute, here you can see with respect to logistic regression, your recall is less, but your accuracy is somewhere around 84%. Decision tree, obviously it is overfitting. We can basically perform hyperparameter tuning over here. This is with respect to training data set, and this is with respect to test data set. Again, you have random forest. Random forest is also perfectly fitting, so we can also use this for hyperparameter tuning. But here you can see the recall is very less, right? And here is gradient boost, where we're getting 88 to 89% with respect to F1 score. Recall is also very less, so we can probably use hyperparameter tuning for gradient boosting. And finally, for AdaBoost, here you can basically see this. Now, what I'm actually going to do is that for improving the accuracy with respect to gradient boosting, I'm going to just remove this and I'm going to try with a random forest parameter and gradient boost parameters, right? So I've already created the parameters how we are going to perform the hyperparameter tuning. We're going to play with this loss. We are probably going to play. You can play with learning rate. You can also play with n estimators, criterion, and you can play with all these parameters, and you'll try to use randomized to get the best parameters. So I've already created the parameter list. Here we go with respect to gradient params. Okay, so here we are using all the combination of this, basically log, loss, deviance, and exponential. So you can see that I have actually put all these three. Then criterion, you have this three. You can put this minimum sample splits, number of estimators. So I'll just remove this also so that my training happens a little bit quickly. And let me just go ahead and execute. Okay, and expected. Let's see where is the error. Okay, I have to basically close my dictionary over here. Right. So this is my RM parameters, and if you probably see, this is my gradient parameters. So here. I'll just go and execute this. Probably go and search my gradient parameters. These are the parameters. Now all I'll do is that I'll just update instead of using random forest, I'll use gradient boost. Right, and this is gradient boost classifier. I'll just go and execute this. And probably write gradient boost classifier with all my gradient parameters. Right. And then I can probably start my training like how we did it for all the other things. So random CV models, here you can see I have gradient boost and I have random forest. Now randomized CV will happen on this. So we will start the training, probably it will take some amount of time. And once this training gets over, then I'll come back in the video. But here also we'll try to update it. So what I'm actually going to do here, I'm just going to remove all the parameters. And this will be my updated parameters with respect to gradient classifier. So let me update this over here. And I can probably give all my parameters what is basically required, right? And inside whatever parameters comes out of this, I'm just going to import it over here. And let me write gradient descent. And then we can basically create our, I'll write not gradient descent, but gradient boost. Okay, so this will basically be my gradient boost classifier. Okay, so once this happens, we'll just update those parameters over here, then do our predictions with respect to all these things, and then finally, whatever ROC AUC curve will come, we'll try to plot it over here, which we have already seen in our previous videos. So yes, it has got finished. Perfect. You can see 42.9 seconds. Gradient boosting classifier has got with the help of randomized CV, we have actually performed the hyperparameter tuning, and these are the parameters that got selected. Now see, with respect to random forest, these are the parameters I got. I'm not going to update this, but I'll update this. Okay, so here I have n underscore estimator is equal to 500. The first parameter I got this, and here you can also see minimum sample split. Okay, let's see. Minimum sample split is nothing but 20, comma max underscore depth is 15, comma loss is assigned to exponential. Okay, so these are the parameters that are getting selected for the training purpose. And then finally, you have something called as criterion, which is nothing but MSE. Okay, so yes, I've done it. I'm not updating random forest. You can update random forest, but I really want to show you with respect to this. So here is all the training will happen, and probably I'll get all my accuracy. So yes, inferencing will also take some time with respect to gradient boost. So here you can see random forest is quite quick over here, but after this we have to wait for some time to see this. Okay, and now gradient boost has actually come. Now you can see how the accuracy has increased, right, for training and for test. This is super perfect because we have actually done some kind of hyperparameter tuning over here before with respect to gradient boost, right? If you see over here, the accuracy was less, I guess. So here the accuracy was very less. Now you can see the accuracy has increased with respect to training and test, right? This is super important, super good. So sorry, this is the right, and your recall has also increased. And one more important thing is that here you can see F1 score you're checking with respect to weighted average also. Okay, so basically here you can see calculate F1 score. Here the average weighted. We're making sure that we try to give there's a beta parameter in the F1 value, and whenever we have this, we are basically setting it to 1, giving importance both to true positive and false positive and false negative. So finally, here you can see the model performance is improved, and definitely for this use case also, I think no, even how random forest is working well, but it is not giving that much good recall. But here I'll be using this to give very good recall. Now my ROC curve is this much. I'll just update this value over here. Okay, and I'm just going to initialize my model like this, right? So all the parameters are here, perfect. So I'm just going to update it with respect to this entire thing. And now if I probably execute it and probably see my ROC curve, it will be an amazing ROC curve. You'll be seeing that 90% of the area will get covered. Okay, so this is probably going to take some time because again, there are so many parameters that is getting setting. And here you can see how beautiful I'm getting an ROC curve. And again, over here I'll not write ADA boost, but here I will change the value to something else. So here you can see ADA boost is there. Let's see where is the plot values with respect to that. Plot, this is the receiver low. I'll go model. Okay, I have to basically use gradient boost over here. Okay, gradient boost classify. Perfect. Now, if I probably execute it, here you'll be able to see the updated ROC AUC curve. And yes, we're in the right thing. We're also saving this AUC.png file, and we will be able to get the curve. And but this area under the curve is quite good, somewhere around 90%. Now, this has got updated. So I hope you have understood how to train the model, how you can use the features. At the end of the day, try to use this sklearn, try to see what all parameters are there, and just by changing these parameters or playing with the parameters, selecting the right value, you get some amazing results. Okay. So yes, sir, this was it. I'll see you all in the next video. Hello guys, in this video we are going to implement the gradient boost regression algorithm. And again, same problem statement that we have basically taken in used car price prediction in random forest and ADA boost. We're going to take that same. The reason is that we really want to compare all the machine learning algorithms. So here you can see that we will just start the model training and model selection. Till here I've executed the code. So in order to just go and import it, first of all, you'll see that gradient boost regressor is basically present in sklearn.ensemble. So we will go ahead and import this from sklearn.ensemble. I'm going to import gradient boost regressor. Okay. So we will be importing gradient boost regressor. Ensemble spelling is wrong, so it is not coming. So now let's see. Import gradient boost regressor. Okay, so now we're going to basically see that with respect to random forest ADA boost, gradient boost regressor, linear regressor, ridge, and lasso, which is the algorithm that is going to perform well. And again, why I'm showing you all this thing, because in a real world scenario, whenever you work in any specific project, you really need to try each and every machine learning algorithm. So I'm just going to import it, and this will be my evaluate model where I've basically taken my mean absolute error and mean squared error. The same problem statement, whatever we did in random forest, feature engineering, and EDA part, I'm not like again repeating that thing, but we're just trying to see the performance with respect to gradient boost regressor. Now here, in order to add a gradient boost, all I will do, I'll just make one name like gradient boost regressor. Okay, and then I'm just going to initialize with gradient boost so that I will be able to get with respect to all the models that I'm actually checking over here. So once I execute this now, here you can see all the remaining code is with respect to making the prediction for the train, for the test, and then we are basically checking the performance. So in linear regression, here you can see 66% R square. In lasso, similar result. In ridge, also similar result. In k-nearest neighbor, you're getting 86 and 91, which is good. Decision tree, obviously this is going to overfit because decision tree is training to its complete depth and splitting the nodes to its complete depth. Random forest, the performance is good, so definitely we will be selecting random forest for hyperparameter tuning. But along with that, other than that, I think let's select the other algorithm. ADA boost is definitely not performing well, so I'm not going to take this. But if we consider gradient boost, it is much more better than the decision tree with 94% and 91%. Now, two algorithms that I'm actually going to play in this particular scenario is that one is with random forest. So I'm just going to remove this, and I'm going to remove KNN. Okay, one with random forest. Obviously, with random forest, the kind of hyperparameter tuning will be done based on all these particular features, and you can add any number of features. Now, similarly, with respect to gradient boost regressor, we can also play with all these features. And again, as you know, randomized search CV or grid search CV, if you're using this, all the parameters can be played, right? So loss can be assigned with all these values, learning rate can be assigned with different values, and underscore estimator can be assigned with different values, subsample criterion, all these things can be assigned with different values. So I'm going to consider this as an example. I've already made the parameters, so let me copy and paste it over here. So here is all the parameters that I'm going to play with: loss criterion, minimum sample split, and underscore estimators, max underscore depth, underscore estimator basically means how many decision tree we're going to use in gradient descent. Learning rate also I've basically used. Let me just use some other learning rate parameters. So like this, 0.03. Okay, so all these learning rates parameter I'm just going to use. So two algorithm, random forest and gradient boost, we're just going to perform hyperparameter tuning. Here I'm just going to remove KNN because I don't require it. ADA boost, I don't require it. Now instead of this, I will go with gradient boost, right? For the hyperparameter tuning. So I'm just going to initialize this over here. And then the parameters that I'm basically going to use is nothing but, you can see over here, this is nothing but gradient underscore params. Okay, so these are all the parameters that I'm going to play with. So random underscore CV models. Now randomizer CV, based on all these parameters, we're just going to play with it. Okay, so here it is for name, comma model, comma params in random underscore CV models. We're going to assign the model, param distribution, the number of iteration is 100, cross validation is 3, and then it will try to find out the best parameters. So I'll start the execution over here. This is going to probably take time. Till then I will also update all these values. So random forest, I'll keep it like this. And here I'm just going to write gradient boost regressor. And this I'm just going to equate to gradient boost. Okay, this execution is going on, so it is not showing. I'm just going to keep my code ready. Okay, so till here, everything has been done. We're just waiting for the training to get completed, and I think it'll just get completed at some time. But still, we have played with so many different parameters. It is going to take some amount of time since I also have a powerful system, and sometimes it also takes more things because based on the number of combination, right? That is how it is basically working. Because we're doing total 300 fits with respect to different parameters over here. And number of iteration, here you can see 100, right? For every cross validation, 100 iteration will happen. So here I think it is going to get over. Let's see what are the parameters that will get selected. And after we assign this, all we will be doing is that we'll do fit. And again, we'll check the performance and we'll try to find out the MAE, RMSE, R square by using the same evaluate model that we created. And we'll get our performance. Once we get our performance, then you'll be able to see which is performing well. If suppose gradient boost is performing well, you can use gradient boost. Otherwise, you can directly use random forest. Okay, but we really need to try all these steps before selecting the model and using all the all the parameters, hyperparameter tuning and all. You can again play with parameters if you want. It can make some amount of difference, but understand that initially training will be more than sufficient to select the model. And then for that particular model, we should try to perform hyperparameter tuning. If you're saying that, Krish, why we did not take decision tree? Yes, we can also take decision tree, perform hyperparameter tuning. But I thought, right, let's try with random forest and gradient boost. Okay. So I think some amount of time. So this was with the first model, this is finished. Now with the second model, this is happening. And it'll take some amount of time. Not a problem. So till then, I'll pause the video and then we'll come back. So guys, finally you can see that the entire training is done and you've got the best balance for random forest and gradient boost. Obviously, with respect to gradient boost, it has taken 9.9 minutes in my system and somewhere around 54 seconds in my with respect to random forest. But again, it depends on the system configuration, how much time it may probably be taking. So yes, for yours, I think it'll take more amount of time because in my current system, I have 64 GB RAM and it is a very good processor. So finally, I get my all the best parameters. So all I'm doing is that I will copy this entirely and paste it over here with respect to providing all the parameters. And wherever there is colon, I'm just going to assign that specific value. So here it is, and then you can see here I'm just going to write equal to. This is going to be equal to max depth 10 is selected, loss Huber is selected. So out of this, you can see what are the best parameters that I got selected, right? Criterion, and I think I don't have to use even quotes over here, right? Because these all are some parameters that we provide, right? So I'm just going to remove this, remove this, remove this, remove this, remove this. So Huber will be used, criterion, MSC will be used. So done. And now I'll just do the training and probably see the performance. So invalid syntax, okay, criterion colon, right? So here we can basically go ahead and write equal to. So yes, done. Now here is how my performance is with respect to random forest. Let's see, with respect to random forest 0.9780, 0.93 for the test data, and here you can see for gradient boost, I'm getting 99%, and this for the test data, I'm getting 93%. So now, when compared to random forest, gradient boost is performing well in this specific problem statement. So probably in a real world scenario, after validating this, I will probably go with gradient boost because the R2 square is good. The root RMC is also less when compared to this, that is random forest, and here you can see mean absolute error is also less when compared to random forest. So definitely the choice would be this thing. So yes, I hope you understood the video about how you can basically train. Initially check whether gradient boost is working or not, and then you can play with multiple parameters over here and try it out. Okay. So yes, this was it. I'll see you all in the next video where we'll be also discussing about XGBoost training, so that there also we'll try to see in the coming like how we can train that with using various parameters. So yes, I will see you in the next video. Thank you. In this video, we are going to discuss about a new machine learning algorithm which is called as XGBoost. That is nothing but extreme gradient boosting machine learning algorithm. And with the help of this algorithm, we will be able to solve both classification and regression problem statement. Again, as usual, we'll take up a classification data set and we'll try to solve it. We'll try to see how the decision tree is basically constructed inside the XGBoost and how sequentially we can actually construct it. What are the important parameters that we should look at it, and what is the function equation altogether in order to calculate the final output. So all these things we'll be discussing. Before that, let's take a very simple example over here. So here is my entire data set. The dataset has two input features, one is salary and credit score, and based on that, whether you'll get a credit card approval or not. Okay, so this is the entire dataset with respect to this, and here are some steps that I've actually written in the right hand side, and we will probably follow this entire steps in order to find out the XGBoost itself, or how to create a decision tree inside XGBoost. So to begin with, first step again is it to basically construct a base model. So let me just go ahead and write over here. So first step is basically to create a base model. So let's say this is my base model, and obviously with respect to different base model, right? Whenever we are creating a base model with respect to classification, as my classification is a binary classification over here, what I'm actually going to do, I'm going to keep a probability of 0.5. So anytime whatever output this particular model will be giving, it will basically be giving the probability of 0.5. Okay, so this is super important step. Let's say that this base model is not biased towards anything. Okay, not towards anything. So we are just going to take it as a probability of 0.5. Later on, what output it is going to give, we'll discuss about it. Now let's go to the second step. Construct a decision tree with the root. Now we are going to construct our first decision tree, which will probably begin as after my base model. So the next that I'm actually going to construct is basically a decision tree over here. Now before I construct this specific decision tree, you really need to understand what data set I'm actually going to use. We are going to use salary, credit over here, and approval as my output feature. Now before that, whenever let's say after creating a base model, I know the probability that I'm actually going to get is 0.5. Okay, so with respect to any records over here, what is the residual that I'm actually going to get? Because my residual 1 in this particular case, let me just write it down as R1. The residual 1 will be the difference between this y and my y hat, which is my base model, as 0.5, right? Because my base model basically gives me the output as 0.5. So I'm just going to find out the difference between this and this. Now in this particular case, my difference over here will be minus 0.5, it will be 0.5, it will be 0.5, it will be minus 0.5, it will be 0.5, it will be 0.5, and it will be 0.5. So I hope everybody is able to understand over here. After constructing a base model, what I do is that I basically calculate my residual. Now, before I go ahead and construct my next decision tree with this root, the input feature that I'm going to consider is salary and credit, and my output feature that I'm going to consider is R1. Okay, so let's go ahead and let's try to construct a decision tree. Now, this third and fourth important step that you will be able to see, guys. Here I have basically written calculate similarity weight and calculate gain. This both step will actually help us to find out which feature should we select. Whether salary is the best feature to select and split my decision tree, or whether credit is the best feature to basically select, to construct my decision tree. Let's say that, for instance, I have anyhow found out that salary is my feature that I really want to use it and use it for the splitting purpose. Later on, we'll try to compare it with credit. Okay, so let's go ahead and let's consider that here I'm actually going to take salary. So this will be my feature with respect to salary. I'm going to use salary in order to construct my decision tree. Now, with respect to salary, you know that how many different types of output that I have with respect to salary? Two different types, right? One is less than or equal to 50k. Okay, and one is greater than 50k. Now, with less than or equal to 50k, how many different types of values I have, and with greater than or equal to 50k, how many different values that we have, or leaf nodes that I can say how many different values we have. Now let's go and see with respect to this particular data set. With less than or equal to 50k, I have minus 1.5 here, and this is again less than or equal to 50k. Then again I have 0.5k over here. So And again, one more less than or equal to 50k, I have 0.5. So I'll keep on writing this minus 0.5, 0.5, 0.5. Okay. So first of all, I will go ahead and write it minus 0.5, 0.5, and 0.5. And I can also see one last record is basically having less than or equal to 50k. Again, I have the value as 0.5. Okay. So here I'm basically going to write it as 0.5. Similarly, greater than 50k, I have three records. It is minus 0.5, 0.5, and 0.5. So here I'm going to basically use minus 0.5, 0.5, and 0.5. Okay. And finally, here you can basically see that, and this is the next decision tree one that is getting constructed sequentially. And if I probably take up this particular root node, I'm going to combine both these values over here. So it will be minus 0.5, 0.5, 0.5, 0.5, 0.5. So this many 0.5s are there. And oh, last one, I guess it is minus 0.5. So let's me compute it over here. So this is basically minus 0.5. Okay, so minus 0.5. And similarly over here, I have minus 0.5, 0.5, and 0.5. So perfect. One computation, because when I was trying to subtract the 0 by minus 0.5, I had to get minus 0.5 over here. Now, this is what we have done with respect to the first split. Let's consider the salary is the best feature to do it. Okay, I will now show you that how can I compare two different splits with the help of similarity weight and calculate with the help of gain. So let's go ahead and try to calculate the gain, similarity weight for each and every node. So here you can see that I'm having this left side split with respect to this. So obviously, let's go ahead and calculate the similarity weight for the left node. So here I'm going to basically write similarity weight for the left child. So here I'm just going to write it as LC. And you know my formula, what it is? Summation of residual square divided by summation of probability 1 minus probability. This probability is nothing but whatever is the probability with respect to my base model. That is what I'm actually going to use. Now, if I probably do the summation of residual square for this node, so this is my left child. So how I'll do, I will basically write 0.5, okay, and I will go ahead and write plus 0.5, and then I will probably go ahead and here you can basically see residual square. Okay, so don't get confused with respect to this because this is super important. And I know many people will basically do this confusion. When I say residual, all the summation of the residual I have to probably take up. Okay, so minus 0.5 plus 0.5. So here also I have again another 0.5 and again minus 0.5 whole square. Okay, divided by if I say summation of probability multiplied by 1 minus probability, I have to probably take my base learner probability, that is 0.5, and I have to make sure that how many number of residuals I have, that many number of time I have to do the summation. Okay, so here I'm going to first of all use probability. This will be 0.5 multiplied by 1 minus 0.5. So this will be my first for the first residual. For this residual, then again the same step I'll construct it for the next residual. Okay, then again same thing I will do it for the next residual. Then again the same thing I will do it for next residual. So this is what I have to probably do for all calculating all these probabilities for all the residuals itself. Now you can go ahead and do the calculation forward. So here you can see this and this will get deducted, this and this will get deducted. So this entire value will be equal to 0. So if I probably calculate the similarity weight for this, it will be equal to 0. Before that, if you really want to do the calculation here, you can do it. It will be 0.5 multiplied by 0.5, 0.5 multiplied by 0.5, 0.5 multiplied by 0.5, 0.5 multiplied by 0.5. So this entire value will be equal to 1. Okay, so 0 by 1 anyhow it is going to be 0. So here I can definitely write that my similarity weight is equal to 0. Right. So this is the first step. Similarly, with respect to the right node, also you can basically do it. So here I'm going to basically consider the similarity weight for the right node. Okay, so right child. Here I'm going to use right child. So again, summation of residual square. So here I'll be writing 0.5 plus 0.5 plus 0.5 whole square. And here obviously you know that as many number of times if I write probability multiplied by 1 minus probability, suppose if there are 3, so here I'm definitely going to get it as 0.75. So this and this will get deducted. So it will be 0.25 by 0.75. So if you probably do this particular calculation, it will be 1 by 3. So 1 by 3 is here. So the similarity weight with respect to this is 0.33. Okay. Now similarly with respect to this root node, if you really want to calculate with respect to the root node also we can do it. Now be a little bit smart. This and this will get deducted, this and this will get deducted, this and this will get deducted. So I'll be having 0.25 divided by 1, 2, 3, 4, 5, 6, 7. 7 basically means 7 multiplied by 0.5 into 0.5. So it will be 0.25. So if I probably see this, it will be somewhere around 35, 14, 1.75. So this is going to be 1.75. Okay. Now just do the calculation. I've quickly done it. I know you'll be thinking English. How did we get this? Don't worry. Just try to calculate it. You will be able to get it. Okay. So that is how we basically calculate the similarity weight for the root node. Okay. For root. And this is nothing but this value that I'm actually going to get. You can go ahead and do the division with respect to this, but I'm directly going to write the value. So it is 0.14. So here the similarity weight, I'm going to get it as 0.14. Okay. Now, whenever we have this kind of similarity weight with respect to the split, the next thing that I really need to find out is something called as gain. So in order to compute the gain, it is very much simple. All we do is that we take the left child, we take the right child, and we probably subtract it with the root node. So left child, obviously you know that how much the similarity weight is 0 plus 0.33 minus 0.14. So if you probably do this, here I'm going to get 0.21. Okay. So this is the gain with respect to the split. Let's say I take up any feature and do the split over here. We will be comparing this gain. Whichever split will be having the highest gain, we'll take that particular feature and we'll start splitting. Okay. So this is super important, super easy. So let me rub this. Now what we have to do is that further going ahead. Now this is my split, right? Now further I can also do more splits for this. Let's say I'm going to probably consider the further split from here, right? And the next feature that I can consider is credit, right? So if I probably consider credit, let me do one thing. Let me just make this equation go a little bit down so that you will be able to see this. Okay. So I'm just going to paste it and let me put it more down so that it will be looking good. Okay, just a second. Oops, something happened. Okay, so this is fine. So here you can probably see all the similarity weight and all. So here I'm going to just rub it. Okay. So what I did, all the calculation, I moved it to the next page because after this step, I really need to show what exactly thing will happen. So here is my entire calculation with respect to the gain, with respect to the left child, right child, and with respect to the root. Okay. Now let's consider we are going to take the next feature called as credit and make the further split. Now again, if I probably take credit over here, okay. If I probably take credit, now credit usually has two types. Okay. One side I can basically take bad, and one side I can basically take good and normal. The another kind of split that can happen from the same node is that if I take credit over here, okay, one side I can have bad and good, and one side I can have normal. So that is what I was trying to talk about. You know, out of these two split, which split should I take? Right. That is the main thing. So that is the reason what we do. We again go ahead and calculate our we go ahead and calculate our similarity weight, and we go ahead and calculate our gain, you know, in short. So here you can see when the credit is bad, here you can see that what value is going to come. So first of all, you can see when the salary is less than or equal to 50k. So the next step here you'll be able to see credit. If it is less than or equal to 50k and the credit is bad, here I'm going to get 1 minus 0.5. So here I obviously 1 minus 0.5 I'm going to get over here out of all these 4 records, right? And the other scenario, whenever my salary is greater than or equal to 50k, less than or equal to 50k, I don't have any other records that has bad in this side. Okay, because everything I have either good or normal, right? So remaining all these 3 records will be coming over here. So 0.5, 0.5, 0.5, right? 0.5 and minus 0.5. So I have all the records over here. Okay. So let me again write it down, minus 0.5. Now what I will do is that again for this split, I will go ahead and calculate the similarity weight. So let's go ahead and calculate the similarity weight for this left child. So obviously here, it will be minus 0.5 whole square. So it is obviously going to be 1.25 and divided by, that what do we divide by? We basically divide by probability of summation of probability multiplied by 1 minus probability, right? So this will in turn be 0.5. So here obviously I'm going to get it as 1 because the reason why we get it as 1 over here because you can clearly understand that I just have one simple root node, right? So here this is my similarity weight is equal to 1 because I just have one leaf node. Okay. So similarity weight with respect to right node, right child, here also you can basically calculate this and this will get deducted. So again, this will be 0.25 divided by 0.75. So if I probably go ahead and calculate this will also be 0.33. Okay, so here I'm going to get the similarity weight of 0.33, right? Now, similarly, with respect to credit, I already know what is my similarity weight on top of it is 0. So in short, you will be seeing that finally I will be getting a gain, which can again be calculated by 1 plus 0.33 minus, here you can see it is 0, right? So overall, here what I'm actually getting is 1.33. Okay, 1.33. Now this is with respect to this split. Let's say again we calculate with respect to the split, and let's say if you're getting less than 1.33, then we'll try to select this. But if you go ahead and do or calculate the similarity weight and again with respect to the split also, we'll be getting 1.33. So out of these two, let's say that we have selected this. Now with respect to any new data set, how will the prediction basically happen? We're going to see. And here I have actually constructed the entire decision tree of this, but by using this specific data set. Now let's say I pass this specific record. Now when I pass this specific record, the first thing is that it passes through this particular base model, right? So when it passes through this particular base model, it gives the value with respect to probability. But if you're getting the value with respect to probability, one thing that we really need to do is that we really need to calculate the log of odds. Okay, we basically say log of odds. We cannot directly use the probability because in logistic regression also you saw that, right? Whenever we used to get a probability, we used to pass it through a log of odds function, right? Which is my cost function. So in short, my first formula, whenever for a new test data, it should basically pass through log of odds, and log of odds is basically given by a formula p log of p. Let me write it down much more clearly. So here you have log of p divided by 1 minus p. And this is basically the log of odds formula. So in the first instance, let's say if my first record is basically passing over here through the base model, okay, if I probably calculate, okay, what will be this probability if I place it over here to find out the log of odds? So log of odds, if I try to calculate over here, it will be log of 0.5 divided by 0.5. So log of 1 is nothing but 0. So whenever it passes through this base model as an output, I will be getting my output as 0. Okay, this is super important. Okay, now let's say if my first record passes through this, let's say if this is my data that is getting passed, okay, through my XGBoost, then obviously the first value that I'm going to get from my base model is 0. So I will just write it down over here as final output. Let's say the predicted output that we are going to see when I give my new test data. In this particular case, I'm giving my first record. My first record is going to get 0 as an output. Okay, and top of it, what I'm actually going to do, I'm also going to apply a sigmoid activation function. Okay, so first base model, it is basically going to get 0. Okay, so here you can see, like let me just create this once again so that you will not have any confusion. So this is my base model, and then it will probably pass it through my decision tree 1. Okay, which we have actually constructed. Okay, and this decision tree will be up till some new depth. Okay, so first thing, my base model, I have already shown you that my output over here is 0. Okay, so for any new data, let's say in this particular case, I'm passing this first data point. So less than or equal to 50K and credit is bad. It passes through the base model. Here the output that I'm going to get is 0. So here I will be getting 0. And on top of that, I'll apply a sigmoid activation function. Let's say that I'm applying an activation function over here. And this is basically my sigmoid activation function. Okay, first model that we pass is basically 0. Now when it goes to this decision tree, that is this decision tree, what is the salary? Salary less than or equal to 50K, so it is going to go over here. And over here it is saying credit is bad, then again it is going to go from here to here, and then it is going to go from here to here. So finally you can see that I'm getting minus 0.5, but here you can see that my similarity weight that I got initially was 1, right? So when I apply this, in short, that will basically be my output. But before that, we will be adding a learning rate, and my similarity weight will be 0.1, will be 1, because that is what I got my similarity weight over here, right? The similarity weight in this particular case was 1. So this is basically my similarity weight, right? So after this, what happens is that this sigmoid activation function, I'm just going to expand. Let's consider my alpha is 0.1. Learning rate is usually between 0 to 1. In this particular case, I'm going to use 0.1. So here I'm actually going to get 0.1 multiplied by 1. And here, finally, you'll be able to see that I'm going to expand this. In short, this is going to be 0.1. So this sigmoid activation function is given by 1 plus e to the power of minus whatever I'm actually getting as 0.1 over here. So if I probably apply this and if I try to calculate it, how much I will be getting. So here, let me open a browser and let me just do it in front of you. So I'm just going to search for over here 1 divided by 1 plus e to the power of minus 1 or 0.1. Always remember with the help of sigmoid activation function, we are going to get a good probability because sigmoid activation function always gives us output between 0 to 1 that we have already done. So here you can see it is minus 0.52, right? So here you can see alpha 1 multiplied by this value, and finally you'll be able to see when I apply this sigmoid activation function, how much is this I'm getting 0.52. So whatever 0.52 I get over here, this will basically be my predicted output. This will be my new predicted output y hat. So this will be 0.52. Okay. Similarly, let's say that I've computed for all the other records. Let's consider for the next record. For the next record, it is like less than or equal to 50K, green and 1. Okay. So green, sorry, good, right? So less than or 50K, again, first of all, it will pass to the base model. So second record, what will be the output? Okay, first thing is that obviously I'm just going to apply a sigmoid. The first value that I'm actually going to get is 0 because it passes through the base model. And then I will be using my learning rate that is 0.1. And here we really need to find out what will be the output with respect to decision tree 1. Right? And this is basically my decision tree 1. Right? So here you'll be able to see when I pass less than or equal to 50K, it passes over here. The credit is good, I guess. In this particular case, the credit is good. This is my second record. Everybody see this? This is my second record. The credit is good. So finally I go on to the right hand side. And here you can see that I've got 3 records over here, but my similarity weight is 0.33. So what I'm actually going to do, alpha multiplied by 0.33. So here again you'll be seeing sigmoid 0 plus 0.1 multiplied by 0.33. Right? Then what I'm actually going to get, it will nothing be 1 plus e to the power of minus whatever the multiplication will be coming with respect to this 0.33 multiplied by 0.1. Okay, so here you'll be able to see, I'll open the calculator, and here it will be 0.33 multiplied by 0.1. So it will be 0.0, I think it is 0.033. Okay, so this is nothing but 0.033. Okay, now again, if I go ahead and calculate with the help of calculator, 0.033, I'm going to get the output as 0.508. Okay, so anytime I will basically be getting between 0 to 1. So this will be 0.508, which will be my final output for the second record with respect to the predicted one. So it will be 0.58. Right? So like this, I'll be getting a lot of values. Again, I will go ahead and compute my R2. So whatever R2 I'm actually going to get, now in this particular case, my R2 will be 0 minus 0.52. So here I'll be getting 0.58, and similarly here I'll be getting 0.42. So like this, all the values will be there. And then again, we're going to construct the next decision tree considering this input features and R2 as my output feature. Then again, we go ahead and calculate similarity weight and calculate the gain. And this process will keep on going unless and until we get all this kind of trees, which will start with a base learner, and then it will multiply with alpha, multiplied by another decision tree, which will be over here. And alpha is basically my learning rate to avoid overfitting. Then again, there'll be an alpha multiplied by another decision tree output. Okay, and this will continue till the end. And so this in turn is nothing but this is my XGBoost classifier. Okay, this is my super XGBoost classifier. Now, this was the entire working about the XGBoost classifier. I know there were a little bit of ups and downs because I've written up and down. But again, if you just go through the video again in order to understand two important things. First of all, with respect to the base model, I have to calculate log of odds, and with respect to finding the final output, I have to apply an sigmoid activation function, which is also called as logistic function. This is also called as logistic function. Okay, logistic function. Okay, if there are multi-class classification, then the logistic function will be converted into a softmax activation function. Okay, and then whatever I'm actually using, I'll keep on adding it. So finally, you'll be seeing your output, final output with respect to predicted points will be sigmoid function with respect to your base learners, base learner probability. Okay, the base learner plus alpha 1, your decision tree 1 output, plus alpha 2, the decision tree 2 output, plus alpha 3, decision tree 3 output, and so on. Okay. Now, one super important point which I did not say, whenever we compute a similarity weight, there will be also one more parameter which is called as lambda. And this lambda is basically your hyperparameter. Okay, we basically do a lot of cross-validation in order to select the specific lambda. And one more thing is that there is always the thinking that till when we should basically keep on splitting this. Should we keep some restriction with respect to the similarity weight, right? So in order to find out that specific thing, what we do is that we set up a cover value. The cover value is given by this equation, that is probability of 1 minus probability. So whenever any weight is less than this particular output that we get, when we apply this, whatever output that we are getting, what we do is that we slice down that entire tree. Suppose in this particular case, let's say we are going to get 0.25, and now suppose my similarity weight is basically less than 0.25, so we stop the splitting at that point of time. So this is specifically called as your cover value. Okay, so this is nothing but this is your cover value. We also say this as cover value. So similarly, in case of regression or in case of classification also, we basically say this as cover value. Now in classification, we'll be seeing the formula will be changing with respect to similarity weight and gain. Only that is the changes, but almost the process will be entirely same thing. Suppose if you're doing the regression problem statement at that point of time, you'll be seeing that there will be some changes with respect to similarity weight and gain. Okay, other than that, I think everything is fine, and you just have to follow this particular step in order to construct the XGBoost machine learning algorithm. So I hope you like this particular video. Yes, please make sure that you keep on revising things. Then only you'll be able to understand multiple things, and this is how you basically create a sequential decision tree in XGBoost. So yes, I'll see you in the next video. In the next video, we'll discuss about XGBoost regression. Thank you. In this video, we are going to discuss about XGBoost regression machine learning algorithm. Again, like how we discussed about XGBoost classification machine learning algorithm, we took a simple data set and then we saw that how the sequential decision tree will get created. Similarly, we're going to do that, follow the same step in XGBoost regressor. We'll try to compare what is the exact difference between both of them. Okay, so to begin with, here I am taking a simple data set. This is a regression data set altogether. So my input features are experience and gap. Over here, you can see based on experience and career gap, I need to predict what is the salary. So here, salary is my output or dependent feature. And so this is a regression problem. So in short, with the help of XGBoost regressor, we can also solve a regression problem statement. Okay. Now, if you remember about XGBoost classifier, again, guys, remember in XGBoost classifier to select the feature and probably construct the decision tree, we use something called as similarity weight, right? So if I talk about similarity weight, this was the formula with respect to similarity weight. So similarity weight was nothing but summation of residual square divided by summation of probability 1 minus probability, right? So this was the formula that we specifically used for classification problem, and after that we also use a formula for gain. Now in this, when you're solving regression problem, again this formula is going to change slightly a bit. The denominator will be changing since this is a regression problem statement altogether. So let's start with the first step. Then again, I'm just going to note down all the steps that you have to probably follow in order to create an XGBoost regressor. That basically means sequential decision trees. First of all, we basically create a base model. So let's say we create a base model, and this base model, since this is a regression problem statement, the base model will be giving me the output of what is the average that we are going to get over here, right? So if I probably calculate the average, it is 40 plus 42 plus 52 plus 60 plus 62 divided by 5, we approximately get somewhere around 51k. Okay, it is somewhere around 51.2, but I'm just going to consider as 51k. So whenever any data that passes, if I probably take experience and gap and pass through this base model, my output that I'm actually going to get is something like 52k. Okay, so we have understood our base model is obviously we are getting somewhere around 51k, not 52. I'm extremely sorry about that. So 51k, because this is the average that we calculated out of all the salary, and this is the base model which is not at all biased towards any values. Okay, whatever is the average over here with respect to the output that we are going to get. Now we understood my base model output over here is specifically 51k. Now the first thing that we calculate again. Over here, I will write it as y hat. Now, when we are calculating with respect to the y hat, one thing you have to make sure that here I'm having 51k. So every time when I write with respect to whenever I pass my any data over here, like let's pass this experience as 2 and gap as yes, it is going to give me 51k as my output. So in the first case, my y hat will be 51k. Okay. Now what we are going to do in the second step is that we are going to compute our residuals. Okay. So like how we did in the XGBoost classifier. So the residual I'll write R1. All I'm going to do is that find out the difference between 40 and 51. So obviously I'm going to get minus 11k, and here I'm probably going to get minus 9k, and similarly over here also I'm going to get 52 minus 51 1k, and I'll not write k over here because again it will just look like okay I'm providing some unit. So here residual we're just trying to find out the error. So this will be minus 9, this will be 1, this will be 9, and this will probably be 11. So these are my residuals. Now in the second step, what we did is that we computed the residuals. Okay, residual computation by using this predicted output of the base model. Now coming to the third step, which is super important, is that in the third step we are going to construct decision tree using because after this we really need to create one sequential decision tree, right? Using x of I as an inputs and r1 as my output. So with respect to my decision tree, what I'm going to use x of I with respect to all my inputs. X of I is nothing but my experience and gap, and r1 is specifically my output feature for the first decision tree. Now let's go ahead and construct it. So first of all, let's say that I'm going to pick up experience as a feature and start creating a decision tree. So in the first instance, let's say that I am using experience. In this experience, okay, let's say this is my experience. Now with respect to experience, since this is a continuous feature, you know that how we have to split in a decision tree. We can take up every record and we can start splitting it. Like we will just take up 2, okay, and here I will say that, okay, if my value is less than or equal to 2, so 2 splits I'll make binary, less than or equal to 2 and greater than 2. So with respect to this particular split, like I'm just taking the first record, I'm keeping 2 as threshold and I'm splitting it. And similarly, if I want to try, you can also try with other records also. Okay. So let's say I've taken this. So obviously, if it is less than or equal to 2, I'm going to get a residual as -11 on the left hand side. So here I'm going to use -11. Okay. So this will basically be my leaf node in this case. Okay, -11. Now greater than or equal to 2, I will be having 4 records: -9, 1, 9, and 11. So here I'm basically going to use -9, 1, 9, and 11. Okay. So these are my records over here that I've actually got it with respect to experience. Now, as soon as I come over here, now we have to calculate the similarity weight. Now, if you remember, in XGBoost classifier also we computed the similarity weight, and formula was very simple for classifier. It is nothing but residual square divided by the thing that we are going to use over here is nothing but summation of probability 1 minus probability plus lambda. Okay. Now here we are going to specifically change the formula a bit, and over here the formula will not be probability 1 minus probability multiplied by 1 minus probability. Since this is a regression problem, here the thing that we are going to consider is we are going to use number of residuals. Okay. So here we are going to use number of residuals. Residuals basically means how many residuals are there with respect to this node with respect to this node. Okay. So let's go ahead and compute the similarity weight. I'm going to write SW for the left child first of all. So for the left child here, it is nothing but residual square. So 11 square is nothing but 121 divided by 1 plus. Now lambda value is a specific hyperparameter. Okay, lambda value is a specific hyperparameter. And as you know that if the lambda value increases, your similarity weight decreases. Okay, so this is basically a kind of cross validation you have to do in order to select the lambda value. For this particular use case, let's consider lambda is equal to 1. So I'm just going to write lambda is equal to 1 plus 1. So here in short, I will be getting 121 divided by 2. So in short, I'm getting 6 to the 12, and this will be 5.5. Right, so 65.5, I'm getting my similarity weight over here. Okay, with respect to this. Okay, now similarly, let's go ahead and compute the similarity weight with respect to the right child. Similarity weight with respect to the right child. And now here you can see that right child has a lot of values, like they have 4 different values. So I'm just going to use this -9 plus 1 plus 9 plus 11 whole square divided by how many number of residuals are there? Total number of residuals that I can find is 1, 2, 3, 4. So it will be 4 plus 1, which is nothing but 5. Okay. So this and this will get cancelled. So it is nothing but 144 divided by 5. Let me just open up the calculator so that you will be able to see it. So 144 by 5 is nothing but 8.5. Not 8.5, I guess it is 28.5. Yeah, 28.5 is my similarity weight of this side. Okay. Now, similarly, you go ahead and calculate the similarity weight for this root node, because in the root node, I will be having all these records, right? So if we combine both of them, so here I'll be having -11, -9, 1, 9, 11. So when we consider all these things here, if I apply the same formula, I'll be getting similarity weight as 0.16. Okay. Now, once we calculate the similarity weight, which was my 4th step, the 5th step is basically that we calculate something called as gain. Okay, gain. Now, in order to calculate gain, I'm going to just write gain is equal to similarity weight of the left child, that is 65.5, of the right child. I have to add and I have to subtract this with 0.16, I guess, right? Or it is 0.16. So when I do this calculation here, you'll be able to see that I will be getting somewhere around 98.34, right? So here I'm going to get 98.34. Now you may be thinking, Krish, why did we do this? Because see, if I do one more split, and let's say I'm going to change the threshold now. Initially my threshold was the experience 2. Now if I make my experience with 2.5, I can again make another split, right? So let's say if my experience split is basically based on less than or equal to 2.5, and this is greater than 2.5, then again my split will change. Here now I'm going to get -11,9, and here I'm probably going to get 1,9,11, right? So what I can do is that our main aim is that within the decision tree, whether should I use this split or this split for my decision tree 1, that you really need to think about, right? Which split should I use? Okay, so obviously if I probably calculate the similarity weight here, here, and here, and let's say if I get the gain as 100 or 108, okay, and obviously for this it will be greater than this. You can go ahead and compute it. If I probably do show you all the calculation, the gain that I will be probably getting for this entire split is somewhere around. So the gain will be somewhere around 143.42 for this. Okay. Now here you can see 143.42 is greater than 98.34. So out of this 2 split, I'm going to definitely use this split. Similarly, I can compare with other thresholds over here. Okay. So that is how we basically select our first decision tree, and we can do further splitting with the help of gap also. So probably I can go ahead and do the further splitting with respect to gap. Let's say that I have selected this particular split because the gain is high. So how will my base learner look like now? My base learner is over here. This is giving me the output. What output this is giving me? We actually saw it is nothing but 51k. Then my next decision tree will be having this split wherein, let's say my experience is less than or equal to 2.5 and greater than 2.5, right? And let's say over here I have what all values I have -11,9, -11,9, and this will probably have my other values, which is nothing but 1,9,11. Okay. Now what I can do, I can further do splitting of this. Let's say for greater than or equal to 2.5, if my gap is yes or no. So if my gap is yes or no, I can probably make another split with respect to this, and here I will be having yes or no. If my gap is yes, then I will probably be getting 11 over here. If my gap is no, I'll be getting 1,9. Okay. So let's say that I've done this kind of further splitting based on the data that I actually had, and I've made this entire split like this. Okay. Now, super important thing that you really need to note down over here. Okay. Is that how do I find out my final output? Because this is just my decision tree 1, right? This is just my decision tree 1. This is my base learner, right? And you know that with respect to XGBoost classifier also, what we do, regression. First of all, let me just recall XGBoost classifier. In XGBoost classifier, what we do, we take the log probability of a log of odds of the base learner. Okay. Plus alpha 1, which is my learning rate, and then I take decision tree 1 output, then alpha 2, decision tree 2 output, similarly like this up to alpha n decision tree n output. Similarly, with respect to XGBoost classifier, so XGBoost regressor, let's say I pass this test record, let's say I'm just passing this record. So let's see what will be the output in my case. So when I pass this record, so obviously experience is greater than 2.5. So if experience is greater than 2.5, so I will take this route. And over here in my this specific record, my gap is no. So if my gap is no, I'm going to probably take this record, okay, this path. Now here you can see that my output has 1,9. Now in order to find out the output of this, I just have to find out the average of these two numbers. So it will be nothing but 5. So my XGBoost regressor first of all passes through the base learner, the test record, new test record passes through the base learner. So my base learner has the value as 51k plus alpha 1. Here also alpha is basically be my learning rate. And let's consider learning rate over here as 0.1. You can also consider 0.2, 0.3. This is again a kind of hyperparameter, okay? So here in this particular case, I'm taking alpha as 0.1. Once we take this alpha, all the other alpha value will also be having this. And the decision tree one output will basically be 5 because I got the output over here as 5. Okay. So here if I multiply by 5, so here you'll be able to see I'll be getting 51 plus 0.5. Now when I say 51 plus 0.5, here you'll be able to see I'm going to get 51.5. Okay. Now with respect to this, this will be the output. Okay. Output for the third record that we are given. And over here, what was that? You could see that my experience was 3 years and my gap was no. So for this, the output that you'll be able to see, I got 51.5. So I'm just going to write down the y predicted output, the new predicted output after decision tree 1. So I'll write it as y hat, my new predicted output. So here you can see for this, how much I'm getting basically 51.5, right? So finally, I can see that I'm getting 51.5 over here. Okay. So guys, we have got the new predicted output for this record, like 51.5. Now what we are going to do is that we're going to calculate the predicted value for all these records, okay? So let's consider I want to pass this record where the experience is 2 and gap is yes. When the experience is 2, so here, obviously you can see it will first of all pass through the base learner. So what I can basically write over here, first of all, when it passes through the base learner, 51 will get added, plus my learning rate is 0.1. Now I really need to find out what is the output of the decision tree 1, okay? Now if I go over here, so since my experience is less than 2, so here you can see it is coming to this node, but here in this node I have two values, minus 11, minus 1, minus 9. So here the output will basically be the average of this two node, which is nothing but it will be minus 10. Okay. So here I'm going to basically multiply by minus 10. In short, what we are going to do, we are going to subtract with 0.1, which is nothing but 49.9. So my output over here will basically be 49.9. And this record also will go on the left hand side, so this will also be 49.9. What about this record? That is 4, no, 60k. So here you know that what will happen, the first record, first base learner will give 51. Okay. And then I have a learning rate 0.1. And my next output of the decision tree 1 will be, when I go over here, 4 is greater than 2.5. That is fine. We are going over here. And with respect to this, what is the record that I have over here with respect to gap? No. So the no will basically give me 1.9, which is nothing but 1 plus 9 divided by 2, which is nothing but 5. So the output will be 5 in this case. So here you can see 0.1 multiplied by multiplied by 5, which in turn will be equal to this value itself, 51.5. So here also I'm going to get 51.5. Here also I am, okay, here I'll be getting a different value because here we will again multiply 51 plus 0.1 multiplied by, now the decision tree output with respect to gap as yes will give me the output as 11. Okay, so here the output is 11. Okay, because I just have one more. So here you can basically write 0.1 multiplied by 11. Okay. And this is nothing but 51 plus 1.1, which is nothing but 52.1. So here is my 52.1. Now after I calculate my new predicted output, because I have just created one base learner and one tree, okay, now my work is that I have to create another tree. And to create this another tree, I have to give my independent feature and new residual R2. Now R2 will basically get computed by the difference of this and this, right? So if I probably subtract this and this, it will be minus 9.9. Here probably it will be minus 7.9. Here it will be 0.5. Here it will be 51, 8.5, I guess, 8.5 or 9.5. 8.5 will come over here. And here you'll be able to see I'm going to get somewhere around 52 to 62. This is nothing but 9.9. Okay. So I hope I've done the calculation correctly. If there is a slight mistake, don't worry about it, you can do it. Now in my next decision tree that I'll be constructing here, I'll be taking my independent feature experience and gap and my output feature R2, and I'll be constructing this decision tree. And this will keep on going unless and until we have multiple decision tree that is created like this, right? So this is what is the entire process of implementing the XGBoost regressor. In short, in XGBoost regressor also we'll be applying these things. Now there is, if I consider my similarity weight formula, and inside the similarity weight, we have found out what is the formula, residual square divided by number of residuals plus lambda. I hope this is the formula with respect to your similarity weight in regression. Okay, this is super important to cover up. Okay, and with respect to classification, you already know what is the similarity weight, and we obviously have to calculate similarity weight and gain in order to find out which is the best one. So this is nothing but residual square divided by probability, summation of probability 1 minus probability plus lambda. Lambda, understand, is a kind of hyperparameter. As we keep on increasing, the similarity weight keeps on decreasing. Okay. Now this is super important to understand all these things, and there are also some amount of hyperparameters which we'll be using, and that I will definitely show in practical. But here I think you got an idea about XGBoost regressor is working and what is the importance of lambda and how the decision tree is basically getting constructed. But in short, these all are sequential decision trees that are getting constructed. First we go with base learners, and then we keep on continuing to create different decision trees. So I hope you understood this video, and yes, I will see you in the next video with some practical sessions. Thank you. Hello guys, so now we are going to complete the practical implementation of XGBoost. Again, we are taking up the same problem statement since we really need to try all the machine learning algorithms and the holiday package prediction. So what I'm actually going to do now is that we are just going to import for XGBoost. Already we have seen the different examples like random forest classifier, gradient boost, boosting classifier, decision tree classifier, AdaBoost. Now first of all, what you need to do is that you need to install XGBoost. So first of all, just go ahead and right click install XGBoost. So by default, it will not be present. Okay. So probably once you install this, automatically you can see the requirement is already satisfied. I've already done the installation. Now the next thing that we are going to do with the help of this specific classification problem, we're going to solve with XGBoost classifier. So after installing XGBoost, what we're going to do is that we're going to just import it. So I will write from XGBoost import XGB classifier. Okay, so I'm just going to use this specific library that is called as XGB classifier, which will basically do the classification. And again, to include that over here, I'm just going to make another key value pairs, like how we did it for random forest and gradient boost, even AdaBoost. And I'm just going to initialize to XGB classifier. Okay, and once this is done, we'll just go ahead and do the prediction. We'll see the training performance, test performance, and all. And again, here with respect to the training data set, we're going to see the accuracy, F1 score, precision, recall, ROC, AUC score. And similarly, here also we're going to see all the other details. So let me just go ahead and execute. So finally, here you can basically see that with respect to AdaBoost, I'm getting a very good accuracy of 99% and all. But with respect to test accuracy, also I'm getting somewhere around 93. But my recall is a little bit less. So probably with the help of hyperparameter tuning, I can basically do well, right? Since I have a good accuracy with respect to all the other things other than recall. Okay, Now what we are going to do over here is that we're just going to perform hyperparameter tuning. Now again, for hyperparameter tuning, we have to use this kind of parameters over here. This was the parameters that we use for gradient gradient classifier. Similarly for XGBoost classifier, I've already created all the parameter combination that you definitely want to play with. So I'm just going to play with paste it over here. So in XGBoost, the main important parameters are like learning rate, match depth, number of decision trees, column sample by tree, and some more parameters are there. So here I've actually created this, and I'm going to play with all these parameters. So let me go ahead and execute it. So here now this is my RF params, and this is my XGBoost params. Okay. So probably if you go and see an XGBoost PyPy, so XGBoost XGBoost PyPy, right? So here you'll be able to see all the information regarding XGBoost, right? And let's see, probably in the GitHub, you'll be able to see, your documentation will be able to see. So just go through this entire documentation. Here you'll be able to see all the parameters that are there. So you can get started with XGBoost and you can see all the parameters that are involved in this, and you can basically play with those kind of parameters, all that is there. Even one more thing that is amazing with XGBoost is that you can also run XGBoost with the help of GPU. Okay, so here also you can assign the GPU parameters and you can play with the XGBoost over here. Okay, so yes, definitely you can also try this. Just need to set this. XGBoost regressor. So here you have something called a GPU underscore ID. So by default, what is the NVIDIA GPU that you'll be having? That specific ID you have to give, and mostly it will be 0 for that particular case. Okay, so here is my XGBoost parameters. Now the next thing that I'm going to do, instead of writing gradient boost, I'm just going to use XGBoost over here, and this will be XGB classifier. And here the parameters that I'm actually going to give is nothing but XG params. Okay. So let me just execute and see this whether this is right. Okay. Now once I execute this is my random CV models, and now you can see all the random CV models. This is RF, this is XGB classifier. So many different parameters here. You can see GPU ID and all. Right now I'm not going to use GPU, I'm just going to use CPU, and with the help of that also we can do the prediction. Okay. Learning rate, max depth, and all are there. You can definitely use this. Now what we're going to do, we're just going to run this randomizer CV. I've already given up my params, my model, and let's see how it will basically give us the best param. So the fitting has already started. Here you can see first it will go with random forest, and then probably after some time it is just going to go with XGBoost. And finally we'll be able to see the best param. So it is taking 10 seconds somewhere. And probably random forest will get quickly completed, I feel, but XGB classifier will take some more time. So yes, you can see 20.7 seconds it has taken to complete for the random forest. Now again for the XGBoost, it is just going to do total number of 300 fits. And once it completes 300 fits, then you can see, okay, XGBoost was quite fast within 11.6 seconds. So these are the parameters that we have got in XGBoost. So what I'm going to do, I'm just going to use this parameter. So it will be XGBoost. Again, here I'm going to initialize XGB classifier. Number of estimators that it is going to take is 200, right? And I'm just going to remove all these things because I don't require it. And then the next parameter is about the match depth. Match depth will be 12. And learning rate is, okay, learning underscore rate is called 2.1. And column sample by tree. So I'm just going to copy this. Column sample by tree is equal to 1. Okay. Let me write in the next line. This will be equal to 1. Okay. So now I'm going to just train with all this model and I can see the performance how it is. So yes, I think it is executing. So with all these parameters, and now finally I'll be able to see the output. Now here you can see that I'm getting this much. Recall with respect to random forest is 0.67, but with respect to XGBoost it is increased to 78%. Okay. I think before it was a little bit less, I guess. Let's see what was it before. It was 70%. But now just with the help of this parameter tuning, you can see that how good we are able to get the accuracy. Right? It is increased by another 8%, which is good. Again, you can play with different parameters and all. So here you can see that ROC score, how much it has basically covered, 0.82. So I'm just going to paste it over here, make this to XGBoost, and probably we are just going to see our curve, right? So here I'm just going to copy and paste this. Okay. Copy and paste this entire thing over here. So let's quickly do it. And here we go, right? So done. And now probably I'll go and see, okay, invalid syntax. Okay, I have to give a comma over here. Now it will work. And finally, you'll be able to see this is how my ROC curve actually comes, and this looks good. It's trying to cover 88% of the entire area, right? So the area under the curve is very, very good. So yes, this was about XGBoost classification. Two things that you always need to remember. First of all, install the library. Use the basic XGBoost only. You'll be getting good accuracy. Then play with different parameters based on the documentation that you have, and perform randomized CV or grid CV like how I perform. And definitely there will be a good accuracy increase. Okay. So yes, this was it. I hope you were able to understand with respect to XGBoost. I will see you all in the next video. Thank you. Hello guys, so in this video we're going to implement the XGBoost regressor, and one thing that we're going to do again, the same problem statement that we have actually taken in gradient boost regression, that is use car price prediction so that I can use multiple model and test it. Now before that, I just need to go ahead and import it. So I will say from XGBoost import XGBoost regressor. So here you'll be able to see classify and regressor. Already we have seen with respect to classification. So let's go ahead and import. This will be our evaluate model, which we are basically checking with ME, RMSE, R squared error. R squared. And now we're going to just go ahead and use one more key value pair with respect to XGBoost. And here I'm going to just say regressor, and this is going to get initialized to XGBoost regressor. Okay. And again, we're going to see it for train test, and we're going to see all the model performance. So once I execute it here, you'll be able to see good things. Obviously, decision tree is coming random forest. So if you see over here, perfect. So XGBoost is giving somewhere around 98% R square and 93% R2 score with respect to train and test data. Gradient boost is giving 94 and 91. Okay, AdaBoost is giving really less. So obviously I'll not go with this. But random forest is giving 97 and 93. Now 97 and 93 when compared to 98 and 93, I feel XGBoost is better when compared to random forest. But anyhow, I'm going to use this both of them. So I'm just going to remove this gradient parameters. And one thing that I'm actually going to do when evaluating all these particular models, we'll do some kind of hyperparameter tuning with respect to XGBoost. So here I've actually created all the parameters like learning rate, match depth, and estimator. And again, you can put any values as you want to test the different models. So once I go ahead and create this, now the next thing is that I'll just go ahead and write XGBoost like how we did it for the previous example, right? This will be my XGBoost regressor. So, and this parameters that I'm going to basically replace with XGBoost params, right? So once I execute this got executed, and here you can basically see with respect to the random source CV, I'm just going to try with these two parameters, these two models in short. One is random forest and one is XGBoost regressor. So again, the fitting will take some time, but I think XGBoost when we did it for classifier, right, it took less time when compared to this. So till then, I'll just go and probably change this with respect to the best parameters that we are going to get. Okay, I'm just keeping everything ready so that I don't have to probably till then the timing till then the training is basically taking place. I think we can complete all this work, right? Perfect. So fitting is going on. 20 seconds has gone. And now I'm just going to play with all the parameters that we have probably taken. What are the parameters we have? Learning rate and another estimator. So I'm just going to repeat all those things. So here we go. Right. So it's taking some amount of time with respect to training of the model. Let's see how much time it will probably take. We are basically doing it 300 iterations. So here you can see 57 seconds it took. Now with respect to XGBoost regressor, it will take some more time. Okay. So I can also use learning rate. So learning rate is also there. I'm just going to copy and paste it. Okay. Is equal to some value, and then I'm going to play with some more parameters like max depth and column sample by tree. Okay. So here we go. Max depth, comma, and then column sample by tree. I'm just keeping all the code ready so that once the training actually happens, we can just directly replace it over here. Is equal to some value. So yes, I've got XGBoost estimator as 300. Random forest you could see I'm getting somewhere as 200. Minimum sample split I'm getting somewhere as 2. Max features that I'm getting is 5 instead of auto. This was in the previous training, I guess. Max depth is none. Okay, this was fine. And so jobs is 1. Now NRS estimator over here for XGBoost is 300. Learning rate is somewhere around 0.1. Max depth is 5. And column sample by tree is somewhere around 0.5. Okay. So all these parameters have been selected. Now what I'm going to do is that I'm just going to train my model. Okay. So here we go. Right. So here you can basically see I'm getting somewhere 98 to 95 R square, which is better than the previous one. It looks better than the random forest regressor. So I hope you have understood how to basically do the regression algorithm training. And finally, here you can basically see. And definitely try out with different problem statement. So yes, I will see you in the next video. Thank you. So guys, till now, whatever videos we have seen in the previous session was something related to supervised machine learning problems. All the algorithms like linear regression, logistic regression, decision tree, random forest, XGBoost, gradient boost, ADA boost, all these algorithms were examples of supervised machine learning algorithm. Now, whenever I say supervised machine learning algorithm, that basically means, let's say you have a data set. In this specific data set, in supervised machine learning algorithm, the data set that is basically given, you used to have some features, let's say F1, F2, F3, F4, and you would always have a dependent feature, one dependent feature, and this specific is nothing but this is my dependent or output feature, right? And all the other features used to be my independent features or input features, right? Now, this was the kind of problem statement we used to be given in supervised machine learning, and two types of problem statement we were solving, either regression or classification. Regression or classification. Now, if I consider unsupervised machine learning, in unsupervised machine learning, and we'll try to also understand the difference. So in unsupervised machine learning, you will be seeing that you will be solving a problem statement which is called as clustering. Clustering. That basically means you will be grouping your data into similar clusters. Now, let's say that I have been given a data set. In this data set, I may have features. Let's say the feature is age, years of experience, and your salary. Here, our aim is not to find out anything as such. That basically means I don't have a specific output feature in this particular data set. Okay, in this entire data set, I don't have a specific output, no output. Okay, that basically means this is not a supervised machine learning problem statement. I'm not saying that your model should be able to predict salary based on your age and experience. No, I'm not saying that. Let's say if you have some data which has all these particular data points with respect to age, experience, and salary. Now, if I try to apply any unsupervised machine learning algorithm, and I'll also talk about which all unsupervised machine learning algorithm are there. If I try to apply an unsupervised machine learning algorithm onto this specific data set, okay, then here we will be able to group this data together, group or cluster this data. Okay, now what does this basically mean? So suppose I have this entire data set. So when I'm grouping, the information that I may be able to get right from this particular data set is that people who are having similar age, similar years of experience, and similar salary. So when I apply unsupervised machine learning algorithm, you will be able to create clusters that may have the similar types of values within those clusters. Okay, let's say this particular group or cluster, I will mention it as cluster 1. This may have similar age, experience, and salary. So all the people who are inside this particular cluster with respect to this particular data points may have similar age, experience, and salary. So I may be having some data points which will be falling in this particular data in this cluster. That basically means, let's say some of the records like this may be falling in this cluster. Some of the record may be falling in this cluster. Similarly, I may be having more data points that may be falling in other clusters. Right? So that is what an unsupervised machine learning algorithm will do. At the end of the day, we are clustering these data points into a specific group. Okay, but why do we do this? Okay, one basic example. Let me talk about a real world scenario. There's a use case which is called as customer segmentation. Now, in customer segmentation, what do we do? Let's say I own a specific product. Okay, and I have a list of data of which all people have bought this specific product. Okay, and I may also be having some information like the salary, their spending score. Let's say I have all this information from those people who have bought this product. Then what may happen is that when I bring a new product into the market, by just seeing these data points, I will be able to understand that who are the people will definitely buy this particular product for the first time in the first day itself. And if they're probably buying this specific product on the first day, I may give them some kind of discount, right? So obviously, I can definitely apply an unsupervised machine learning algorithm, and I can say that, okay, there is a group of customers considering the salary, spending score. There's another group of customers. I know that in this group of customers, people like to buy the product as soon as a new feature comes. Let's say Apple. Okay, so I may be saying that, okay, let's go ahead and probably give this people who buys my product regularly around 15% of discount. Let's say these are the other cluster of people who buys this product not on a regular basis, but yes, sometimes. So as soon as this product launches, I may probably increase the discount rate to 20% so that they will be interested to buy the product as soon as a new feature will come up. So this example is called as customer segmentation. And based on segmenting these people based on some features, that basically means clustering, right? I am providing some features over here, right? So this can be a perfect example with respect to customer segmentation. Now, in unsupervised machine learning, what all algorithms will be learning? So the first algorithm that we are going to learn in unsupervised machine learning, okay? The first algorithm is nothing but k-means clustering. K-means algorithm. The second algorithm that we will be learning is something called as hierarchical clustering or algorithm. Okay. The third algorithm that we'll be learning is something called as BB-scan clustering. Okay. And finally, the fourth thing that we are going to see is something called as Silhouette scoring. And this mechanism will basically used to see the model that I have probably got. In short, I'll be using this particular mechanism to validate the specific models. Okay. Super important, Silhouette scoring. So we'll be covering this algorithm one by one. We'll be understanding the maths in-depth intuition behind it, the geometric intuition behind it. Then we'll go to hierarchical clustering, BB-scan clustering, and finally we'll be seeing Silhouette scoring. Okay. So yes, let's go to the next video and let's start our first unsupervised machine learning algorithm, that is k-means clustering. Hello guys. So we're going to start a new machine learning algorithm which is called as principal component analysis, and we also call it as PCA, and we also say it as dimensionality reduction. Now, before we go ahead and understand what exactly is PCA, first of all, we need to understand why should we use PCA or dimensionality reduction. So for this, we really need to understand about a topic which is called as curves of dimensionality. Okay, so curves of dimensionality. And in order to make you understand this specific topic, let me take some examples over here. Let's say I have various models. Okay, so let's say this is my machine learning model M1. This is my machine learning model M2. This is my machine learning model M3. This is my machine learning model M4. And I still have some more machine learning models, so be patient. Okay, M5, and this is my machine learning model M6. Okay, so let's consider I have this many machine learning models. Now, let's say that I have a data set, and in this specific data set, I have somewhere around 500 features. Okay, and whenever we say about dimensionality, this basically means we are talking about something called as dimensions. And whenever I say dimensions, this is nothing but this is features. Okay, so let's say this data set that I specifically have is to basically determine or find out the price of the house. So some of the features that I may have in this data set is like house size, right? Let's say number of bedrooms, or it may be number of bathrooms, or it may be I may also have features like number of bathrooms, right? I may have this many kind of lot of features. Okay, now obviously, to basically find out the price of the house, what is the most important thing? Probably you need to know the house size, you need to know the room size, you need to know the number of bedrooms, you need to know how many number of washrooms, right? Let's say for the model M1, I have provided around the most 3 important features to train out of this entire 500 features. Okay, let's say after that for the M2 model, I provided somewhere around 6 features for training the model. Okay, similarly for the model 3, I have provided around 9 features, let's say for training the model M3, right? And after that for the M4, let's say I have provided 50 features. Okay, or let me just not make it as 50 right now. Let's say that, okay, in this particular case, I have provided probably 15 features. Okay, so let's say over here, I have provided 15 features. And here, now I have increased the number of features. Here I have provided 50 features for training this particular model. And then probably here I have provided 100 features. And then here I have actually provided 500 complete features. Okay, now what will happen when I'm providing this many number of features for every model? Okay, now let's say this model M1, I will be getting some accuracy. Okay, and this accuracy is based on these 3 specific features, right? So here, let's say this is my accuracy 1. So here I am specifically getting accuracy 1, right? Now, after I train my model with these 3 features and probably train this particular model, I'm going to get accuracy 1. Now let's go to the next model where I specifically use 6 features, and let's consider the 6 features all are very, very important for determining the price of the house. Then what will happen is that my accuracy 2 will still increase, right? When compared to accuracy 1. So here I can definitely say accuracy 2 will be greater than accuracy 1. Then let's say M3, again, when whichever features we actually provided, like the 50 features, are still more important when compared to the previous 6 features. So I may get an accuracy 3, which may be more good at this point of time. Okay. Now let's say when I probably went to model 4, here now you'll be able to see that I'm providing 50 features. Now in these features, there may be a scenario that some of them may not be at all so much important, right? And some may have more importance, some may have very less importance, some may have no importance at all, right? So now when we will try to find out the accuracy, here you'll be able to find out the accuracy will keep on decreasing when compared to the previous accuracy. Now, what will happen is that in this scenario, you'll be seeing that this accuracy 3 will be greater than this accuracy 4. Okay, and I'll explain you why this specific thing will probably happen. So let's say this is my accuracy 4, and here you can see that the accuracy 4 has decreased when compared to accuracy 3. Then when I go to the next model where I'm specifically providing 100 features, here the accuracy will still decrease. And then when we go to the next model where I've specifically provided 500 features, and this may include all the features that I provided in the dataset, here you'll be able to see the accuracy 6 that you will be getting will still more decrease when compared to the previous accuracy. Now, you may be thinking, right, why this thing is basically happening. This is the reason why we say curse of dimensionality. Now, just imagine, guys, it's just like over here, in model M1, M2, and M3, when we were seeing that after training with, let's say in M3 model, we were training with 15 features, the accuracy was quite increasing over here. And we can consider that this all features were quite important for this particular model to perform well, But when we went to accuracy 4, when we went to probably this model 4, here we have increased the number of features. Now, this specific model did not require that many number of features to do the prediction. Over here, you can just say that the model is overfitted, right? The model is overfitted. So model should be given that many number of features through which the accuracy should keep on increasing. But here you can see that the accuracy is decreasing. Similarly, after this particular step, when we go to the next step, here also you could see that as soon as I provide 100 features, and obviously in these features there may be a situation that some of the features may not be at all useful, but still it is model is basically getting trained on that, and a lot of confusion actually happens within the model itself. Why? Because see, model is altogether inside, if you probably say, right, any machine learning algorithm, those are nothing but mathematical equations. Now with respect to mathematical equations, as you keep on feeding new and new features, it will try to learn those features also, even though it is not that important, right? So because of that, your model will get overfitted and it will definitely lead to a lot of confusion. And based on that, as the number of features gets increased, your model will start performing, like it will stop performing well, And from that point of time, your model performance will also degrade. Now here, your second point is that your model performance will also degrade. Why? Because as the number of features are increasing, just imagine the number of dimensions are increasing, your model performance will degrade because now the mathematical calculation will happen for that many number of dimensions. So because of that, the model performance will also degrade. Okay, let me give you a very simple example. Let's say you are a human being. Okay, let's say there's a person. I'll just consider there's a person over here. Let's say, and suppose I will just ask this person, okay, what is the cost of a house in this specific location? Okay, in location A. What is the cost of the house? Okay, then the person will probably understand some of the features. Okay, which location this is. Okay, and let's say he does not have any other location, any other feature. So this location may be my feature 1. Now here he may guess that, okay, your house may cost between 450K to 500K. Okay, now he say that no, I specifically want a 3 BHK apartment. Okay, now I have got a new feature. Okay, then he may say that, okay, fine, this was for an average. He just thought that, okay, this may be an average price for a 2 BHK apartment. Now when he says 3 BHK apartment, then he may say that, okay, now your price may be rising between 600 to 500 to 600K. Then he suddenly says that I need a house near a beach. Okay, now this particular parameter is added. Now you know that what will happen, the person will start thinking and this price will keep on increasing. Okay, then let's say after some point of time, the person demands increases. The other person wants to buy the house. He says that I want a house near to a celebrity. Okay, near to a celebrity house. So let's say now this particular feature is also added. Now here again the price will keep on increasing. Like this, it will keep on increasing. Now suddenly the person says, now I also want something like in beside my house there should be a lot of grocery shops. Now this particular feature may not be that important to basically increase the price or not, but still we are adding this particular feature for training our model, right? Now what will happen? this may create an impact, but it will create a very less impact. Okay, then suddenly you'll be saying that, okay, how many number of schools are there surrounding my house? Then suddenly one more feature will keep on getting added. Now, as soon as we keep on adding this many multiple things, this person who is about to say the price, right, he will also get confused at one point of time, right? Because we are just overfeeding him with multiple features. Okay, I want this, I want that, I want this. So now the person will still get confused and he will not be able to tell you the proper price. That basically means the performance of this particular person, who's a domain expert in telling you the price range of the houses, will decrease, and he may also not be able to tell you the accurate result. And this is the same thing that is happening when we train our model with many features. That is where your curse of dimensionality comes into picture. Now the question arises, how do we prevent it? There are two different ways how to remove this curse of dimensionality. So two different ways to remove curse of dimensionality. One is feature selection. Now, what does feature selection will be saying? That we will try to take the most important features and then we'll try to train our model. That is what happens in feature selection. The second technique, which we are going to discuss in the series, is something called as PCA. And I'll not just write PCA, I'll just say dimensionality reduction. And in this series, we are going to focus more on dimensionality reduction. And in dimensionality reduction, there are again many algorithms. We'll start with PCA, that is principal component analysis. Okay. So two ways to remove curse of dimensionality. One is through feature selection. In feature selection, what we do is that we try to take the important features and then we train our model. Whereas in the case of dimensionality reduction, what we do, and this process is basically called as feature extraction. Okay. Feature extraction. Now, feature extraction basically says that we'll try to derive a feature from a set of features, where we'll be capturing much essence of the previous feature. Let's say that I have features like F1, F2, F3, and this is my output. What we'll do is that we'll try to derive a feature like F1 and let's say we'll try to derive a new feature. This will be on D1 and D2 from out of these three features, and we'll use these features to basically find out our output. Okay. Then we'll try to see that how do we derive this particular feature and all everything. In short, we are extracting this new information. So that is the reason we say this as feature extraction. Super important topic. Okay. So I hope you got an idea about what is curse of dimensionality. In brief, if I tell you that as we keep on increasing the number of features, those features at one point of time when we're training those models, my model will get confused because I have so many features to learn, and because of that, the performance of the model will basically degrade. And I've also given you an example with respect to a specific person, right? If you keep on adding features and if you ask this domain expert what may be the price, then he or she may also get confused with respect to this, right? So how do we prevent or remove curse of dimensionality? There's two techniques. One is feature selection, and the other technique is something called as feature extraction. In feature extraction, we're going to learn about the first technique, which is called as dimensional reduction, and in that we're going to learn about this algorithm, which is called as PCA. Okay. In short, we will be extracting some features out of the previous feature. So this was my original feature, and out of this, we will be extracting some features like this. It may be in lesser dimensions, and obviously remember this will be in the lesser dimensions, and we'll try to capture the essence out of all these original features, the same essence of variance, I can also say, and then we'll try to derive this particular feature, which will be able to perform well when we are training a model. So yes, in the upcoming video, we're going to now deep dive into what is principal component analysis, and we're going to understand the geometric intuition. So thank you. I'll see you on the next video. In this section, we are going to discuss the differences between feature selection versus feature extraction. And this technique, as you all know, is used in dimensionality reduction, which will actually help us to reduce the number of features or to extract some important features from the older features that we already have. Now, before we go ahead and understand about this, we really need to understand why should we perform dimensionality reduction. So here I'm going to note down some important points, and this can also be an interview question. The foremost reason is to prevent the curse of dimensionality. Prevent curse of dimensionality. So that is the reason why we specifically use dimensionality reduction. Coming to the second point over here is that to improve the performance of the model. To improve the performance of the model. Now just imagine, guys, in your data set, if you have 100 features, that basically means 100 dimensions are there. Obviously, to train the model, right? Because in every model, when the training happens, some mathematical equation is already present over there, right? So those mathematical equation gets applied to all the 100 dimensions, right? So because of that, it may take more time for training of the model. So basically, to improve the performance of the model, we can also use dimensionality reduction. The last point that we are going to discuss is super important, to visualize the data. And at the end of the day, once we are able to visualize, we will also be able to understand the data. Now you may be thinking what exactly this is. Guys, we human being, we can, at the max, we can see in a 3-dimension way. We can visualize anything in 3 dimension, right? That is in 3D. We can also visualize in 2D, right? We cannot visualize 4D or any dimension that are higher than 3D, right? Suppose if in my data set I have 100 dimensions, obviously I cannot visualize this. So in order to understand this data, what I can do, I can reduce the number of dimensions to 3D or 2D, and I can also see this particular information clearly in front of my eyes so that we'll be able to understand the data, right? So if in any interview question, if someone asks you, why do you specifically use dimensionality reduction, you should definitely talk about these 3 points. One is curse of dimensionality, which I've already explained, improve the performance of the model, right? Visualize the data. If you really want to visualize the data in 2D, 3D or 1D mode, you can definitely use dimensionality reduction. And the major aim is basically to understand the data. Now let's go ahead and discuss about feature selection, okay? So this feature selection is a process wherein it will help us to select the most important feature, which will actually help us to predict the output, okay? Now, in order to understand the feature selection process, let's consider that I have a feature which is called as X and I have a feature that is called as Y. Now, let's say I have some data points over here, something like this. Now, with respect to this, if I say when my X value is increasing, my Y value is increasing, and if my X value is decreasing, my Y value is decreasing. So here I can definitely say there is some kind of relationship, right? In this particular scenario. That is, when the X is increasing, Y is increasing, and when the X is decreasing, Y is decreasing. Similarly, I can have one more relationship wherein when my X is decreasing, my Y is increasing, and when my X is increasing, my Y is decreasing, right? So this is also another relationship that I can have between X and Y. And in this particular case, let's consider X is my input feature and Y is my output feature, right? With respect to X, I need to predict what is Y. Now, whenever I have this kind of relationship, then here you'll be able to see if I plot with respect to X and Y axis, here you'll be able to see all the data points will be in a linear relationship, right? When it is in a linear relationship, then it will probably follow this particular approach where X is increasing, Y is increasing, and X is decreasing, Y is increasing. And that is true in this particular case. When X is increasing, Y is increasing, right? Now, similarly, in this particular case, if I probably want to draw a scatter plot, my scatter plot will look something like this with respect to X and Y, right? Now, if I probably try to see this, all the points will be in this inverse relationship. Now, whenever we have in this inverse linear relationship, then you'll be able to see that it will follow this specific approach. In this particular case, it will follow this specific approach. Now, obviously, you know that when you have this kind of linear relationship, then definitely X value will be very helpful in finding out the Y output. And mathematically, we can also find out a way to quantify this relationship. And the technique that we specifically use in this is something called as covariance. Okay. So here, if I really want to find out the formula between covariance of X, Y, the formula that is used is summation of I is equal to 1 to n, X minus X bar multiplied by Y minus Y bar divided by, here I'll write X of I, Y of I, divided by n minus 1, since we are doing it for sample data. That is the reason we use n minus 1. Now in this particular case, let's say if we are going to get a positive value. If it comes as a positive value, that basically means we are going to follow this specific relationship. If it comes as a negative value, then we are going to follow this specific relationship. So for this, whenever we get negative, we are going to follow this. Whenever we get positive, we are going to follow this. That basically means the relationship between X and Y will have this kind of relationship, that is the linear relationship, when my covariance is positive. When my covariance is negative, it will follow inverse linear relationship. And along with that, let's say if my covariance is approximately equal to 0, that basically means there is no relationship between X and Y. No relationship between X and Y. No relationship between X and Y. So if I try to plot this in this kind of scattered plot with respect to X and Y, I will be just getting a scattered plot which may be in circular way. And here you can not definitely find out the relationship between X and Y. That basically means when X is increasing, whether Y is increasing or not, or whether Y is increasing or Y is decreasing, whether X is increasing or not, right? So whichever have this kind of highly positive correlationship, covariance, a highly positive relationship, which we basically calculate through covariance, we can definitely say that those features are super important features, right? So in this particular case, I can definitely say that if I get a covariance as positive, I can definitely say X is a super important feature, and it will definitely be helpful in predicting Y. But if I get the covariance between X and Y is 0, I'll definitely say that there is no much relationship between X and Y, right? So I can definitely remove this specific feature also, right? Now, let's understand along with covariance, there is also a technique which is called as correlation. And we basically say it has Pearson correlation. And Pearson correlation can be given as a formula of covariance of X, Y multiplied by standard deviation of X multiplied by standard deviation of Y. Now, with the help of this, your correlation will be ranging between -1 to +1. In this case, there is no such range. It can be any positive value, it can be any negative value. But with the help of Pearson correlation coefficient, you will be getting a value between -1 to +1. The more the value towards +1, now understand, this is a super important point. The more towards the value of +1, the more positive correlation it is. The more positive correlated it is. X and Y is, okay? And the more the value towards -1, more negatively correlated it is, right? So same thing gets applied to -1, right? More negative correlated it is. And similarly, if my correlation between X and Y is near to 0, that basically means no relationship, okay? Now, this was an idea to talk about the relationship between X and Y. Now, how this particular process is basically used in feature selection. This is just one of the techniques, guys. There are other techniques also in feature selection, but I just really want to give you a brief idea before we go ahead and understand PCA, okay? Let's say I have a specific data set. And let's say this is my housing data set. In this data set, let's say I have features like house size. The other feature that I have is something called as fountain size. Let's say that these houses are present within an apartment, and we are also going to take this as a property to predict the price of the house. Now, in this case, these are my independent features. And this is my output or dependent feature. So that basically means I'm going to use this two independent feature to predict the output feature. And obviously when this value changes, this is also going to change. Now guys, if you just apply common sense, you know that fountain size may not be a very important feature, because obviously even though you have a bigger fountain, a smaller fountain, it does not mean that your house prices increase within an apartments, right? Within a number of apartments, right? And obviously most of the bigger apartments, group of apartments will definitely have some kind of fountain in it, right? Just to put some nice showcase, this fountain is basically used, right? Now, if I go ahead and take each and every feature, let's say one of the feature I have taken house size and I plotted along with the price house. And let's say if I found out this linear relationship, definitely this indicates that this house size is an important parameter to determine the price, because it has this linear relationship. And how do you calculate the linear relationship, or how do you quantify the relationship between house size and house price? You can definitely use something like covariance. And obviously you will either get a very high positive value, or for some other use cases you may also get some negative value, okay? Or you can also apply correlation. That basically means you'll be getting a value between -1 to +1. Now in this particular case, you definitely can say house size is an important property, and obviously important attribute, and just by common sense also you can come to the conclusion. Now, what about the feature? That is, if I try to plot this feature, that is fountain size and probably price of the house. Now in this particular case, let's say my plotting happens like this. And let's say that this is not at all that much important, right? Now here you can clearly see that there is no relationship between fountain size and price of the house. You can see that, or here you can definitely see that even though the fountain size is increasing, the price of the house is stagnant almost within the specific region, right? So definitely we can come to a conclusion that the relationship between fountain size and price of the house will be very, very less, or it will be approximately equal to 0. Or let's say it is ranging between 0 to 0.25, okay? Not that positively or negatively correlated, right? So in this particular case, what you can do is that you can consider that fountain size is not that important feature, and you can drop this feature. Now, these steps that we have performed, we are basically saying this as a feature selection process. And here you can also make sure that you can apply covariance and find out how a correlation and find out like what is the relationship between the fountain size and price of the house. So this is how you can come to a conclusion whether fountain size is important or not, and based on that you can basically drop it, right? And this is what we usually do in the feature selection process. We use correlation and covariance to do it. Okay. Now let's go ahead and discuss. I hope everybody got an idea about feature selection. Now what we are going to do is that we are going to discuss about an important topic, which is the next topic, which is called as feature extraction. Now what does exactly happen in feature extraction? In feature extraction, let's say I have features like x1, x2, and let's consider the same housing example. Now let's say I have something like house size, and let's say I have like number of rooms. And finally, I have something called as price of the house. Now, in this particular case, you want to reduce your number of features from 2 to 1. That is what we are doing, right? We are in dimensionality reduction. Let's say that I want to reduce my 2 features into 1 feature. That is what we do. Now, in this scenario, you know that, obviously, or let's say instead of house size, I'll just write room size. Okay, room size. Now, here I really want to perform some dimensionality reduction, wherein from 2 features, I want to convert this into 1 feature. So, obviously, I cannot use feature selection. Why? Because both these features are super important in predicting the output, that is your price. Both these features are super important, right? These are my independent feature. And if I also try to find out the correlation or covariance between my input and the dependent feature, here you'll always be able to find out either very high positively correlated or high negatively correlated. We'll be able to find it out. And it is a common sense question, guys. This is obviously going to have a linear relationship with respect to this specific feature. On the top, we basically had fountain size, and I just tried to show you an example like plotting it. It did not have a linear correlation. Now, in this particular case, I obviously cannot drop one of the feature and just consider one feature, because here we can definitely see that there is some relationship between the independent and the dependent feature. So in this case, what do we do? In this case, we perform something called as feature extraction. Now, in feature extraction, the core idea is that we take this two independent feature, we apply some transformation, to extract new feature. And let's say this new feature is something called as house size. I'm just giving as an example. And my output feature is something called as price. Now, instead of using this new feature, that is room size and number of rooms, if I also get to know the information of the house size, then also I will be able to predict the price. So in short, from these two features, I'm trying to derive a new feature or extract a new feature, which is called as house size. Now just imagine for a domain expertise, if domain expertise is given with these two fields, room size and number of rooms, he or she will definitely be able to predict or tell you the price. Now, instead of giving these two features, if we just give one feature to the domain expertise, then obviously he or she will also be able to predict the price with some difference, right? With some difference. Obviously, some amount of information is lost over here, but again, domain expertise will also get some clear idea about, like, with the help of house size also, he or she can definitely predict the price. So in feature extraction, what we are doing is that we are trying to extract a new feature from the feature that is already present. Okay? And this is how we basically reduce the number of features or dimensions. Okay? Usually here the example that I've taken only 2 independent features, but guys, in a real world scenario, you'll be having 10 to 15 features, and we'll try to reduce it to 2 to 3 features. Okay? Now once I reduce this, I'll obviously be able to visualize it in a proper way. I'll be able to see it, and I'll be also able to understand the data. Now this is the idea behind feature selection versus feature extraction. So in this video, I've covered so many things. First of all, why dimensionality reduction? Then why feature selection? What is feature selection? What is covariance? What is Pearson correlation? There's also another correlation which is called as Spearman rank correlation. Then we have taken an example with respect to dataset housing. Then I showed you that how we can go ahead with feature selection and how do we come up with feature extraction. Some transformation will happen. What kind of transformation will happen? What is the idea behind or geometric intuition behind PCA? We'll discuss that in the next video. Okay. So yes, in the next section we'll discuss about this. So guys, now let's go ahead and discuss about the geometric intuition behind the principal component analysis. Now, obviously, you know that principal component analysis is used for dimensionality reduction, right? Dimensionality reduction. That basically means we are going to extract some features with respect to the older features that are present in the data set. Let's say I have features like size of the house and number of rooms, and this is basically the price of the house, which is my output feature, right? This is my output feature. Now here, let's go ahead and probably plot a data points between the size of the house and the price of the house. So let's go ahead and plot some data points over here. And let's say this is my size of the house, and this is basically my number of rooms. Now, let's say that I have some data points which looks like this, right? Let's say I have some data points which looks clearly like this, okay? Now, in this particular case, you can see that from this, you're able to find out when the size of the house increases, the number of rooms are also basically increasing. And obviously, it is a common sense question. It really needs to increase. When the size of the house increases, you can assume that, yes, the number of rooms is also going to increase. Now, let's consider that with the help of PCA, okay? I want to reduce this 2 dimension of features into 1 dimension, okay? Into 1 dimension. Now, if I want to perform this, that basically means I just want to convert this 2 dimension into 1 dimension, okay? This is what I'm actually looking with the help of PCA. That basically instead of having two independent features, I just need to have one independent feature and try to basically create that independent feature, try to find out this one dimension or independent feature. Now in this particular scenario, let's say that one way, obviously I've already taught you, right? Feature selection. In feature selection, what you can do, you can take either one of the feature and you can ignore the other feature. And a simple way of converting a two dimension into one dimension is that what I will do over here is that I will make sure that I will plot all this point in my x-axis. Let's say I'm just going to project all this point in my x-axis. So here you'll be able to see here I'm getting the point, here I'm getting the point, here I'm getting the point, right? So once I do this, you'll be able to see that I will be able to project all the points over here. Now when I project all the points, obviously I'm able to get all my data points in one dimension. So this data points that you'll be seeing, we are able to get it in one dimension. So here what I've done, I have basically converted this into from 2D to 1D, right? And one more thing with respect to the specific data points, which is super important to understand in PCA is that if I probably see the first data point and the last data point, the area between this is basically my spread of the data points. Now, if my spread is huge, then what will happen? My variance will also increase. My variance will also increase. If my spread is increasing, my variance will also increase. Okay, so this is both are directly proportional to each other. Now, what is the disadvantage by using this approach where I'm directly projecting in my x-axis? So here, obviously, the size information is getting captured, but the number of rooms information is getting lost. So this information that you had related to number of rooms. Why this information is getting lost? Because understand over here. If I try to project from here to the first point also, right? Here also you have some amount of spread. Now, as I said, if the spread is increasing, the variance is also increasing. And over here, because of this variance, here also some information regarding number of rooms are there, right? And you're directly skipping this information. You are neglecting this information when you use this specific approach, right? Wherein you're directly projecting into one axis. So here, with this approach, what is the major thing that is happening? There's loss of information, right? And in this case, you're losing the information about the number of rooms. Obviously, you created from a two dimension, you created a one dimension, and this is all your one dimension points. But from this, when you convert it from this 2D to 1D, you are losing much information from the number of rooms, right? About one specific feature. Now, because of this, what will happen? Once you lose all this information, your model may not perform well with respect to the specific predictions of. So here, in short, you're doing feature extraction, but you're doing feature extraction with a lot of information that are lost, right? So in this feature extraction process, you're losing a lot amount of information, right? So I hope you have got this specific idea. Now, you also have to take care when you do this kind of feature extraction. This information need not be lost that much. So how do you prevent it? So in PCA, to give you a brief idea, let me draw this particular diagram again. Let's say if this is my size, and this is my number of rooms, and let's say these are my data points over here. Let's say these are my data points over here. Now in PCA, what you do is that you do some kind of transformation on this axis, on this x-axis and y-axis. What kind of transformation? You apply some mathematical equation. I'll again not talk about the mathematical equation right now, but I'll just name it. You apply something called as eigendecomposition. Eigendecomposition on some matrix. Okay, we'll discuss about this, what exactly this is. But in short, you're going to apply some transformation, and this is the specific transformation. And with the help of this specific transformation, you will be getting a new axis, which will look like this. Let's say this will be a new axis, which will look like this. Okay. And once you get the specific axis, what will happen is that then you will try to project this information over here. You will try to project all this information over here. Now, when you try to project this specific information, okay, now suppose since you have two features, you will try to apply some transformation which will change the size axis to some other axis like size dash, and one more axis will get created. Let's say the other axis will be exactly perpendicular to this axis, okay, and this will be your number of room dash, and then you will be projecting all these points over here. So when you project all these points over here, here are your data points. Now in this projection and in this projection, what are the differences? In previous projection and in this projection, what are the differences? Now see, in the x-axis, if I consider this as my new x-axis, here you'll be able to see that the spread is properly captured with respect to the specific points. And similarly, if I try to plot all this point on this new axis, here you'll be able to see your spread that is going to get lost once we project over here will be very, very less. So here, what you're doing is that you're applying some transformation and you're creating a new axis like the size dash and number of room dash. And once you create this new axis, all you do is that you now just project all this point to this particular axis. And after projecting this point, you can see that maximum variance is getting captured for all the points over here. So here, maximum variance is getting captured. And why this is better than this? Because in the y-axis, you're not losing much information. You're just losing this amount of information, right? This amount of variance you're basically losing, right? When you project it on the x-axis. Now with this transformation, you're able to convert your two dimension into one dimension, and you're making sure that much information is not lost. And how do you come up with this specific point? Because see, in the y-axis, because of this new dimension, here the variance is less, right? So even though you project this point over here, most of the variance is basically getting captured by your x-axis. So much information is not lost. If you compare the previous example here, once you project it into the x-axis, huge amount of information is getting lost because here the variance is quite high or spread is quite high. Here it is not that high, right? So I hope you have understood. Our main aim in PCA is that to find out this kind of lines, right? So after transformation, which is the new axis that is basically getting created. Now since I just had two dimensions, so after I do the transformation, I basically call this as principal component analysis 1. So PCA 1, principal component 1, and we basically say this as principal component 2. Suppose if you have three dimensions, that basically means you will be having three principal components. Always remember PC1 will be capturing the maximum amount of variance, and then PC2 will be capturing the next maximum amount of variance. Similarly, if you have three dimensions, then PC3 will be capturing the maximum amount of variation after maximum amount of variance after PC1 and PC2, right? So over here, in geometric intuition behind PCA, our main aim is to basically find out principal components, right? Like how we find out this. And at the end of the day, we really need to find out one line that should be able to capture maximum amount of variance. And once we take this PC1, and then we can convert this into from a two dimension, we will just be taking up this specific point and it will finally get converted into a one dimension point, right? So I hope you got an idea about what is the geometric intuition behind PCA, that is principal component analysis. We'll talk more about what is eigendecomposition on metrics and what is this specific transformation. With examples I'll try to show you, but just understand that your main aim is to find out the principal component, which has, after projecting all the points, it should have captured the maximum variance or spread, okay? And why variance is important? Because variance basically talks about the data, how the data is basically spread. And with the help of variance, you'll be able to capture more and more information. So guys, the final goal of a PC algorithm will be that to find out the principal components in such a way that maximum variance will be captured. So suppose if I have two dimension points, then I will basically be having PC1, then PC2, right? And we know that the variance with respect to PC1 after we project all the points in that particular component will be greater than the variance with respect to the principal component 2 once we project it. Suppose if we have specifically three dimensions, then here you'll be able to see that we will be getting three principal components. Okay, that basically means like we'll be having three different axes. One is PC1, PC2, PC3, and obviously the variance with respect to PC1 will be greater than the variance with respect to PC2 after we project the points, and the variance with greater than PC3. Okay, so this variance will be following this specific approach. So let's say that if I have a task wherein I have two dimension points, which is like this, and let's say I want to convert this 2D to 1D. So at the end of the day, what I will be doing is that the PC algorithm will be finding out the best principal component line. It can be this line, 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 and it will try to select the two best principal component lines. And how we say that this is the best principal component line, because once we project, let's say once we project the specific points on this line, right, we will be able to call this line as the best line only when the variance that is getting captured is maximum. Okay, so let's say this line has actually captured the maximum variance. So I will say this as PC1. Suppose if this line has captured the second maximum variance, then I will basically say it as PC2. So this specific line will be my PC2, right? And at the end of the day, if I'm converting this into 2D to 1D, then what will happen? I will basically be taking up all the specific points that I've actually plotted over here. Okay. So guys, the final goal will basically be to get the best principal component. And how do we say that it is the best principal component? Which captures maximum variance, right? Which captures maximum variance. Okay. Now let's say that if I want to convert a three-dimension point to one dimension. Now in the case of three-dimension points, we will be getting three components. One is PC1, PC2, and PC3, right? And obviously, it can be all these three lines, any of the best three lines. And you know that the variance of PC1 will be greater than variance of PC2, and this will be greater than variance of PC3. So since I really want to convert this into one dimension, what I'll do, I will project all the points in PC1, and I will be taking all these points as my one dimension point, right? One dimension point. Let's say if I want to convert this three dimension into two dimension, then what I'll do, I will probably take PC1, and I'll also make sure that I'll project all the points in PC2, and I'll take this two information and combine it together to basically get my two dimension, right? So this is what is the approach that we are going to follow. Again, let me repeat it. The major and final aim of the principal component analysis is to find the best line after the transformation, which will be able to capture maximum variance. And the line can be existing anywhere in the space, right? And with respect to that, based on the number of dimensions that you want to convert, you can take that many number of principal components. Okay. So yes, in the next video, we are going to see the mathematical intuition behind how this transformation basically happens, and that is where we are going to learn about eigendecomposition on a specific matrix. We'll talk about what are the steps and how do you project it. We will also see that how do you project the specific point on the specific line, and how do we make sure that the variance will be maximum. We'll be discussing about that. Okay. So yes, I will see you all in the next video. So guys, now let's go ahead and understand the maths intuition behind the PC algorithm. Now over here, let's consider that I have this two axes x and y, and I've just plotted this point. And let's consider that my aim is to convert or reduce from two dimensions to one dimension. And as you know, the final goal of the PC algorithm is to find out the best principal component line after the transformation from this axis in such a way that maximum variance will get captured. Now let's say for this example, I'm just going to consider this is that specific line, which is my principal component 1, because as soon as I plot all this point over here, you can see that maximum variance will get captured, right? So that is the reason why we are selecting this as the best principal component line. Okay. Now what PCA is actually going to do in order to come to this conclusion, like whether this is the best or not, there are two important things. One is projections, and the second thing is the cost function that is related to the variance. Okay, so let's go ahead and discuss about both of them. Okay, so out of all these points, let's do one thing. Let's take up one point, and for now, I can just consider this is my point P1. Okay, which is denoted by x and x1, y1. Okay, this is obviously denoted by x1, y1 because why? This is my x-axis, this is my y-axis. So let's say this is denoted by x1, y1. Okay, so I can consider also this P as a vector. Okay, so let's say that this is a specific vector, and this P1 is a vector, and let's consider that we also have a unit vector which is specifically given as u. Okay, so this is my unit vector. Now the first point, let's go to the first point. The first point is all about projection. So let's say that if we really want to project this P1 into this particular point, okay, into this particular vector, then we will get something called as P1 dash. Now, we really need to find out what is this new projection, because see, over here, our main aim is to capture the maximum variance. The maximum variance will only get captured when all the other points that you'll be seeing in this, right? Once we do the projection over here, once we do the specific projection over here, then only we'll be able to take all this point and calculate the maximum variance, or we will be able to calculate the variance, right? So that is the reason why we really need to project this particular point over here. So once we project, let's say if you're trying to project P1 to P1 to this particular unit vector that is u, P1 dash, then this projection is given by an equation. Let's say if I'm saying projection of P1 on u, right? If we write the specific equation, the equation will be given something like by, we can write it as P1, that is magnitude of P1, P1 vector multiplied by u vector divided by magnitude of u. Okay, so this is the equation that is basically used with respect to the projection of a specific vector on a unit vector. Okay, and since this magnitude of u is equal to 1, since this is a unit vector, and whenever we have a unit vector, the magnitude of that particular vector will be 1, we can write the projection of P1 on u is equal to nothing but dot product of P1 multiplied by u. So this is the entire thing that we basically get. So as soon as I do a dot product of P1, which is given by this coordinate x1 and y1, and let's say this unit vector is given by the coordinate x2, y2, when we do the dot product with respect to P1 and u, I'm actually going to get P1 dash. Okay, so this is nothing but this is P1 dash. Now this is with respect to the projection, which everybody needs to understand. Okay, now let's go towards understanding like this. When we do all the projection, let's say once we project P1, we will be getting P1 dash. Let's say there will be another point. Let's say this is P2. Then we'll be getting P2 dash. Then we'll get P3 dash. Then we'll get P4 dash, right? All the points, we will finally project it. Let's say P0 dash. Like this, we have all the points and we get finally Pn dash. Now, once we have all these points, and remember, whatever value we get from this particular dot product, it is a scalar value, right? And when we can take up all the scalar values, so this all values that we're going to get after projecting it, this all will be a scalar value itself, right? Scalar value itself. Now, once we have all these values are basically talking about the distance. Let's say, what is P1 dash basically talking about? It is just talking about the distance from here to this particular axis, right? So let's say if I'm probably calculating distance from origin to this, right? It is basically talking about this specific distance, right? P1 dash. Similarly, P2 dash, suppose if this is P2 dash, I'm basically talking about this distance, right? From here to P2 dash. Now, once I have the scalar values, then it becomes easy for me to compute the variance, right? Let's say these are all my points. So I'm just going to select all these things, okay? And these are my points, P0 dash, P1 dash, P2 dash, P3 dash. So let's say I'm talking about the specific points. Let me give us some different notation so that it becomes easy for you to understand. So let's say this is x0 dash, x1 dash, x2 dash, x3 dash, x4 dash. Like this, I have xn dash, okay? Now, in order to compute the variance, I can simply use an equation that is summation of I is equal to 1 to n. And here I will specifically be using, how do you calculate variance? You will be able to take x of I minus x of I, this will be x bar, which will be the mean of x whole square divided by n. So if you use this equation, you'll be able to calculate the variance. And understand here, your main aim will be to find out the unit vector, the best unit vector which has the maximum variance. Your goal is basically to find the best unit vector. And how do we say best? Because it captures maximum variance. So this is the example with respect to this, what we have actually discussed. Here, at the end of the day, we are trying to find out the vector which captures the maximum variance, right? So this basically becomes our cost function. So here, I'm just going to write max of variance. We have to find the max of variance. So in short, we have to find the best unit vector which captures the maximum variance, right? So this is, in short, an understanding where you are taking care of two things. One is projection and one is the cost function, wherein you are focusing more on getting the maximum variance, right? Now, we will try to understand. Now see, obviously we cannot keep on go ahead and selecting different units vectors and probably trying to find out the best vector in that way. So what happens is that there's a technique which is called as eigen decomposition, which we specifically say as eigenvectors and eigenvalues. Suppose, okay, this eigenvectors and eigenvalues, because our main aim is, as said, right, we really need to find out the unit vector, right? Whether the unit vector should be this, or this, or this, or this, right? So how do I find out which unit vector we should basically select to capture the maximum variance? So for that, we will be using something called as eigenvectors and eigenvalues. And there are some steps, right? That are steps which are involved in this. First of all, the first step will be that I really need to find out the covariance matrix between features. And in order to find out eigenvectors and eigenvalues, what I need to do is that this eigenvectors and eigenvalues will be computed or will be found out from this covariance matrix. How? That we'll discuss about it, don't worry. And whichever eigenvector will be the largest one. When we say the eigenvector which is largest one, that basically means for the eigenvector where the eigenvalue is high. This eigenvalue basically talks about the magnitude of the eigenvector, okay? So this eigenvalue is nothing but, this is basically the magnitude of the eigenvector. This will basically capture the maximum variance. And this is mathematically proved, guys. I will not be proving you this thing, but here, according to linear algebra and with some of the mathematical equation, we can definitely prove this. So in order to, why do we compute eigenvectors and eigenvalues? Because see, at the end of the day, I really need to find out the best unit vector so that maximum variance is captured. And we cannot keep on doing hit and try, right? So what we do is that in order to find out, we really need to go ahead and find out eigenvalues and eigenvectors. Eigenvectors and eigenvalues. And the step is that first of all, we will go ahead and find out the covariance matrix between the features, okay? Between the features, we'll go ahead and find out the covariance matrix, and then we'll try to find out the eigenvectors and eigenvalues. The eigenvectors and eigenvalues can be found out by the simple equation that is A vector V is equal to lambda vector V. We'll try to understand this specific equation, what exactly this equation is. This is nothing but linear transformation of matrix. So we'll try to understand what exactly is this linear transformation of matrix. And then once we do this, you'll be able to get some eigenvalues. Whichever eigenvector has the highest eigenvalue, which is nothing but magnitude of the eigenvector, that specific vector will get selected. If suppose this is the vector that has the highest magnitude, then this will get selected because mathematically it is proven that whenever we project on this specific line, maximum variance will get captured. Okay, so this is what we're going to do in the next step. We'll understand about eigenvalues, eigen decomposition from a specific matrix. Okay, so I hope you have understood till here. Now let's go ahead in the part 2 of the maths in-depth intuition behind PC. In this video, we are going to discuss about eigenvectors and eigenvalues. Now, already in the previous video, I've spoken about it, what eigenvectors and eigenvalues can actually do. See, at the end of the day, we have to find the best principal component line, which will be able to capture maximum variance. And in order to find this, we will be using this eigenvectors and eigenvalues. Because in short, whichever eigenvector, like if suppose, let's consider that we have some data points. Let's say I have some data points over here. And this data points, let's say I want to find out the best principal component line in such a way that once we make sure we project this in this particular line, we should be able to capture the maximum variance. Now, what is so amazing about this eigenvectors and eigenvalues, and we'll also be talking about linear transformation, okay? And we also say it as eigen decomposition of covariance matrix. That basically means for this particular matrix, we will try to find out the eigenvectors and eigenvalues, okay? Now the most important thing about these vectors is that, suppose let's say I have a specific matrix, okay? I can have any specific matrix. On this matrix, or if I have a vector, let's say the vector is V, okay? And this vector will have a different coordinates, let's say. If this vector, on this particular vector, let's say if I apply some linear transformation, okay? What does this linear transformation basically mean? I'll give you an example. That basically means on this particular vector, let's say if I apply linear transformation with this specific matrix, then I will be getting one lambda value, and this lambda is nothing but my eigenvalue multiplied by the same vector. So here you can see that this basically means that, suppose I have a vector with this particular dot. On top of this, if I apply linear transformation, what does linear transformation basically mean? Let's say I have my coordinate system, and right now it is in this grid manner. Okay, let's say this is entirely all my data is in this grid manner, right? When I say linear transformation, this entire data can be moved, or this entire plane can be moved in different direction. Okay, I'll just show you one example directly. So always understand, in order to compute the eigenvalues and vectors, so what we do is that, let's say if A is my matrix, okay, on top of it, if I apply this matrix on the top of this specific vector, like if I apply the linear transformation on top of this specific vector, then I will be getting lambda, which is my eigenvalue, along with that same vector. So this is the equation that I will specifically be using in order to find out eigenvalues and eigenvectors. Okay, and from this equation, whichever eigenvector has the biggest magnitude or has the maximum magnitude, because for a space, for a matrix, I can definitely have multiple vectors. Okay, so from this, whichever has the maximum magnitude, that will be used as a plane or principal component, because it is practically proved through maths. Again, I'm not going to go towards that particular proof, but this principal component will be able to capture maximum variance. Okay, so let me go ahead and show you one example. Okay, so here I will just show you one example. So this is a linear transformation. Let's say I have one vector over here. Okay, I have one vector. So this vector is nothing but 1, 1, right? So here I hope everybody is able to see this. Okay, 1, 1. So this is my vector. Now on this particular vector, if I apply a linear transformation with this matrix, okay, with this matrix, now what will happen? You see, because once we do the linear transformation, this particular line will now get changed and it will display something like this. See, after I apply this transformation, my new points that I'm going to get is something like 4, 4, 2, right? Now 4, 2 is nothing but, here you can see the lambda value will be 4, 2, because 1, 1, 0, 1, 0, 1.0, 1.0 is my vector, right? So here also you'll be able to see I can multiply lambda multiplied by this particular number. So here you can see 4, 2. That basically means for a vector, if I apply a linear transformation with this particular matrix, I'm going to get a lambda value with 4 and 2 as its lambda, as its eigenvalue. Now, let me just show you the eigenvectors also. Let's say here I've checked on eigenvectors, and let me also show the snap grid. Okay, so here you'll be able to see what is basically happening. This line that you see, right? This is basically my vector. Okay, now here you can see for this particular point, when I apply this transformation, the vector is in another direction and this is in another direction, right? Now let's say my initial point was somewhere here. And if I probably apply the same operation, now it is -1, 0, right? Then what will happen is that you can see the new transformation, right? I'm actually getting -2, 2, and here you can see this is in the direction of the vector. So what I can do is that I can project this particular point into this plane, right? So here this will be my longest vector with this longest magnitude. Okay, just for an example I'm considering. Like that, if I keep on doing another points, right? If I keep on doing, let's say I'm putting it over here, right? And if I go back, here you'll be able to see this was my initial vector. Now after applying linear transformation, it has gone outside the plane. Similarly, again, and this time vector did not match. Suppose if I have this point over here, and if I try to apply it, here you can see again this will get transformed to different values. So your lambda value will keep on getting changed based on the different vectors. Okay, so from this, we can definitely see that what is happening is that from this specific equation, we will be able to get the eigenvectors, and this eigenvector which has the maximum magnitude. When I say maximum magnitude, that basically means the max eigenvalues. That will be selected as the best principal component line. Okay, in this particular case, it is PC1 because it captures maximum variance. Okay, so at the end of the day, you'll be able to see with the help of these eigenvectors and eigenvalues, you'll be able to see this. Okay, and the same thing is happening. Now let's go ahead and understand the steps to calculate eigenvalues. Steps to calculate eigenvalues and eigenvectors. Value and eigenvector. Because as I said that you require a matrix, right? In this specific case, we have to calculate the covariance of the features, right? Now let's say if your features were x, y, your independent feature, and this is your z as your output feature. So for this, I want to extract another feature which can be x dash. So what I'll do is that I will try to find out the covariance of x, y. So let me write down the equation of covariance of x, y. So here you can see that I will be able to write summation of I is equal to 1 to n x of I minus x bar multiplied by y of I minus y bar divided by n minus 1. Okay. Now here you can definitely see that if I really want to find out the covariance of x, y, usually we get 2 cross 2 matrix. Okay. Now this specific matrix looks something like this. Okay. Let's say I'm just going to divide like this. So this will be a 2 cross 2 matrix. This will be x, this will be y, this will be x, this will be y. So if I try to find out the covariance of x, x, then what it will become? So if I try to find out the covariance of x, x, here you'll be able to see I can also write this as variance of x. Why? Because x, x basically means x of I minus x bar, right? So x of I minus x bar, it will be nothing but x of I minus x bar whole square, which is nothing but variance of x, right? So here you'll be able to see that I will write variance of x. Here this will be covariance of x, y. Here it will be covariance of y, x, and here it will be variance of y. Okay, because covariance of y, y is nothing but variance of y, right? Now this is the first step. We have to compute this specific matrix, and this is for a 2 cross 2 matrix. If suppose if I have 3 independent feature x, y, z, then I have to probably create 3 into a 3 cross 3 matrix, right? I have to basically create like this 3 cross 3 matrix. Now here you'll be able to see that I will be creating this kind of lines, and here will be one, here will be another, right? Now again here all in the diagonal element it will be the variance of x, variance of y, variance of z, and remaining all you'll be able to see this. And one more thing, that variance of covariance of x, y is equal to covariance of y, x. This both will be equal, right? Now what we are going to do in order to find out the eigenvalues, we will take up this covariance matrix. This let's consider it as A, and we will try to take a vector v. And this A will be taken, which will be my covariance matrix, and I will try to apply transformation of the vector, and finally we will be getting lambda over here, and this vector will be given back. Now since I have two features over here, f1 and f2, let's say, then I will be getting two lambda 1 values, right? Lambda 1 and lambda 2. Lambda 1 will basically be giving my principal component line 1 magnitude, and whereas my lambda 2 will be giving me the principal component 2 magnitude, right? So this will be PC1, right? So like this, when you have three features, you are going to get lambda 1, lambda 2, lambda 3, which will specifically talk about the eigenvalues. So just by using this equation, at the end of the day, you will be getting an eigenvector, and that eigenvector will be giving you 2 or 3 based on the number of features that you have, that many lambda values. Let's say if it is giving lambda 1 and lambda 2, that basically means you have 2 eigenvalues, and whichever eigenvalue is the highest over here, that will be, and it will already give that in that specific value, like the lambda 1 will be the highest and lambda 2 will be the highest. So this way you'll be able to get this lambda 1 and lambda 2, which are specifically the eigenvalues, and then this can be considered as PC1 and this can be considered as PC2. So guys, just to revise all the steps now, what we are going to do is that let's consider the first step over here. So I'm going to write it down. The first step that again we are going to do, let's say that I have my data points over here. So let's say this is my x and y, and let's say I want to probably first of all convert this into 2D from 2D to 1D. Then the first step that I'm actually going to do is basically standardize this data. Now once I standardize this data, what will happen is that all these data points that you will be seeing, it will be zero centered, you know. So here you'll be able to see all the data points like this. Okay, let's say these are my data points that are got zero centered. After this, the second step is that we go ahead and find out the covariance matrix of this x and y. Okay, let's say this is my x and y. So we basically find out the covariance matrix, and again, in the case of two independent features, I'll be getting a 2 cross 2 matrix, right? So this will basically be my 2 cross 2 matrix with respect to x and y, x and y. Here I'm going to get the variance of x, and here I'm basically going to get covariance of x comma y, and here I'll be getting covariance of y comma x, and finally I'll be getting variance of y, right? Now after I get this covariance matrix, all I have to do is that find out eigen vectors and values. And how do I find it out? By just applying, let's say this is my matrix A. So this A, when we apply a transformation on vector V, I'm going to get this eigenvalue of V, right? Now, since this is a 2 cross 2 matrix, here I'm going to get lambda 1 and lambda 2, okay? So these two values are my eigenvalues, okay? And this lambda 1 will basically be indicating me by PC1, that is principal component 1 line, and this will be my PC2 line. So in short, after this particular points, what we are going to do is that, let's say that we will be creating two different lines. One line may be this, one line may be this. Or let me just draw it in different color. So let's say this may be my PC1. Okay, so this may be my PC1 and this may be my PC2. Okay, but as we know that the first lambda 1 value which I'm getting, which is nothing but the magnitude of the eigenvector, here it will capture the maximum variance. So this variance that is getting captured will be maximum. So we go ahead and select this. Now, let's say if I want to convert from a 3 dimension to 1 dimension, then what will happen? I will get 3 lambda values, that is 3 eigenvalues. Now what I can do, I can combine this to lambda 1 and lambda 2 and probably take, okay, since I've already explained you, this lambda 1 is nothing but PC1, this is PC2, and this is PC3, right? So I can combine PC1 and PC2 and convert this 2 dimension into 1D, and then this can also be taken as another 1D. So when I combine this two, right, it becomes a 2D, right? So if I probably want to convert from 3D to 2D, I'll be going in this way. So let's say if I want to convert from 3D to 1D, so once I find out my eigenvalue and vectors, I'll be getting lambda 1, lambda 2, lambda 3. I have to combine all these 3 and probably get 1 dimension in this case. Similarly, in the case of 2D to 1D, so let's say if I want to convert from 2D to 1D, here I'll be getting lambda 1 and lambda 2. This is nothing but my PC1, this is nothing but my PC2. So we can combine this two both and we can get a 1 dimension point, right? When I say combining, that basically means I'm talking about projection. Once I project all the point, I will be able to get that specific dimension. So I hope you have got an idea, but these are the steps that we basically follow in order to find out the projection. But at the end of the day, you know, you're trying to find out with respect to any data points, you're trying to find out the best principal component line that can fit on this data such that it captures maximum variance. Now, like in this case, this can be, or in this case, this can be, right? So this can be my PC1, this can be my PC2. Why I'm saying this? Because maximum variance is captured. See, maximum variance is getting captured, right? So this was the idea behind principal component analysis. I hope you have understood the maths behind it. If not, I would suggest please revise it. I've written around 9 pages just to make you explain about principal component analysis. So yes, I will see you all in the next video. Hello, so guys, in this video, we're going to implement the principal component analysis implementation, where we'll focus on doing dimensionality reduction, or we can also say feature extraction. We'll try to see that how we can implement this with the help of sklearn and Python. So to begin with, what I'm actually going to do quickly is that import some of the libraries, like import matplotlib.pyplot as PLT, okay, import Seaborn as SNS, import NumPy as NP, and I can also import pandas as PD. Along with this, I'm just going to say matplotlib inline, right? So all these things we are basically going to import it. Now what we're actually going to do is that we're going to first of all load our dataset. So load the dataset, and the dataset that we're going to play is with a breast cancer dataset. So over here you'll be seeing from sklearn.datasets, if I write, we'll be able to import load breast cancer. So here it is. And what we're going to do is that with the help of this specific dataset, I'm just going to write something like cancer underscore dataset is equal to load breast cancer. Okay, and here we go and import it. Now finally, if you probably go and see my cancer dataset.keys, you'll be able to see various keys like data, target, frame, target names, and all. So over here, and if I probably just go ahead and probably print cancer underscore dataset.decr, if I probably print this, you'll be able to see this entire information how your dataset looks like. Okay, so here is how your dataset looks like. You can see this. You have features like radius, texture, perimeter, area, smoothness, compactness, concativity, concave, point, symmetry, fractal dimension, and your class is basically malignant and benign. This is the output feature, and with respect to this, you have so many number of records that are having malignant as output and 357 records that has benign as output. Now in the next step, what we're going to do quickly is that I'm just going to create a simple data frame. So here I'm just going to write df is equal to pt.dataframe, and here first of all I'm just going to use my cancer dataset, and here I'm just going to take all my data because that data key has the entire data over here, and you can definitely check out over here itself, right? With respect to all the attributes, you'll be able to see something like data key over here. So this data key that you're able to see, right, it'll basically be having that. So here cancer underscore data of data, you'll be able to get that, and the columns that I'm basically going to take is nothing but my feature names. Okay, so here is my df.head, right? So these are all my features that are there with respect to all this. Now what I'm going to do is that I'm not going to just solve some classification or regression problem statement. Principal component is more about dimensionality reduction. Now let's say if I have probably 10 to 11 features, and obviously I cannot visualize this. I have to basically convert this into 2D or 3D, 2 dimension or 3 dimension, and then probably will be able to visualize it. But here our focus is not to remove the features, but we are going to extract some features, making sure that some of the variance is basically getting captured. And again, whatever theoretical concept we have learned in principal component analysis, we will just try to take all these features and try to extract only 2 features that captures the maximum amount of information out of it. Okay, now to do this, what I'm going to do first of all, I'm just going to apply standardization. This is a good step to do in feature scaling also. Sorry, in PCA we have to definitely do feature scaling, and for that we're going to use standard scaler. So I'm going to write from sklearn.preprocessing import standard scaler, and here I'm basically going to write scaler is equal to standard scaler, right? And once I execute this, all I have to do is just write scalar.fit on my entire df, right? So once I do this, once I execute this, that basically means my entire fit has actually happened on the scalar data frame. And then I can transform this entire data frame based on the standard scaling. And I'll try to save it in a variable which is called as scaled data. Okay. So here, in order to perform the transformation, I just write scalar.transform. Okay, and here you'll be able to see df, and finally you'll be able to see my scaled data in the form of standardization. It is basically in the standardization that basically means the mean is 0 and the standard deviation is 1. So most of the data will be ranging between -3 to +3, right? So that is how this entire standardization process have actually taken place. Now what we are going to do is that out of all these particular features, we're just going to extract two features. So in order to do that, what we can do is that we can apply PCA. So here I'm just going to write applying PCA algorithm. Okay, and for applying the PCA algorithm here, I'm just going to use from scalar dot decomposition. I'm going to just import PCA and I'm just going to execute it. And here we'll be writing PCA is equal to principal component analysis. And here by default, if you probably go and see, I have to give this value which is called as n underscore components. Right now, let's say if I have this many number of features, I want to convert this into two features. I'm going to extract two features out of it, which captures maximum variance. So all I have to do is that just go ahead and write this n underscore component as 2. Okay. So once I probably do this and probably execute it, then all I have to do is that just write PCA dot fit underscore transform on my data. That data specifically is the entire scale data. I'm just going to give my scale data over here. Okay, and probably once I transform this particular data, and if I write this is my data underscore PCA. Now yes, you can see that once I execute this code, what will happen is that my data underscore PCA will just have two columns now, one column and two columns. Why we have basically converted this into two columns so that we will be able to visualize it. That basically means out of all these columns that we specifically had, right? Now what has happened is that after applying PCA, is transform the entire data into two columns, right? So two feature columns we are able to get it, and it's converted in such a way that maximum variance is basically getting captured. And again, for that you have eigen decomposition concepts, which we have well discussed in the theory part. Okay, so now here you'll be able to see that we are able to capture these two features, or we are able to extract two features out of that entire two. And this process is basically called a dimensionality reduction. Okay, now if I probably go ahead and write PCA dot, let's see, there's one more important function I just need to show you to you. Let me just have a look. Explained variance, right? So once I execute this, here you'll be able to see this is the explained variance of feature 1 and feature 2, and probably if I don't exactly use n underscore component is equal to 2, then here why 2 explained variance, it is saying that because from this two feature this one variance is being able to get captured, right? And now here if you probably if I probably take this up and apply the PCA without giving n underscore components, right? So let's say if I probably just give over here and I don't give my x underscore components, right? Oops, let me just write. Okay, and probably then if I write PCA dot fit underscore transform on my data, and that data, let's say, is scale data, then what I'm actually going to do is just going to create that many number of components, how many number of features were there, right? Now, if I probably go and search for PCA dot explained variance, so here you'll be able to see with respect to every feature how much variance is basically getting captured, right? And probably if I try to add this up, we will be getting some value that is near to 100. Okay. So here you can clearly see this many number of features so that many number of explained variants are there. Now you know that what we have done is that we have basically applied n underscore component is equal to 2. And once I do this, I'm getting two features as my extracted, and if I probably see my explained variance, this is how much it is getting captured. Okay, so I'm just going to remove this since we need to just focus on two variables or two features, right? Now we will try to see that with the help of these two features, will we be able to do something? Right? Will we be able to do something? So the best way is that we'll try to see it in the most visualized format. So here I'm copying a code where it is written as plot.figure, and here you can see data underscore PCA. I'm just going to use data underscore PCA over here, data underscore PCA. So this is for my first feature, and this is for my first feature. Zeroth feature over here, and this is my first feature. I'm just trying to plot it in the scatter diagram, and over here, what I have actually done is that we are going to also take the target column. Now this target column here you'll be able to see that where our target column basically exists in this, right? So cancer underscore data of target, if I probably write, we'll be able to get all the target values over there. And then the type of mapping we're going to use is something called as plasma. My next level will basically talk about first principal component and second principal component. Always understand the first principal component will have maximum variance captured when compared to the second one. Then as we go with respect to the third one, again the variance will get reduced. Okay. So once I probably execute it, here you can see that how clearly my data points is visible. And even for this particular problem statement, I can probably solve it with the help of any classification problem statement. But here you can definitely see that out of all the 11 to 12 features, we have easily converted this into two features. And now it was able to capture maximum amount of information. So that is the reason my data points is clearly separable. And this was all about principal component analysis and how can you implement it. Probably if you wanted 3 components, you just need to write 3 components over here, right? And let me just show you. That will also give you an idea. Like, see, when I wrote n underscore components equal to 3, I got 3 features. Now if I probably go and write explain underscore variance, I'll be getting 3 values. This is PCA1, this is PCA2, and this is PCA3. PC1, PC2, PC3, right? And here you can see that this variance is getting decreased, right? So PC1 will be having the maximum number of variance that will be able to capture out of this, right? But now here, just for the displaying purpose, you can also do it for the 3 dimension. I'll just keep it like this, and this is how it basically looks like. Okay, so you can definitely try out your own examples. You can take up a data set and try to convert it into 2 features, 1 feature, 3 features, as many you actually like, right? So this was a perfect example with respect to principal component analysis. 2 things we have learned over here is that how we can perform dimensionality reduction, and along with that, how we're also able to understand how much variance it is able to capture, right? So yes, this was it from my side. I hope you like this particular video. I'll see you in the next video. Have a great day. Thank you, and all. So guys, we're going to start our first unsupervised machine learning algorithm that is called as k-means clustering algorithm. And in this video, we're going to understand the geometric intuition behind k-means clustering algorithm. Now, first of all, let's consider that I have some data points over here, and obviously I can show you in 2 dimensions. So over here, let's say that I have all my data points, which is basically spread like this. Let's say between x and y axis. And suppose if I have this kind of data points, obviously directly from seeing this particular data points, you can see that okay, there are 2 groups of data points together. Our final aim is that whenever we have this kind of data points, this entire data points after applying k-means clustering will become something like this. So let's say if these are my data points, I'm just trying to draw the same one. So don't worry if 1 or 2 points have got missed, right? So after applying k-means, we are going to get something output which looks like this. This will be one group, and this will be the other group. Okay, and remember, this will be my one cluster. Let's say this will be my cluster 1, and this will be my cluster 2. Along with these clusters, you will also be getting one important thing which is called as centroids. Now, since here I have got 2 clusters out of it, so I'm going to get 2 centroids of these clusters. Okay, this will be one centroid, and this will be the other centroid. Similarly, if let's say I have data points which may probably having 3 different groups. Suppose let's say this is my one group, this is my another group, and this may be my another group, right? So after I probably apply k-means again, I'm going to get an output which will look something like this. Okay, So this is the entire geometric intuition behind K-means clustering, and we'll try to understand how this entire step will basically happen. Okay, so let's say these are all my points. So here also I'm going to get one centroid over here, sorry, one group over here, second group over here, third group over here with different centroids. Okay, so in short, what we are able to do is that we are able to cluster similar kind of points together. Okay, that is the main aim behind K-means clustering. So now, once you have understood geometric intuition, let's go ahead and let's see that how this entire group is basically getting created. Okay, so again, I'm just going to draw the same points over here. Let's consider with groups like this. Okay, let's say I have some of the data points over here and some of the data points over here. And we will go step by step in creating these groups. Okay, so the first step is that we initialize some centroids. Okay, initialize some centroids, that is some K value. That is the reason we say K means. Okay, and whenever I say about centroids, I'm basically talking about K value. Okay, this is nothing but this is called as centroids. Now in this particular case, let's consider that, okay, I know there are two groups, so I'm going to initialize two different centroids. Okay, so in this particular case, I can definitely draw one centroid over here, and this is randomly initialized, and the other centroid somewhere over here. Okay, over here, or let me draw it over here itself so that it'll be easy, right? So this is the first step. We initialize some centroids. Now you may be saying, Krish, why K is equal to 2 you have taken? Okay, we'll try to understand how to select the K value later on, but let's understand that, okay, I'm just going to know that, I definitely know that for this particular thing, you definitely require two centroids, but later on I'll show you how you can select the K values. Okay, now the second step, that is, and it is a super important step, is that we will try to find out the distance from this particular centroid to all the points. Let's say for this particular point, if I say this is, we'll just try to find out for which centroid this point is near, whether this centroid it is near or this centroid it is near. Here you can definitely see that obviously the distance between the centroid and this point will be near when compared to this. So if this particular centroid is near to this, we are going to just mark it as orange color. Okay, similarly you'll be able to see this point will be near to this point will be near to this. In a simpler way, if I really want to find out how do I do it, I'll just try to create a straight line. Let's say this is my straight line, and I'll try to create another perpendicular line which will be passing through this line. Okay, so in this particular case, let's say this is not exactly perpendicular line, but yes, now in this particular scenario you can see this is a perpendicular line to this particular line. And obviously to find out the distance, we will be using something called as Euclidean distance or Manhattan distance. Okay, we will also understand about how does Euclidean distance actually work and Manhattan distance actually work. Okay, so we will be using either one of this, and we'll also try to understand that when should we use Euclidean distance or when should we use Manhattan distance. Okay, all those points will be covered. Now here you can see that all the points that are below this line will basically be nearer to this particular yellow centroid. Okay, so most of the points that you'll be seeing over here, this will become yellow, 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 and similarly this will become yellow. Okay, and with respect to all the other points here, what will happen is that here this will become orange, this will become orange, this will become orange, 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 orange. That basically means these points are nearer to the centroid. Okay, and this will become yellow. Okay, now in the second step I've already seen we need to find out the points that are nearest to the centroids, and we will mark them in that particular group. Okay, so right here you can see over here the centroids color is basically given over here just to indicate in this way. Now coming to the third point, which is a super important point. Now after the marking is done, what we are going to find out is that we're just going to move the centroids. Now how do we move the centroids? This is super important. Now you know that you have got your group of points that are nearer to this centroid and nearer to this centroid. We're just going to find out the average of all these points. Like average of all these points. That basically means we are going to consider all this point and find out the average, right? So I will just remove this. Okay, so let's say these are my centroids that are near to this points. So I'm just going to find out the average, and whatever average will come, this centroid will get updated. So if I go to my next diagram, then what may happen is that, so these are my points over here. These are my points over here. Okay, I'm again going to use this. Okay, these are my points over here, and here you can see some of the points that are probably yellow in color. So these are some of the points that I'm just marking so that you'll be able to understand. Now when my centroid is getting updated, then what will happen? It will probably move from this point to this point, from the older point to this point. We're just going to try to find out the average. So here average will be computed. The average point will basically be the new centroid location. Similarly, with respect to this all points, you'll be able to see some of the points are here and some of the points are here. And initially my previous centroid was here. Now let's say it was here. Now it is going to move to a new location. Let's say the location is somewhere, since most of the points are away, it's going to move it over here. Okay, so I'm just going to rub it and I'm just going to use the new position. So here it is my new position of my centroid. Okay, perfect. So this was my third step, move the centroids by finding out the average. Again, we will be repeating this all steps. Okay, that is my second step. Okay, then again we really need to find out which are the points nearer to the centroid again. So here you'll be able to see again, if I probably try to create two lines that are perpendicular to each other. Okay, one point over here and one point over here. So let's say this is exactly center, perpendicular to each other. Now what is going to happen in this particular case here, you can clearly see that some of the points have again got mismatched, right? Now this yellow point, this yellow point will become an orange point because this is nearer to this particular centroid. What about this point? This will basically become my yellow points, right? Then again what will happen? Again the same step will happen. We'll try to move the centroids now by finding out the average. Now once I find out the average, my new points will move from here probably to here. Okay, similarly my yellow points will move from here to probably here. Okay, we're just trying to calculate. But again the next step what will happen? Again this line will get created and finally you'll be able to see. Okay, so once we move from here to here, let me draw it once again for you so that you will be able to understand this points, right? This is a super important thing, so I really want to draw it again. But if you understand the geometric intuition, this is how the internal working will basically happen. So now my new points are over here, here, okay, here. And this is my new centroid. Similarly to this, you'll be able to see, I'll be able to see points like this. And the new centroid will probably be over here. Now here you can see that again we'll start the second process by finding out whether there's a change in the points or not. So I'm just going to create two lines which will be perpendicular to each other. Now definitely you can see that now I'm clearly creating two groups. This is my one group and this is my another group. This is my one group and this is obviously my next group. Okay, so this is how we have clearly created two clusters. This is my cluster 1 and this is my cluster 2. Okay, and obviously by just seeing this, initially my data points was like this, right, with two groups. And obviously by following these 3 points, 3 steps, we were able to get this, right? Now your question may be, Krish, fine, this was clear, right? This data points had just 2 groups. What about data points which may have 3, 4 groups? So how do we exactly select the K value? This K value is super important. Okay, so understanding how to select the K value, we'll try to do it in the next video. But understand what are the steps. Initially, some K centroids is basically initialized. It can be randomly initialized here and there. In our case, we have initialized K is equal to 2. Then which are the nearest points? We will just try to group that particular point, or we'll try to mark that point with respect to that specific centroid, and then we'll move the centroid by computing the average with respect to the new points. Now, how do we know we have to stop over here? Because here we can definitely see there is no movement of points. Everything is correctly grouped when compared compared to the previous stage, right? So here we are going to basically stop and we will clearly getting at two different clusters. Okay, so this particular step is super step that we will be performing in order to get the k-means clustering, and this is super easy. Now the next thing that we are going to discuss, how do we select this k value? So let me write down the question over here itself. How do we select the k value? How do we select the k value? So let's go ahead and let's discuss this in the next video. Thank you. So guys, now let's continue the discussion with respect to k-means clustering, and here we are going to answer this particular question. How do we select the k value? You already know that here in my previous problem statement I selected k is equal to 2 because from my eyes only I could see that okay, there are two different groups, but in the real world scenario you'll be finding a lot of overlap points, right? So how do we select the k values? Now in order to understand this, first of all I want to bring a new notation which is called as WCSS. WCSS basically means within cluster sum of squares. Within cluster sum of squares. Okay. Now what does this basically mean? Okay. First of all, in order to find out the k value, we will start with the process. We'll initialize k value from 1 to some value, let's say 20. Let's consider that we are going to play with 20 different centroids. Like at a time, first initially we'll take one centroid. In my second iteration I'll take two centroids and all. For as I initialize, okay, probably k to 1 to 20, we will just initialize this, or we will just traverse this. Let's say in my data set, initially I have the specific points. Okay, when my k is equal to 1, that basically means I'm going to consider that many number of centroids. Okay, so let's say these are my data points. And obviously from this you can definitely see, right? Now, if I consider k is equal to 1, then what I'm going to do, I'm just going to initialize one centroid, and it can be initialized anywhere, okay? And we'll also be learning about a new initialization technique as we go ahead. Now, as soon as I initialize with k is equal to 1, in this particular case, it's k is equal to 1. Now, what will happen is that I will just go and compute the distance from every point to this particular centroid, okay? So I'm just going to compute the distance from every point to this particular centroid, okay? Once I compute it, you obviously know that this distance will be quite high, okay? This distance will be quite high, right? So let's say I computed this, and this is my WCSS. WCSS is nothing but here I'm going to do the summation of 1 to n, and we are going to find out the distance between every point, between the points to nearest centroid. Okay, nearest centroid. Right now, since I had just k is equal to 1, so this is my nearest centroid. So let's say obviously in this particular scenario, and this will be square, okay, within cluster sum of squares. So we are going to do the squaring part also. Okay. Now, when obviously this WCSS value will be high. So what I'm going to do is that on the left hand side, I'm just going to plot a graph, and this particular graph will be with respect to k value and WCSS value. So some values will initialize over here. And obviously when k value is 1, when it is 2, when it is 3, we're just going to plot it. Okay. For the first instance, obviously my value will be high when k is equal to 1, right? So my k value when it is 1, it will be very, very high. Now coming to the second scenario, when my k value is equal to 2. Now when my k value is equal to 2, let's say in this particular scenario, my k is equal to 2, right? So for this particular data points, I'm just going to consider 2. These all data points over here. Same data points. I'm just trying to mostly write in the same way. Now in this particular scenario, what will happen? Two centroids will be initialized. Let's consider this is one centroid and this is my another centroid. Okay. Now whichever points are nearer to this particular centroid, we'll just try to calculate the distance. Now in this particular case, let's say this point is nearest to this. Okay. So what we're going to do, we're going to compute the distance, right? So this distance, we're just going to compute it, and finally we're going to do the summation, right? And obviously you know that in this particular scenario, all these points will be nearer to this, right? Nearer to this. Now, when I compute the distance here, obviously in this particular case, I will again be getting some WCSS value. But when compared to k is equal to 1, k is equal to 2, WCSS value will reduce. Why? Because there are two centroids. Initially, I just had one centroid. If you see the distance, right, from all the points, it is obviously going to increase. In this particular case, since we are dividing this data points between two centroids, so if you go and compute the distance, it is obviously going to reduce. So let's say with respect to k is equal to 2, this point will come somewhere here. And when we continue to do this with k is equal to 3, k is equal to 4, you'll be seeing that my value will keep on decreasing like this. And after some point, it will be almost stable, right? Now, when I combine all these points together, this point, this way, this is basically called as elbow method. Okay, this is called as elbow method. Now, what does elbow method basically say? That we have to find out a point wherein there is an abrupt decrease in WCSS, and then after that it is going to stabilize. Let's say that in this particular case, right, here you can see there is an abrupt decrease, and after this it is almost becoming stable, right? Just see that elbow, right? You have probably seen our elbow. So in that elbow, which will be the middle part, right, that you can consider this specific part, right, where your WCSS is abruptly decreasing, and after that specific point you can see that it is stable. So we have to go ahead and select that particular k value. Okay, so that is the concept of elbow method, and how do we select the k value? Now, this is a super important technique, and in practice also I'll try to show you is that we will try to construct this elbow method, wherein we'll play with different k values, and wherever there is an abrupt decrease, and after that when it is stabilizing, we're going to select that particular k value, because from here you'll be able to see that the distance between the within cluster sum of square is basically getting reduced. Okay, so this is how we basically find out the k value. Now let's discuss about two things. One is Euclidean distance. How do we compute the distance between 2 points in Euclidean distance? Okay, now in Euclidean distance, what we do is that suppose let's say there are 2 points, P1 and P2. Let's say there are 2 points, P1 and P2, and obviously this point is denoted by x1, y1, let's say, and this point is denoted by x2, y2. Okay. Now, if I really want to apply a Euclidean distance, in order to find out the distance between these 2 points, the formula is super simple. We'll just compute by using the Euclidean distance formula, that is root of x2 minus x1 plus y2 minus y1 whole square. Okay. So this is what is the formula with respect to the Euclidean distance. Again, let me write it down in a clear way so that you'll be able to understand it. So Euclidean distance is nothing but the formula is root of x2 minus x1 whole square plus y2 minus y1 whole square, right? Suppose if it is a 3-dimensional point, then we have to continue writing like z2 minus z1 also, right? So this is basically the Euclidean distance. Now, in case of Manhattan distance, what we do is that in case of Manhattan distance, you'll be seeing that our points will be like this, right? Now we have to compute the distance from here to here and then here to here. Okay. So in this particular way, we'll be able to compute the Manhattan distance. Okay. So suppose if this is A, B, C, I will probably be taking AB plus BC. Okay. By that specific way, we'll be able to compute it. Now here you can see that if I probably plot this point over here. Okay. So this is basically my x1. This is basically my x2. Okay. Similarly, this is my y1 and this is my y2, right? So if I really want to apply to find out this AB is nothing but x2 minus x1, and this BC is nothing but y2 minus y1. So the overall formula with respect to Manhattan distance can be written by absolute value of x2 minus x1 plus y2 minus y1. So if we use this particular formula, we'll be able to compute the Manhattan distance. Now, when should we use Euclidean distance or Manhattan distance? I think everybody has seen Iron Man movie, right? So in Iron Man movie in US, right? Consider countries, many of the states in US, right? In US, what happens is that your cities, how they are planned in blocks. right? Like this, they're planned in blocks. So here you'll be having buildings, in the middle you'll be having road and all the other things, right? So let's say if your entire city is planned like this, I want to go from this particular point. Let's say I want to hire a Uber from this particular point to this particular point. Then how do I go? I cannot go directly like this, right? Obviously there will be buildings. So usually the technique that I follow is basically to calculate the distance will be used over here as Manhattan distance. Manhattan distance, right? Now, similarly, in the case of Euclidean, let's say in air traffic control, right? In air traffic control, if I probably say I'm going to go from point A to point B. Obviously, in this particular case, I'll not be going like this. Instead, I can go directly like this. So based on this, the distance will get computed. So in this particular case, I can definitely use something called as Euclidean distance. Okay, Euclidean distance. So this is the basic difference between Euclidean and Manhattan distance, and I've also showed you how to initialize the k value over here. Okay. Now, as we go ahead, we're going to understand one very important thing, because see, at every k value we initialize these points. Okay. What if the initialization is done in such a way that both the points are very near to each other? Let's say if I have two centroids that are very much near to each other, if it is initialized in this particular way, then what may happen? What is the problem that you may face? That is what we're going to discuss in the next video. But in this video, we have discussed about like how do you find out this k value and what is the importance of what is the meaning of Euclidean distance and Manhattan distance. So yes, I will see you all in the next video. So in this video, I'm going to discuss about something called as random initialization trap in k-means clustering, and there's an initialization technique which is called as k-means plus plus. Okay, so this is what we're going to discuss about this. Let's say, guys, I have this kind of data points, and according to you, probably if you apply k-means clustering, we should be able to get this kind of clustered groups, and obviously it looks correct because all the groups are over here, and here you can see some of the data points group is here, so definitely 3 clusters I'm able to get with k is equal to 3, right? Now let's say that what if, and obviously you know that whenever we initialize centroids, I told you that we randomly initialize some of the centroids in this particular space. What if that random initialization goes wrong? So in that particular way, let's consider that we are just going to initialize 2 centroids that may be very near to each other. One centroid which may be over here, somewhere here. Now in this particular scenario, you'll be able to see that even though in this scenario, if I try to see all the nearest point, you'll be able to see that okay, perfectly we are able to get all the points that are initialized, right? So this will be one group, this will be the other group, and this entire thing will be the other group because these are the points that are near to this, right? So in this particular scenario, when this kind of initialization of the centroid happens, the final output that you will probably be able to see is that how you'll be getting the output over here. So in this case, you'll be seeing that these are my points, and obviously here my yellow centroid is there, so this will be created as a yellow group, and here you have other points, right? Other points with this orange one, and obviously this will be created as another group over here. And finally, all these points that you see on the right hand side, right? You'll be able to see that there will be one point in between, and that all this will be grouped together, and this group will be basically displayed in another cluster. Now see, from the initial, right, we directly from our eyes we could see that there are specific 2 clusters on the right hand side, and this should definitely be belonging to one cluster. But since my initialization of the centroids, it did not happen properly. It was randomly initialized. So some points got here, some points came over here, and this was my third centroid. This is my centroid 1, centroid 2, centroid 3. In this kind of initialization, you could see that my output is coming like this, right? And obviously from the algorithm that we have learned, yes, this clustering looks fine. Yes, we are able to group together. But understand what was the main thing we had to get in this particular way. But because of the initialization technique of the centroids gone wrong, it was randomly used, right? We used random initialization, right? We used this initialization technique, and we got one centroid away, one centroid away, one centroid. Because of this, we got this specific output, which is definitely wrong, right? Because this is how you have to actually get. So in this particular scenario, we basically say that this is called as random initialization trap. So there are some problems whenever you randomly initialize all the centroids, you may be getting a different cluster of groups, that may not work well with respect to your data set. So for this particular case, what we do is that we use k-means plus plus initialization technique. Now you may be thinking, what exactly is this k-means initialization technique, k-means plus plus initialization technique? Now in this technique, what we do is that we initialize all the centroids in such a way that at least it should be at max distance that it can, right? Let's say this, if this particular point is initialized away, this centroid is initialized away, the next centroid that is getting initialized is quite far from the previous centroid. Similarly, the next centroid, suppose if I'm considering case equal to 3, then the next centroid that will be initialized will be quite far from there, right? In this sample space, the centroids that are going to get initialized, it will be initialized in a far away, right? That is what this k-means plus plus will basically do. And in practical, also I'll try to show you, and random initialization will not happen for each and every data set, yes, but for some of the data sets, suppose this kind of initialization basically has happened. At that point of time, we will be right? So definitely try to use k-means plus plus initialization technique whenever you're using k-means clustering. And again, if someone asks you in an interview why specifically it is used, it is just to initialize the centroid in such a way that it is completely at a far distance between each other. So after this, when we apply all these techniques, right, we will be able to get this kind of clustering techniques, basically cluster groups, right? So I hope you like this specific video. In this video, we have discussed about the random initialization trap, and in our previous video, we understood about Euclidean distance, we understood how to find out the k value, and finally, we also understood that how the working of the k-means clustering will work, right? And we will try to see more practical implementation as we go ahead. So yes, I will see you all in the next video. Thank you. Hello guys, so in this video we are going to implement the k-means clustering algorithm. We have already seen the theoretical intuition. Now in order to implement this, we'll be using Python, and along with that we'll be using sklearn k-means. Okay, so as usually discussed in the theoretical part, we have understood how we can actually implement a k-means clustering. We really need to use an initialization technique which is called as k-means plus plus. And I hope you have understood why we should basically use it. And what we are going to do is that we're just going to use this particular functionality, and we're going to probably create a clusters, right? So to begin with, what I am actually going to do, first of all, I'll make some amount of cells, okay, and then we will first of all import some of the libraries. So let's say I want to import matplotlib.pyplot so that we can actually do the plotting part, and then we will also be importing from sklearn.datasets. We're going to make some datasets by using this make underscore blobs function, and we'll see that how the specific dataset will be created. And obviously, I want to also import, let's say, I want to play with data frames, so I'll be having pandas as pd, import numpy as np, probably if I really want it. So, and then I'm also going to write matplotlib line, right? So all these things have basically been done. Now what I'm actually going to do, I'm basically going to create my x and y axis, and here I'm specifically going to write make underscore blobs. And in make underscore blobs, you have a lot of features, like how many number of samples you want, how many number of features you want, how many number of centers you want, right? And that kind of dataset is basically going to create. So in this particular case, let's say my sample, I'm just going to keep it as 1000. Let's say the total number of datasets or data points that I want is 1000, and my y value, right? It will be decided from the centers, right? Hello guys, so in this video, we're going to implement the k-means clustering algorithm. We have already seen the theoretical intuition. Now in order to implement this, we'll be using Python, and along with that, we'll be using sklearn k-means, okay? So as usually discussed in the theoretical part, we have understood how we can So in this video, I'm going to discuss about something called as random initialization trap in k-means clustering, and there's an initialization technique which is called as k-means plus plus. Okay, so this is what we're going to discuss about this. Let's say, guys, I have this kind of data points, and according to you, probably if you apply k-means clustering, we should be able to get this kind of clustered groups, and obviously it looks correct because all the groups are over here, and here you can see some of the data points group is here, so definitely three clusters I'm able to get with k is equal to 3, right? Now let's say that what if, and obviously you know that whenever we initialize centroids, I told you that we randomly initialize some of the centroids in this particular space. What if that random initialization goes wrong? So in that particular way, let's consider that we are just going to initialize two centroids that may be very near to each other. One centroid which may be over here, somewhere here. Now in this particular scenario, you'll be able to see that even though in this scenario, if I try to see all the nearest point, you'll be able to see that okay, perfectly we are able to get all the points that are initialized, right? So this will be one group, this will be the other group, and this entire thing will be the other group because these are the points that are near to this, right? So in this particular scenario, when this kind of initialization of the centroid happens, the final output that you will probably be able to see is that how you'll be getting the output over here. So in this case, you'll be seeing that these are my points, and obviously here my yellow centroid is there, so this will be created as a yellow group, and here you have other points, right? Other points with this orange one, and obviously this will be created as another group over here. And finally, all these points that you see on the right hand side, right? You'll be able to see that there will be one point in between, and that all this will be grouped together, and this group will be basically displayed in another cluster. Now see, from the initial, right, we directly from our eyes we could see that there are specific two clusters on the right hand side, and this should definitely be belonging to one cluster. But since my initialization of the centroids, it did not happen properly. It was randomly initialized. So some points got here, some points came over here, and this was my third centroid. This is my centroid 1, centroid 2, centroid 3. In this kind of initialization, you could see that my output is coming like this, right? And obviously from the algorithm that we have learned, yes, this clustering looks fine if we are able to group together. But understand what was the main thing we had to get in this particular way. But because of the initialization technique of the centroids gone wrong, it was randomly used, right? We used random initialization, right? We used this initialization technique, and we got one centroid away, one centroid away, one centroid. Because of this, we got the specific output, which is definitely wrong, right? Because this is how you have to actually get. So in this particular scenario, we basically say that this is called as random initialization trap. So there are some problems whenever you randomly initialize all the centroids, you may be getting a different cluster of groups, that may not work well with respect to your data set. So for this particular case, what we do is that we use k-means plus plus initialization technique. Now you may be thinking, what exactly is this k-means initialization technique, k-means plus plus initialization technique? Now in this technique, what we do is that we initialize all the centroids in such a way that at least it should be at max distance that it can, right? Let's say this, if this particular point is initialized away, this centroid is initialized away, the next centroid that is getting initialized is quite far from the previous centroid. Similarly, the next centroid, suppose if I'm considering k is equal to 3, then the next centroid that will be initialized will be quite far from there, right? In this sample space, the centroids that are going to get initialized, it will be initialized in a far away, right? That is what this k-means plus plus will basically do. And in practical, also I'll try to show you, and random initialization will not happen for each and every data set, yes, but for some of the data sets, suppose this kind of initialization basically has happened. At that point of time, we will be right? So definitely try to use k-means plus plus initialization technique whenever you're using k-means clustering. And again, if someone asks you in an interview why specifically it is used, it is just to initialize the centroid in such a way that it is completely at a far distance between each other. So after this, when we apply all these techniques, right, we will be able to get this kind of clustering techniques, basically for cluster groups, right? So I hope you like this specific video. In this video, we have discussed about the random initialization trap, and in our previous video, we understood about Euclidean distance, we understood how to find out the k value, and finally, we also understood that how the working of the k-means clustering will work, right? And we will try to see more practical implementation as we go ahead. So yes, I will see you all in the next video. Thank you. Showed how we can actually implement a k-means clustering. We really need to use an initialization technique which is called as k-means plus plus, and I hope you have understood why we should basically use it. And what we are going to do is that we're just going to use this particular functionality, and we're going to probably create a clusters, right? So to begin with, what I'm actually going to do, first of all, I'll make some amount of cells, okay, and then we will first of all import some of the libraries. So let's say I want to import matplotlib.pyplot so that we can actually do the plotting part, and then we will also be importing from sklearn.datasets. We're going to make some datasets by using this make_blobs function, and we'll see that how the specific dataset will be created. And obviously, I want to also import, let's say I want to play with data frames, so I'll be having pandas as td, import numpy as np, probably if I really want it. So, and then I'm also going to write matplotlib line, right? So all these things has basically been done. Now what I'm actually going to do, I'm basically going to create my x and y axis, and here I'm specifically going to write make_blobs. And in make_blobs, you have a lot of features, like how many number of samples you want, how many number of features you want, how many number of centers you want, right? And that kind of data set it is basically going to create. So in this particular case, let's say my sample, I'm just going to keep it as 1000. Let's say the total number of data sets or data points that I want is 1000, and my y value, right? It'll be decided from the centers, right? So if I really say centers equal to 3, it's just going to create 3 centers. So here also I have one more feature which is called as n_features. So I'm going to say that how many number of columns I want. Let's say I want 2. You can also have 10, 15, 100 columns, but at the end of the day, I really need to visualize and see that how my k-means have actually clustered this particular centers properly, right? So by default, I'm taking n_features is equal to 2. Suppose if you take 5, 10 features, you can also use PCA and reduce the number of features into 2 dimension or 3 dimension to see the visualization techniques, right? So here I'm going to basically use this and we're going to execute it. So here is my x value. So these are my data points with 2 features, and with respect to my y, it will basically be having labels. And since my centers are 3, I'm going to have labels like 0, 1, 2. Now understand, we're not going to use these labels, guys, because understand we are solving an unsupervised machine learning technique. In unsupervised machine learning technique, I will just take this x features, that is, so whatever feature 1 and feature 2 are there, and I'm going to apply clustering on top of it. So what it is going to do, it is going to cluster this data into how many number of groups. Like we don't know how many number of groups. So over here, obviously, we have given that we should basically have 3 groups, right? And based on that, our data point looks something like this, right? With respect to the specific labels. But whenever we apply a k-means clustering or high-level clustering or DB scan clustering, we don't know how many number of groups it will be. So we will try to find out with the help of k-means clustering that how many groups we are able to get from this particular independent feature, and then we'll verify whether we are also getting the output as 3 or not. Okay? But in a real-world scenario, it will not be possible. We'll also be seeing validation techniques by using Celoid scoring, okay, or Celoid coefficients, to just determine that whatever clusters we have got is valid or not. So all those things we're going to cover up. Now, the first thing that I'm actually going to do over here is that I'm just going to plot this coordinates, let's say. So I'm just going to write plt.scatter, okay, and I'm just going to write x of 1. So here this will be my 0th column, okay, and this will be my first column, and then my y or my color value will basically be my y. So this is what I have actually got. So here you can see 3 clusters clearly is visible, right? And if I probably don't use this color, then what will happen? I will get this kind of data points. And obviously, but just by seeing this, you can understand that okay, we have 3 clusters, right? And we really need to try to find out this 3 clusters with the help of k-means. Okay, we should basically get that the number of clusters that is selected by k-means is 3. And for that, we'll be using something called as elbow technique also. Okay, so let's go ahead, and over here right now I'm just going to write c is equal to y because I obviously know what is my output, but I'm just going to use x and then try to find out the cluster with the help of k-means. Now the next step, what we're going to do is that we're going to basically perform standardization. Standardization, which is a feature scaling technique, right? Feature scaling technique. And for this, I will be using from scalar dot pre-processing import standard scalar. Okay, so here it is. So here is my scalar, and then I'm going to basically write my standard scalar. Okay, so let's see what is the error. Okay, the spelling mistake is there, so I'm just going to write standard scalar. Perfect. So my scalar is there. Now all I have to do is that I have to basically transform this entire x value, right? So if I write scalar dot fit underscore transform, and before applying fit underscore transform, also what I'm actually going to do, I'm going to do a train test split, so that we can also see for the test data how we can actually do the prediction. Okay, so for that I'm just going to go scalar train test split. I just want to copy the code now, okay, so that I'll be able to save time. So it is basically present in the model selection. So let me go away from scalar dot model selection import train test split. Okay, and then I'm just going to copy the code from here. Okay, simple and easy, so that I don't have to worry much about it. So let me just go over here, copy this, and paste it over here. Okay, so this too is done. I get basically my x train and x test. Okay, and as you know, feature scaling, what we are going to do, we're just going to write scalar dot fit underscore transform for my x train data, right? And this will basically create my x underscore train underscore scaled data. Okay, and obviously, you know, for test data, what we're going to do for test data, I'm just going to write test underscore scaled, and here I'm just going to use, instead of writing fit transform, I'm just going to use transform. Again, why do we do this? Because we really want to prevent it from data leakage. I don't want my model to basically do this. Okay, so here we have got executed. Perfect. Now this is my train and test with respect to the scaling. We don't do scaling for the output feature. So till here everything is perfectly fine. Now what we do is that now I'm just going to import from scalar dot cluster import k-means. Okay, k-means. Okay, so just scalar import k-means. Now with the help of k-means clustering, we are going to just apply the clusters on top of this x-train data set. Okay, and understand one thing over here, guys. Since we have already made y-train and y-test, I'm not going to use this, but I'm going to specifically use this train and test. Okay, x-train and x-test. Okay, so just for my purpose, you know, I will directly ignore this y-train and y-test because I don't require that, because we're just going to apply this in the independent features. Okay, perfect. Now let's go ahead and let's try to see how we can perform an elbow method. In the theoretical part, we have already discussed how do we select the k value. So we have to use something called as elbow method. So to select the k value. Okay, so first of all, what I'm going to do, I'm going to create within cluster sum of square. That is the distance between each and every point with respect to different k values, right? And we'll try to find out what is the distance with respect to each and every point in that specific cluster. Okay, and based on the number of centroids, this is determined by k. Obviously, I've discussed all this in the theoretical things. So I'm going to say for k in range, and I'm going to try with different values of k. Let's say 1 to 11. Okay, all I'll do, I'll just apply this k-means clustering, and here I'm just going to say k-means. The first thing is n underscore cluster. Okay, is equal to k, and here I'm just going to initialize my k in it, and basically write k-means plus plus. Okay, so this is the initialization technique that I'm going to do. So in the first instance, what will happen with respect to k is equal to 1, it's just going to do the k-means, and then we're going to basically do k-means dot fit on my scale data, right? So this will be my x train underscore scale. Okay, and then what we're going to do is that I'm just going to say that WCSS dot append whatever within cluster sum of square will come, right? It will be saved in one feature which is called as k-means dot inertia. Okay, so if you probably write k-means dot inertia, you'll be able to get this. Okay, so here your entire within cluster sum of square with respect to different k values will get shown. So once I execute this, so here you'll be able to see with respect to 1 to 10 what are my WCSS value, and as you'll see that this WCSS value will keep on decreasing as your k value increases. Okay, and probably you can try for any number of k values. If I probably go for 20, 30, that many number of things. Okay, but how do we determine what should be the exact k value? So in order to do that, what I'm actually going to do is that I'm just going to plot this elbow curve with the help of this specific WCSS value. So here I'm just going to write plot elbow curve, right? And I'm going to say plt dot plot range of 1, 11, and here I'm just going to write WCSS, and then I'm going to say plot dot htrix range of 1, 11. Okay, so this will basically be my htrix value, and after that I'm just going to create my x label, and here I'm going to basically say number of clusters, and then I'm going to basically write plot dot y label with respect to WCSS. Finally, this is my plot dot show. So once I execute this, here is how the curve we are actually getting. So obviously the value will keep on decreasing, but you really need to find out one region, like how we have this elbow, right? And we have to find this knuckle region, right? From where the value suddenly abrupts and then it becomes stable. So here you can see it is falling down, this WCSS value is falling down, and from this particular point, it is becoming stable. So we can definitely say with the help of k is equal to 3, we should try to cluster it. And obviously with respect to the y value that you see over here, we have centers as 3, right? So this is how we are able to validate with the help of this elbow method. So at the end of the day, what I'm actually going to do is that I'm just going to create my k-means clustering. Okay, with the help of this 3 clusters, right? So once I do this, and probably once I execute it, all I will be doing is that I can basically write k-means dot fit underscore predict. Okay, and over here you know that when I say n underscore cluster is equal to 3, it is just going to create 3 centroids. Okay, 3 centroids. So I can now predict fit underscore predict on my x underscore train underscore scale data. So here this is how my output will look like. Now similarly, if I want to do the prediction for my test data, so all I will do, I will write y underscore predict, y underscore predict. Okay, and then I will probably use k-means dot predict method, and this predict method will basically happen on x test scale data, right? So here you can see I'm just going to use scale, and finally I'm just going to get my y underscore predict, right? Now this is how what is the labels I'm getting with respect to x test scale data. All I will do, I'll just plot this entirely. Okay, now here I'm just going to write this instead of writing x underscore x, I'll write x underscore test, and here also I'll go to write x underscore test, and finally c will be nothing but y underscore predict. Now here you can see that with respect to the prediction test data also, I'm able to get a good plot with respect to my predicted output over here, right? And obviously we know, see in this problem statement we know how many centers are there, but in a real world problem statement you'll just be given this independent feature, that is x, nothing other than that. Okay, and so that is the reason why I did train test split, right? I told you to ignore this. Let's consider that we don't know this, and finally here you can basically see this also, right? Now validating the k value can also be done by 2 more things. Okay, so here obviously we were able to see this k values, right? But for this elbow method, sometimes it becomes difficult also. Suppose if this downstream is not right, if there is no stability in this particular value, at that time it becomes a very difficult value to select the k value. So for validating the k value, we'll be using two techniques. One is knee locator, we say. Okay. So first of all, in order to apply, first one, I'm just going to say this is knee locator. Okay. And the second technique that we are going to use is something called a Silhouette scoring. Okay, I've already made a theoretical video on Silhouette scoring. You can just go and see for that. Okay, and but here I'll just show you the implementation part. Okay, so all these techniques we'll try to do. Now, first of all, we'll go with knee locator. For knee locator, we will try to install one library which is called as knead. Knead. Okay, so once we install this here, it will take some amount of time. So in my case, it is already satisfied. You can directly install this over here. Now from this knead, I'm going to just import knee locator. Okay, and with the help of this knee locator, right, all we are going to do is that we're going to initialize this kl is equal to knee locator. Here I have to give all the ranges 1, 11. Then my WCSS value. And if you see more parameters, so here you have your x value, y, which will be variable. S is another parameter which you can probably see over here. Okay, all the parameter information is given over here, right? You can definitely check it out. Curve, this is super important. Now you know that over here when I probably see this, right? What kind of curve this is basically following, right? It is a kind of a convex curve, right? So instead of writing concave, right? Over here by default concave. Concave basically means it will be just the reverse of like this, like ulta, like you can just say opposite of a parabola, right? So something like this. That will be basically concave. If I say convex, it is just going to create this parabola curve, right? So instead of writing concave, I'm just going to use convex. Okay. So the third one, the curve that I'm going to basically use for this problem statement is nothing but convex. Okay. And you know that there is also one more parameter which is called as direction. In this you can have increasing or decreasing. But now in my case, obviously you can see the values decreasing. Okay, so over here you can basically use decreasing. Okay, and then finally you can see that I'll just try to execute it. Now if I go ahead and write kl dot elbow, so here you'll be able to see that I'm also getting 3 as my k value. So obviously from this elbow method we are able to validate that. Okay, fine, we are able to get the 3 values. So what it is going to see, it is just going to find out where is the abrupt changes. Okay, so with respect to this you can actually validate. Now coming to the next one, which is called as Silhouette scoring. Okay, now Silhouette scoring is super amazing because this will also help you to validate it. Okay, now here what I'm actually going to do, I'm just going to import from sklearn.metrics, import Silhouette score. Okay, and I'm just going to import it. Now what I'm actually going to do, I'm going to basically create a list. But let's say I'm just going to mention this as Silhouette coefficients. Okay, and then over here I'll say for k in range 2, 11, and here I'm just going to apply all my k-means algorithm with respect to all different cluster values. Okay, and underscore clusters is equal to k, comma, in it. I'm just going to say k means plus plus, right? Okay, so once I do this, next I will just do dot fit on my x train scale, right? So once I do on this, after this I'll just try to compute my score. Okay, so my score will basically be derived from this Silhouette score, and here you need to provide two parameters. One is x underscore train underscore scale, comma, with respect to this k means whatever label you got. So on dot label underscore if you do, you'll basically be getting all the labels. Okay, now with respect to this, it will try to find out the score, and with respect to different k value, I'm just going to use this, and I'm just going to append all the score value over here. Okay, so once I execute it, here you'll be able to see I'll be getting different Silhouette coefficients. So these are my values. Okay, now what I'm actually going to do, I'm again going to plot all these things, and again the plotting technique will be same, like how we plotted it for the specific things, right? So similarly, I'll do the plotting over here. Now once I plot it, here you can see that at k, number of clusters k is equal to 2, the Silhouette score was somewhere here. Then for 3, it became very high, that is greater than 0.7. And then for all the other values, it is decreasing. So wherever the value is quite high, or which is the value is highest, I can definitely use that. So from this, I will be able to say that my k value should be equal to 3. Okay, since my Silhouette score is highest. Okay, so that is the technique we can definitely use. So here you could see this, and within 30 minutes we are able to understand so many different techniques with respect to k-means clustering. So I hope you have understood this video. You can definitely try for any number of parameters with respect to any number of features. Suppose if I put 50 features over here, you can later on what you can do, you can apply PCA, reduce the number of dimensions of features into 2, and then probably apply it. The reason I made it to 2 so that we will be able to visualize the data, right? So yes, this was it from my side. I will see you all in the next video. Thank you. Hello guys, so we're going to continue discussion with respect to clustering algorithms. In our previous video, we discussed about k-means clustering. In this video, we're going to discuss about the hierarchical clustering. Now, whenever we talk about hierarchical clustering, let's understand the goal, what we're trying to do over here. Let's say that if this is my data set, after applying the hierarchical clustering, we will be able to get this three groups of data, right? Three clusters of data. But if I really want to compare this with k-means clustering over here, even though my k is equal to 3, then the number of groups, but here there will be no centroids. Okay, in k-means we specifically had centroids with respect to each and every cluster. Now let's go ahead and understand like what is the basic mathematical intuition behind forming this particular clusters. Okay, so in hierarchical clustering you specifically have two types. One is agglomerative clustering and divisive clustering. Okay, so if you are able to just understand one, okay, then you will be able to understand the other one itself because it is the reverse of that. Agglomerative basically means combining, divisive basically means dividing. Okay, so just keep this point in mind because the geometric condition that I'm actually going to discuss is with respect to agglomerative. Okay, and then automatically you'll be able to understand about the divisive. Okay, so now let's consider these are my 6 data points and then we'll try to understand what are the basic steps that needs to be taken in order to understand this. Okay, so here I'm just going to write down all the steps. So the first step is that for each data point, initially we'll consider okay it as a separate class. Okay, so what do I mean by this is that I have 6 points over here, so each and every point will be considered as a separate cluster, okay, or separate class or cluster. Here I'll not say class, but at least I'll say it as cluster. Okay, cluster. So let's say P2 is my next point, so this will be a separate cluster. P3 over here will be a separate cluster. P4 will be another cluster over here. P5 will be another cluster and P6 will be another cluster. Okay, so let's consider these are my 6 cluster. Okay, then coming to the second step, which is super important, we find the nearest point and create a new cluster. Okay, so let's say which is my nearest point. This two are my nearest point, so I will make this as one cluster. Okay, over here. Okay, so this will be my new cluster over here, and the next nearest point, if I probably consider, will be P1, P2 because this is specifically very, very near. Then I will go ahead and create this cluster, right? I will go ahead and create this cluster. Then you know that it is P4 is very much near to this cluster of P5, P6. So what we will do, we will try to combine this into another cluster like this. Okay, and then over here also you can basically see P3 is very much near to this particular cluster. This is my P3. Okay, so I will go ahead and combine this cluster over here, and finally both this cluster will be near, so we'll go ahead and combine something like this. Okay, so this is the steps that we specifically need to follow. So in the third point here, I can definitely write after doing this step is that we have to keep on doing the same process, unless and until we get a single cluster, right? So these are the 3 steps that we specifically follow, and this approach is called as agglomerative approach. You know, on smallest point we are trying to cover up all the points and create as a single cluster. Divisive approach also I'll try to discuss it, but before that let me also introduce you a new diagram which is called as dendrogram, because still we need to decide, okay Krish, you have actually covered up all the points and you have put it inside a single cluster, but still I do not know that how many number of clusters we need to take, right? So how do we decide that? And for that we'll be using a new technique which is called as dendrogram. So let me go ahead and again create this particular points and let me write down all the steps that are going to happen. Okay, so here the first thing that I'm actually going to do, okay, so let's say this is my P1, this is my P2, this is my P3, and similarly this is my P4, P5, and P6, right? The same points, okay? And on the right hand side, I will construct a dendrogram. This dendrogram is basically constructed based on all the points. So let's say this is my P1 point, this is my P2 point, this is my P3 point, this is my P4 point, this is my P5 point, and this is my P6 points, okay? And on the y-axis here, you'll be basically having something called as Euclidean distance, okay? And Euclidean distance can be 1, 2, any values, whatever values or whatever distances that we have in our diagram, and that with respect to that we'll be basically using it. Okay, now what do we do in the first step? We find out the nearest point. So we say that first of all each and every point is a separate cluster, right? So here you can see each and every point is there. Now you go and find out the nearest point, that is P4, P5. Okay, so what you do, you combine them as a new cluster. So here I'm basically going to write P4, P5. Let's say the distance between this cluster is this much. Okay, so I combined this, I broke this into a single cluster. Now after that, you know that which is the nearest point after this? Obviously it is P1, P2. So I'm going to combine P1, P2. Obviously it will be greater than the Euclidean distance when compared to P4 and P5. I hope everybody is able to understand how do we find out the nearest point. Obviously we can use Euclidean or Manhattan distance. I've already discussed this in the k-means cluster, right? So now what I'm actually going to do, I'm going to combine P1 and P2, and let's say this will be my this distance, right? So I've combined this. Then you'll be able to find out which is the nearest point, whether P6 is near to P4 or P5, or whether P3 is near to P1 and P2. Let's consider that P6 is near to P4 and P5. So what I'm going to do, I'm just going to combine this as a separate cluster, right? So here is my separate cluster. So this will become another cluster. So in short, my P6 is basically getting combined over here. Okay, so here I'm going to draw another diagram, right? And finally you'll be able to see P3 will also get combined. So let me create another diagram for this, and here you'll be able to see P3 will get created. So when this P3 is getting combined to the cluster P1 and P2, so here you'll be able to see, you will be able to find something like P1. You'll be able to find something called as P2, P1, P2, which is as a cluster will get combined to P3, and here you'll be able to create this kind of dendrogram. Always remember that based on the Euclidean distance, this height of the building is basically created. I'll just consider it as building. Okay. So finally, when we combine both these things, that basically means you're combining this cluster and this cluster. Let's say this cluster is getting combined over here, right? Now, finally, this is my entire distance. Here you can see that, and when we combine it, it becomes a huge cluster like this, right? So totally all the points have been covered, and in the right hand side, we have created something called as dendrogram. Now is the point that how do we decide what should be the number of clusters? This is a super important thing that we really need to find out. How do we decide that this should be the number of clusters that is that we have to take? In this particular case, let's say my k is equal to 2. With the help of k is equal to 2, obviously I'll be able to get 2 groups, right? P1, P2, P3, P4, P5, P6, right? But just by seeing this particular diagram, how do I find out whether k is equal to 2? This is the most important thing. Now remember, before I go and explain you how we decided the value as k, the approach that we have used over here is basically bottom to top, right? So this particular approach is something called as agglomerative. Okay, and the difference between agglomerative and divisive is that divisive we go from top to bottom. Okay, so that basically means first of all we go from here. In this, you know that we have combined all the points like P1, P2, P3, P4, P5, P6, right? In the next one here you'll be able to see I have P1, P2, P3. In this I specifically have P4, P5, P6, and then here I have P1, P2, here I have P3. Here similarly I have P4, P5 points, right? So these are the clusters. From the divisive approach also what will happen is that we combine all the points from the top, and then we go ahead and divide all the points from the bottom, from the top to bottom, like how we did it from agglomerative clustering from bottom to top. Okay. Now this was all about the dendrogram. and how we can construct a dendrogram from this particular points. Now comes the main point: how do we select the k value? See guys, k value basically selected based on this Euclidean distance threshold. Okay, so we define some kind of threshold. Let's say the threshold, if I consider the threshold to be 4, then what will happen is that we'll just try to create a horizontal line from here, and I'm saying that the points, right, that are present in this particular clusters, should not be having more than Euclidean distance threshold as 4. That is what this line basically specifies. All the points that are within the clusters and that are in different clusters, the threshold should be made sure that it should be always less than 4, right? So what we are doing over here, we are trying to set up some kind of threshold value. Now this is super important. Threshold value helps us to basically identify how many number of clusters will be there. Let's say, and we'll also try to find out the relation. Once we decrease the threshold, what will happen? So over here, when I probably cut this line, right? When I cut this line, considering some threshold value, here you'll be seeing that it passes through 2 points, right? When it passes through 2 points, that basically means my cluster should be 2. Okay, my cluster should be 2. Now, obviously, for this particular problem statement, your cluster needs to be 2 because you just have 2 important clusters that you can directly see from your eyes. But what happens if I reduce my threshold? Let's say if I create a new line, if I say that my threshold is somewhere around 2.5, and I start creating a straight line over here. Now, over here, you know that how many points it is passing, how many vertical lines it will be passing. It will be passing through this, right? So 4 points, 1, 2, 3, 4. Now, in this particular case, you can see that if it is passing through 4 points, you'll be saying that I have to use the k value as 4. So here, the threshold or the Euclidean distance, as it is saying, it is just like we're keeping a threshold. That what if the distance between the points, if we are decreasing it, that basically means the number of clusters will increase, right? So here, when I try to create a horizontal line on this, the k will be 4. Now, if I keep on decreasing this threshold, then let's say I make this threshold come over at this particular point. If I'm just setting up my threshold as 0.5, then how many points, how many vertical lines it will pass through? Here you can see it will pass through 6 vertical lines. That basically means, again, we have come to our similar points that we had, right? P1, P2, P3, P4, P5, P6, right? So it is our duty to select the best threshold, and we have to always make sure that when the threshold is basically selected, we should get a good number of clusters. But again, selecting the threshold can be a tough challenge. So with the help of dendrogram, there is a simple hack. Okay, you just need to find out the longest vertical line such that none of the horizontal line passes through it. So let's say that which is the longest vertical line. Let's say this is the longest vertical line, but here you can see that most of the horizontal line will pass, right? This will get passed over here, right? And this will also get passed over here. So I cannot select this as my longest vertical line. What about this particular line? No, it cannot be selected this because here horizontal line is getting passed through it. What about this vertical line? Yes, this vertical line can be selected because none of the horizontal line is passing through it, right? When I say none of the horizontal line, basically means other horizontal line, not the horizontal line that I am creating, right? So here you can consider in this building, if I try to extend this line, this is basically a horizontal line which passes through this line, right? Similarly, here you can see if this is the line, over here also a horizontal line can be created and it passes through all these lines. So I cannot select this specific lines as my longest line, right? Similarly, if I go and select this, here also you can see the horizontal line is passing, right? So it cannot be selected. It cannot be selected. The only longest vertical line is this one. So as soon as I find out the longest vertical line, all I have to do is that create a horizontal line through it. And once I create a horizontal line, we'll just try to see that how many points it is passing through. If it is passing through 2 points, that basically means I have to select my k value as 2. That is the technique we should definitely apply in dendrograms, which will actually help us to select the k suitable values. Okay, and the same thing you can also do with the help of Python, which I'll be showing you in the practical section. But understand, the main technique is that select the longest vertical line such that no horizontal line passes through it. Horizontal line passes through it. Okay, this is the technique that we should apply. And with the help of this, what we are actually doing, we are able to set up our threshold value, which is nothing but Euclidean distance, right, in the y-axis. So I hope you have understood this particular video. I hope you understood about agglomerative and divisive and what is the differences between them. So in the next video, I'll be trying to explain you the differences between hierarchical and claiming clustering, and then we'll try to note down some of the points which will be important for you all, so that if anybody asks you in the interview, you'll be able to answer it. So I hope I was able to make you understand all these points. Please make sure that you revise this if you're not able to understand. Hello all. So in this video, we are going to basically implement a hierarchical clustering implementation technique using sklearn and Python. And again, we're going to use this algorithm that is called as agglomerative clustering. With the help of this, we'll try to perform hierarchical clustering. So first of all, as usual, we'll go ahead and importing libraries. And this time I'll make the problem statement a little bit interesting, while I'll also be applying PC and reducing the number of dimension of the feature. So to begin with, what I'm actually going to do, import pandas as PD. Okay, import numpy as np, because these all are common things which you basically need to do it, right? So import matplotlib.pyplot as plt, right? And then I'm also going to import from sklearn, import all the datasets. Let's say which dataset I'm going to use. I'll just show you. Okay, and this all will get imported. Now the next thing that I'm going to do is import iris dataset. Okay, so iris dataset that I'm going to specifically use, and here I'm just going to say datasets.load underscore iris. And once I load this, I will probably get my iris dataset. So here you can see on side right, you'll get 3 key value pairs. One is data, and here I specifically have 4 features. Then you have target, then you also have target names. Okay, so what I'm actually going to do is that I'm just going to convert this into my iris data frame, which will be pd.data frame. And here I'm just going to take my iris.data, okay, and probably execute this. Okay, and now my iris underscore data will basically be this all 4 features. Along with this, what I'm actually going to do is that I'm just going to say dot columns is equal to iris dot feature names. I'm just going to assign it to the feature names over here. So probably if I again go ahead and write iris underscore data, I'll be able to get this out. Okay. So what we have done is that we have imported all the important features. So these are all the features that are basically present. And again, I'm not that interested in the flower type. Okay, what kind of flower? Because the output feature is basically in the target. But at an overall idea, if you really want to see the entire data set, you can just include the target data over here with another column and use that specific target. Now I'm going to basically use this entire data and try to perform clustering. Now, in order to first of all perform clustering, what I'm actually going to do is that we'll first of all perform standard scaling of feature scaling. Now, right now, you know that my data is completely over here as iris underscore data. So here, what I'm actually going to do is that I'm just going to write from sklearn dot, let's see where does standard scalar fall, in which library, standard scalar sklearn. Okay, so here you can see preprocessing is present, so I'm going to write from sklearn dot preprocessing import standard scalar, and then finally you'll be able to see and go ahead and write standard scalar. So here now I will just go ahead and write scalar dot fit underscore transform, and here I'm just going to basically give my iris data over here. So this will basically be my iris underscore data, and this will basically get converted into my, let's say, x underscore scale, which is my independent feature. So I hope iris underscore data spelling is right. So once I execute it, so here you'll be able to see x underscore scale. Okay, so these are my scaled data, right? Now this is always the first step. We have to do feature scaling, and this process is basically called as standardization, because at the end of the day, internally, whatever techniques we use in hierarchical clustering, or some Euclidean distance, some Manhattan distance, some distance measurement formula will definitely be there. Now in the next step, you're just going to apply the PCA and reduce the number of dimensions. Apply the PCA. Okay, so in order to apply PCA, I'll just write sklearn PCA. So here you can see sklearn dot decomposition. So here you can see from sklearn dot decomposition import PCA, right? Now here in the PCA, what I'm actually going to do is that I'm just going to write n underscore components is equal to 2. That basically means I'm just going to convert this 4 dimension into 2 dimensions and then probably construct or apply hierarchical clustering. So here, if I execute this, here you can see this will basically be my PCA, and then I will just write PCA dot fit underscore transform, and I'm going to just apply this to my scale data. Once I see this, you'll be able to see this two features, right? So now here I will just say PCA underscore scaled data, which will be my final data where I'm specifically going to apply my hierarchical clustering. Now the step will be quite easier, guys. Now, first of all, whenever we really want to perform a hierarchical clustering, before this, let me just go ahead and write plt.scatterplot, and here you'll be able to understand why I'm specifically plotting the scatterplot also. So here I will write PCA scaled with respect to all the values, 0th column, and again PCA scaled with all the values, comma 1, right? So once I execute this, this is how my data looks like, right? And obviously, if I try to plot this color, so in order to plot this color, you obviously know that in iris.target, that specific value, output value is there, right? So I'll just write iris.target and just execute it. Now this is how my 3 clusters look like, right? Now we'll try to see whether we'll be able to get 3 clusters or not. And obviously with the help of PCA, we are able to extract some meaningful information. And clearly we can see that the clustering also looks fine, right? With respect to the real data. Now the next step that I'm actually going to perform over here is that I'm just going to apply agglomerative clustering. And in agglomerative clustering, the first step is basically to construct a dendrogram. So to construct a dendrogram. So we will try to construct a dendrogram, and for plotting a dendrogram, I'm going to basically use SciPy library. So I'll say import SciPy dot cluster dot hierarchy as sc. Okay, and then I'm just going to plot the dendrogram over here. So for that, I'll just set up a plot dot figure, and my fig size is equal to 20,7. Okay, and then I will say plt dot title, and this will basically be my dendrograms. Okay, and here I will just go ahead and create dendrogram sc dot dendrogram, and here I'm just going to use sc dot linkage. In order to construct a dendrogram, we have to basically use the same sc.linkage, and inside this, I will just pass up my dataset. My dataset is obviously what PCA underscore scale. Okay, PCA underscore scale, along with the method that I'm specifically using. There are different methods. Again, with respect to this, you'll be able to see the methods like WOD, single, all these different kind of methods are definitely there. You can definitely explore in the agglomerated clustering what all things are there. Here you have WOD, minimizes the variance of the cluster being merged. Average uses the average distance of observation of the two sets complete. Or maximum linkage uses the maximum distance between all the observation. Single uses the minimum of the distance between all the observation of two sets. So I am specifically using over here as well. You can also change it, and you can basically see how the performance is, right? So once I probably use WOD, okay, and then I will probably just do plt.title, and in the title, I'm just going to write dendrogram, okay, and then finally you'll be able to see X label. And here you will specifically have sample index. That's it. And I'm going to just write plt.y label. And here I'm specifically going to use Euclidean distance. By default, Euclidean distance will basically be used in this, right? In agglomerated clustering. So once I execute this, let's see, SciPy.cluster.hierarchy has no attribute dendrogram. Okay, dendrogram. So it's not dendrogram, it's dendrogram. Okay. So finally, you'll be able to see some plottings will definitely come over here, and it is probably taking some time. So this plot looks pretty much good with respect to our clusters. Obviously, now in this particular case, in order to solve this, right, it is very simple. If you really want to find out what will be the number of clusters that we specifically want from this dendrogram, all you have to do is that find out the longest vertical line and try to create a horizontal line such that no other line passes through it. Now let's say if I'm going to take this longest vertical line over here, you can see that the horizontal line is passing through it, right? This specific horizontal line. So here you can see this specific horizontal line is passing through it, right? So this will not be considered. You can take this longest vertical line because from here, none of the horizontal line is passing, right? If I probably take this, you'll be able to see if I draw a straight line. So 2 points it will basically passing. So we can definitely consider 2 clusters. Or if you really want to check again, you need to find out the next vertical line. Over here, this is the longest vertical line so that none of the horizontal line passes through it. But here, that is also not possible because here you'll be able to see that one of the horizontal lines is passing through this, it is passing through this, right? So this way also you're not able to find out. So what you can do is that you can either take 2 clusters, right? Or you can also play with one more cluster like 2 or 3 or nearby like 2, 3, 4, something like that. But definitely from this diagram, I can definitely see that we should take 2 clusters. Okay. Now what I'm actually going to do is that in order to apply that, right? So I will go ahead and import my agglomerated clustering. So I'll cite for my scalar dot cluster import agglomerated clustering, and here I'm just going to specifically say cluster agglomerated clustering. The number of clusters that I'm probably going to take is 2. There's another parameter which is called as affinity, and here I'm just going to specifically take Euclidean. Let me just check whether we applied it for PCA scale. Yes, Euclidean. Okay, and then we are also going to use the linkage, the same linkage that we have specifically used called as WOD. Okay, so this is done, and then now I'll just write this as cluster, and then finally I'll do cluster dot fit on the RGS dataset. Okay. That is nothing but PCA underscore scale data. So once I execute it, let's see one error is coming. Euclidean. Okay, spelling mistake is there. Always make sure that you write the same spelling. Okay, so here this is the spelling, and you can definitely check out from here, right? So Euclidean affinity over here you can see Euclidean. It can be L1, L2, Manhattan, cosine. So these are all the other things you can basically use, and any one of them can be applied over here. So once I do this, the agglomerated clustering is applied. Now if I probably try to apply this cluster dot labels, if I write dot labels, and here is what is my label looks like, right? All I'll do is that based on this, I'm just going to apply it over here. Okay. And probably I'm just going to change this to iris.target to cluster.labels underscore. So here you can see it looks a good clustered group. Obviously from our real data, we could see that there are 3 groups. But again, what this entire clustering is saying that no need of 3 groups. You can basically have 2 clusters because they are clearly separable. So this is the entire technique of applying hierarchical clustering. The main important thing is basically to construct a dendrogram and see that how many number of groups are there, right? And here you can clearly see that you really need to find out the longest vertical line so that none of the horizontal line passes through it. In this particular case, you can see none of the horizontal line is passing. So if you try to find out the longest vertical line, all you have to do is just pass a straight line through it. So here you'll be seeing 2 points are basically transfer you're passing through, right? So that basically means you have to go with 2 clusters. So this was all about the hierarchical clustering. I hope you are able to understand this. Just try it with respect to any dataset, but here I've also applied PCA. Here I have also applied this dendrogram I've constructed, and finally I've applied agglomerative clustering. So yes, I will see you all in the next video. Now, guys, let's go ahead and understand the differences between k-means versus hierarchical clustering. Now, one important thing I really want to find out, and I'm not just going to talk about the differences based on the working, but based on these two important parameters, one is scalability and one is flexibility. If I consider with respect to data set size, if this data set size is huge, we should definitely use k-means clustering, right? And for small data set, the clear winner is hierarchical mean clustering, right? So here, obviously, for the larger data set, we have to use k-means. For smaller data set, we use hierarchical clustering. Why? Because in hierarchical clustering, we create dendrograms. So if you have a huge data points, right, many number of data points, a huge data set, this dendrogram will not be able to clearly see. So it will be very, very difficult to make the decision of how many number of clusters we need to have. K-means clustering. If I talk about k-means clustering, this is a super important point. K-means clustering is only applicable for numerical data set. Okay, only numerical data. Whereas hierarchical clustering is just not only applicable for numerical data, for other data also. Why? Because it just try to find out which is the nearest point. Let's say this is the nearest point. If these 2 points are some movies also, okay, so we can definitely do it with the help of cosine similarity, right? So it may not only depend on numerical data, but it is also, wherever probably you can just try to find out wherever we can use this cosine similarity also for all those things where cosine similarity can be applied. For that also hierarchical clustering can be applied. Okay, so hierarchical clustering, this is the most major advantage when compared to k-means. Okay, now coming to the third point with respect to visualization. In k-means we basically use centroids, right? Now if I'm specifically using centroids in k-means, sometime if I say, and the technique that we specifically use is something called an elbow method, right? This elbow method sometimes it becomes difficult to find the number of centroids. Okay, sometimes it becomes difficult because we have to probably see that where there is a sudden decrease in the WCSS value and then when it is stabilizing. In the case of hierarchical mean clustering, it becomes a little bit easy to find the number of clusters. Okay, but again, if you have a huge data set, k-means clustering is the clear winner because obviously you cannot go and create dendrogram for such a huge data set. But I would suggest always make sure that this is the most important point. And in interviews also they may ask you, k-means clustering, it is only applicable for numerical data. When you have variety of data, definitely you will be able to apply hierarchical clustering. Okay, so just try to find out this. See about cosine similarity, where cosine similarity is basically used. Let's say I have 2 movies, one is this action movies and one is this comedy movie. I can definitely find out the cosine similarity between these 2 movies. So that is what I'm saying, variety of data. It may not only be numerical data. But in k-means, since we are using Euclidean Manhattan distance, over here you'll be able to see that only numerical data will work. Obviously, when I try to show you the distance between this point, I told Euclidean distance. But here you can also use something called as cosine similarity. Okay, so this is a super important point. So yes, this was the basic differences between k-means and hierarchical clustering. So I hope you understood this, and please explore more about this variety of data and definitely try to understand what cosine similarity is. Okay, yes, I'll see you all in this video, we are going to discuss about a new clustering algorithm which is called as dbScan clustering. Now, already in our previous video, we have discussed about k-means clustering, we have discussed about hierarchical mean clustering. Now, dbScan clustering is also a clustering technique. We will try to understand how dbScan clustering will actually make clusters. And along with that, in the upcoming videos, we'll also be discussing about the advantages and the disadvantages. Okay, so let's go ahead and let's understand how does dbScan clustering actually work. Now, this is one of the diagrams that I've actually taken, and the source is Wikipedia. Definitely, I would like to give a huge amount of credit to Wikipedia. So please make sure that you support Wikipedia by doing some donation because it is a non-profit organization, right? So let's go ahead and let's understand. Okay, over here in this diagram, you'll be finding 3 main points. Okay, so let's consider one is the red point, and this I will be considering as a core point. I'm just mentioning it as a core point. Okay, let's go ahead with the next point. Over here, you'll be also seeing yellow point, and this yellow point is nothing but it is called as a border points. Okay, and finally, here you'll be also seeing one blue color. So let me just quickly take one blue color over here, and let me draw it like this. And this particular point is specifically called as outlier. Okay. Now, let's understand which all points becomes a core point in this. And obviously, this point are just like my data points that are distributed in this 2D plane, right? So which point actually becomes a core point, which point actually becomes a border point, and which point actually becomes an outlier point, we'll try to discuss. Okay. So first of all, let's go ahead and discuss about this specific core points. And along with this, we'll also consider 2 more parameters. One is minimum points that we have to probably consider. In this particular example, we have considered 4 minimum points. And the second one is something called as epsilon, which is nothing but the radius that we're going to use to draw a circle around any specific points. Okay, so this is the 2 hyperparameters we will basically be using for dbScan clustering. And how do we select this? Again, some kind of hyperparameter tuning is also done with respect to this. We play with different values, but at the end of the day, when we will be continuing the series, we will be understanding a topic which is called as Szilard scoring, which will actually help us to select this both the values. Okay, now let's consider that for this particular example, I've taken minimum points is equal to 4, and this epsilon is nothing but it is a radius, some value. Okay, now for the first one, right, I'm just going to consider for the red point. Okay, so let's go ahead and discuss when does a point, specific point be called as a core point. Okay, this is the first scenario. Let's say I have a data point over here, and we take some epsilon value and we draw a circle around it. Okay, now why I have marked this as a red point or a core point over here, there are some conditions. First is that there should be at least some minimum number of points that should exist within the circle. So let's say if my minimum point is 4, that basically means if I have 4 points within this, and I can also have greater than 4, right? But if I have at least that many number of minimum points within this, then I will consider this as a core point. So here, my first condition is that number of points within the radius, right, or epsilon should be greater than or equal to 4. Okay, that is nothing but that is my specific minimum points. Okay, so this is the most important point over here. So if this particular point satisfies this condition, and these points are nothing but the other data points that will be existing in this space, right? So if this many number of points have been there within the epsilon, then I can definitely consider this as a core point. Okay, super important. Now let's discuss about the next point, which is called as a border point. Now, what does border point actually specify? Okay, let's say if this is a border point, and I create an circle considering one epsilon value. Okay, epsilon value here also epsilon is there. Let's say if there are number of data points within this epsilon value, but the number of data points will be less than the number of data points will be within this radius. Okay, within this radius will be less than, let me write it properly more, will be less than minimum points. So here what we have done is that here clearly we are seeing that when does a point is basically called as a border point, if we have, let's say if you have created a circle with some radius epsilon, if the number of points within this particular circle is less than the minimum number of points, that is it is less than 4. In this particular case I have 3. So that point of time I will basically call it as a border point. Okay, it's super important to understand because then only we'll be able to understand this particular diagram. Why this is specifically a red point, why this is specifically a border point. Okay, now coming to the next point, which is also called as outlier point. Outliers. Now in this particular case, whenever I take any point and create a circle within epsilon, no other point will be existing. Then I can definitely say this as outlier. Okay, this as outlier. These are the basic differences between all these particular points. Okay, now in DB-scan clustering, what happens is that based on density, based on density in various regions, we can actually group based on these core points, border points, and outliers also. Now let's consider this specific example here. Why this red point is marked as a core point? Because if I draw a circle with some epsilon value, let's say this is my epsilon value that I'm going to consider, or I can also use some other red point over here. Let's say if this is my epsilon. Now within this epsilon, you will be able to see there are at least 4 number of minimum points: 1, 2, 3, 4. So if this satisfies this condition, so sorry, it is 1, 2, 3, 4. Okay, we can also combine this specific point and we can also count it. Okay, so if that many number of minimum points are basically present, I will mention this as a core point. Okay, let's say why this is also marked as a red point, because if I probably draw a circle, right, over here also you can see 1, 2, 3, 4. So 4 minimum points is basically present. So that is the reason why we are marking this as a red point. Similarly, let's say whether this is also a red point or not. If I probably draw a circle with the same epsilon, 1, 2, 3, 4 is basically existing, right? So that is the reason why we basically mentioned this as a core point, right? Now let's go ahead and see with respect to this specific border point. Now here, this is nothing but this is my border point. This is my border point, right? And if I probably consider this is my core point, right? And finally here you'll be able to see this is my outlier point, right? Outlier. Okay, so or I can also say this as noise. Noise basically means outlier only. Okay, so this is completely noise. So this outlier I can also mention it as noise. Okay, super important. Okay, so here why we are calling this as a border point. See, when we draw this particular circle, you know that minimum number of points are 4, but here within the circle I just have 2 points, 1 and 2, right? So here this particular condition is also not getting satisfied, so I'm marking this as a border point. Similarly, I'm marking this as a border point. Okay, now based on this, what will happen? Different similar clustering will basically happen. Border point will be clustered in a separate way. This core points will be clustered in a separate way, and noise and outliers is going to skip from that specific data. So one important thing with respect to DB-scan clustering is that it even though your data will have noise, your DB-scan clustering will be able to handle it in an amazing way, right? So this is the major advantage with respect to DB-scan clustering. Okay, now let me go ahead and show you some of the examples like how the clustering will basically happen, and here you'll be able to see this technique that we are specifically using in DB-scan clustering. This will also be able to handle non-linear clustering also. Okay, non-linear clustering also. So let me just show you some examples and see some kind of outputs directly and how it looks like. Okay. So guys, now let's go ahead and try to see some of the examples, after we apply DB-scan clustering on a specific data, what kind of groups we will be able to get, And both these images have been taken again from Wikipedia as a source. Again, a huge shout out to Wikipedia for this amazing resource that they have actually provided to the entire world, right? Now over here, you'll be able to see that, in the left-hand side here is one specific image. And this is basically saying DB-scan can find non-linear separable clusters. This data set cannot be adequately clustered with k-means or Gaussian mixture or EM clustering. Okay, these are some of the other clustering techniques. Now here you can see that all these points that are actually present over here, these are nothing but these are my noise. Okay, so with the help of DB-scan clustering, we will not be taking up any noise data, right? So it is being able to separate completely the noise data, right? And these are data points that you will be able to see that based on that particular core points and border points, it is being able to group it, right? Similarly, here also a non-linear structure approach is also there, not non-linear, because it is completely in a different shape, right? So this is the output that we usually get with DB-scan. The second example is quite interesting over here. Now see, in the left-hand side, when we have this specific data, if we try with k-means clustering or if we try with hierarchical mean clustering over here with respect to this specific data, here you'll be able to see that it is not able to group together. It is just considering all these things within a single cluster, and even it is taking all the outliers. But after we apply DB-scan clustering, here you'll be able to see that we are getting specific different kind of groups, right? So as said, for non-linear data, it is being able to work well. So here you can see one group is basically getting categorized over here. This is my another group. This is my third group, fourth group, fifth group, sixth group, and there are also some points that has been left out over here, which is basically an outliers, right? So at the end of the day, when we are applying techniques which are related to the core point, border points, and outliers, we will definitely be able to get this amazing clustered groups. But always understand that at the end of the day, we have two important parameters. One is the minimum points and one is the radius. So in the practical example, I'll try to show you how to do with an sklearn library, and we'll try to perform this DB-scan clustering by initializing some minimum points and epsilon values as radius, and we'll try to then see in a visualized manner that whether we are able to get some good number of points or not. Okay, and we'll also be discussing the advantages and disadvantages with respect to DB-scan clustering, right? So yes, I will see you all in the next video, but I hope you have understood how does our output looks after we apply DB-scan clustering. So yes, I will see you all in the next video. In this video, we are going to discuss about the advantages and disadvantages of DB-scan algorithm. Okay. Now, here I've completely displayed the Wikipedia page. The reason is that because it has covered almost all the points, I don't have to write this particular point again. I'm just trying to save some amount of efforts. But just by reading these advantages and disadvantages, you'll be able to understand. And each and every point, I will also try to make you understand if there is any kind of confusion. Okay. So first point to go ahead with is that DB-scan does not require one to specify the number of clusters. That basically means like how in k-means we specify number of clusters. Like that in DB-scan we don't have to do it, because in DB-scan we have core points, we have border points, we have outliers or noise, and based on this all the points, it will be able to do the clusters properly, which we have already seen in the diagram. Okay. Here also in this particular Wikipedia, here you'll be able to see this particular part. See, all these clusters is made together, right? This entire red points are clustered together because these all are core points, right? And these are my border points, right? So similarly, we don't have to specify any you don't have to specify the number of clusters in short. Coming to the second point, DB-scan can find arbitrary spaced clusters. It can even find a cluster that is completely surrounded by a different cluster due to the minimum points parameter. Now, what does this basically mean? First of all, here in the right hand side, you can see that we have got a DB-scan clustering, and it is completely in a non-linear separable clusters. You can also get a linear separable clusters, and you can also get clusters which may look something like this. Let me just show you. Suppose I have some data points which may be looking like this, and let's say these are one clusters like this. Okay. And within this, you may have another point which may be having another cluster which may look like this, right? So it will also be able to create this kind of clusters also, right? So that is what it is basically saying. You can even find a cluster completely surrounded by, because we use something called as minimum points parameter. So in this case, we will be using minimum points parameter and epsilon because of this two, and obviously because of the functionalities of core point, border point, and noise point, we'll be able to get this specific kind of clusters also. Coming to the third point, it is super important. DB-scan has a notion of noise and it's robust to outliers. Since it is being able to detect all the outliers over here, and it is not taking it as a part of the specific cluster, it is basically robust to outliers. Super important point with respect to anything if you really want to understand. Okay, and that is one of the most important properties. Like if you have an outlier, I would suggest always go ahead with DB-scan. Okay, DB-scan requires just two parameters and mostly insensitive to the ordering of the points in the database. Okay, this is just a simple definition. It is mostly insensitive to the ordering of the points. Coming to the last one, fifth one, DBScan is designed for use with database that can accelerate reason queries using R-tree. Okay, so probably there's a new amazing technology that's probably coming up, a new amazing subject. It's called as graph knowledge. There, probably DBScan will definitely be getting used. Okay, so it is used for designed for the use with the databases that can accelerate reason queries, because common queries that is being basically pulled up, we can directly pick it up from there and we can retrieve it to the user, so that it will be very much faster. And obviously, one of the important thing is graph knowledge. If you know about graph knowledge, if you know of some of the concepts with respect to graph knowledge, DBScan will definitely be getting used. The parameters, minimum points, and epsilon can be set by domain expert. As I said, that these are kind of hyperparameters. So with the help of a domain expert, we can basically set it up if you have understood the data properly. Okay. Now these are some of the advantages. Now let's go with respect to disadvantages. DBScan is not entirely deterministic. A border point that are reachable from one cluster can be a part of the other cluster. Okay. So what does this basically mean? Let's say that I have a border point over here. Okay. Let's say let me go over here. Let's say I have a border point over here. This border point can be the border for this cluster also. It can also be the border for this cluster also. Right. So this kind of scenarios will definitely be there. So DBScan, that is the reason it says that it is not entirely deterministic. Okay. This is one of the disadvantages that you can basically see. Okay. Now let me drop this so that you'll be able to understand more points. The quality of the DBScan depends on the distance measure. Okay. Distance measure used. Right now, most of the distance measure that we use is something called as Euclidean distance. But as we keep on changing the distance measure, if it is Manhattan distance, and there's also another distance measure which is specifically called as region query. Okay. Okay, region query is a function which takes that distance. So there is also different distance measure like Manhattan distance, Euclidean distance. If we change that distance measuring parameter, then we may have a different quality of clusters. We may have different kind of clusters, and because of that, the quality of the DBScan may vary. Okay, DBScan cannot cluster data set with larger differences in densities. Now, what does this basically mean? Let's say I have some data points, and let's say over here, I'm just going to draw it. Let's say some of the data points over here are densely available. Let's say these are densely available over here, and some of the data sets may be the density may be a little bit more, right? So like this, or let me take another example with respect to this, and some will be like they may have higher densities like this. So if we try to apply DBScan for this kind of data, it will not be able to cluster the data, because why? Because we use a minimum threshold that is radius, right? Epsilon, right? So it will not be able to cluster the data which has varying densities. Okay, varying densities. And this particular thing, you'll be able to see that there is a varying density. In this, all the other points will be within epsilon, but in this, some of the points may become outliers, and some of the points may even become a border point. Okay, so when you have this kind of scenarios, DBScan will not be able to perform well. If the data and scale are not well understood, choosing a meaningful distance threshold epsilon, it can be difficult. So if your data points, let's say F1, F2, F3 feature, right, and we don't know the scale that is basically used to measure all these things, at that point of time, your epsilon value will be a difficult task to select. So usually what we do in this case, we standardize our data set, right, even though we don't know the scale, just to overcome this particular issue. Okay, so I hope I've covered most of the points with respect to this, and I hope you've got an idea about what are the major advantages and disadvantages with respect to DBScan. Yes, in the upcoming videos, we're going to see some practical implementation. I'll see you in the next video. Thank you. Hey guys, in this video, we're going to implement DBScan clustering algorithm with the help of Python and sklearn. So probably if you go and search for sklearn DBScan, you'll be able to see the algorithm that we are specifically going to use. Okay, so we are basically going to use this, and obviously we have completed with respect to understanding the theoretical implementation, and we have understood what is this epsilon, what is the border point, and what is the code point and all. We have understood the differences. So what I'm going to do, I'm going to show you an example how we can basically implement the DBScan algorithm. And first of all, let's go ahead and import all the libraries. I'm going to import the DBScan. Okay, then from sklearn.datasets, I'm going to import one new technique of creating our data, which you probably don't know, or I'm not shown somewhere as such. So here it is. And then I'm just going to import matplotlib.pyplot as PLT. Okay, as PLT. And then apart from that, you can also probably import this matplotlib with inline, right? So once we do this, so we'll be able to display this in the Jupyter notebook. Now, in order to create or use this make moons, so the make moons basically means it will try to show you your data set in the crescent format, right? Like moon format, right? Moon shape format, sorry. So suppose if I write x, y, and probably if I use this make moons, so here you'll be able to see how many different features are there, like n underscore samples and all. Let's say that my number of samples that I'm probably going to consider is somewhere around 100 or 250. Let's say I'm just going to make it as 250. Let me say that, okay, the noise is somewhere. I'm also going to add some noise, so that noise is just like some outliers, and I'm just going to keep it a little bit, so that we'll try to see how my data set would look like. But at the end of the day, it will make two interleaving half circles. Okay, so yes, if I probably execute it, and if I probably see my x value, you can see two features are there. So it is going to create two half circles. So probably if I write plt.scatter with respect to x of 0, colon, comma, and my second feature, which I will probably write x of colon, comma 1, and probably my color, if I don't use color, right now my data set will look like this, but if I probably use color with my y value, it will look something like this. So what I will do is that with the help of DBScan, right now I need to basically cluster this particular data point. So in DBScan, we'll just use one important thing that is specifically called as epsilon, and with the help of epsilon, we can definitely construct the entire, we basically can cluster these data points. Again, for first step, whenever we do, first of all, we are going to do feature scaling, and here we are just going to apply standard scaling. Okay, and then I will say from sklearn.preprocessing import standard scalar. Okay, and then I will just say scalar is equal to standard scalar. I think we have done it for many number of times. Scalar, not worries. Spelling mistakes happens, so no need to worry that. And then finally, I'll just try to make my x underscore scaled, and here I'm just going to say scalar.fit underscore transform as my x. So finally, you'll be able to see x underscore scaled. Here is my scaled data points. Okay, now this is done. Now what I'm going to do, I'm just going to apply my DBScan with some epsilon value. Let's say I'm just going to apply epsilon is equal to 0.3. Okay, and this I'm just going to assign it to DBScan. And once executed, then all I have to do is that just write DBScan dot fit on my x underscore scale, right? Oh, okay, this is not capital, this is small. Okay, so finally you can see over here, I'm able to get my DBScan with respect to this. If I probably write DBScan dot labels, here you'll be able to see all the labels that you're able to get, right? Zeros and ones, right? So with this epsilon, it is trying to categorize this into two different labels, right? Based on the data points that we have. Now, all I will do is that I will again plot this quickly, and then we'll try to see to it. Okay, so here I'm just going to copy this. I'm going to paste it over here, and we'll try to add one color points. It will be C is equal to, and then I'll write DBScan, okay, DBScan dot labels. Just try to plot it. Now this is how amazing it looks, right? And probably if I try to see it with the real data points, again, I don't have to put this because we don't know what will be the output. But in our case, we know how it is looking like, right? So here is my y, and it looks almost same, right? So DBSCAN is being able to cluster the data points pretty much efficiently based on the theoretical concepts that we have learned. Now similarly, you can do with any number of features, any number of data sets. Again, you can play with this epsilon value. With respect to Szilard scoring, I will try to probably use different epsilon value and try to see that how my Szilard coefficient score is, and then probably I can decide based on the epsilon value itself, right? So yes, this was the implementation of DBSCAN algorithm. I hope you're able to understand this. I will see you all in the next video. Thank you. So guys, in this video, we are going to discuss about Szilard clustering. Now, already in our clustering algorithms, we have covered something like DBSCAN, we have covered k-means clustering, hypermean clustering. Let's say with the help of k-means clustering, right? Let's say for a specific problem statement, in the k-means clustering, we have selected the k value is equal to 4 with the help of elbow method, right? Now, how do I validate this specific model, or this k value is super suitable for this particular problem statement, right? How do we validate that k is equal to 4 will actually give us the best results, Similarly, let's say if you have considered any supervised machine learning algorithm like classification problem statement, okay? In that, we will be using some performance metrics, right? What kind of performance metrics we'll be using? We may be using things like accuracy, we may be using precision, recall. And why we are using those performance metrics to basically validate this classification model, right? To see whether my model is performing well or not. Similarly, Szilard scoring is one amazing technique which will actually help you to validate the unsupervised machine learning algorithm like k-means or hypermean clustering. Okay, so we'll try to understand what exactly is Szilard clustering, how do we basically apply it, what are the steps over here in understanding or in getting the Szilard score. Okay, so here is all my steps. This is my first step. I will discuss about it and provide you all the examples. Second step, and finally, this is my third steps, right? So let's go ahead and let's understand over here. Now, the first step says that for every data point that belongs to C of I, now let's consider that this is my cluster. Okay, and in this specific cluster, I have all these data points. Okay, these are all my data points that are present inside this cluster. Okay, now the first point in Szilard scoring or Szilard clustering, it basically says that for every data point I belongs to C of I. Let's say this is my C1 cluster, and within this particular cluster, I'm just going to consider a point that is this specific point. Okay, let's consider this is I. Okay, we are going to compute the distance, and this distance will be the distance. And we can also say this distance can be the average distance from this particular point to all the other points that are present in this cluster. Okay, so that is what this first statement says. For data point I belongs to C of I, data point I in the cluster C of I, let A of I. So here we are basically computing A of I. And A of I is nothing but it is the mean distance between I and all the other data points in the same cluster. Okay, so that is the reason why we are dividing by 1 by C of I minus 1. By minus 1 because I'm not computing the distance from this particular point to itself, right? So that is how we basically compute A of I by using this specific formula. Okay, please remember this formula. In short, what we are doing, we have just considered one cluster, we have taken one point, and from that particular point, we have computed the distance with average distance with all the other points, right? So we have done the summation of all the distances and then divided by total number of points minus 1. Okay, so this is the first step. And by this way, we will be able to compute A of I. Okay, now let's go to the second step. In the second step, it says that we then define the mean dissimilarity of I to some cluster C of J. Let's say that this was my cluster over there, and this was my point. Okay, let's say this is my C1 cluster. Now, the first step what we did is that from this particular point, we computed all the average distance, right? Like this. And we computed A of I. This is perfectly fine. Now we'll go and compute B of I. Now, what exactly is B of I? What it will do is that we'll take the nearest cluster from this particular cluster. Let's say this is my nearest cluster, C of 2, which is very near to this specific cluster. There may be other clusters also. There may be other clusters that may be available over here, but the nearest cluster is this specific cluster. Let's say this is C3. Now, let's say here we also have some data points. Now, what we are going to do in the second step is that from this particular data point, right, for the same data point that we use in the cluster 1, we will try to compute the distance. And this distance will again be the average distance, average summation of the distance, right? So here what we're doing, we're just computing it. And by this, what we'll be getting, we'll getting D of I, right? Minimum J equals to I, that basically means which is the nearest cluster over here. And we are trying to find out the average distance from this particular point to all the other points that are present in this specific cluster. And by that specific way, we will be able to get D of I. Okay. Again, let me repeat all the points. We then define the mean dissimilarity of point I to some other cluster C of J. So this will be the nearest cluster as the mean of the distance from point I to all the other points in C of J. So for each data point I belongs to C of I, we now define B of I. This minimum is basically used because we are going to consider the minimum, the nearest cluster which has the minimum distance. And from this specific point, we can go ahead and compute the average distance of all the other points. That is the reason why we are dividing by C of J, because that many number of points are present inside this particular cluster, right? So in this particular case, this will be my C of I and this will be my C of J. Okay. So in this particular case, I will be getting D of I. Now, obviously, from this particular scenario, what observation we can definitely take out that A of I is definitely going to be D of less than D of I if my clustering is done well, right? Obviously, if my clustering is done well, whatever A of I am getting from this, the distance over here, it will obviously be less than D of I, right? If D of I, if A of I is greater, that basically means the clustering will not be done well, right? Obviously, the clustering if it is not done well at that point of time, we will be getting A of I that will be more than D of I, right? Now let's go to the third point, which is a super important point. Then we calculate the Szilard score, right? So then we calculate the Szilard score, and the formula is very simple: D of I minus A of I maximum by A of I comma B of I, right? And whenever this particular formula we basically apply, our value of Szilard score will be ranging between 1 minus 1 to plus 1. If the more near to plus 1, again I'm going to write more near to plus 1, better clustering model we have created. Better clustering model we have created. Okay, so here you can basically see B of I minus A of I, this one will be getting the value between minus 1 to plus 1. We can also write this equation like this: 1 minus A of I divided by B of I. Here, if A of I is less than B of I, we'll be getting some values. It will be 0 when A of I and B of I are equal. And if A of I is greater than B of I, then obviously we're going to get this specific value, which will be towards minus 1, right? So from the definition, it's clear that we'll be getting the specific value, right? Now, in this particular case, if A of I is less than B of I, then we know that our value will be nearer to 1, approximately equal to 1 or nearer to 1. If A of I is greater than B of I, then this will be moving towards minus 1, right? So that is what you'll be able to see. You'll be getting the negative values over here, and here we'll be getting the positive values, right? So this is how we use for validating the model. So it is a super important concept in Szilard scoring. Again, let me repeat. In the first step, take a specific cluster. Let's say these are my points, and then with respect to this particular points, what we do, we calculate the average distance. We will consider this. We'll calculate the average distance. Once we calculate the average distance, we are basically going to find out D of I. Then in the next step, we take up another cluster, and from that same point, we will try to calculate the average distance to the other points in this specific cluster, and we compute D of I. Right? The formula is basically given. And then Here you'll be able to see once we apply the select score formula, we'll be getting the value between -1 to +1. The more the value towards +1, the more the better model, the more better the clustering model has been created. If you're getting the value near to -1, that basically means B of I is greater than B of I. So definitely there is something wrong with respect to your clustering model, right? So this was an idea about the entire select clustering. In the next video, we're going to see some practical implementation, and we'll try to see that by applying K-means clustering, are we able to get, are we able to validate it with the select score or not? Okay, so that I'll be covering in my next video. Thank you. Hello guys, so we are going to continue the discussion with respect to the unsupervised machine learning, and now we are going to continue the series of unsupervised machine learning where we are going to focus more on implementing anomaly detection. Now, whenever we talk about anomaly detection, it basically means to detect outliers, right? Now, when we consider outlier as a very important parameter while solving a specific problem statement, that anomaly detection is the use case that you really need to focus on, right? Now, over here, I've just given you some examples, but let me just give you a small real world examples. Let's say, your bank account is over here. You are probably present in India right now. Now, if someone tries to use your user ID or your password or your phone number from a different location altogether, right? Let's say they want to use it from outside of India, then suddenly you get a message from the bank saying that someone is trying to log in into their account. Not only that, your Gmail account and all. So how it is being able to determine that, it is very much simple. It is just considering that some outlier event is basically happening, some anomaly event that is basically happening. And usually when we talk in terms of security point of view, this is very crucial statement itself, right? Now, just to talk in a simple point of view with respect to an outlier, let's consider that I have two features like height and weight. Now, in this particular feature of height and weight, what we do over here is that all these are the data points, but this data points that we see over here, these are basically kind of outliers, right? Now, outliers can play a very, very important role for a specific problem statement, and it can also not play a very important role for some specific problem statement. Like, let's say that I want to detect whether the person is having cancer or not, right? So not every person will have a cancer, only some number of people will have a cancer. So in this case, this person who's having a cancer can be considered as an outlier, and it is very crucial for a specific problem statement, right? So similarly, wherever we are trying to predict or we are trying to find out that specific outlier that may be very important for a specific problem statement, that is where anomaly detection comes into picture. Okay, one more basic example with respect to bank account I've actually told. You may be also getting a scenario that for a specific I need to probably find out which all IPs from a list of IPs are basically a kind of a fake IP or hacking IP. Something that can happen. Let's say a hacker may come from some other kind of mediums. They may try to hack some kind of servers. So from what IP it is basically coming, can we find out that it is an anomaly or not? All those things we will be able to do it. Right now, in anomaly detection, again, understand we need to detect outliers, but this outlier can play a very important role. One more example I would like to give you, and recently I know everybody sees IPL, right? Indian Premier League. I think you are fond of cricket, okay? Now let's say in IPL there are 20 overs, okay? I just create a random data. In the first over, the team is scoring 15 runs. In the second over, the team is scoring, let's say 10 runs. In the third over, the team is scoring 12 runs. In the fourth over, let's say that I write by mistake over here, the team is scoring 100 runs. Is it possible? It is not possible, right? Because see, in this case, maximum how many runs you can basically score in an over? It is 36, right? If something greater than 36 is coming, obviously, by using a different anomaly detection technique, I can actually be able to find out, yes, this is a specific outlier, or this is completely unique from all the other overs. So this kind of uniqueness, I really need to find out from a specific data, right? So in anomaly detection, you're going to see 2 to 3 types. Okay, the first type that I'm actually going to focus on is basically called as isolation forest. Okay, isolation forest. Now this isolation forest is again an anomaly detection technique, and internally over here you're going to use decision trees. Even though this is an unsupervised machine learning, but you are going to use the decision trees for some specific purpose. Now let's understand for what purpose you will be using it. Okay, now let's consider that I have this F1, F2 feature. Okay, and I have a lot of data points, something like this. Or I'm just considering 2 features, or I can have multiple features over here, F3, F4, like this. Okay. Now what does isolation forest basically say with respect to anomaly detection? This basically says that what we will do is that we will try to create. Okay, and let's consider that I have some specific data points like this. Okay, so let's say I have some specific data points, something like this, and I have one more data point over here, one more data point over here. Okay, now let's consider this is just for F1 and F2. Now, just by seeing this, because see, I can consider this as one cluster, right? But this 2 data points are completely different. I may also have some cluster of data points which looks over here. This I'll not consider it as outlier because this is a specific cluster itself, okay? But when I talk about this particular data point and this particular data point, I definitely can see that, okay, this is a kind of an outlier over here, okay? Now, what does isolation forest basically say and how we are able to determine this data point as an outlier, okay? So internally, isolation forest, it will try to create decision trees, okay? By considering various features, and it will try to split it. And a split will happen in such a way that for every node, for every data points, it will try to go ahead and create a leaf node. Okay, for every data point, right? For every data point, the leaf node will get created. Now, imagine one thing very important over here. Okay, very, very important. Let's consider that I have this outlier over here, right? This data point. Now, in order to find out this particular data point, I will also remove this so that I can make your understanding very easy. So by decision tree, what we'll try to make a split something like this. As soon as I make a split, I know that I'm able to get one leaf node over here, and this particular leaf node can be for this particular data point, right? Now, this data point is obviously an outlier, right? And for every data point, similarly, we'll try to go ahead and create a leaf node with respect to any number of splits that may happen. Okay. But understand one very important thing is that how we are able to differentiate it with respect to the other points, right? Why I'm not considering this as an outlier, instead I'm considering this as an outlier, because this is an isolation forest. Isolation forest basically means I'm going to make this particular data point completely isolated. Isolated basically means separated, right? Now in this case, in this point, I'm getting this particular point over here, so it is completely isolated as a leaf node. Isolated as a leaf node. Now why I'm saying this as an outlier, because I'm able to isolate this data point very, very much quickly. Just let's say in this case, just in one split, I'm able to isolate when compared to all the other points over here. For all the other points, again, I may go ahead and make a split something like this. I may go ahead and make a split something like this, right? So over here you can see that the density is also high, and over here group of data points will also be available, right? So I'm getting a generic group of data with respect to all the other splits. But in the case of an isolated data point, I'm able to quickly get it. Let's say if another data point is over here, this also I can isolate it by making a split. So this can probably be another leaf node which can actually belong to this. So this point can also become isolated, right? Now in order to find an outlier, it is very much simple is that how quickly we are able to isolate them. The path that we are following, in this case it is one path, in this case it is 2 paths. We are able to isolate both of these data points. And when we are able to isolate this very much quickly, this and this data points are considered as an outliers. How to construct a decision tree and all, we have learned about it. The entropy, gain, impurity, everything, information gain and all. Now here, I'm specifically not saying decision trees because here we are creating isolated trees. Again, the term over here, I'm going to mention it as isolated trees. Why we are saying it as isolated trees? Because we are isolating this data point. Okay. But how to measure this path and all? For that, a simple mathematical formula is basically given. Okay. And for this, like for every data point, right, we will go ahead and compute the isolation score. Okay. I'll not say isolation score, but I'll just go ahead and compute the anomaly score. Okay. Like if I say that, okay, for this particular data point, what is the anomaly score? Why you're considering that as an outlier? For this data point, what is the isolation score? For this data point, what is the isolation score? And if it crosses a specific threshold, we consider that as an outlier. Very simple. If you know about the decision trees, I think this will be super easy for you all to understand. Okay. Now let's talk about the mathematical formula that we specifically use. Mathematical formula that we specifically use to compute the anomaly score of a new point. So I'll write over here, compute anomaly score for the, so sorry guys, this is anomaly. Okay, it's not anomaly. Sorry about that. It's something written as anomaly. Okay, sorry for the spelling mistake. This is also anomaly. Okay, now how do I compute the anomaly score for a new point? Very simple. If I consider this new point, let's say this new point, I'm going to consider this new point. I'm going to go ahead and compute the anomaly score. I'm going to consider this as a new point. I'm going to go ahead and compute the anomaly score. Very much simple. Okay. First of all, the notation that I'm going to write is in this way: S of x comma m. Okay. What is m? I will just talk about it. M over here basically means sample size of the data points. Sample size of the, or I can say number of data points. Just simple way. Number of data points. Okay. So this is my m. Okay. Now considering with respect to the x, what is x? X is nothing but for which data point I want to compute the anomaly score. So here I will just write it as data point. Okay. Now this formula is basically given to compute the anomaly score as 2 to the power of minus e to the power of h of x. I will talk about what is h of x divided by c of m. Okay. So it is something like c of m. Okay. C of m. I will talk about this notation, but let's talk about it one by one. Okay. First of all, what is h of x? H of x is nothing but the average search depth for x from the isolated tree. I told you, right? Whenever we are computing, right, what we will compute? The path. How quickly we are able to get to this isolated leaf node. If I'm able to get it in just one depth, like one path, right? So I will just say the depth is only one, right? Then if I'm able to get isolated in 2 depths, so I will just go ahead and write 2. So that is what this h of x basically gives, okay? And e of h of x will be that value where it is basically calculating the average, okay? So here I will write it as e of h of x, okay? Then similarly, c of m. What exactly c of m is? It is basically saying average value of h of x, or I can also say average depth of h of x. Now, what is the difference between it? First, I was just computing for only the x data point. What is the depth? Average data point, right? And like this, a lot of isolation trees will be created, right? A lot of isolated trees will be getting created, right? If I probably select different features, a lot of isolated trees will get created like this. We will just not be dependent on one tree. If I'm using isolation forest over here, we will be having many trees. And for every tree, the path may be different for an isolation forest because based on the features, I can split it and however I want. If I have 4 features, I can start with F3 feature, I can start with F4 feature. Okay, so based on that, multiple different isolated trees will be there. So the first thing, what is the average search depth for X from the isolated tree? So let's say over here it was just one path, over here it was 2 paths. In the third tree it can be 4 paths, 5 paths, something like that. 5 depth path, I'm saying. Okay, depth 1, depth 2, depth 3, like that. I will try to calculate the average of all those them, and then I will get the E of X of value, E of H of X value, right? Now similarly, if I say with respect to every data point over here, right? What will be the depth? Let's say for this particular data point 4 is the depth, for this particular data point 5 is the depth. Right here we are not going to consider X in C of M. We are going to consider for every data point. So then we'll just try to go ahead and calculate the average depth of H of X in all the isolation tree, right? Now, my simple understanding will be that if I'm able to find out the outlier, this E of H of X will obviously be very less than C of M, right? So my S of X comma M that I probably calculate, this one, it will be approximately equal to how much? See, if this value is very much less than this, so this divided by this will be a very small value, right? And if you probably use 2 to the power of minus of that small value, right, you are actually going to get, like let's say if it is 2 to the power of minus 0.5 or minus 0.1, minus 0.2, like small values, it will be approximately equal to 1 or very much near to 1. So then we can basically say the anomaly score is very good. The anomaly score. So this is what is my anomaly score is. And if it is coming very much near to 1, then we can consider that as an outlier. Obviously, we need to define a threshold. See, let's consider that we define a threshold that anything that comes above 0.5, this threshold can be played off, right, with different value. If it is greater than 0.5, it will be considered an outlier. And we know that if E of H of X is very less than of C of M, then this particular value will be approximately equal to 1. Okay, and vice versa, if this E of H of X is greater than C of M, then my H of X comma M will be approximately equal to 0.5. Okay, or less than 0.5 also it can be. So then we will just consider that this is a normal data point. And this is how we basically go ahead and probably calculate the isolation forest, right? So this was the entire idea behind anomaly detection. All we are doing is that internally we are creating many isolation trees. The only difference between isolation and decision trees is that in isolation tree we are isolating each and every data point separately, and just we are seeing that how much time or how much depth it is probably taking us to receive or to come to that particular isolated point. And just by using this specific formula, this mathematical formula, we can basically find out whether a data point is outlier or not for a specific problem statement. Okay. Now let me show you a practical example with respect to the isolation tree. So here is the isolation forest anomaly detection. Now here I have considered a healthcare data. So this data is probably hidden, okay, because of the security issue. Now with respect to these 2 features that I have, okay, so let me just clear all the outputs so that you will be able to understand it. Okay. Now first of all, I will go ahead and read this healthcare data. Now this healthcare data has 2 features. Okay, and these 2 features are specifically talking about some kind of disease. Okay, every person will not have a disease. Okay, this can be too specific, any body specific. You can see any parameters which will determine that specific disease. Okay, so here I have 2 specific features over here. Very much simple. Right. Now with respect to this 2 specific feature, not every person can have a disease. Right. Only that outlier things that are probably present, that person can have a disease over there. Right. So what we'll do for this particular thing, right? Internally we'll try to create an isolation forest, multiple isolation forest, and then we'll try to predict. Okay. Now first of all, if I just go ahead and import matplotlib and just see the data set. So here is how my data set looks like. So here you can see this data points, if it is grouped together, you can say that these all are normal data points. This is basically talking about that specific feature in this data set. You may be thinking, why it is like that? The data set is designed in that specific way. All this group of points that you will be seeing, right? These are almost normal data points for a normal healthy person, right? And these are outliers looks for the the person may have a disease and all. But out of this all data points also, right, we cannot just come to a conclusion that everybody will probably have a disease or kind of thing, right? So what we will do, we will try to perform anomaly detection out of all these data points, which are the kind of outliers that you feel that we can probably have a look onto that specific patient. Okay. So for this, again, if you go to sklearn.ensemble isolation forest, we use this. Please read this. Okay, this is super important. Isolation forest algorithm returns the anomaly score of each sample using the isolation forest algorithm. The isolation forest isolates observation by randomly selecting a feature and then randomly selecting a split value between maximum and minimum values of the selected features, and this recursory partition will happen unless and until we get a terminating node or leaf node. Okay, so this all information is there. Now here you can see it is basically talking about n estimators. There is something like max samples, like how many features I have to probably consider, and one more parameter is something about contamination. Okay, so contamination over here, if you probably go and see, right, the amount of contamination of the dataset, that is the proportion of outlier in the dataset used when fitting to determine the threshold on the scores of the samples. Okay, if auto the threshold is determined as in the original paper, if float the contamination should be in the range of 0.5. So we'll try to put the value between 0 to 0.5 to make sure that through this we are also able to provide some threshold value, because above this it will be considered as an outlier. Okay, all those things are considered. So here I've written contamination as 0.1. Let me do it as 0.2. So first of all, I have imported sklearn.ensemble, import isolation forest, and then we have used isolation forest over here. Understand, this is unsupervised machine learning. Okay, anomaly detection is completely based on unsupervised. Okay, so here I've written contamination as 0.2. So anything above 0.2 I will be considering it as an outlier. Then cl.fit of df and cl.predict, and this way I will be able to get my predictions. So morning will be there. Don't worry about that. So here you can see wherever I'm getting the value as ones, these are basically normal data points. Wherever I'm getting the value as -1, these are basically the outliers, like how we did it in the DB scan. Okay, and then I will go ahead and import numpy, and I'll say wherever the prediction is less than 0, just get the index, and here is what is my index. Okay, so here I will write it as index outliers. Okay, so these are my index over here. Okay, so 4th, 20th, 24 index will be there. Okay, the next thing is that I'm converting this df.values to an array in x variable. I'm saving it, and here I will just use that same index, and now I will display all my outliers. Now see, lovely, the entire scattered plot will come. Initially my scattered plot was something like this, right? So here, let me write it as index. So let's say initially this was my scattered plot. Okay. Now if I copy and paste this line where I'm taking index comma 0 feature, first feature, and I'm saying edge color will be red. That basically means whichever will be the outlier, that is basically going to consider as red. Okay. And this is what index is basically present, because this is basically considered that are the outliers, right? Out of that. So what I will do, I will copy this over here, I'll paste it over here so that you can see it. Now here you can see all these points. These are basically considered as an outlier in this specific data point. And just by using anomaly detection, how clearly we are able to isolate them, right? And this is all possible because of the simple decision tree that we have learned, right? And like that, multiple decision trees will get created, and the same formula will be applied to do this, right? So I hope you were able to understand a simple example. When we are implementing end-to-end project, we will definitely do some kind of clustering to make you understand over there also. So yes, this was it from my side. I hope you like this particular video. I will see you all in the next. Hello guys, so we are going to continue the discussion with respect to the anomaly detection, and in this video we're going to understand like how we can perform anomaly detection using DB-scan clustering. Now I've already spoken about DB-scan clustering. We have understood the entire theoretical concept. We have understood how does clustering actually happens with respect to DB-scan, and the most important factor about DB-scan is that it is actually able to create clusters, or it is able to create groups in a non-linear separable data, and that is the power of DB-scan clustering. When we are discussing about DB-scan clustering, because of this power, or wherein you can basically create clusters from a non-linear data, there we will also be able to determine the outliers. And this outliers, if it is important for a specific problem statement, that is basically a kind of an anomaly detection application that we can probably create. So in this video, I'm again going to revise you with respect to the DB-scan clustering, whatever things we have actually discussed in the past. When I say in the past, just a couple of sessions back, and along with that, we'll also try to implement a new practical example. Okay, and then we'll try to see that how we are able to perform the anomaly detection. So with respect to the DB-scan clustering, there are three major points that everybody needs to remember. One is the core point, one is the border point, and one is the noise or outlier. Now in this particular problem statement, since we are performing an anomaly detection, this noise or outliers will play a very important role. So finding the noise and outliers in a specific data set is basically distinguishing that particular data point from all the normal points. Okay, and then whenever we talk about core points, border points, how do we determine that? I'll talk about that. But one important thing is that it is basically this entire DB-scan clustering is applied. It performs well when you have a non-linear clustering data. Okay, and there are two hyperparameters that we are specifically using. One is minimum points, the other one is epsilon, which is nothing but the radius. Now whenever we talk about the core point, when do we say a specific point, a specific data point is a core point? When the number of data points within this particular radius, within this particular circle, right, should be greater than or equal to minimum number of points. So if the minimum number of points is 4, if I probably see and count over here, combining this point, they are around 5. 1, 2, 3, 4, 5, 6 points. So it is greater than or equal to minimum points, that is 4. So we can basically call this as core point or the red point. Okay, and similarly, because this kind of points will be distinguished in my entire data set, we'll try to categorize this into core point, border point, and noise or outlier point. Now coming to the next point, that is called as bordering point. Now when do we say a specific point is a border point? When the number of data points within the radius will be less than the minimum points, that is 4. Okay, if it is less than this particular minimum points, then I will probably be getting this particular border point. Okay, so over here you can see it is less than 4. Only 3 points are over here, so we will probably categorize this data point as the border point. Okay, similarly coming to the outliers, inside this there will be no other data points within this particular epsilon radius within this particular circle. Okay, so whenever we are given this particular data points, we categorize into core, border, and noise. So here also if you see this particular example, if I'm considering minimum points is equal to 4, we are able to categorize this red point, yellow point, and the blue point. Okay, but in our entire problem statement, we will try to focus on this particular outline, because this is the point that we really need to find. We are not going to focus more on the core point or the border point. Okay, so if I probably show you an example, some example after we apply a DB-scan clustering, see in this particular left hand side, this is a non-linear cluster data point, right? Here we are able to get 2 clusters, but there are so many outliers, and this outliers data point is my anomalies, right? That's completely different from the normal data points that we specifically have. And similarly, in the right hand side, if you see, there is one image on the left hand side, and here we have actually created a group. This clustering has basically happened with the help of k-means, and this clustering has happened with the help of DB-scan. Proper clustering are happening in DB-scan, but here you're also able to get the outliers. So this is the main purpose of DB-scan clustering. Whatever things we have learned earlier, the same thing. But now let me just go ahead and probably show you a practical example. Okay, so I will just go ahead and clear all the outputs over here, and let's see with respect to the DB-scan. Now here what we are doing is that I will try to create my own data set which is completely linearly separable. So for this, I'm going to import a library which is called as make circle. I don't require this make moons, because in the previous example I'd actually given you with respect to this make moons, which will basically create a non-linear data. And then I've imported DB-scan, I've imported mat.lib, and this is my make circles, the data set that I've done. Now in the next thing is that I'll be using this make circle. The number of samples will be 750. I'm using some factors and some noise. The reason I'm using noise is that because even though I'll try to create a circle, it should have some specific noise. Otherwise, it will just be in one single line, all the points will be there. Okay. So this is my x comma y. When I execute this, I'm getting y. Okay, but I will not use this y. Okay, this y is my output feature, right? But as we suggest, right, I will just be using this x feature, and then we will try to apply the dbScan, and then we will try to find out the outliers. So if I try to plot it with respect to y, see here you can see two groups. But dbScan obviously can also find out clusters within this, and it will also be able to find out whether there are any outliers or not. Now I will go ahead and import dbScan. I'll use epsilon as 0.10, and again we'll do fit predict on x. Once we do fit predict on x, I will probably be getting all my clusters group. See over here 1 1 1, second cluster, second group, seventh group. Wherever there is a value like -1. See, this is -1. This -1 are nothing but these are all the outliers, right? So dbScan is able to distinguish this point that's completely different from the normal point. Okay, so if I go and see dbScan._labels, I'll be able to see the same point. Now if I try to do the scatter with respect to this dbScan.labels, now see, here is where I'm getting so many different clusters, right? So this is my green cluster, this cluster. But the most important thing over here is that you need to distinguish this outlier. See, these are my data points which are outliers. If I probably consider this, these are my outliers. These all data points are my outliers, right? And that is the importance of this. From all these data points, we are able to distinguish abnormal data points, right? And that is what we are able to do with the help of dbScan. So I hope you are able to understand this super amazing thing. Again, this is a very cool application with respect to the outliers and all. If I try to see the real point, my real data point was just like this. But here, with the help of dbScan and some epsilon value, I can play with epsilon value with respect to different, right? That is a kind of a hyperparameter. But here, yes, with respect to any data points, you'll be able to see the outlier. So I hope you're able to understand this particular video. This was it with respect to the dbScan, where we are specifically focusing on anomaly detection. Yes, this was it from my side, guys. I will see you all in the next video. Hello guys, so we are going to continue the discussion with respect to the anomaly detection, and in this video we're going to see how we can perform anomaly detection of finding the important outliers using local outlier factor. Now, before we discuss about local outlier factor, this is a very simple technique altogether. I really want to define two important terms. One is the local outlier, and the second one is something called as global outlier. Okay, I'll be talking about these two important terms, and we really need to distinguish this, right? In our previous videos, we have learned about dbScan clustering and how it can basically be used to find out the anomalies. We have also discussed about how we can use isolation forest to determine what are the anomalies, right? Now, in this data set, you can see clearly that I have two clusters of data points, right? Now, in this two clusters of data points, it is very much clear that I have two groups. Now, if I talk about this particular data point, right, you can see that both the data points are near to this particular cluster. So I can basically call both this data point as local outlier. Why? Because it is very much near to a specific cluster. Okay, but if I talk about this specific data point, this is basically a global outlier. Right? Why we are saying this as a global outlier? Because this is completely different when compared to this all data points that we have, right? Completely different. Whereas this local outliers are somewhere near with respect to this particular cluster. Now, in order to find out this kind of anomalies, it is very much easy with the help of dbScan or isolation forest, right? Because we isolate those kind of data points. But if I really want to determine this particular points that are the local outliers in a proper way, then I can definitely use something called as local outlier factor. Very simple algorithm. So we basically also say LOF, and we also determine something called as an LOF score. Okay, but the entire funda is very much easy, very much simple. Okay, the concept is very much simple, and internally this entirely uses k nearest neighbor concept. Okay, with the help of k nearest neighbor, what they will try to determine, the local density. Super important term, local density. Now let me talk about this, how this entire local outlier factor works. Let's say I've taken k is equal to 5 as my neighbors, because in k nearest neighbor also we try to find out the k value. Okay. Now what we are going to do, we will give a one point like this point, and we'll try to find out whether this is an outlier or not. Now if this needs to find out whether it is an outlier or not, what it will do, it will find out the nearest 5 neighboring points. Let's say these are my nearest 5 neighboring points. It will calculate the distance and it will do the average distance and all. Now after doing this, okay, it will keep that information aside. Then we will go ahead and consider this outliers. Sorry, this data points, not outlier, this data point, and then we will observe what is the density with respect to this particular neighboring points. So from here, every point, it will try to calculate the distance between the nearest 5 neighbor points from that particular point. So with that, we will able to get, see, anyhow when we are calculating the average distance, if the average distance is less, that basically means the density is more. If the distance is more, that basically means the density is less. So this is the funda that we can basically apply. So over here, what we are going to do, we are just going to compare the density from this particular neighboring points to this particular point. Okay. So first thing what we are going to do is that, let's say if I want to check whether this particular point is an outlier or not. So what we'll do, we'll take k is equal to 5 or whatever k value we want. We will try to find out the distance. Okay. Then we'll take all the neighboring points, and then with respect to k is equal to 5, we'll try to find out whether the density is more over here or more over here. If the density is less over here, then this can be considered as an outlier. When I say outlier, I'm talking about local outlier. Okay. Again, let me repeat it. So let's say if this is my data point, I will try to find out the k nearest data point. So let's say this is my k nearest data point. Over here, we have calculated the average distance, right? Average distance. If the distance is more, that basically means the density is less, because from this particular neighboring points, if I try to compare all these data points, these are near, right? So the distance will be less, but the density will be more because there are so many data points nearby, right? We are just going to compare the local density, whether the local density is high over here or high over here. You know, in this scenario, since there are many data points, it will be high over here. So this can be considered as an outlier. So this is the entire funda behind local outlier factor. Now this was about the theoretical intuition. I really want to give you one task, guys, because I'm not giving you task with respect to any machine learning algorithm. So local outlier factor is already available in SKLearn. We will read this, okay? Unsupervised outlier detection using the local outlier factor. Now see, every line that I read, you'll be able to understand it. So please let me read it. I've already explained you the theoretical intuition. The anomaly score of each sample is called the local outlier factor. It measures the local deviation of a density of a given sample with respect to its neighbor. It's okay if you have not understood this line also, because next you'll be able to understand. It is local in the anomaly score, depends on how isolated the object is with respect to the surrounding neighbor. Now in this particular case, if I see this particular points are completely isolated, right? This point is also isolated, this point is also isolated, right? How well they are isolated. More precisely, locality is given by k nearest neighbor, whose distance is used to estimate the local density. Okay. Now this is super important. By comparing the local density of a sample to the local densities of its neighbors, this is the most important line in this paragraph. By comparing the local density of a sample to the local density of its neighbor, one can identify samples that have a substantially lower density than their neighbors. Just by comparing it, one can identify the samples that have a substantially lower density than the neighbors. These are considered as outliers. Again, everything is same. We are using k-nearest neighbor, so here you have n underscore neighbor. The algorithm, you can see ball tree, KD tree, brute, auto, everything is discussed. I've already discussed all the theoretical mathematical intuition. Then you have this matrix Minkowski, like which parameter, like Euclidean distance, you want to use a Manhattan distance. Okay. So take a specific data set like this DV scan data set, okay, and just try to apply this local outlier factor. This will be a task for you. At least now, guys, you have learned machine learning, you know about non-supervised machine learning, you have seen so many different problem statements. I feel you should be able to do it now. Okay. So yes, this was it from my side. I hope you like this particular video. I will see you all in the next. Hello guys, so we are going to start a series on Dockers, and in this series we are going to understand how to work with containers, specifically Docker containers. We're going to understand what is the difference between containers and virtual machines. We're also going to understand what is the difference between images, Docker image and container. And then finally, once we get that in-depth intuition behind Dockers, we'll start our practical implementation wherein we'll see how we can Dockerize our entire web application or any application and probably run it as a container in any specific cloud. We'll also see that how we can convert or publish our Docker image into Docker Hub repository. So there are many things that is going to get completed, but understand Docker is super important for any developer who's working in IT company, because this actually eases the deployment process. So let's go ahead and talk about Dockers and containers in the next video. Hello guys, so in this video I'm going to discuss what are containers and why do we use containers. Now let me give you an example. Let's say that I'm not using containers at that point of time. So what is the problem that I may face while doing the development and while deploying it into any kind of server? So let's say I'm a developer, okay, I'm probably working in Windows machine. And let's say I am the only developer in my team right now, okay, so this is basically developer A, okay, and I'm working in a Windows machine. So let's say we are creating a data science application. So this is specifically a data science application that we really want to create. This is our project, okay, and in this project, obviously, to start my development process, I need to install a lot of dependencies. Let's say I want to install Anaconda, I want to install different libraries, I want to install MySQL separately if I'm using any database. If I'm using a NoSQL database, I'll be installing MongoDB, let's say. So all this installation process will take place, and I'll be installing all this exe file, and then I'll probably I'll create my development environment, and I'll start my development process. Now let's say tomorrow another developer joins my team, and I've already started the development. Okay, so now this particular developer, let's say he or she is basically using Linux machine or Mac machine or Windows machine. So let's say this is developer B. Okay, now when developer B will also join, so first thing the developer B needs to do, again, do all this installation of all the dependencies that is required to set up his or her development environment. Okay, so for his or her development environment, they also need to do this complete setup. Now let's say because of some libraries mismatch, or it can be because of some dependencies, let's say some of the installation does not go well, then what will happen? Whatever application I may have probably developed, I may have actually developed over here, or developer A may have actually developed, this will not work over here. Why? Because there is obviously some kind of library mismatch, there's some kind of dependencies mismatch over here, right? Now because of this, what may happen? My application will not run. Okay, let's say anyhow developer A has helped developer B for doing all the installation, and now it is working perfectly fine. So let's say this development team has now created a dev environment, and from this dev environment they have implemented some of the stories, and now they need to send this entire application to the QA environment. Okay, so we will basically send this to the QA environment, so the testing will start. So let's say obviously if you're sending it to the QA environment, it will be a QA server, right? So let's say over here the QA server is there. Now in order to set up this QA server, again we have to do this installation process. Okay, and let's say there was another team who was setting up the server, and they missed some of the installation and the configuration, right? They missed some of the thing. Let's say this part is basically missed. Then what will happen? This entire application may not work, or some of the modules in that application may not work, right? So some of the modules or application may not work, right? Now suddenly the QA team will start complaining, hey, nothing is working in my QA website, right? Your QA environment, nothing is working. We cannot test the application. Then developer will say that, hey, everything is working in my machine. You can see over here, all stories are working perfectly fine, right? So like this, QA and developer will be on a war, right? But understand the main issue. What is the main issue that is happening? Basically, the library installation has not happened properly. So this is the main problem over here. But anyhow, the dev and the QA team are fighting for anything. Now this used to happen before using containers. This kind of issues were usually happening whenever we really want to move our application or deploy our application in some other environment. We have to install all the dependencies and configurations manually, right? And this is a major issue because the team who is basically doing the setup, right? They may miss some of the libraries. They may not have that specific knowledge, and because of that, they may miss a lot of important mergers, or not mergers, I'll say, but important part of that entire web application or any kind of application that they are deploying, right? Now, what happens if we use containers? And this entire issue is now fixed with the help of containers. So first of all, we'll try to understand what is the definition of containers. Okay, so containers is nothing but it is a way to package. It is a way to package. Just a second. It is a way to package applications with all the necessary dependencies and configuration. So very simple definition. Containers are a way to package application with all the necessary dependencies and configuration. Okay. Now, once we make this package has a very important property. It is basically a portable artifact. What does portable artifact basically means? We will be able to easily share and move this package to any environment. Package to any environment. Super important. That basically means once we make this package with all the necessary dependencies and configuration, these are the very super important keywords, we will be able to share and move this package to any environment. Right? Now, coming to the third and the most important point. This makes the development and deployment. This makes the development and the deployment more easy and efficient. I'll not say easy, but at least efficiency will be there. Easy, why I'm saying? In terms of making sure that all the configuration are there or not. Okay, so this will definitely makes the development and deployment more easy and efficiently and in sync. Okay, super important. Sync also is very much important because all the developers will be working and they'll be able to do it in an easy way. Now let me give you a very good example of a container. Okay, let's say you're staying in house A. Okay, let's say you're staying in this house A. So this is a rented house, and then you suddenly bought a new house, which is house B. Okay. Now, when you bought this house B, you really need to shift from house A to house B. And in house A, there are a lot of things like furniture, TVs, so there are like TV, furniture, washing machine, here you basically also have kitchen utensils, many things as such, right? Many items are basically present over here. Now, if you really want to shift from house A to house B, it will not be feasible that you take each and every item, like each item, and just go to house B and just put it over there and then come back again and take the other item. You cannot take this item separately because there are chances that you may miss some of the items. So what we can do in this particular scenario, and obviously, when you are also shifting, first of all, you will take all these things. Okay, you'll take all this furniture, TV items, and you'll put it inside a container. Let's say washing machine, kitchen utensils. Okay, let's say you have bed, you have different things, clothes, right? You'll put this entirely inside a container. Container basically means you're packaging it completely, right? You're completely packaging it. You're putting it inside this. You'll put this container in one lorry or truck or some big vehicle, and then you'll slowly shift this over here. You'll move this container over here, and then you will unpack it, right? You'll unpack it, and you will again place all the furniture back to your house, right? In your house B. So you'll unpack it over here. So over here you are packaging it, and here you are unpacking it, right? So this is the same concept with respect to containers also. So in containers, suppose you are developing an application. So let's say you are developing an application over here. This specific application has a lot of, let's say this is my application. Whatever dependencies you have in this application, you will try to put all the dependencies over here. Let's say I require some Python version. Okay, I have some tools installation that I need to do. So all these packages will get installed over, will be put up over here in the form of base image in multiple layers, which I'll be talking how this will be. And this will be packaged as a container. Now once this is packaged as a container, let's say from the dev environment it is packaged as a container. Now we can take the same container, go to the QA environment. Let's say this is the QA environment. And I can run this container. We can run this container over here with all the dependencies available within this package. Run the container. So we can take this container over here and just run it. And automatically how in the dev environment it used to run, it also run in the QA environment. Similarly, we can take the same container and we can also do it for the production also in a similar way. We can also take this in the production environment and we just have to run this particular container over here also. And because of this, there will be no issue with respect to dependencies or with respect to any other packages. Why? Because we have already containerized this entire application. Okay. So this is the concept with respect to container. Now you may be thinking, Christian, what is Docker? Okay. Now let me just show you what exactly is Docker by just going to its web page. Okay. So here, what is Docker? Okay. So Docker is an open platform. See, it is an open platform for developing, shipping, and running applications. And this applications is nothing but it is just like a container. Okay. So we are going to use this open platform for doing all this process, basically packaging the entire web application, moving it, shipping it to different environments. Docker enables you to separate your application from your infrastructure so that you can deliver software quickly. With Docker, you can also manage your infrastructure in the same way you manage your application. So in short, see, Docker definitely helps you for speeding up your development process and your deployment process. Okay. You'll be also able to test it quickly and deploy your code quickly. So here it is all about Docker. We have basically discussed about the containers. But in short, if I talk about Docker, it is an open platform which will actually help you to create this kind of containers. Okay. Now in the upcoming video, we are going to see some more differences between containers and virtual machine. We're also going to understand what exactly is Docker image, and what is the difference between Docker image versus Docker container. And then finally, we'll be doing the installation of Dockers and we will be implementing some of the amazing things. We'll see how we can Dockerize or create containers through it. Okay. So yes, let's go to the next video. I hope you like this. If you're facing any issues, please make sure that you revise this. Revision is super important to understand, and always try to understand with some specific examples. It will be very helpful for you. So yes, I'll see you in the next video. So guys, we're going to continue the series on Docker, and in this video, we're going to discuss about Docker image and containers. Now, let's say that this is my entire application, and this obviously has a lot of dependencies. So let's say it has a lot of dependencies and configurations. So in order to convert this application into a container, right, what we have to do is that we have to containerize, or we can also say Dockerize this entire application. Now, in terms of container, what we do is that we basically create layers of images. Okay. Now, what are these layers of images? I'll just talk about it. So let's say I'm going to create multiple layers of images. Let's say the base image will be one Linux base image. We'll have a Linux base image, and the size will be very, very small. Again, you have different version of Linux also, which you can probably take it as a base image. And let's say in this, I have one application that is MySQL or MongoDB, right? Now this MongoDB can also be added as an image over here. Okay, so MongoDB image will also be added over here. So in short, a containers is nothing but it is a combination of layers of images. Okay, layers of images combined. So let's say if this is Linux, and then I may have some more dependencies. Let's say I may have Python 3.7 installed on that. So this will be another image which will be taking care of installing Python 3.7. Suppose if I really want to install Anaconda, so this can be another image which will also be added as a dependency in this container, right? And there can be many different dependencies and configuration which we can add inside this particular container. And all this is nothing but images, right? Now let's understand what is the difference between image and container. So if we take this entire layers of images, then this is exactly called as Docker image. Okay, super important, guys. Please try to understand the difference. This difference many people are confused with respect to image and containers. Whenever I'm creating the containers, whatever images I've used, all the layers of images with respect to all the dependencies, if I combine all these things together, then this is basically called as a Docker image. Okay, and once I take up this Docker image and probably run this Docker image, okay, if I run this, then internally what will happen is that it will first of all create a container, and this container is nothing but it is an environment. Okay, and within this environment, considering all the dependencies, it will try to run this application. Okay, it will try to run this application, right? All the dependencies will make sure that everything will get installed within this environment, and then this application will get started. Okay, now let's go ahead and list down some of the important differences between a Docker image and a container. Okay, so here, first of all, let me write it down. Here I have Docker image on the left hand side, and I have container on the right hand side. First of all, the first basic difference, if I talk about Docker image, is nothing but it is the package or the artifact, and we know that we can move or share this particular artifact or package, move or share this artifact, right? In different environments. Okay, so whatever environment, in your machine, in my machine, wherever you basically want, you can basically do it. Okay, now once I take this Docker image, and the first step, if I take this Docker image and run it, okay, first of all, what it will do is that it will actually start the application. It will start the application. So let's say it is going to start the application, and in order to run this application properly, what it will do, first of all, it will create a container, install all the dependencies within the container. This container can also be considered as an environment, which will make sure that all the dependencies is basically created in that, and then we will be able to run this entire application over here, right? So in short, this is my Docker image. Once I run it, it is in short going to create a container with all the dependencies installed over here, right? All the installed dependencies, and this is specifically the environment where my Docker image will be running. Okay, so this is the difference between Docker image and container. I hope you are able to understand this simple thing. Yeah, going forward, I know still I'm not showing you any practical things, but as we go ahead, I will try to show you a lot of practical examples. Before that, we really need to do the installation. But one important point that we really need to discuss is that what is the differences between container and virtual machines? Because we can also do the same thing with the help of virtual machine, but there's a slight difference. Okay, usually these Docker images are very small. Okay, very small, and why it is very small, we'll try to understand the reason going forward. You know, when we are going to understand the difference between Dockers, containers, and VMs. Okay, so yes, I will see you all in the next video. Now, before we go ahead and learn more about Dockers, we really need to know the basic differences between Docker and virtual machines. As you all know, Docker and virtual machine, both the main task is basically to perform virtualization. Now, with respect to any OS, like let's say that in this specific OS, the system, the Windows machine that I'm working on, if I probably install Docker, how it is going to virtualize my OS, and when I probably install virtual machine, how it is going to virtualize my OS. So both the things we are going to discuss, and we're also going to find out the main differences. Now, before we go ahead and understand the differences, first of all, we need to understand how the operating system is basically made up of, right? So suppose I take operating system, it can be Linux, Windows, or Mac, any one of them. Okay. So if I probably consider the operating system, first of all, let's say in the base I have hardware. The hardware can be CPU, RAM, anything as such. On top of it, you will be having something called as OS kernel. Okay, that is the operating system kernel, and this kernel is basically responsible in communicating with all this kind of hardware. So this is basically my layer one. And if I consider one more layer on the top of the OS kernel, we have something called as application layer. Okay, we have something called as application layer. Now, in any operating system, and this is probably my layer two. Okay, and this is what it usually happens with different operating systems. Let us consider Linux as an example, right? Now, you know that Linux, we have different variation of Linux, right? We have Linux Ubuntu, we have Linux Red Hat. You know, what is the basic differences between all these particular Linux is that their UI changes. So with respect to UI, most of the changes actually happens in the application layer, right? The kernel will be almost same, right? Now, if I consider Docker or virtual machine, which layer of the operating system it will virtualize? Okay, so let's go ahead and let's see with respect to the Docker. So I've drawn the same diagram over here. If I consider Docker, right, this Docker will be virtualizing the application layer of the operating system. That basically means Docker images, you know, will be able to communicate with the OS kernel. Okay, similarly in the case of VMs, VM basically virtualizes both the application layer and the OS kernel layer. Okay, that basically means whenever we install the VMs, at that point of time, whenever we install the VM, it will have its own application layer, and it is also going to have its own OS kernel layer. That basically means a VM is a complete separate subsystem, you can say, which has been installed in the host OS, right? So this will have their own OS kernel. Whereas in the case of Docker, it just is an application layer. Let's consider like I have a specific image. I pull that image, install it. This image will be able to communicate with the OS kernel, and this OS kernel is of the host. Whereas in this particular case, VM has its own OS kernel, and it will probably, this OS kernel will be also communicating with the hardware. So whenever you install VMs, you also need to assign some amount of resources from the system, like hard disk, let me RAM, separately to the VM. So this is the basic differences between if I talk about the Docker and the VMs. But one important point is that what is the advantages and what is the disadvantage with respect to this? First of all, if I consider with respect to Dockers, since we are just virtualizing the application layer, Docker image size is usually smaller. image size is usually smaller, right? This is a super important point. Okay. Whereas in the case of VM, if I probably consider VM, the size will be big because it virtualizes both. It has both application layer and the OS kernel layer. The size will be huge. Okay, probably in gigabytes. This may be probably in megabytes. Okay, something like that. Now, similarly, if I go with respect to the next thing, is that if I talk with respect to Dockers, right? We can Dockers container start and run much faster. Start and run much faster when compared to the VMs. Why this happens? Just imagine, guys, because Docker just has an application layer. Application layer will be communicating with the OS kernel of the host. Whereas in the case of VM, it has it has its own application layer and the OS kernel. So just to start both of them, it will definitely take time. So VM is comparatively slower. Comparatively slower. One more important point is with respect to the compatibility. Okay, now this is a super important point with respect to compatibility. We can compatibility, so we can install any VM. Any VM we can install. Let me write it down completely in depth so that you'll also be able to use this notes whenever you go for the interview. We can install VM on any OS. This is super important. Okay, on any OS. This is a very important interview question. You can install VM on any OS, so there will never be any compatibility issue. But in case of Docker images, there may be a compatibility issue. So we may find a compatibility issue. That basically means what? Let's say I have a Windows machine. Okay, let's say this is a specific Windows machine. In this, I cannot install Docker images that are of Linux. Let's say, right? So here, if I try to install and probably try to communicate with the OS kernel, this will not be possible. Yes, it will be possible if the OS kernel supports. So right now, if you consider Windows 10 and greater than Windows 10, right? This usually supports even Linux images also, Linux Docker images also. But if we consider Windows version which was less than 10, it was not supporting this. Okay, so the compatibility issue has been fixed because the update in the OS kernel has happened after Windows 7. Okay, Windows 10 and below Windows 10, it will definitely not work. So these are the super important points. The first point is that again, let me revise, is that Docker image size is usually smaller. Obviously, it will be smaller because it just virtualizes the application layer. That basically means we can just run the application layer over here and it will just communicate with the host OS. The second point is that Docker containers start and run very much faster when compared to VMs, obviously because it does not have its own OS kernel. And the third part is compatibility issue in VM does not exist, but in Docker images, compatibility issues exist. Okay, so I hope I have covered most of the points with respect to Docker versus virtual machine. Now, in the upcoming videos, we'll try to install Docker and we'll try to play with it and we'll try to do many tasks as such. So yes, I will see you all in the next video. Thank you. So guys, we have covered so many topics related to Dockers. We have understood what is Dockers, what is the difference between Dockers and virtual machine. We have understood about containers, Docker images, and many things. Now let's go ahead and start working on Docker. So basically in this video, I'm going to install the Dockers. So to begin with, Docker can be installed in different operating systems like Mac or Linux or Windows. Okay. So first of all, just go to docker.com. And if you see over here, all the information regarding Dockers is actually given. So here you can basically search for it. You can see Dockers makes development efficient and predictable. It takes away repetitive mundane configuration tasks and is used to out the development lifecycle for fast, easy, and portable application development. And everything I've actually explained with a lot of beautiful examples, right? So first of all, let's go ahead and click on Get Started. Now, once I click on Get Started, two things you basically require. One is Docker Hub. It is not compulsory, but at least we'll keep Docker Hub over here. And for this, if you want to create a sign up, create it. Otherwise, even sign up is not compulsory over here. But we will go ahead and install Docker Desktop. Okay. Now this Docker Desktop can be installed in Windows, Mac OS, and even in Linux. Okay. So first of all, here you can see all the options with respect to this. You can install for Mac Intel chip. You can also install for Mac Apple chip. I think Mac Intel chip is the older version of Mac, I guess. But now I think you have Mac Apple chips yourself. Then you also have download for Linux. So for different distribution, also you can download. So now I'll click on for Windows. Here you can see as soon as I click on Windows, here you'll be able to see that the Windows installation is basically happening. For Docker for Windows is basically happening. Okay, installation is happening. But before we go ahead and install this, okay, there are some of the important things that you really need to note down because there are some requirements whenever you need to install Dockers. Let's say for Dockers, if I really want to install on Windows, here you'll be able to see that there are some kind of system requirements. Okay, first is WSL2 backend. So what are things you basically require? It shows Windows 11 64-bit Home or Pro version, or Windows 10 64-bit Home or Pro to 21H1 version, okay, or higher, okay, or an enterprise or education. So only this kind of configuration. Like suppose if you have Windows 10 or Windows 11 with 64-bit and this is either Home or Pro version, then only you'll be able to install Dockers over here. And the other requirement is that the following hardware prerequisites are required to successfully run WSL2 on Windows 10 or 11. Okay, so you basically need to have 64-bit processor, 4 GB system RAM, BIOS hardware virtualization support must be enabled in the BIOS settings. That basically means what? Suppose if I go and open my task manager and if I probably go and click on, sorry, just a second, if I go and click on CPU, here you'll be able to see one field which is called as virtualization. This needs to be enabled. Okay, if it is not enabled in your system, then probably what you have to do is that shut down and restart your machine and continuously press F11, right? By that, what will happen? Your BIOS setting will get enabled, and from there you have to make sure that you have to enable your virtualization. Okay, so please make sure that you have this because, and again, if you're using different processor in your laptops or in your desktops, there are different ways of enabling your virtualization. Okay, so based on the type of processor, you have to actually do it. I'm having AMD Ryzen processor, so usually like over here in AMD Ryzen by default virtualization was not enabled, so I had to restart my machine, press F11, open my BIOS settings, and go over there and enable my virtualization. You can definitely search in the Google how to do it. You'll be getting a lot of articles for the same thing. Okay. Now the second thing is that by Hyper-V backend and Windows container also you can basically do the installation. So these are the system requirements again: Windows 11 64-bit, 10 64-bit. For Windows 10 11 Home, see the system requirement in WS. Hyper-V and container Windows feature must be enabled. Now what does this basically mean? If you probably go and search for let me just see over here you'll be getting an idea. So I will just go and open my Windows features. Just give me a second. So I'll just go and open it. So now if I probably go and search for Windows features, so here you'll be able to see when you turn your Windows features on and off, here there'll be something called as Hyper-V. So this needs to be enabled. Okay, and when you enabling this, that basically means that is the requirement that is given over here, right? Hyper-V and container Windows feature must be enabled, right? So I have actually enabled this part also. Okay, Hyper-V. Okay, so please make sure that you also have this particular setting done. And following hardware are required to run client Hyper-V on Windows 10. We'll learn all about this. So again, there is 64-bit processor, 4 GB RAM, and BIOS hardware. And this will basically, now again, your BIOS setting virtualization needs to be enabled. Okay, so but anyhow, if you have all these things by using this WSL2 backend also, we can actually do the entire thing. Okay, so the installation is basically with respect to Windows. Okay, now if you have these requirements, and again, you may be asking, Christian, what about the people who are having previous version of Windows? For them, how the installation will happen? So there was a tool, something which is called as Docker Toolbox. Now right now the Docker Toolbox is not there. It has been deprecated. It is not getting provided. Now for the people who have less than Windows 10 version or who's not having this matching Windows version operating system, what you can do is that you can download a virtual machine within your system, and then you have to install a Docker desktop inside that particular virtual machine. Again, it is a very tedious process, guys. So my suggestion would be that if you really want to learn Docker, definitely have this version. Again, with the help of VMs, also you can do it. That basically you install the VM in your system, and inside that VM you have to download the Docker desktop. Okay, based on the different operating system. Now this is with respect to Windows. Let's go and see with respect to Mac. So here, Mac with Intel chip, Mac with Apple chip, whatever Mac version you have. So here also you can see all the versions with respect to the Mac OS, what version it needs to be, at least 4 GB RAM, a VirtualBox Creator 2, this is required. And then in order to install it, just go and click either on this, a file will get downloaded, like DMG file, and then double click on this, and all the steps have been given over here. Okay, so just follow this particular step and do the installation. And similarly with respect to Linux, in Linux you know that we definitely have different distribution. Let's say your distribution is like Debian, Fedora, Ubuntu, or go and click on Ubuntu. Let's say it is Ubuntu. Just follow the steps. First of all, the prerequisite is that to install Docker successfully, you must meet the system requirements. Check out the system requirements. Go over here. The system requirements is 64-bit kernel and CPU support for virtualization, KVM virtualization support. This is there. Okay, some Genome or KDE desktop environment, and again, this will depend on various distributions that you're specifically using, and at least 4 GB of RAM. Okay, Docker Desktop for Linux runs a virtual machine. For any information on why Docker Desktop run a virtual machine, you can also find out a reason. Okay, so here you can basically find out this. Okay, and as said, when we start this process, this requirement this is there. Then first of all, we uninstall the tech preview or beta version of Desktop for Linux. Run this. Okay, you need to have a 64-bit of either Ubuntu Jammy Jellyfish or Ubuntu Impish Entry. Now, these particular steps you definitely need to follow to install all the things. Okay, but now let me just give you an example how you can go ahead and do it with Windows. And again, based on various distribution on Linux, you can basically do it. Okay, now in my system, I have this Windows 10 64-bit Home or Pro, so I basically have a Pro version. So I will be just clicking on Docker Desktop for Windows. Here you'll be able to see an exe file will get installed, will be downloaded. Just go ahead and click this, double click it, and just keep on pressing next. Already all the installation will happen. But before that, make sure before you do this installation, right? So virtualization needs to be kept as on, right? So this needs to be enabled over here. Okay, and that is only enabled when you restart your machine in the BIOS setting, and from there you have to enable it. Okay, guys. Once the installation of the Docker Desktop will get completed, you will be able to see a icon over here which will say Docker Desktop running. Okay, so this specific icon will be available over here. And once you go into the search bar and search for Docker Desktop and just open the specific app, here you will be seeing that this kind of app will get opened, right? And in this app, you'll be having something like containers, images, volumes, dev environment. What all are this? When we run a specific container, you'll be able to see the list of all the containers running over here. Whenever you download any images or you build any images, all the images will be shown over here. Right now, let's say that I have some images that I have actually created. So here you can see Boston_image, MySQL, and Alpine. So I have created some of the image over here. So here you'll be able to see that those image lists will be available. Similarly, with respect to dev environments, I'll be also discussing as we go ahead. Right now, yes, if you really want to run a sample container, just go and run this. But before that, let's say whether our Docker has been installed correctly or not. Just open your command prompt and just type dockers. Okay, once you type docker, you'll be seeing all these commands will be there, right? So like this, build this. If this is working fine, that basically means your Docker has been installed successfully. Okay, so with respect to Docker, if you really want to find out the version, it is very simple. Just write docker -v, and this is the current version of Docker that is installed in my system. Okay, so I hope you got an idea about how to install a Docker in Windows, in Linux, in Mac. And always remember, the first thing is that your virtualization needs to be enabled in Windows. Okay, because in previous version of Windows, initially in Docker we had something called as Docker Toolbox, but now it is not available. It is completely deprecated. So you have to do this. Otherwise, the other way is that you have to install VMs in your machine, and in that particular VM you have to install the Docker Desktop, and then probably use that. But again, there'll be a lot of configuration issues there also. So it is better that you have a Windows 10 level. Similarly, I've shown you how to do the installation in Linux and Mac. Definitely follow this documentation. This documentation is super important whenever you are learning anything, right, guys? So this documentation will be giving you all the steps that is basically required to do the installation, right? So yes, this was it from my side. I will see you all in the next video, and in the next video we are going to learn about some of the amazing Docker commands. So yes, I will see you all in the next video. Thank you. So guys, in this video, we are going to see some of the basic Docker commands, and we are going to see that how we can pull a Docker image from the Docker Hub repository and how we can run that image as a container within my local machine. Now, this video is going to be quite amazing because you're going to see some amazing commands with respect to pull, run Docker image as a container, and many more things. Now, first of all, just go to the Docker Hub, and here you don't have to even log in. You can search many of the public repositories that are present inside, or public images that are present inside Docker Hub from here. Okay. So first of all, we are going to try with something called as Docker getting started. Now here you can see there's a command. If we probably write this particular command, this image is going to get pulled from the Docker Hub, and then it will run as a container within my machine. Okay. Now, first of all, I will go and search for getting started. So let's go ahead and search for getting started. Now here you can see Docker/getting started is from the Docker itself, and it has 10 million plus downloads. And obviously, to start with Dockers, this is a perfect way to start. We can download this image and we can run it within our local machine as a container. So I will go and click on this. Here, there's some important information that you need to see. Now, as soon as you see this, right here on the right hand side, you'll be able to see some pull command. So that basically means if I really want to use this image or pull this image from this Docker repository, I just have to use this specific command. Now, if you go and see with respect to tags, there will be the recent tags that are updated in this specific Docker image. Okay. Right now, we'll also be seeing different tags with respect to different images that are present in Docker repositories. Okay. Now, to start with, what I will be doing, the first step, if I really want to download this image, I have to go ahead and write this particular command, that is docker pull docker/getting started. So let's go ahead and let's do this specific step. So I've opened my command prompt, and I will probably write docker -v to just see that everything is working. I'm actually working on Docker version 20.10, and based on the updates and based on the Docker desktop that you're installing, this will definitely keep on changing, okay? Because the recent updates will keep on getting added in Docker. Now I'll clear the screen. As said, I'm going to download the first image from here. Remember, when we download the image, it does not come as a container directly as soon as you download it. For running that particular image, we have to use a separate command. So first of all, I will go and copy this particular command, docker pull docker/getting started. So once I go over here, once I paste it, and once I press enter, here you'll be seeing that the image will get downloaded. So here you can see using default tag latest. So if this is not already installed, it will do a new pull from the Docker Hub repository, and it will download this image. Now here you can see a lot of layers got pulled from this Docker Hub repository. This is what I'm actually saying. This entire Docker images will be having multiple layers with dependencies from one to other, right? All those layers will get downloaded. These are like smaller images, all the dependency images, right? Now this is perfect. Now if I really want to see whether the Docker image has got downloaded or not, I'll just go and search for Docker images. So here you can see that obviously I have Boston_image, which I created somewhere around 2 days ago, which we'll also see how to create this specific image from our side when we build the application. In this series itself, we'll try to understand. The second one is Docker getting started. This is the image that got downloaded over here. It is somewhere around 28.8 MB. Okay. Now similarly, if I go to Docker desktop, here you'll be able to see images. So here also it keeps the track of all the images that are getting downloaded. Okay. Now let's go ahead and run this particular container. Now in order to run this container, here you can see that you have to run it something like this, okay, by using this command. Now let's understand what this specific command is. And as soon as I run this particular image, right, as a container, you'll be able to see that we'll also be able to access it from our local machine itself, okay, this specific container. Now first of all, let's go ahead and understand the commands in order to run it, okay. So here you can see it is docker run -d, one parameter using, -p, one parameter we are using, and this is 80:80 docker getting started. So if you see over here, mention. Now let me explain you each and every parameter that is basically used. Once I write docker run, this is basically used for running the Docker image. If I basically write -d, this will run the image as a container in a detached mode. That basically means independently it will be running. Okay, and we should definitely follow this detached mode because we don't want our command prompt to be in the middle of something so that I can keep on continuing writing different commands. Okay, so -d is nothing but detached mode, and then -p is basically assigning port and mapping port from our local host. So local host basically means this is my host machine in which Windows I'm actually working, and in this Windows machine I'm installing a container, a Docker image. I'm running it as a container, right? So the container environment will be different, my host environment will be different. Always understand that. So here if I write 80:80, this basically means that I am assigning my host port as 80, and from the host port I will communicate with the container port, and the container port will be nothing but 80 itself. So let me just explain you what exactly we did. What is the difference between container port and host port? Let's say I have downloaded the Docker image, right? So here I have the Docker image. Now as soon as I run this Docker image, what should happen is that this will create an environment which will be a container environment. So let's consider this will be a container environment, okay? And this container environment is actually running in my host, right, in my Windows machine. So my Windows machine becomes my host, right? So here is the container environment that is running, right? And let's say this application is running over here, okay, the get latest application. Now in order to access this application from my host machine, let's let it be Windows in this case. So let's say this is Windows. Okay. Now, when I am basically wants to access this app from my host machine, I have to access it through some port. Okay. So let's say this is my local machine, like 127.0.0.1, and this will basically be my 80 port. Let's say I'm going to use 80 port from my host. Similarly, in order to access this app, I also require a port from the container. So let's say if I'm assigning it to 80, that basically means this port is opened from this particular container environment. So this mapping is basically done from that specific command. So here you can see 80:80. 80 basically, first 80 basically means the host environment port, that is my Windows machine, and I'm trying to access the container app through this 80 port, which is exposed from the container. That specific port number is exposed from the container. Now coming to the next thing is that all I have to do is that go ahead and probably write my Docker, my image name in short. So Docker getting started. Okay. Now, if you really want to check, first of all, whether my image has got downloaded or not, okay, so you can also go ahead and write Docker images. So here you can see Docker getting started is there. Now, let me just go ahead and run this particular image. So I'll write docker run -d for the detached mode, -p where I will be assigning my host port to the container port so that I'll be able to access the application. And then I have to go ahead and write my Docker/getting started. Okay, so this is my image name. Now, as soon as I run this entire image will be a container environment will be created, and this application will run inside that. So once I execute it, so here you'll be able to see, yes, I'm able to execute it, okay, in the detached mode. Now, what I will do, I will write Docker, and if I really want to see which all the application is working or not, so here I can basically write Docker PS, not application. If I say that whether to just verify whether the container is working or not, I can write Docker PS. Now here you can see my Docker is basically running as a container, right? And what is the port and what is the IP that I can basically use? It is 0.0.0. 0.0.0 is nothing but it is the local host itself, and this local host I can definitely access by 127.0.0.1. Okay, so this is what is my local host. So if I go back over here, you can see this is the host port 80 and this is the container port 80, right? So what I have to do is over here is that just write :80 and just press enter. So here you'll be able to see this getting started application has now started, right? So here you'll be able to see what all things happen. Now let's go through this, what all getting started is all about. This is just to give like how you can basically run a Docker image in your local host or in your host machine. Congratulations, you have started the container for this tutorial. Let's explain the first command that you ran. In case you forgot, here is the command. So this is the command we use. -d basically means run the container in detached mode in the background. -p 80:80 basically means map port 80 of the host to the port 80 in the container. So we are mapping the host port to the container port so that we can access it from this particular host port. And Docker getting started is basically the image that we are going to use. Okay, and then you can basically find out all this information and all, right? And the command that we specifically use to check whether the Docker is running or not, or whether the container is running or not, that is Docker PS. And obviously I can see that a Docker is basically running. Here you'll be able to see the port information also. Okay, now I will clear the screen. Okay, now let's see if I really want to stop the container, then how do I stop it? So if I go ahead and write Docker PS, here you'll be able to see the container that is running. If I write Docker stop, I have to write Docker stop and I have to use the container ID. So I'm just going to paste it over here and press enter. So once I do this, here you'll be able to see now if I go and type Docker PS, the Docker container has stopped, right? But if I probably see the Docker image, so here you'll be able to see the image is there. Now let me run this Docker container once again. Okay, and let's execute this. So it is now running over here. Let me go and see my Docker desktop. Here you'll be seeing in containers also it gets updated. The first one we started and we exited, that information is also being seen. So let's say that if from the past one day, whatever Docker container, whatever images or Docker images you run as a container, all that information is also getting updated over here. And you can delete that specific information also. Okay. Now in this particular case, I've just started a container. So here you can see that it is running. Okay. And based on that, you can definitely just call this as :80 and you'll also be able to see this. This tutorial is working fine. Okay. Now let me go ahead and let me write Docker stop. Okay. I'm going to just stop the container ID. The container ID is, let's see. First of all, I'll just go and see Docker PS because I really need the container ID. So this is the container ID over here. So I will write Docker stop this specific container ID and press enter. Okay. I think I've used one extra space, so let me do one thing. Okay, so I've used one extra space. Let me clear the screen now and make sure that you don't even use spaces over there so that it'll not run. So okay, so it's working absolutely fine. I used one space, so it thought some other commands. So now that specific container is not there. Okay, now similarly, if I have my Docker images, you'll be able to see Docker is getting started, image is present. If I want to remove this image, I can also use a command which is called as Docker image remove. Okay, and I can use this particular image ID. Okay, and paste it over here. So here you can see that I'm getting some error response from daemon conflict. I'm able to delete this because it may have some information. See, as soon as we stop the container also, right, and we remove the container, it will have some information that will be linked. So this kind of error will come. So for in this particular case, I will remove it forcefully. Okay, now once you remove it, you can see untagged and deleted. Now see my Docker images. So here you'll be able to see that image has got deleted. Okay. Now I'll again clear the screen. Now this is all about this one, and here also you can see in my images it will show exited. Boston image is only there, container is only one is there, and this has got exited. So I'm also going to delete this. No need to delete it if you don't want to delete it. Now let me go back to Docker Hub and let's try one more image, and just as assignment. But anyhow, I'll do it in front of you. So what I will do is that just search for over here as hello world. Okay, so this is a hello world Docker image, and this is also a Docker official image. That basically Docker has only uploaded this specific image. And here you'll be able to see all the steps, right? All you have to do is that Docker pull hello world and Docker run hello world. So for pulling the base image, you just need to write pull, right? And in order to run, you just write Docker run hello world. Okay. Now here you'll be able to see that what this entire thing will get generated. This print message will get generated from this particular image, and then it will automatically stop. That is what this hello world will do. Okay. So just pause the video and just try it out. And once you have tried it out with respect to the hello world, then continue the series. Okay. So what I'm actually going to do now, let me go ahead and execute it. So first of all, I'm just going to write Docker. This time I'll not pull. Okay. Directly if I run also and basically write hello world, if this image is not present, right, what it will do, it will pull the image from the Docker Hub repository. So no need to write Docker pull again. You can directly write Docker run hello world. If this image is not present over here, then it is going to pull from the Docker Hub and then it is going to run it. So once I enter it, you can see unable to find the image hello world latest locally. So here you'll be able to see that all the pull will basically happen. And here this is printed completely. To generate this message, Docker took the following steps. Docker client contacted a Docker daemon. The Docker daemon pulled the hello world image from the Docker Hub. The Docker Hub created a new container from the image which runs executable. The Docker daemon streamed that output to the Docker client, which sent it to your kernel, right? And then now if I probably go and see Docker PS, you will not find any container because it has got exited. You know, it displayed this message and it got exited. But if you go and see Docker images, this image will be available, right? So this is hello world. Okay. Again, let's open some another Docker image. Let's say Redis. Now, see Redis is there. Redis is an application which we specifically use for the caching purpose. Now, over here, in order to run this, if I write Docker pull Redis, and here you have a lot of tags. Okay, a lot of tags with respect to Redis also. So specific tags also you can pull it. Like if you write tag by default, it takes the latest tag. That basically means whichever is the latest version that will get downloaded. But suppose if you want this tag like bullseye, you can basically use this. If you want this version of tag of Redis, you can also use this. Okay, so different version, different containers will also run. One more super important point that you really need to know is that we can run any number of containers on the same port. Let's say this is a container for hello world. Okay, let's say we can also create another container for getting started. Okay, and this can also be assigned to the same port. Let's say my container port is 80 here also, my hello world port is also 80, but my host port should always be different when I'm communicating with this. And similarly, let's say for my local host I'm communicating with this, right? I should make sure that I should be assigning some different port like 5000. Okay, this 5000 will be linked to 80. And one more thing, guys, not 80:80 also, we can also try with different port if you want. Okay, so host port can be configured based on your host environment, whichever is available with respect to that. Okay, so in this video we learned about Docker images, pull, run, you know, how to run a specific image by using the run command in the detach mode, how to assign port and all. Right now, as we go ahead, what we're going to do is that we're going to create our own application. We'll create a Docker image and we'll also push this into the GitHub Docker Hub repository, not GitHub, Docker Hub repository, so that we can search for this. Now, let's say if I'm searching for Krishna, I have actually posted some of the things. Probably I have to sign in. Let me just sign in over here. So I'm just going to sign in over here, and here you'll also be seeing that I've also pushed some Docker images so that other people can use. Okay, so if I probably go and click on repository, so this is one ML model I'd actually created long back. This is the sentiment analysis. Here you can see that how many number of times it has got downloaded. You know, all these things are there. So this is also kind of image. You know, if you really want to pull or push this to a new repository, I have to use push command. But if you really want to use this, you can actually use pull command like Docker pull Krishna06 sentiment analysis, and you can use this in your machine and you can build it as a container or you can run it as a container. Okay, so all these things we'll try to see in the upcoming videos where we will create our own Docker image and we'll try to push it into the Docker Hub so that any person can download it and run it as a container. So I hope you have understood this particular video, and yes, I will see you on the next video. Thank you. So guys, till now we have seen how to pull a Docker image from the Docker repository. We also saw how we can actually run that as a container in our host machine. We also saw a lot of commands like Docker PS, Docker images, Docker pull, Docker run. You know, if I really want to see that how many containers are running, I can definitely use Docker PS. Similarly, if I really want to see that how many images are there, I can actually use Docker images. Now, what we are going to do is that we're going to create a Docker image, and I'll take that specific Docker image and we'll also try to push it into the Docker repository. So whatever application I'm actually developing over here, we'll Dockerize it completely. We'll create a Docker image, we'll run it. I'll also show you how to build this particular Docker image and how to run it as a container. And later on, we'll also try to push this entire application into the Docker repository so that you can also download this Docker image and run it in your own local machine. So let's go ahead and let's see. So here I've actually developed a very simple Flask application. In this application, you'll be seeing that this is just returning hello world. Okay, so let me just run this application. So here I just have two files, one is app.py and one is requirement.txt. Okay, so let's go ahead and let's run this. So I'm just going to run it. So let me clear the screen first of all, and if I run Python app.py, so here you'll be able to see that my application is running on 127.0.0.1 and 5000 is the port. So once I execute it, here you can see that it's displaying hello world. Okay, so this is a simple web application over here with the help of Flask. And for this, in order to run this application, I require one library that is called as Flask itself, which I'll be using which I'll specifically using in this Python web application. Now let's Dockerize this application. So first of all I will do Control C. I'll come out of this. Now I'll go to my app.py. First of all, one change that I really want to make is that in this app.run, right, I will also try to provide my host. So my host will be, let's say, 0.0.0, and I'll also talk about the importance of this particular host that is 0.0.0. Along with that, I will also give my port. So let's see, the port that I'm going to assign is nothing but 5000. So I'm just going to assign 5000 as my port over here. Okay. So two information, one is host and one is port. I've actually provided it. So once we run this, let's check whether it is running fine or not now, because we will definitely be requiring a host IP address. Now 0.0.0, what it will do is that it can access your local address also. It can also access your local host address also. So suppose my IP, let's say if I go to my command prompt and if I probably search for IP config, so here you will be able to see that my local address is nothing but 192.168.56.1. I will also be able to access my local IP address and I'll also be able to access my local host address. Okay. So let's go ahead and run this and let's see whether it is true or not. So here you'll be able to see that, yeah, it is running on 0.0.0.5000. So what I'm actually going to do, I'll just open my command prompt and I will just copy this IP address over here. And let me just open my browser and see whether everything is working fine or not. So here I'm just going to use my local IP address with 5000 as a port. And if I run it, here you can see hello world is also there. And I can also run with 127.0.0.1 and I can also run it with localhost, right? So it is also going to give me the same thing. So that is the importance of 0.0.0 IP address. This can also be an important interview question for all of you. Okay. Now what I'm actually going to do is that I made these changes. Now let me go ahead and create my Docker image. Now first, to create a Docker image, I have to create some files. The first file that I'll be creating, which is called as Dockerfile. So this is the Visual Studio that I'm actually using, okay, over here. So in this Docker file, what I'm actually going to do is that I'm going to use some commands, and with the help of this specific commands, it will actually help us to create a Docker image, okay. Some of the important commands that we will be using is something called as from, okay. Here I really need to specify a base image, which I'll be discussing about what exactly is the base image. As I said, that the lower base image should be a Linux kernel or Linux operating system, right? So first command is from, then I'll be using copy, then the other command that I'm going to discuss about is working directory, and then we'll also be using a command which is called as run, okay. And finally, we will be using a command which is called as cmd. So this is the command that we are going to run in order to run our Flask app, okay. So these are the basic commands that we will be using. One is from, copy, work directory, along with that run command and the cmd command. Okay. Now instead of the base image, I have to, and this base image will be the first layer, right? And it should be a Linux image in short. And one of the Linux image that I found out from the Docker Hub repository is nothing but Python 3.8 Alpine. Okay. You can also use Python 3.7 Alpine. So this specific base image I'm basically using, and what it will do is that it will try to pull this particular image from the Docker Hub repository. Next is the copy command. Now this copy command is super important because this copy command it is just saying that from my local repository, that is the current working location, this both the files should be put up inside this base image in one folder. Let's say this folder is app, right? So in short, what I'm doing is that in my Docker image, I'm creating an app folder, and I'm making sure that everything, all the files that are present over here, I'm just going to copy it inside this app folder. This app folder will get created in the container or Docker image, right? And this dot basically says about my local repository. Then after that, I also have to set up my working directory. Obviously, if I'm copying all my files to this app, right, then what will happen is that my working directory should be this /app, okay? And then after this, I will also be installing or running this particular command, that is pip install -r requirement.txt. Now, why do you do this? Because all the dependencies with respect to all the libraries will be present over here, and I really need to install all these libraries. So for that, I'm writing pip install -r requirements.txt. And finally, the command that we're going to run is python app.py. Now, when I do this, in short, whatever the files that are present in this app folder will be this app.py and requirement.txt, right? So it will first of all do all the requirement, all the installation of all the libraries, and then it will run this app.py file by using this command, that is python app.py. So this is a Docker file that is created, and as soon as I build this entire file or build this application, you'll be seeing that a Docker image will get created with all this information, right? So inside this image, you'll be able to find out this app folder, along with that, all these files will be present inside it. Okay. So let's go ahead and let's try to build this now. My app.py file is ready. Now, in order to build it, please focus on the commands that we are going to use. The first command that we will be using for building is nothing but you'll be seeing over here. Let me just close this. First of all, this is a PowerShell, so I don't want to use a PowerShell right now. Okay. Let me just close this, and then we will try to see that. And for this, I'll just take a command prompt. So here is my command prompt. The first thing, in order to build the images, I will write docker build. We use -t as a parameter over here, and then we give our Docker image name. The Docker image name will basically be, let's say, I will be saying welcome app. So suppose let's say this is an app which will basically welcome everyone, and then I will be using this dot over here. This is the entire command to build the Docker file or Docker image. So once I execute it, here you'll be seeing the building process has started. Now everything step by step, all the things will happen. The copy command will run, the pip install will be running, right? So if I probably see over here everything from the first step, right? So here you can see copy command has run, then the working directory is set to app, and then the requirement.txt has been this particular command is basically getting run. Okay. Now, if you want to see whether your Docker images has been built or not, so what you can do, you can write Docker images over here, and obviously you can see welcome app. Boston image is one Docker image that I created long back, but right now the new Docker image that we have created is welcome app. Okay. Now I'm just going to clear the screen. Now it's the time to run this specific Docker image as a container. Now there are two things with respect to this. First of all, understand if I'm running this Docker image, two important information that needs to be given is your host port and your container port. So that mapping needs to happen. So I'm going to write Docker run -p. I'm not running this in a detached mode, but instead I will be running this so that I can also see some logs. And first of all, I'll be writing -p, where I will be mapping all the ports. So let's say this host container port is 5000, and host port is 5000, and the container port, obviously you can see over here it will be 5000. I'm just assigning it to 5000, and I will probably be running this by calling my the Docker image itself, right? So Docker image is nothing but welcome app. So once I do this, here you'll be able to see now my Docker will run. Now here you'll be able to see two IP. Okay, one is 172.170.2:5000. Now if I probably run this, now what is happening over here? You have to probably check it out. Here, as soon as this this URL gets hit, it will not run. Why it will not run? There is some reason behind it. Now this IP is nothing but it is the IP present inside my container. Okay, and it is basically running in this 5000 port. Obviously we cannot access it, but we can access it from our host container through a specific port. Now what will be that specific port? So here you can see one address as 127.0.1:5000. So this is with respect to my local host, right? So if I execute over here and if I see it, here you'll be able to see that my entire URL is running. Similarly, if I do it with my local host also, since I've assigned 0.0.0, this should also be running properly fine, right? Even I can also try it my local host. So this will also be working fine. So here what is actually happening is that this application is running inside my container, okay? And with the help of port from my local host or from my local IP address, by using this port, I'm accessing this application which is present inside the container, okay? Now what I'm actually going to do over here, as soon as I run this here, I will again create another command prompt, and let me just write docker ps, okay? Now if I write docker ps, okay, spelling mistakes, not a problem. So if I write docker ps, here you'll be able to see how many containers are running. Obviously, this container is running. And one thing about the port also you'll be seeing over here is that here you have 0.0, 0.0.0, 5000, and this is basically your container port, right? We are accessing from the host port to the container port. Obviously, from this particular terminal, you can see that this probably may be the IP inside the container, but definitely we cannot directly access it. We can only access this through our local host by using this specific port, because while running the container, I have assigned this specific port to it, okay? So this 5000 is basically the container port, this 5000 is my host port. And with respect to the host port, since I have used in my app.py as 0.0.0, that basically means we will be able to access this containers with the help of my local host or 127.0.0.1, or I can also use local IP address for accessing it, okay? So right now I have actually created my container, so my Docker image, and the container is also running absolutely fine. So finally, if I really want to stop it, all I have to do is write docker stop. Docker stop, and let me just open the Docker desktop also. So here also you'll be able to see the container is running welcome app. Similarly, here also you'll be able to see the image welcome app. Okay. Now what if you really want to stop this container? Just write Docker stop and just write this container ID, and it will automatically get stopped. Now here you'll be able to see that this has got stopped right over here. Right. Similarly, I'll be able to find out Docker images. Now Docker image over here is absolutely fine. Now what I'm going to do is that the next section will be quite amazing. In the next section, what I'm actually going to do, I'm going to deploy this particular image in the Docker Hub repository. Okay. And once I deploy it, then what you can do is that you can also pull this particular image and run this particular image Docker image as a container, and you can also access it with your local machine, right, by using the same port that is 5000. So that is what we're going to do in the next video. We'll see how to push this in the Docker Hub repository. So yes, I will see you all in the next section. So guys, in this section, what we are going to do is that whatever Docker image we have actually created, we'll push that into the Docker Hub repository. Okay. Now to do that, first of all, just go ahead and log in into your Docker Hub. So you have to definitely log in into it. Always remember your username and password for this. And just by using the command line itself, we'll try to push our Docker image, like how I pushed over here, like ML_model and sentiment underscore analysis into the Docker Hub repository. Again, guys, this is not a private repository. This will be a public repository. So if I'm deploying it, if I'm pushing it over here, you should also be able to pull in your local machine and run it as a container. Okay. So let's go ahead and let's see the step-by-step process. First of all, as usual, go ahead and just go and do the Docker login. So here you can see that once you go ahead and type Docker login, it will first of all ask for a username. Type your username, then press enter, then it will go and ask for your password. Right now, I've already logged into this, so it is just using the existing credentials. Okay, so clear the screen over here. Now, the next step that you really need to do right now, my Docker images, if I go and see, it is something called as welcome app, right? I have to rename this particular repository, or sorry, this particular Docker image. Okay, so how do I rename it? There are two ways. First of all, I can remove this, okay, and I can again build it. So let me just go and show you an easy way. First of all, Docker image, just go ahead and just directly remove it by using -f and just write welcome app. Okay, then once this is removed, if you probably go and see in the Docker images, here you'll be able to see no images present. Now again, go ahead and build it. So I will say Docker build -t, my name of the image. But before writing the name of the image, this is super important that you really need to understand. If you see over here, guys, see the naming convention should be your username / the Docker image name. Okay, so this is the naming convention that you should follow. Okay, because that will actually help us to understand that which username it is and where we really need to push the Docker image, right? So here I'm just going to write Krishnaik06, and here will be my image name, that is welcome app. Okay, and then I will write dot, and automatically the build process will start again. So once the build will happen, the entire image will get created. Okay, so this will be my Docker images. If I go and see, here you'll be able to see the welcome app. Now let me clear the screen. So again, let me just go and show you the Docker images. So in the Docker images, here you have something like Krishnaik06 welcome app. Okay, now after this, this is one of the way. The other way is that you can directly use Docker tag. And you can change the name of the image also. Okay, so here I'll be using Docker tag, and let's say Krishnaik06 is your Docker name, right? So it will be welcome app over here. Let me change this name to something else. So first, after this, you really need to write one more thing like this. Let's say Krishnaik06. I will change this to welcome app 1, right? So let me do this and let me change it. Now, once you execute it, now if you probably try to see Docker images, here you'll be able to see one more Docker image is basically getting created with welcome -app 1. Okay, so this is how you rename it. Rename your Docker image from the older name to the newer name. But always make sure that if you really want to push this into the Docker repository, you have to put your username in front of it. Okay, but anyhow, I'm going to push this Krishnaik06 welcome app to the Docker Hub repository. So first of all, I'm going to clear the screen, and in order to push it, I'm using a command which is called as docker push, and this will be my Krishnaik06 / welcome app. So this should be my the Docker image itself. Along with that, we'll be using a command which is called as latest. Okay, now why I'm specifically writing latest, this latest will basically show the tag over there. If I go and click on images over here, this tag can be provided with different versions also, like it can be version 1.0, 1.1. So any new updates are basically coming, we can again create the same Docker image with a different version. Okay, and that is basically useful for making sure that your Docker image keeps on getting updated with some new changes and all. Okay, right now I'm just going to use this tag as latest. So let me go over here, and this was the tag that we have specifically used. Now here I'm going to write docker push Krishnaik06, and this should be my welcome app, that is my Docker image name, and the version should be latest one. So I'll just go and press enter. The push is going and preparing, waiting. Everything is going to the Docker Hub repository, and probably once this entire thing's happen, the welcome app Docker image will get created. And the most interesting thing will be that you can also download it and you can run it as a container. See guys, how simple it is really. Okay, so yes, this will take some amount of time because obviously this is somewhere around 58.2 MB. Boston image. This is a data science project, so that is the reason why it has become 1.82 GB. Okay, now here you can see that. Okay, perfect. All the steps have happened. It has been pushed. Now let's go ahead and see over here. Now if I probably reload it, you will be able to see the Docker Hub that is welcome, the Docker image in the Docker Hub, specifically with respect to my username. So here it is, just go and click on this. You'll also be able to see, I've used this particular command which is called as docker push, okay? And if I go and see on tags, here also you can see this. If you also want to pull, you just have to use this particular command, okay? Once you use this command, you'll be able to use this and run it in your own local machine. So let me do that also if you want. So I'm going to clear the screen and probably see my Docker images. Let me do Docker image remove. I'll just remove one of the images, let's say -f Krishnaik06 / welcome API. Welcome app with latest. So if I'm just trying to remove it. Now let's see my Docker images and then we'll try to pull it. Okay. So right now nothing is there. Let me go to my browser. Let me copy this and let me just paste it over here. So once I execute this command, now you'll be able to see my image will again get pulled. So here you can see pulling from Krishnaik welcome app. Now if I go and see my Docker images, here it is. So Krishnaik06 welcome app. Now all I have to do is that run this. I know how to run it. So I'll be using docker run -p, and let me use this time -detach mode also. So -d and p. Okay, and I will be assigning the port as 5000 of the host to 5000 as the container port. Along with that, I will just write my Krishnaik06 welcome app, and this will be my latest. And once I run this, I think everything should run. See, it is in the detach mode, so you'll just get this specific information. Okay, and now if I go to my browser and check it, just reload this, same thing. reload it with your local IP, reload it with your local host, you'll be able to get this entire information. And that's it. That is how simple it is to basically create a Docker image and all. Now, any requirements, like let's say when you're working in a full-fledged project, right? Any libraries that you want, like pandas, numpy, you can just keep on installing over here. Everything will happen. Where you just need to list down. You have to have your HTML file and all those things are there, machine learning models and all. All the most important thing is this particular Docker file. Now, along with this, guys, you can do many things with Dockers. Even you can install different databases within the container and you can directly use it. Okay. So now in the upcoming sessions, we are going to learn more things about Dockers. So guys, in our previous session, we have already seen how to create a Docker image, how to run it as a container, and finally we also saw that how to deploy that in the Docker Hub repository so that you can also pull it and run it in your local machine. Right now, in this video, we're going to discuss about a very important topic which is called as Docker Compose. Now, let's understand why do we use Docker Compose. But before that, I'll give you a scenario. Let's say that I have my web application which is specifically running in a container. So all the default configuration that is required with respect to the port and requirements that is needs to be installed before we run it as a container, everything is put up over here in a specific Docker file. Okay, so here obviously you will be having a Docker file, right? Over here, right? Now, let's consider that if this particular web application wants to use services like MySQL, Redis, or MongoDB. Now, you know that if you go to the Docker Hub, right, you will be finding different images for MySQL, for Redis, for MongoDB. So it will not be possible just to run MySQL inside this container. So this needs to be run as a separate container. This needs to be run as a separate container. Similarly, this needs to be run. MongoDB also needs to be run as a separate container. And then this web application can basically interact with MySQL, Redis, or MongoDB and basically store or retrieve the data. Redis is specifically used for the caching purpose, which will basically increase your performance of the website. Now, why exactly is Docker Compose used? Now see guys, Docker Compose is a tool for defining and running multi-container Docker applications. Now in this particular scenario here, you can see that you have multiple containers, right? You have a MySQL container, Redis container, MongoDB container. So Docker Compose, with the help of Docker Compose, we will define the entire configuration. So we will basically create a file which is called as dockercompose.yaml file, okay? And then we can join down all the configuration requirements that is basically used to run all these multi containers, and they will also be able to communicate with each other, okay? So this in short is about Docker YAML, Docker Compose, and let's go ahead and see a practical example, and then you will get an idea. Let's say that this is my app.py, and this app.py has a code. Again, this code is not that important, but you need to understand how do we use Docker Compose. So here you'll be seeing that using a Redis, and this is a Python application that I've written. So Redis usually helps us in caching information, and it will be caching within the memory itself, in memory caching. So here, what we'll be doing is that we'll be running this entire code, and we are making sure that the cache is implemented over here by using this specific code. Okay, so this will be my define hello, and whenever I hit this, it will say hello Krish, I've seen this many number of times. So this count will basically be saved with the Redis. Okay, now the first thing is that whenever you want to create a Docker Compose file, now here one thing is that Redis you are using. This Redis is present as an image in the Docker Hub, which I will again show you, and then you'll be able to understand it. Okay, now first of all, I will go ahead and create a Docker file. Now this Docker file will be for this particular application container. Okay, so here I will go ahead and write my Docker file. In my Docker file, you can again the steps will be almost same. Whatever things we have actually used, we have to use those specific commands. Okay, but today in this video I also want to convert something about environment variables. So one command is that from, let's say I'm going to use Python 3.7, and this will be in Alpine mode, Alpine version. Basically the Linux base is this. Why we use this? Because it will be very small in size and can be quickly created as a base and run it as a container itself. Then finally I will go ahead and write my work directory. Let's say this is my work directory, and obviously the work directory that I really want to keep is, you can write anything, any folder, like you want app or you want code, any folder that you want. So this will basically be my working directory. Then I will copy my from the current location, that is this first parameter that you basically indicate is that from the current location, whatever file are there, I'm just going to push it inside this code folder, right? So code folder, since I've set it to my working directory over here, so I'll be inside that particular code location, right? So code folder location. So here you can basically see that I've written dot. Okay. So next step is basically just copying that specific file to over here. Now before this also, I really want to specify some environment files, right? See in Flask, because this app.py is a Flask file, right? We can run it through various ways. We can directly use a command which is called as Flask run, but in that we need to set up some environment variables. So let me just show with respect to environment variables. In case of environment variables, we have to write env, and we can supply it in the form of key value pairs. In case of Flask, I have to supply Flask underscore app is equal to app.py file, which is my file, and the other one is that app.py, and oops. And after I press enter, another environment that I usually put up is Flask underscore, not environment is not required, but I will write run underscore host. So I can also specify my host information when I am actually running the Flask app. So this will be 0.0.0. Okay. So this can either be local machine or your local IP address, anything it can be. So this I've set up the environment, and as soon as I write Flask run, automatically it will be taking up this app.py file and on which environment it has to, or which host it has to basically run, or which IP it has to run. It has all this information. So now this copy command, I hope everybody has understood. From the local repository, we are just trying to copy into this code folder itself, which is present inside the Docker image. And then I'm going to run the pip install -r requirement.txt because this is super important. So here one environment variable I've spoken about, which I have not covered in my previous video. And one more variable that I really want to talk about is something called as expose. So here through this particular expose, I can specify the port number that will be exposed from the container. So let's say if I'm writing 5000, that basically means inside the container, this 5000 port will be exposed to the host environment. Okay. And finally, I will write my command, which will be cmd. This command is basically to run all the, just a second, so 5000. And finally, I'll be having a command which will basically say two things. One is flask, comma, run, right? So this is it. So now here you'll be able to see that I'm going to just execute this at the end of the day, flask run. So as soon as this command runs this, right? First of all, in the environment variable, it will look for app.py, and then it will look for host, and it will just get all the information and it'll start running it. Okay. So I'm saving this. This is what is my Docker file that I'm actually going to create. Now coming to the next one is basically the Docker Compose file, because I need to use Redis in my application. And this is one example with respect to Redis. Probably you also want to use MySQL and all. I'll show you a way how you can basically use the Docker Hub for the same purpose. Okay. So first of all, I'll create a file which is called as Docker Compose .yml file. Now once I've created this docker-compose.yml file, understand why it is basically used so that we can run multiple containers and it will also be able to interact with each other. So this is the tool that is used for defining all those things. So first of all, the field that we're going to use is something like version. So let's say I'm going to specify a specific version like 3.0. Okay. And again, this needs to be followed a key value pairs in that specific way, right? The key value pairs with some space. Okay. Version. The first thing is that I will just write services. This is the syntax that we specifically use. Now with respect to services, I'm going to use web. Okay.
And inside the web, let's say this web, as soon as we write web, this is basically going to create a web service, and this web service is going to use the Docker file of the specific application. So here in the web, the first command that I will probably write is something called as build. So here you can see build right now from where you're going to do the Docker build itself, right? So Docker image build. So here you can see that in the Docker file, we have kept the working directory as /code. So inside /code, all this entire file will be present. So I'm just going to write build as dot, so that the build will happen from the same root folder. Okay. And then I'm going to assign the ports. In this ports, understand what all the ports are there, and please make sure that you keep this indentation, right? This indentation is super, super important. If you do not follow this indentation, then you may be getting a syntax error when you're getting a building. When you're doing the build, that time you'll be getting a syntax error, right? So in this particular case, let's say I'm just going to keep it as 5,000, and this will also be 5,000. So this is nothing by host port to the container port. That is what I'm using. I can also use 8,000 if I want. All this information is there, right? So web build ports. So we are going to also even assign the ports. Now coming to the next one. Now this is for this entire service is definitely for my Docker file, current Docker file for my application. Now I can go ahead and write other web services like Redis. Okay. So now if I basically write Redis and probably write my image name, right? So let's say I'm going to specify my image name. The image name is nothing but Redis, right? Now this Redis, as soon as we write like this, right, it is also going to create another service or container of specific Redis. And this image, when I'm writing this, right, it is going to pull this particular image from the from the Docker Hub repository. So here you can see this will be my one service. So one image of web will get created, the another image of Redis will get created. Similarly, I can go ahead and probably create my own image for MySQL also. Okay, so I can also go ahead and create the image for MySQL. So in this, if I'm specifically writing MySQL and I'm writing like this, I can then give my MySQL image name like this, and let's say this is MySQL that I'm going to use. So this will be another image that will get created within MySQL. This image will get created for Redis, and this will be image for the web, which will basically using this particular Docker file, it will try to run all these things, right? So this is how we combine multiple services. For now, I will just show you an example with respect to web and Redis, and let's see how the output will basically come. So here are two things. I've already explained you about it. You can also specify the image name if you want. Okay, so like this, if you want to specify the image name, then also you can actually specify. If I'm probably writing image is equal to Redis, this is my let's say this is my web app. Okay, so this is my image name for this particular web service, and for Redis, my image name is this. Obviously, if the web app will be built here itself on the local, right? So it is going to use the Docker file. So let's go ahead and execute it now. Okay, guys, now let's go ahead and open the terminal and let's see how to run this Docker Compose, which will automatically be doing the build and running part. So first of all, I will just go and check my Docker images and see whether any image is present or not. So right now, no images. Here you can see it is completely empty. So let me clean my screen. Now I will be using Docker Compose, and let's say I'm writing Docker Compose up. Okay, so let's say if I'm saying up, then automatically what will happen, this entire YML file will get executed. Anyhow, see, I was running in PowerShell, so I'm getting this coloring option. Let me do one thing. Let me just open something like my command prompt, and let me quickly show you. Okay, first of all, Docker images. So here you can see, and then I'm basically going to write Docker Compose, and in order to run it, I'll just write up. So as soon as I do this, all the steps will be going line by line. So here you can see version, this, image, everything step by step. Here you can see Redis has been pulled already. It has been copies, instruction is happening, run pip install requirement is basically happening. Everything is happening perfectly fine. And here now you can see the link, right? So right now the link that you can see by default, whenever Flask runs, it will be running at 5,000 port. But you know that we have exposed it in 9,000 port. So I'm getting some error. Let's see what is the error. Redis attribute has no attribute reset retry. Okay, perfect. That basically means I have done some error over here. Let me just remove this line because I don't require this line. Okay. I was just checking it somehow. Okay, not a problem. So in order to stop it, since I got some error, I'm just going to open another command prompt and write Docker Compose stop. Okay. Now once I write Docker Compose stop, here you'll be able to see Docker will be stopped. I'll also be showing you all the images that will be there. Okay. So there was some mistake in the code. So what I'll be doing is I'll again rebuild it and again I'll send it. Okay. So now here if you go back to the command prompt, again it has come out. Okay. Right now if I go and see Docker images, right, two images will definitely get created. One is web app and one is Redis, right? But we got an error. So here you can see web app is there and Redis is there. This was the image name that I gave, right? So let me do one thing. Since I need to rebuild it again, first of all, I really need to remove these images. So remove -f. If you don't want to remove this image, we have to use the concept of volume, which again I'll show you because in this kind of issues also we can actually fix this. So again, I'm going to use the same thing, and volume part we'll see it in the next video. Okay. And now I'll just going to execute it over here. So done. This is perfectly done. I'm just going to clear the screen. Now if I probably go and see Docker images, nothing is there. I've saved my file in app.py. I made all the issues are fixed. It is already fixed. Now I'm going to write Docker Compose up. So once I execute it, the entire step will happen again. Now let's see whether it will work or not. Okay. Already exists. Now you can see whichever things are already existing, right? It will not going to download it again because somewhere in our local it will be there, right? Now perfectly fine. It is working. You can see build also continuously happened, and after that it is also running. Now if I probably execute this and come over here, you will be able to see one browser which has something like this, but you know that we have exposed it to 8,000. Now I'll execute it. Hello Krish, I've seen 74 times because I had already implemented this and previously ran, and so many number of times I tested it. Okay. Now here you can see that it's working absolutely fine. As you go, if you're running it for the first time, you'll be getting it one, and that is why if you keep on increasing, if you keep on just reloading it, this count will get increased. This is happening through the Redis caching. Okay, just to show you how it is. So if you keep on doing it continuously, it will happen. Now let me show you one important issue. Okay. Now let's say that I want to just change this message. Hello Krish, I just want to write hello Dockers. Okay. And let me save it. Now in this particular scenario, obviously I know that if I try to run it, right, it is not going to get updated again over here. So for this, I have to reload this entire thing. Again, I have to stop the container, and again I have to rebuild all my images, and again I have to reload it. Then only hello Dockers will come, right? So this is a tedious process, right? And this thing can be fixed with the help of Docker volumes. Okay. So that is what we're going to learn in the next video. But I hope you understood that how we are running with respect to different images and as a container by using Docker Compose. Now one more thing that I really want to show you, which you can basically try, and probably I'll also make a video as we go ahead. If I search for MySQL, right, just think over it before my further videos will come, how you can integrate MySQL with your image, right, with your web application or web container, right? Now in this particular case here, you can see that whenever you are using MySQL, you have to use default environments like this and provide your values, right? First of all, you'll pull this MySQL, and here just see the documentation. Here all the documentation will actually help you to understand, and the same command can basically be used in the Docker Compose also, right? Docker Compose also. So I hope you have got an idea about how you can basically run it. Now the next step you can see over here, I'll write Docker images. So here you'll be able to see Docker images, web app, and Redis. But if you go and see Docker PS, Here you'll be able to see two containers are running web app and Redis, and both are communicating with each other. One is exposed from 8000 to 50, and this is 6379/TCP, right? So by default, whatever it is basically giving. And where do we get this? This is from the Docker Hub itself. It'll assign a port from there itself by default. Okay. So this port is getting assigned by default, right? So now if I really want to stop it, all I have to write is docker compose stop. That's it. So once I execute this, all this stop, this entire thing will get stopped. But you still have the images over there. What I would suggest is that if you want to make any changes, please watch the next video. In the next video, we'll discuss about, like, suppose if I'm making any changes, how do I deploy this directly? And after that, whenever I make any changes, it should be available over there itself. That is what we're going to see. So yes, I will see you all in the next video. Thank you. Hello guys, so this is a series of videos to understand about Git, and in this series we'll try to understand that what are the best methodologies to commit the code into a specific repository. Because in IT companies, you know that in your specific team, you'll be having many people. You'll be having front end people, you'll be having people who are working in the back end. Let's say you'll be having an AI team people, right? And many people will be developing or writing a lot of codes, and they have to make sure that when this code commit is actually happening in the main repository, all needs to be in sync, and we really need to follow the best practices that is available with respect to committing our code into the repositories. So in this series of videos, we're going to understand about Git. Along with that, we're going to take up GitHub repository, and we're going to make sure that whenever, suppose if I'm developing a specific project, how the commit should basically happen. Again, as said, this will be a series of video. This is the entire cheat sheet that I'm going to cover one by one from top to bottom. Okay, probably in 4 to 5 videos we'll be able to do it. First of all, to start with, what is Git? Git is a free and open source distributed version control system that's responsible for everything GitHub related that happens locally on your computer. This basically means anything that locally that you do. If you really want to commit that into a specific GitHub repository, I can definitely use Git. Okay, and many companies uses Git, and it is the most common open source distributed version control. So what we are going to do initially is that please make sure that you have a GitHub account. Let's say that I'm going to create a new GitHub repository. Okay, and then we'll try to just see how to just commit or push your code into the GitHub repository. So let's say I'm going to write something like Git tutorials. Okay. So this will be a Git tutorial series. There'll be description. No need to write any description. No need to add a README file. No need to add Git ignore file. Or no need to add a choose a license, anything as such. Later on we'll keep on adding and we'll try to see that how things will come up. So I'm just going to go and create the repository. Now, once we create this repository, the next thing is that since we really need to work with Git, we really need to install the Git tool itself. So in order to install it, first of all, go over here, search for Git CLI. So in Git CLI, you'll be able to see the download section. Now inside the download section, go and select and download the Git tool with respect to your specific operating system. So suppose if you're Mac OS, go ahead with this. Windows, Linux, or Unix, go ahead with this. Suppose I want to go and download for Windows, I will go and click on download for Windows. So once you download it, here you'll be able to see some kind of exe file. Just double click it, click on next, and all the installation will take place. Now in order to verify whether your Git tool has been installed or not, just open your prompt, command prompt, or your terminal in Linux or Mac, and just go ahead and check what exactly it is. So here, if I probably go and see Git version, right? Here you'll be able to see that, okay, fine, if Git version is basically coming, that basically means Git tool has installed. Okay. Now what I'm actually going to do is that I'm just going to create some files locally, and I'm going to commit that specific files in the specific repository. Now, in order to commit it, here you can see nothing is there. You can commit it through two ways. One is create a new repository on the command line, or push it in the existing repository from the command line, or you can also import code from another repository. Like this all repositories is also, it handles that Subversion, Mercurial, or TFS project. I've worked in TFS long back. Okay, but we'll focus on this too. Okay, and then we'll try to see how to commit it. Now here you can see that we have not created any README file, but it is a good practice that we should create a README file in our repository. Okay, so what I'm actually going to do, I've created a README file over here. You can see in this particular folder. Here, this README file, I will try to commit it into this particular repository. So let me open my command prompt again. Okay, and let me go to this specific path. So I will go to this path, and then we'll initialize over here. Let's see. So I'm just going to go to the G drive and clear the screen. Okay. Now to start with, what I'm actually going to do, first of all, I have to make sure that this is what is the entire Git that we're going to initialize over here. So we have to first of all initialize our Git. So if I write Git in it, here you'll be able to see that initialize the empty repository, Git repository, right? Now, if I probably see my dir in Windows, so here you'll be able to see all the files. Okay, but make sure that when it is initializing, right, it also creates this hidden folder called as .git, and this folder need not get committed into the GitHub repository. Okay, this is just for your configuration or other configuration itself. Now, to begin with, what we are going to do is that first of all, always remember, since we really need to commit in this GitHub repository, okay, we have to first of all set up our basic configuration. Now, this configuration is with respect to your user.name and user.email ID, so that it will be able to authenticate and it will be able to understand, okay, I need to commit it over here. So in order to do that, just search for git global config. So first tutorial that you'll be seeing, we have to set up these two things. Okay, that is your username and your user.email. And how to set it up? Just go ahead and write this particular command. This email ID should be the same email ID that you specifically use in GitHub. Okay, so to begin with, what I'm actually going to do, I'm just going to open my command prompt and just see this particular command, git config. So here I'm just going to write git config. Okay, minus global. --global, and here if you search for user.name, so once you execute this, right, you'll be able to understand whether you have done this configuration or not. Suppose let's say you're getting user.name, so here I'm getting Krish Naik. Okay, so that basically means I've already configured. If suppose you're not configured, you can just write user.name, and here you can write something like Krish Naik, like how this methodology has basically been followed in the same way. So here you can definitely write like this, and you can search for Krish Naik or whatever your name is, right? So that is what you can actually use here. Okay. Now similarly, once you enter this, automatically this user.name will be set up. This configuration file or this configuration key will have the specific name that is Krish Naik. Similarly, the next setting that you need to do is user.email. In the user.email, just go ahead and write your email ID like this. Okay. Now this will give you like why we are doing this, because later on when you push the code, right, it will ask for an authentication for this email ID along with your GitHub, right? So that also you can basically do. So that is the reason why you're placing this. So after you do this, just press enter and just keep idle, and then we'll start then don't do anything. Then we'll start the entire initialization process and committing process. So now I'm just going to clean the screen. Now you have done the global configuration where you set up your user.name and the email ID. Okay. Now the next step over here is with respect to this. Okay. Now already you know that I've created a file which is called as README file. Now over here you can see that the first step is saying that, okay, by using this echo command specifically in Linux terminal, I've created my README file. Okay. Now the next thing is that we have done already Git in it. Now we're going to add this README file, and this, as soon as I execute this add command, understand, if I probably go and search for git add, and always remember you have to follow documentation. There are some good documentation with respect to this. One documentation here you can see with respect to git add, what are the possible options, and there are some few options that we use regularly. Okay. Now what exactly this git add will do? Okay. Understand, guys. Right now, if I probably just search for git status, so git status is a command over here. Just let me execute it. So here you'll be able to see if I execute git status. So here you can see that in the git status, no commit yet. Okay. And right now this is basically the untracked files. So here you can basically see that when I write git status, here you can see something called as untracked files, right? Now Right now, if I say untracked files, this basically means this file has not been tracked yet by Git. Okay. Now, if I really want to track this file and make sure that all the changes are also tracked along with that, first of all, I will go and add this Git file. So git add readme.md. So once I execute this, now this file will get tracked. So if I now see Git status, here you'll be able to see that, okay, changes to be committed. So these are the new file that needs to be committed to the staging environment. Okay. Now, staging environment is just a kind of environment which will make sure that, let's understand, like if you are sending some files that needs to be pushed to the repository at that point of time, initially we'll send it to the staging environment, and from that staging environment, it will then push it to the main GitHub repository. Now, what we are actually going to do over here is that, first of all, after after this specific step is basically happened, that basically means we added this readme file. The next step, I will just go and open this Git tutorials. Now you can see that I can put my first commit. Now this commit will make sure that it will go to the staging environment. Okay. So now let me just execute this. So here I'm going to write git commit -m, and let's say that this is my first commit. I'm going to write. This is the first commit. This is the first commit. So once I write this and once I execute this, now you'll be able to see that this entire changes have been moved to the staging environment. Okay. And staging environment is just a kind of environment. It's just like a playground wherein I'm keeping all the things that needs to be pushed to the repository, the main repository. Now, if I go and see for git status again, here you'll be able to see that on branch master, nothing to commit. Okay. This is fine. That basically means whatever I have to commit, that is already there in the staging environment. Now, if I probably go and search for git branch, right? Here you'll be seeing that this particular branch name is master. Okay. Please remember all this command. I will try to show you in the form of story so that you'll be able to do this commit and all as you go ahead, right? Now, whenever you create any branches or whenever you create a GitHub repository, by default there will be a branch called as main branch. So one thing that I'm actually going to do is that I'm going to make sure that I'll rename this master branch and I'll write something like main branch. Okay. So how to do that? Here you can basically see there's a command git branch -m main. Okay. So if I probably write git branch -m and I'll write it as main branch. So now once I execute this, now if I clear my screen and if I write git branch, here you'll be able to see that now my master branch has been changed to something called as main branch. Okay. Now we have done this. It is very, very good. But how do we make sure that this local repository is basically connected to our main repository? So once I do a git push, it should be able to understand that which is the repository that I need to send it to. Okay. So for that, what I'm actually going to do, I'll go back to my repository and I will copy this entire link. See this link that you'll be able to see, this git link, I will try to copy it. Now once I copy it, here you'll be able to see that I will be writing a very simple command, and the command is also visible over here, which will say git remote add origin to this particular value. So that basically means from our local repository, we are making sure that we're telling something that, okay, this is the place where you really need to commit. So here I'll just go ahead and write, I'll say git remote add, okay, and I will write origin, and then this will basically go to my git of my specific repository. So here you can see that this has been connected, right? Now if I probably go and see git status, everything is fine, no, nothing to commit, everything is there already in the staging environment. If I write git remote, this is super important, git remote -v. Okay. So here you'll be able to see that currently in the local from where I'm fetching and pushing. So from my local basically means anything that I commit to my staging environment, that will basically be in this origin variable. Okay. Origin variable. So this origin variable is basically indicating my staging environment. Now finally, I will go ahead and push that my code to the repository. So for doing that, I'll say git push from origin, and the by default the repository, the branch in the main repository is nothing but main. So once I commit this, here you'll be able to see that the code will be going, and this is basically saying that, okay, at this particular location, it has already gone. Okay. So I'm just going to reload this. So in short, over here, it will create a new main branch, and there the commit is basically going. Okay. So second way is this one, which I will be discussing as we go ahead. Okay. Now let me just reload this, and here you'll be able to see that I will be having my readme file with GitHub tutorials by Karish. Now the next step, any changes that I make. Let's say I want to make some changes over here. So I'll open my notepad file. Let's say on the same file I'm making these changes. Okay. Let's say I'm making these changes over here. Let's say here I'm writing one more line: subscribe to Karish channel. Okay. And I'm just saving it. Let's say there's some information in this readme file. Now as soon as I do this, now see the importance of tracking. If I write git status, you know that the file has changed. Here you can see that it is saying modified. Okay. Modified. Now there are two important options. If you feel that this modification is correct, you can add this file. Otherwise, what you can do, you can restore the previous file. Okay. So if I write git restore, okay, readme.md. Okay, restore for spelling is wrong, but let me first of all close this file. Okay, let me close this file. Now, once I write restore and probably just execute this, here you'll be able to see that the file will be restored. How do I know that? Just open this, open your notepad, and just drag and drop over here. Now you can see that the further text that I have written, probably by mistake or nothing as such, I don't want to do that permanently. You can also revert that or restore the previous file that was actually there in the staging environment. This is perfect. Okay, now let's say that I made some changes, and here also I'm going to say, please subscribe to my channel. Then what I'll do, I'll make this one file. Let's say I want to make one more file, and this file is a text document file. And let's say this will be test1.txt. Now here you can see that I have added one file, and obviously readme file has been modified. Now if I probably clear the screen and write git status, okay, here you'll be able to see, okay, this file is modified and this file needs to be added, which is basically an untracked file. Now since two files are there, and I have to make sure that both the changes goes, right? So what I'll do, I'll write again git add. Now instead of writing the file name, I have to make sure that both the changes should go, and all the files that are present inside it, all the changes should go. So I can write dot. So once I do that, here you'll be able to see that by using this dot, all the changes will specifically go, right? So once we execute git add dot, so what will happen? Both the changes will go ahead, and now let's go ahead and see with respect to git status. So now the git status says that, okay, one file has been modified and one file is a new file. Okay, now we need to do the commit. So here when I do the commit again, I'll write my message. So I'll say this is my second commit. Okay, and here you'll be able to see all the changes are there. Now let me write git remote -v. So here you'll be able to see, okay, this is my origin, this is my thing. Now let me just go ahead and push this. So push from origin to main, right? So once I do this, here you'll be able to see one text document will also go. Now if I probably go and reload it, here you'll be able to see one more file has come, and here also it shows the information like how many commit has basically happened. This is my first commit, this is my second commit. So if you probably see the commit details, all the information changes, everything you'll be able to see it. So this is how a simple way we can actually do the commit with the help of command line prompt. I will also be showing you multiple ways how to do this also. Okay. Now let's say there may be a situation where you will be saying, Krish, I already have this repository. How do I clone this? How do I clone and make sure that everything tracking is basically happening? Let's say I create a folder over here, my new folder, okay, and this specific folder, since no need to create over here because again this folder will also keep on getting tracked. So let's say I have one more folder I create over here, and this particular folder will have some name, git tutorial, okay, the same name. So let's say this is my new folder. Okay, now inside my new folder, let's say I open my command prompt. Okay, I open my command prompt, and here what I'm actually going to do is that I'll just go to this particular folder location. So I'll say cd this one, okay, and let's say I've gone to my G drive. So this is I'm in my new folder. Now let's say I want to clone this entire repository over here. So in order to clone it, what I will do is that I'll go over here, copy this, okay, and I'll say git clone, and I will just put this git. So here you'll be able to see in this particular folder location, the entire clone will basically happen. So here you can see git tutorials, all the readme file and text1 file. Now I'll again go to my command prompt. Okay, I'll go to my Git tutorials. Okay, clear the screen. Now let's say that I want to create a new folder over here or new file over here. So let's say I created another new text document and I really need to push this. Now again, if I probably go and see Git status over here, you'll be able to see, okay, untracked file is there, right? So here what I did is already that there was a repository. I cloned it. Now I want to commit in that same repository over here, right? So what I'm actually going to do after this is that just write Git status. I've already written. So now Git add dot, then Git commit. Okay, -m. This is my third commit. Okay, and this commit has already went. If I probably see my Git status here, nothing is there on the main branch, so everything is there. And currently, what is my main branch? If I really want to see, if I go and write Git branch, here you'll be able to see main branch. Okay, and then finally, I will try to push this from origin to main. No need to write to. Now, usually, guys, for the first time when you do this, right, Git push origin main, right, it will ask you for an authentication. Since I've already authenticated it, so you just have to do the authentication to make this push successful because there you need to write the password and all. Okay, so now you can see that the commit has actually happened. I can again reload this page. And here you'll be able to see new text document. Again, 3 commits. This is my third commit. So you can also clone this and you can also start the committing process. Okay. Now in this tutorial, we have learned all these things. In the upcoming videos, what we're going to do is that we're going to see how to revert the changes, how to make sure that everything is tracked parallelly. I'll also show you the concept of branching. Can I create my new branch? Because in a bigger project, when you're specifically working, you really need to create multiple branches when you're working. And once the changes happen, you commit into that branch, and then we do a pull request from there. We merge it. All those things as we go ahead, we'll be learning of. Right. So I hope you like this particular video. I'll see you in the next video. Thank you. So guys, we're going to continue the series of tutorial with respect to Git and GitHub. In our previous video, we have seen how to install Git CLI, and then we did it for Windows. You can similarly do it for Mac or Linux. And then we did the global configuration setup with your username and email address. That we did it. You can also use some color UI if you really want to use to see that how the untracked files will probably look or modified files will basically look. They'll just add some coloring things so that you can actually clearly see in the command prompt. Then we did Git init. We also tried to see how to clone a URL. And now we are going to, with respect to Git status, also we checked it out. We also saw how to add files for your next commit, basically in the staging part. Now we're going to see some commands like git reset, git difference, git different stage, and obviously we have also seen commit and all. Right. Along with this, if you just follow this entire cheat sheet along with that, you'll be able to understand everything. Okay. So after that, we'll also see some branching strategies because see, in a team, many people will be working, many developers will be working. And whenever a story is assigned to you, right, what you will actually do is that you'll take a main branch and you'll probably create a new branch from that. And that branch will be having the copy of the main branch itself because all the code will be actually present over there. Then you do the coding, then you commit it into that particular branch and you merge that branch with that specific main branch, right? So all those things we'll try to do it now. Now, this was my command prompt right now. You can see that if I go and write git status. So what does git status basically do is that it shows modified files. Right now, I don't have any modified files right over here. So I'll go to this folder. I will create a new document. Okay. And once I create it here, you will be able to see git status. And obviously in this particular status, you can see that there is one untracked file which is called as new document 3.txt, right? So over here to make it sure that we are tracking this, we really need to use what command? That is nothing but git add command, right? Git add file. So here you can see add a file as it looks now to your next commit. So that basically means we are basically moving it to the staging. So that is the reason why we have to basically use git add. So here I'm going to use git add. I'm not going to give the file name again and again. I'll just use dot because I just have only one file over there. Dot will make sure that all the files are basically getting added. Now I'll clear the screen and probably now go ahead and see git status. Obviously one file I can actually see over here. Okay. Now let's see what is git reset. Okay. Here one more option that you have is something called as git restore. Okay. So if I write git restore and if I write minus staged and the file name. So the file name is new text document and that file name is 3. Now if I enter this is going to unstage this. Okay, so let's see now if I go and see git status, here you'll be able to see now it is an untracked files. Okay, so this is what you can basically use git restore minus stage with the file name. One more way is that you can directly use reset also. So here I'm just going to clear my screen, or let me just add the file name and then I'm going to clear the screen. Now if I probably see git status, right, here you'll be able to see that all the files this particular file has been tracked and it has been committed to the staging environment, right? Still you can say that this needs to be committed to the staging, right? That's this entire commits you can just say that okay, we have done one step ahead and now we're going to move this into staging. Okay, now let's see there is also one thing called as git reset. So if I probably write git reset along with my file name, right? So I can also use file name over here. You can see this file, right? So file name basically means here I'll be using new text document 3.txt, right? So this is my new file name. So if I do this reset, and now if I probably see the git status, so it will do almost the same task what we did with the restore. Okay. So I hope everybody has understood about what is reset. Okay. Now let me do one thing. Let me add this file again. Okay. And then if I probably do git status, here you'll be able to see that okay, fine, these changes to be committed are there. This is the file that I really want to move it to the staging part right now. Now there is also something called as git diff and git diff stage. Okay. Now see what will happen if I write git diff stage. Okay. So this basically will show me, like if you probably see the description, a difference of what is changed but not staged. Right now the real staging will only happen when this added file will be committed to that particular staging environment. Right. So how do we do that? For that we basically have to write git commit -m along with some message, right? When I do this, then what will happen? This particular new file you'll be able to see it will be moved to the staging environment. Now right now we are just seeing what is the differences that is there and what is the file that I just added but not committed to the stage. So that is what you see over here. Now finally what I will do is that if I'm sure about this particular commit, I will move this file to my staging environment so that it can be pushed to the GitHub repository. So here I'm going to write git commit -m. So let's say this is my new document commit. Okay, I'm just going to give some message and I'll press enter. Okay, now if I clear the screen and if I execute the same thing, here now you'll be able to see nothing is there, right? That basically means everything is moved to the staging environment, which is basically my current local staging environment. I already told you that it's just like a playground. Whichever needs to be committed to the main repository, first of all I'll push it over there, and then I'll first of all commit it over there and then push it to the GitHub main repository, right? Now if I also see git status, nothing is there. Your branch is ahead of origin main by one commit. That basically means it's now checking the main branch over there and it is saying that okay, you are just ahead in your local repository by one commit. Now I'm going to push this entire commit over there. So in order to do that, I'll write git push origin to the main branch, right? Because that is the main branch. So once I execute this, now if I probably go and see over here, one more file called as new text document 3 will get created. Okay, so here you can see, and this was the recent commit that we did with respect to this, all the changes. This was a new file that got added. I did not write anything in the file, but that is fine. Okay, now again, let's go back. We have completed all these things. Now this was regarding stage and snapshot. Stage and snapshot basically means that after we commit, right, something like when we write this particular command, which is like git commit, right? Git commit. This is basically going to take a commit snapshot, put it into the staging part, and that staging part, that entire package will be moved towards the main GitHub repository. Okay, now let's go ahead and understand about the branching strategy. Okay, so branch and merge. First of all, if I just go and execute git branch, Okay, so here you can basically see that I have a main branch. What if I want to create a new branch in my local repository? Now, in order to create a new branch in my local repository, I'll go over here. I just have to write git branch name. Now, why this is specifically used? Now, understand. Let's say that I've been assigned a new story to work with, right? So what I'll do is that first of all, my entire code repository is in the main branch. So I'll take a copy of it. While taking a copy of it, I'm just going to cut a branch from that. Okay, so from the main branch, I'll just cut a branch. Now here you can see this. If I write git branch name, let's say this will be my developer branch name, and if I execute it, now if I probably see what is the git branch that I'm working in, now we are basically working in main branch, right? But I have actually created a developer branch. Now, if I want to move to the developer branch and work in this developer branch, so what I can do, I can basically write git checkout, and here I will basically go to my developer branch. So here you can see that it is switched to the developer branch. Now, if I probably see git branch, here you'll be able to see that I'm in the developer branch. Now this is fine. Okay. Now whatever work you do over here, whatever commit you do over here, it will basically go to the developer branch. Okay. So what I'm going to do, I'll again go and create a new text document. Now my new text document is created. Now what I'm actually going to do, I'll go to write git status. Here you can see that on the branch developer, it has the main copy of the main branch, right? And obviously all the files will also be here. But now I've created a new file. Now I have to make sure that this file gets added into the branch developer, right? Developer branch in short. So here I'm going to again do git add, and then I will be saying git commit -m so that I move this commit snapshot to the staging environment. So let's say this is the new story. I am working as a developer. Okay, I'm just writing my commit. Okay, please don't worry about the spelling and all. Okay, so I'll execute it. Now what will happen? This entire changes will be going to the developer branch, right? So if I probably go and see the git status, now it is basically in the developer staging environment. Now let's go ahead. Now this we have already learned. If you say git checkout with that specific branch name, you'll be able to get a checkout. Okay, now this is super important. Git merge. Let's say that my work is done. Now I have to merge this entire commit to my main branch in the local repository itself, right? So what I'm actually going to do, so I will say, first of all, I will check out to the main branch. Okay, so right now if you go and see git branch, okay, so here you'll be able to see I'm in the main branch. Okay, now what I'm actually going to do, I'm going to say git merge with this specific branch. So it says that merge the specified branch issue into the current one. So I will write git merge with my branch name called as developer. So once I execute this, you can see the new text document found, one file changed, this is there. And if I probably go and see the git status, here you'll be able to see that your branch is ahead of origin main by one commit. Now what you can do, you can also make sure that you write git push, okay, git push from origin to main. Once I execute this, now this new file will be pushed to the main branch. Now if I go over here and probably see in git tutorials, you'll also be able to see the fourth file. And these are all my commits that I've actually done. This is the new story I was working as a developer. Okay, this is super easy. But there is one more thing that we need to find out, and probably we have also collected this, right? Git merge branch. Now we'll also understand about git logs. Now what will git log basically say? Okay, let me clean the screen. If I write git log, here you'll be able to see all the commits from the previous logs that we have done. This is my second commit, third commit, formal commit. I think the latest 5 commits it will be able to say. So I'll just press Q from there. Now what I'm going to write, I'll say git log -p. Let's say I want just the last 3 commit. So here I will be using -p, -3. -3 will just say you the last 3 commits. So this is the new document commit. Here you can say this is the new story I'm working. So all the information of the commits also you'll be able to see from the logs. Now whenever you get this scenario, just press Q, you'll be able to come out. Okay. So yes, in this video we have committed, I have explained you about all these things, differences, stage, commit, this. Okay, merge, branch, and all. Okay. Now what we are also going to do with respect to this, whenever we create a new branch, right? We also need to make sure that we commit that entire, or we push that entire code from that branch to our main repository. Okay, and that I will try to show you in the next video. And we're also going to see all these things, because once we commit from our local repository to our branches in the main repository, let's say that over here I've created a branch, and then from that particular branch I've done the coding, and I push that entire code to that specific branch code in the GitHub main repository. Because right now I just have one branch only, right? I don't have 2 branches, but it is always a good idea that I should be able to push as another branch, and later on we can do a pull request and we can merge both the branches also. So that is what we're going to see in the next video. And apart from that, we're also going to see all these things, all these steps, which will be super important. So yes, this was it for this particular video. In short, we have spoken about stage and snapshot, and then we have also spoken about branch and merge. So in the next video, we are going to continue the discussion with respect to this. So yes, I'll see you in the next video. Thank you. So guys, we're going to continue the discussion with respect to Git. Already in our previous video, we have seen how to install Git CLI. We have seen how to do the setup by configuring all the information of your GitHub repositories and all by using this global username.user.email and all. You also seen about Git init, Git clone URL, Git status, add, reset, and we have seen a lot of commands related to branching, how to check out a specific branch, how to merge a specific branch and all. In this video, we're going to cover a very super important topic because this topic is must for everyone. That's merging branches and resolving conflicts. Now see it, guys. In most of the companies, right, where you have a team of developers, many people will be committing into the same repository again and again, right? So let's say that this is my main repository. So let's say this is my main repository. Okay. Now let's say there are two developers, developer A and developer B. Okay. And let's say they have assigned story 1 and they have assigned story 2 to developer B. Right. Now, when the developer A starts the work, first of all, developer A, and always remember in this main branch, your entire code base repository will be there. Okay. Everybody probably, if they're committing in the developer in any branches, later on they have to merge to this main branch. Okay. So initially to start the story 1, what the developer A will be doing is that it will check out a branch from the main branch because the main branch will be having the entire code base repository. So once they do that, and they will be working on their own stories. Let's say the story's work is going on. At the same time, what happens, because developer B also needs to parallelly start his own story, right? And they have to develop this entire story or any model that they are trying to develop, right? Over here. So what they will do, they will also check out a branch from this particular main branch because the main branch has the code base repository. The entire code base repository is basically present over here, right? Code base repository is present over here. Let's say that. Okay. Now, when a developer A checks out a branch, so it will definitely create this entire module, and at the end of the day, it is going to merge this specific branch over here back, right, to this particular branch. It is going to merge this entire code that is being written in the story 1. It is going to return it back to the main branch. Now, in this point of time, when developer B completes its story, so what it has to do, it has to then merge this entire branch back to the main branch. But here you can see that developer A may have added a lot of files, and probably in the previous code base, in some of the files, in the same file, some changes may have happened where developer B may be working. Now, in this scenario, there will definitely be a situation which is called as conflict, right? Because developer A had also added something in file name 1. Let's say in file 1, they have made some changes in the code, and in the same file, developer B is also making some changes. So obviously, there will be a conflict. Sorry, in the same file, that is in the file 1, let's say developer B is also making some changes. So obviously, there will be a conflict with respect to the changes from developer A and developer B. Now, when the developer B pushes this code, there will be an error saying that, okay, some conflict has actually occurred. So how do we fix that? For that, we have to resolve that conflict. And today in this video, I'll show you how to resolve that particular conflict. It's more about merging your code in a proper way, okay? So first of all, let me just go to my GitHub. I will create a new repository and probably show it to you, okay? So let's say this is my some application I'm trying to develop, okay? Application. I'm just going to write application over here, and let's say fine. This is my application over here, and what I'll do, I will add a README file, and you can also go and add a git ignore file. So here I'll be saying Python, and license can be general public license, and I'll create the repository. Now this is the first step. Now see guys, I have made two folders. Okay, I made a folder git merge conflict. So let's say in this local folder, I'm going to write developer A, and whatever developer A is trying to make the changes in the code, he will try to make in this, and similarly I will be having developer B. Okay. So this will be developer B. Perfect. So developer A, developer B is there. Now what I'll do is that I will just go and open my command prompt and I'll clone the repository first of all. Okay. So I will quickly clone the repository. But before that, let me just open it. Yeah. So I will just clone the repository. Okay. So I will say git clone. How do you clone a repository over here? It's very simple. I will go over here, copy this entire git, go over here. Okay. And I'll say, first of all, I'll go to this specific path because I need to clone in this specific path, right? So here it will be CD. Just go to your E folder, automatically the changes will happen. And now I will say git clone. And I will go to my GitHub repository, copy this, and paste it in my command prompt. Okay. So git clone. So once I do this, you'll be able to see that the entire cloning of the application will take place. Okay. Perfect. I think we are good enough to go with respect to this. Okay, so once the cloning will happen, you'll be able to see that the application is over here, git ignore file, everything is there. The same step I'll be doing it for developer B. Now for the developer B, what I'm actually going to do, let me open another command prompt. It'll be good because I want to execute all the codes in different command prompt. Basically, I want to execute all the git commands in different folder. So here it is. So I'm just going to make a CDE. So CDE E folder. Has it not changed? CDE. Okay. Okay, sorry. So now I'm there in this specific branch that is developer B, and again I'll clone this entire thing. So here I'm going to write git clone, and I'll paste this entire git command. Okay, so entire cloning will happen. Now you can see I will be having developer B also, I'll be having developer A also. Now guys, after cloning, now you can see that every coding that I'm actually going to do as a developer A, I'm going to do over here, and every changes or every story that I create for developer B, I'm going to do it over here. Now this two folders is exactly made like you are just working in a separate system, let's say, and you are doing the coding over there and you're trying to commit it from there. Okay. Now the first thing, let's go back over here. Okay, and let's see developer A. This is the application. So right now, let me just open another command prompt over here. You can see this is for developer B and this is for developer A. Okay. Now a super important thing that I'm actually going to do is that let's check out a branch. So right now, if I probably see git branch, and the branch will be something like master, I guess, master or main. Okay, so git branch. Okay, I have to go inside the folder called as application in developer A. Okay, so I'm going to clear the screen. Now, if I go and write git branch, you'll be able to see git branch. Okay, now here you see that it is a main branch because we have already cloned it from this specific branch. Okay, now as a developer A, let's say that I want to make some changes. I want to add some files, or I want to add my own story, right? Like I want to do some kind of development or any changes that I want to make. So first of all, I will check out the branch. Okay, so I'll say git branch, and I will make a branch which is like developer A. Okay, so let's say this is the new branch, and then I will check out this developers A branch. Okay. So you can see now it is switched to developer A branch. Okay. So now this is. Now if I go and see git status, obviously there will be no changes because I've not made any changes as such. Now I'll go over here in developer A and open this README file in my notepad. Okay. Here application is written, right? So here I'll say changing developer A or adding developer A story. I'm just writing something, some information. It can be code, it can be anything. So adding developer A story. Developer A story. So before application also I'll try to update it. Okay. Perfect. Now this is the changes that has gone. Okay. Now I'll just update it. Okay. And now if I probably see git status, you'll be seeing that okay, there is some file that has got modified and it is inside this developer A. Obviously the branch is developer A. Okay. Now what I'm going to do, I'm going to commit it, right? So I'll say commit -m developer A story changes, right? So I'm just going to add the story changes. Wait. Okay. Developer A commit A. Okay. Something has been wrong. Okay. Okay. Sorry. One thing I missed it out, right? I have to basically git add dot, which I missed it, right? Not a problem. Because again, you always need to make sure that you continuously check the status because I missed that particular thing, so I did not get added. Now I'm just going to commit it. So here will be my commit along with the message saying that developer A story, okay, and I will execute it. Now you can see that this is fine. Which branch I'm in, get branch, you can see developer A. Now what I'll do is that I will check out to the main branch. Now I have done this checkout to the main branch so that I can merge this main branch with the developer A branch, right, in my local. So I'll say get merge. I want to merge developer A to main, right? So I'll write get merge developer A, right? So once I do this, you'll be able to see that, okay, it has gone updated now. Now if I probably see get status over here, nothing is there. Everything is in the main branch. And right now I'm currently in my main branch itself, okay? So here you can see main branch. Now what I will do is that I will push this entire changes from my origin, because after developer A completes his or her story, he has to actually push this entire changes to the main branch, right? So right now we have merged that developer A branch to the main branch. Now this particular main branch is going to get pushed into the main repository. So I'm going to write get push origin to main. So once I do this, you'll be able to see that, okay, all the changes are gone. And if I reload this, here you'll be able to see two commits will happen and update application adding developer A story. So this changes has already happened. Now before that, what happened? Developer B also started that stories, right? Started his or her story. So let's say we go to now the developer B. Okay, we go to now the developer B over here, okay, and I will go to CD application, okay. Now right now you know that, okay, some commit has already gone to the main repository over here, right, developer A stories, okay, and before that only the main copy is basically taken by this developer B. Now again here what it will do, we will just make a branch, okay, let's say get branch I'm going to make for developer B, because this is the process we do. We always have to create a branch whenever we start a new story, so that it is actually a good practice altogether, so that you are curiously working on your story, and when you're merging you'll definitely get some conflicts. Then I'll do get checkout developer B, okay, sorry, developer B, and here you can see that it is switched to developer B right now, okay. Now if I probably go and see with respect to developer B, and if I open this readme file, you'll be able to see that I have updated some of the things over here, application developer B and all. So what you can do is that here I will just of all write something, okay. Let's see developer B, I'm just going to update this application, okay. And the next thing what I'm actually going to do, I'm going to say get status. Now if I probably see status, obviously modified readme file will be there, and then I will add this readme file, get add dot, and then I will say get commit -m. This is basically my developer B commit, okay. Now see in that same file I've actually updated it, right. Now if I probably see now the get status, you'll be able to see nothing is there, okay. Now let's say I'm going to switch back to the main branch. So I will say get checkout main. Now this will again come back to the main branch. Now we will try to merge this entire thing into the main branch. So I'll write get merge from the developer B branch, okay. Developer B branch, and this is basically with respect to the local snapshot, okay. So here you can see that something has been inserted and something has been deleted, okay. Now if I probably try to open this, you'll be able to see that I have got the changes, updated application developer B, perfect. This is fine. Now the main thing is that you have to push these changes to the main branch, but understand developer A has already pushed something over there. So are we going to get an error because he has also pushed some information in the same file? So what I will write get push, and let's see after pushing what will happen. So here you'll be able to see that this rejected error failed to push this is there. This is usually caused by another repository pushing the same reference. You want to first integrate the remote changes by using git pull. So now let me just go ahead and do git pull. So once I do git pull, you'll be able to see that there is some conflict, right? And this conflict was because the developer A pushed something into the main branch over there in the same file. So here it is saying that there is a conflict. Merge the conflict into the readme.md file, and then all you do all these things, right? Don't try to do any dirty work, okay? First of all, conflict all the developer changes. Some of the developer has again pushed before you, so you have to fix this issue. So what now? If I just go ahead and open this, you'll be able to see all the changes. Now you see this is the content that has been updated by developer B, and this is the same content that is developer by that is updated by developer A, right? Now what I'm actually going to do, you have to do this conflict changes manually, okay? So let's say I want to include both of them, so I will go ahead and do this entire conflict changes, and I'll save it. So both the information has now been merged, and you have to do this conflict very curiously, guys, because understand when you're coding in bigger files, there will be functions or modules that may be integrated, or there may be changes in the previous function or module. So you really need to merge that conflict very much in a proper way. Otherwise, it is a complete mess. Okay, I've seen many developers, they completely override your code, whatever code you have actually committed. So this may actually happen. Now here it is. So I'm just going to save this and close it. Now fine, everything merge is done. So now I'll go and see my get status. Here you can see both modified readme file is there. So I will now write get add this, and then I will say get status. It is already fine. Changes to be committed. So if you see changes to be committed, that basically means I'm just going to commit developer B story. Okay, developer B story. So once I do that, done, and all it is get push. Now tell me whether this will work or not. It will obviously work. I'm super sure about that. Now here you can see that everything has been committed. Now if I go and probably reload this GitHub repository, so here you can see updated developer B, updated application, adding developer A story. Everything has got updated, and now you'll be able to see that how we have easily fixed the merge conflict issue, right? Super important topic, guys. So yes, this is what you will definitely face in when you're working in a bigger team. A lot of conflict issues will try to resolve because parallel stories will get implemented by many developers, right? Now yes, this was it, and now we'll in upcoming videos we are going to still follow some more videos. I'm going to create some more videos related to this get rm, move, log, stash, and we'll try to see what is the differences, right? So yes, I will see you on the next video. Thank you. So guys, we are about to start the end-to-end machine learning implementation with deployment. And again, the main aim of this specific series is to develop end-to-end projects. And the things that we are going to learn, the similar things are basically applied in the industry when we are solving any kind of projects. We are going to basically discuss in the series about each and every modules, what all things we can basically do on top of it, and how we can easily crack any data science interviews. This end-to-end project implementation will be a game changer for cracking data science interviews. Why? Because all the students who have till now cracked, or any professionals who have cracked data science interviews, they have really explained the projects very well. Okay. So from your side, only one thing is basically required, that is dedication. If you're able to dedicate properly, if you're able to see, if you're able to understand, if you're able to practice, right, how the project implementation is done, and then you can probably apply in different projects like in deep learning and all. All these techniques will be same. We'll try to create a generic project structure. We'll try to use methodologies, tools, techniques in such a way that you will be able to apply in any kind of projects going forward. Now, what all things we are going to do, what all things we are planning to do, everything we will be discussing. How I'm going to divide this particular parts of all this particular series, that also I'll be discussing. So let me go ahead and let me share my screen. So and all the line by line code, I'll be writing it in front of you. We'll be implementing in such a way that parallelly we'll try to implement. I will be committing the code, and then based on that, we will go ahead with it. Okay. So let's go ahead and let's try to do this. Okay. Now I'll just open this one. So obviously I've spoken about the agenda. So agenda of today's video. is that whenever you are doing any kind of machine learning or deep learning project, the first and the most important thing is that it's all about your repository, right? Where you're committing the code, because you specifically work in a team, right? Team of people. Now, when you're working with a team of people, definitely you will be seeing that there are many people who will be collaborating, right? At the same time, they'll be committing the code, they'll be merging the code, they'll be developing new models. So the first thing is that what we are going to do is that we are going to basically set up the GitHub, right? And this GitHub will be our repository, right? For committing our code. And probably if you're working in team, you can also work in team so that your development will be in sync whenever you're probably developing it, right? The entire application in short. So setting up the GitHub will be the first one. Then in this GitHub, what are the best things that we will be applying? Like let's say in the first case, I want to go ahead and probably set up a new environment, right? So GitHub, and this is today's agenda, what I'm going to basically say. New environment, right? How do we create a new environment? What all things we have to make sure that while working with a new environment, there's some things that we really need to make sure that that thing is in place before implementing the project. It is always a good practices. Then we will try to decide a mini project structure. I'll not say mini, see, anyhow, I'm actually developing the entire project, right? We'll be discussing also about setup, right? Setup.py. Now, what is the importance of setup.py? We'll try to understand after creating the new environment. And finally, how probably I can also build a package using setup.py. We'll also discuss about requirements.txt. So, again, there's a relationship between requirements.txt and setup.py also. We'll discuss about that. We'll create a new environment and we'll do this. We'll do all this tasks today. And in the next video, what we are basically going to do is that we are going to go with the next step, wherein we will be implementing logging, exception handling, and then we'll try to decide a formal project structure. How do we decide a project structure? That also I'll be talking about. What are the best practices that we specifically follow. Now, let's go with the first one, that is set up the GitHub repository. So what I will do, I will quickly go into my GitHub. All the committing of the code will happen in the GitHub, guys. This will basically give us a real world industry experience in short, because we are continuously working, we are committing the code, we are merging the code, we are pulling the code, and all many things we are going to do with respect to that. So the first thing first, I will go to my repositories over here. So I hope everybody has a GitHub account. So let me go ahead and create a new repository. Now, with respect to this new repository, I'm just going to give some names. So let's say my name will be ML projects. Okay. As I'm saying that, this will be a generic, completely generic project structure. Later on, you can replace any data set. We will try to use all those techniques. What all techniques is basically required, that will follow. So ML projects. So right now I'll keep it as a public so that I will be able to share this with you. Okay. And then let's go ahead. Don't click anything as such right now. Okay. Don't click anything. Just write ML project. Don't even write description. I'll show you how we can basically write everything and all. So I will just go ahead and create the repository. Now, once you create the repository, this is what you specifically get. Okay. Now this is about my ML project. Now what I did is that I will probably go into my E drive. Okay. So I have created a folder. Now inside this, I will be doing my entire project development. Okay. So I will copy this path. I'll open Anaconda prompt. Okay. Now, the reason why I'm opening Anaconda prompt, I will just go to this specific path. So let's go to E drive. So I'm in this particular path, that is ML projects. Right now here you can see that I'm in the base environment, right? And obviously, if you have Anaconda prompt or if you have VS Code, anything as such, okay, we can actually start. Again, to talk about, many people are also talking about the prerequisites. You really need to know Python programming language, modular coding. You need to know about machine learning algorithm. So if you are dedicatedly following my machine learning playlist or the deep learning playlist or the Python programming language, it will be more than sufficient. Now from here, what I'm actually going to do is that I'm just going to type code dot. Now this code dot will basically launch a VS Code instance. Okay. So if I execute this, so this is how my VS Code instance will look like. Okay. So here you can probably see this. It will show GitHub could not be connected. It's okay. We can just start this. So this is an empty project completely initially to start with. And this is my VS Code that you will be able to see. Okay. This is my GitHub repository. Okay. And this is my VS Code. Okay. VS Code. Right. Now, first thing first, I have to make sure that I will sync with my GitHub repository over here. Okay. So to start with, what I'm actually going to do over here is that I will just go ahead and open a terminal. So here is my new terminal. Okay. So this is my new terminal, right? It can be a PowerShell, or I can also use command prompt, right? It is up to us, right? Whatever terminal that you want to specifically use. Okay. Now the first step is always to create an environment, right? Now what I want is that, guys, I don't want to create a separate environment, but instead what I'll do here only, an environment will be getting created, and whatever packages I'll be installing, that will come inside this particular folder. Okay. So let me just show you what I'll do. So basically what I'm saying is that inside this particular project itself, my environment will get created, and whatever packages I install, that all will get created over here. Okay. So let's go ahead and see how to do that. So guys, now let's go ahead and create a new environment. And for creating a new environment, I'm going to basically use a command. You can also search this in Anaconda also, you'll be able to search it. So first is conda create, okay, -p, okay. And the environment name, I'm going to basically give venv. Python, this entire project I'm going to develop with 3.8. And finally, I'll just use Y notation just to make sure that the installation happens. And for that, you need not have to ask for the approval again. Like it'll just ask for the approval where we have to either type Y or no, like yes or no. So here by default, I'm giving Y. So once we execute this, here you'll be able to see that the installation will happen. And my environment will get created. Now here you can see venv is getting created. Anything that I will probably install, like your libraries and all, it'll just get installed itself over here, right? So this is where I'm going to make sure that all my packages are available over here. And this is a good practice because at the end of the day, I can freeze all my libraries from this particular folder itself. Now, after doing this, I'm just going to clear my screen. So I'll write CLS. And what I'm actually going to do, I'll just write conda activate, okay, venv, which is my environment, and I'll just write like this. So automatically you'll be able to see that I will be inside this particular environment. So I've activated my environment in short. Okay. So perfect. We have done this. We have actually created our environment. We have done everything as such. Okay. This is perfect till here. Now the next thing what we are going to do is that we are going to clone this entire repository and we need to sync this with the GitHub so that we'll be able to commit all our code. Okay. So we will just follow this step by step and we'll see that how we can make sure that whatever things we are committing, right, we basically commit in this specific repository. So first of all, we really need to initialize the Git. Okay. So I will go over here, open this project. So let me go ahead and write Git init. Okay. So once I write this, I'll be initializing an empty Git repository in this specific location. Okay, so you'll be able to find out this particular folder. Right now it is hidden. Okay, but if you go into the folders itself, you'll be able to see it. Perfect. Now after that, we'll go to the next step where I will just add my README file. Okay, so I'll just add a README file. But before adding, let me just create one README file over here. Okay, so let me do one thing. Oops. Okay, let me do one thing. Instead of creating a README file over here, what I'm actually going to do is that I will just create a README file over here itself. Okay, I can create it over here also. I can create it over here. That is up to you. So let me do one thing. Let me quickly do one thing over here. I'll just minimize this. I will just create a README file here itself. So I'll just create one file. Okay, it is going inside this particular folder. No worries. So now let me go ahead and create one readme.md file. Okay. Now, readme.md file is just like a file where you can probably write your descriptions, whatever things you are, like what are the steps that you should basically write over here. Okay. So here I can basically write end-to-end machine learning project. Okay. So this is done, end-to-end machine learning project. I'll just save it. Now let us go ahead and add this README file in my GitHub repository. So in order to do that, I will just write git add my README file name, whatever file is there. So here you can see that it has got added, and I'm following the same steps. So here you can see I've added the README file itself. Now in order to commit it, I will just go ahead and write git commit -m first commit. So here I'm just going to use this particular. I'll just say that okay, fine, I want to commit this particular thing. So here will be my normal message. This is my. I will just say first commit. Okay. So with the help of first commit, let me just make my face a little bit small. Okay, so that you'll be able to see this. Now, once I do this first commit, I'll just press enter. Here you can see that all the file changes are happening. One file change, one insertion is happening, and they have basically seen this. Okay. Now, if you really want to see that, what is the status with respect to the commit? So I can just write git status, and here you can basically see use git for adding this kind of environment. Everything you can probably add it. Okay. What I will do also is that I can also add a git ignore file. Okay, that we'll talk about it. But right now, I have made sure that I have basically committed my readme.md file. Okay, over here. Now the next step will be that I have to push this file. So let me just clear the screen all over here. Let me push this particular file into my GitHub repository. So for doing that, before that, we will go ahead and check out our branch to main. So just copy this. Okay, and I'll paste it over here. And then the next step, what I will do is that I will just write git remote add origin. So I have to make sure that this origin is added so that it is in sync with this GitHub repository, right? So I will just go ahead and paste it over here. Done. Now, if you probably go and see git remote -v, you'll be able to see that I have actually basically synced it with my own Git repository over here, right? With respect to origin. Now, finally, in order to push this data into the GitHub repository, we just need to use this command, that is git push -u origin main. Okay. Now, before this, let's say you are doing it for the first time, then you also have to set git global, right? So here, git global config is there. So just go over here with respect to that, and you just need to type this command. Okay. So you need to sync your username and password, right? So sorry, not password, email and username, user.name. So user.name and email, like I have already done that because this git repository.github account that I have, that is with my own personal email ID, right? So if I just go and copy this and paste it over here, right? Here you'll be able to see my email ID is already synced. If you want to change the email ID, just after this same command, you can use double quotes and write your own email ID. So I've already done that. So what will happen is that I can directly push. So here you can see for the push, what command you'll be using, push -u origin to main. That basically means from the origin to the main, the commit will basically happen. So here I will write origin to main, right? So once I do this, here you'll be able to see that my code has got committed, and this is how quickly I will be able to see now the file. Now if I will reload it, here you'll be able to see my readme file has got updated. Okay. Now this is how I have made sure that all my sync with respect to this particular code and the GitHub repository is done. So anytime I probably write any code over here, I will later on always try to commit the code that side. Okay, so please make sure that you do this particular setting first of all. Okay, you may get minor issues that may be with respect to configuration and all, but if you have seen my Git tutorials and all, I've already explained all this kind of things to you. Okay, now after this, what I'm going to do, I'm also going to create a new file, and this file will basically be my git ignore. Okay. So git ignore file. So here it will just be asking me options like what type of what programming language git ignore you want. So I will just go ahead and write Python, and I'll just commit the changes. So this will basically be the reason why I'm creating this is that because some of the files that need not be committed in the GitHub, that all will get removed. Okay. So some of the common things like .python version is not required. When we build the packages, all this will come, right? Suppose I have venv environment, so that also I can probably write over here. That will also not get committed. Okay. So I'm committing the change. So here I will say create git ignore, okay, and I'll commit the change. Okay. So now here you'll be able to see in my ML projects I have two files, git ignore and readme file. So for this, in order to make sure that everything is updated on my side also, so I'll just clear the screen and I write git pull. Okay. So once I do git pull, so all the updation will happen. Now here you can see I have this git ignore file also. So if you search over here venv, see by default this venv is also there because this is my environment, new environment, right? And I don't want to commit that specific in my GitHub repository. Okay. So perfect. We have done this. The first step of setting up each and everything with respect to the environments and always mapping and already mapping to the GitHub repository has been done. This is perfect. I've shown you everything scratch by creating manually. Later on, we can also automate this entire process. That also we'll see how we can basically do it. First, we'll start with some basics. We'll try to develop this. Once you get an idea, later on we'll move towards automation. Okay. Now, the next thing that we are going to basically do is set up our setup.py, and I'll talk about what is the importance of setup.py and all. Right. So let me go ahead and let me just create a new file. So the new file that I'm going to create is setup.py, and one more file that I'm actually going to create is something called as requirements.txt. Okay. Now requirement.txt will have all the packages that I really need to install while I'm actually implementing my project. Okay. So everything will basically be coming in this requirement.txt. Now what exactly is setup.py? Now see guys, I hope you've seen a lot of packages in Python, right? So Python PyPy. If you go and search for Python PyPy, so there are a lot of packages. If I probably search for any projects, any packages over here, let's say if I'm probably searching for Seaborn, right? So this Seaborn. Do you mean Seaborn? Yes. So in this Seaborn, you'll be able to see this is my package, right? In Seaborn. Now, how this package you will be able to install just by writing pip install Seaborn, right? Now, how this package is basically created, right? And for this, also setup.py file is required. So if you search for Python setup.py, right? Python setup.py. Understand the importance, okay? So if you probably see this, the setup.script is the center of activating, building, distributing, and installing modules using distributed. So I will talk about this, what exactly it is. But what I'll do over here is that I'll just create a setup.py, and this setup.py will be responsible in creating my machine learning application as a package. And that can be, you can also install this package in your projects, you can also use it, right? So with the help of setup.py, I will be able to build my entire machine learning application as a package and even deploy in PyPy, right? So Python PyPy, which we basically saw. And from there, anybody can do the installation and anybody can also use it. So that is the reason why we specifically use setup.py, okay? So it's very simple, building our application as a package itself. So in setup.py, there's many things that is required over here, okay? So what I will do is that quickly, I'll write down code, initially what all things you basically require in setup.py, okay? So to start with, what we will do is that I will write from setup.tools, and there are some basic things that you really need to do. From setup.tools, import, find packages. So this will automatically find out all the packages that are available in the entire machine learning application, the directory that we have actually created. And then I will just go ahead and write setup. So find packages and setup is basically required. Now what I'm actually going to do over here is that quickly go ahead and do the setup, and here you can basically see that all the parameters that is basically required. See, whenever we are creating the package, right, we really need to write like what name is the project of, what application is the project of. So let's say if I write name is equal to ML project. Okay, so this is my ML project. You can also use this as a kind of constant, but I'm writing it over here, and you have all these parameters. See, version, description, non-description. So this is basically talking. You can basically consider this as a metadata information about the entire project. Okay, so here I will just write my version. So version will be 0.0.1. So here you'll be able to see that whenever my next version will come, I'll just keep on updating this, and automatically that entire package will be built and it will be going to the pipe where you can also use it. Okay, so author, let's go ahead and make it to Krish. Okay, so Krish will basically be the author, and then you can also use author underscore email. So this will basically be Krishna. Just a second, why this thing is again coming back 06@gmail.com. Okay, and again comma. So author email is done, and then what we can do, packages. So here you'll be having something called as packages, and I can use this find packages. Now see, this will be very powerful. Okay, how it is able to find packages, we'll discuss about it. But I'm just using this function, this module that I've actually imported. And finally, we can also write install underscore requires. Okay, so install underscore requires will basically I have to just mention all the requirements that I want, like pandas, numpy. Okay, numpy. So here I can basically write numpy, or I want cbon. So whatever libraries I want, I can basically write it over here. So automatically it will do the installation of all the libraries. Okay. So this is done. Yeah, this is the entire thing with respect to the important parameters that I basically require. Okay. Now this is once we create it. Now this setup.py, how it will be able to find out how many packages are there and all. So for this, what we do is that I will just go over here. Okay. I will just go over here, create a new folder. Let's say I'm going to name this folder as src source. So if you want this source, right, the source to be found as a package, right, what we need to do is that inside the source, we will try to create a file which is called as in _init._py. Okay. So once we do this, with respect to this, what will happen whenever this setup.py, this find packages is running, right, it will just go and see in how many folder you have this _init.py, right. So it will directly consider this source as a package itself, right, and then it will try to build this. So once it builds, right, you can probably import this anywhere wherever you want, like how we import cbon, how we import pandas, similarly, right. But for that, we really need to put it in the PyPy package itself. But in our case, what we are going to do over here is that just to make sure that this gets built as a package itself, we will be using this and we'll try to create this particular file _init.py. Okay. So these are the basic things that we have actually done. Now, my entire project development will basically be happening inside this particular folder. Okay, inside this folder, and whenever we create any new folders, also there also we'll be using this file, so that that internal folder also behaves like a package once we build it. Okay. Now this is fine. Now there will be a scenario wherein, guys, we will be requiring many packages as such. Okay, I will probably require 100 packages in a project, right? And it is not feasible to write something like this. So what we do is that usually in this case, we make sure over here is that we try to create a function. Okay, and that function I can basically give my path over here. So let's say I create a function which says get underscore requirements. Okay, get underscore requirements, and if I probably give my requirement.txt, it should be able to read all those files. And now I have to create this function. Okay, so this function I will try to create it now. This function, the main work is that whatever path I'm giving over here, it should basically take this up, and whatever libraries should be over here, like pandas, numpy, okay, numpy, cbon, this all will get installed, and it will be taken one by one packages, and it will try to install it over here. So let's, for right now, I'll just take these 3 packages and I'll write it over here as setup.py. Okay, now let me just go ahead and write this definition. So quickly, in order to write, I will just write definition. Get a setter, no, not required. So here I will say get underscore requirements. Okay, and here 2 things I will try to do it over here, so that our task becomes very much easier. Okay, one is to definitely give what kind of input parameter I'm trying to give, right? So I will just make this as file underscore path. Okay, and this file underscore path is str, and this will basically go with, this will return a list. Okay, and in order to return a list also, we can basically write in a function, right? So this will be in the form of str, and obviously for this this list is not being recognizable because we need to import a library from typing import list. Okay, so in short, what I'm saying, my function will return a list, right? Because this requirement.txt will basically have a list of libraries, right? So once I probably go inside this particular function with respect to list, I'll quickly write a definition also. This function will return the list of requirements. Okay, so done. This is done. Perfect over here. Now we'll go ahead and write the code. So let's say requirements, I'm just going to make it as a list, and then I'm going to open the requirement.txt. So requirement.txt, this will be in the form of string or whatever file path that I'm specifically giving, right? So this file path, whatever I'm getting, so I can also use it over here. Okay, with this, I'm going to open this, and let me create this as a temporary object, file object. Okay, and then what I'm actually going to do over here is that I'm just going to write requirements. Now as I'm reading it, right, one thing, if I write file underscore obj dot read lines, right? So once we read the lines, what will happen? So inside this requirement.txt, this line will get read it, right? One element will get picked up. But there is one thing, a specific problem over here. Inside this requirement.txt, when we go to the next line, there will be /n that will get added. And whenever we try to use read lines, that /n will also get recorded over there. So what we are going to do over here is that once we get this requirements, right, we will try to replace the /n with blank. Okay. So for that, I will just write a list comprehension where I will say for requirements and requirement.txt. Requirements. Okay. So for requirement, just a second. Okay. So I'm going to take this particular requirements, and then I will just say req dot, there's a function called as replace, and then I will try to replace /n with blank. Okay, so this will basically be my for loop, and this is my entire list comprehension that I'm getting, and this I will try to replace it in my requirements. Okay, so I've done very simple. I've just read the object. I made sure that I'm replacing /n by blank, and I'm just replacing it in this requirements. Okay, so finally you'll be able to see over here that I'm getting this particular value. Perfect. So this is for this. Now always understand, guys, that I can directly install this setup.py, or what I can do is that I can, whenever I'm trying to install all this requirement.txt, okay, at that point of time, the setup.py file should also run to build the packages. So for enabling that, what we need to do is that we will specifically write over here as -e minus e dot. So when we probably give this minus e dot, this will automatically trigger setup.py file. Okay. Now there is one more thing over here is that in get underscore requirements, when we are reading, right, that minus e dot y will also come. Okay. And probably in get requirements, when we are installing this package in the form of list, minus e dot will also come. It need not come. Okay, over here. It should not come over here because wherever we have this requirement.txt, from this, if we have this particular value, if I'm installing this, it should get connected to the setup.py. But when I'm actually running my code over here, that minus e dot should not come. So what I'm actually going to do quickly over here is that I'll just say I'll just write one more condition saying that okay, fine, my hyphen e should not be available in the requirements, and I can actually remove it. So what I will do, I'll just say if minus e dot, or let me just create a constant. Okay, the constant will be something like this: hyphen underscore e underscore dot, which is nothing but it is given by you'll be able to see that minus e dot. So this is how it is there, right? So I can write a condition if hyphen dot e dot in requirements. Then what I have to do, since I don't want it in the setup.py, because it will automatically trigger. See, from requirement.txt automatically it will get connected to setup.py file. I'll just show you how that will basically happen. So if this is present in requirements, so all I have to do is that I have to just requirements.remove, and I will just write hyphen e dot. Okay, so done. So finally you'll be able to see after doing this, I will just return my requirements. Okay. Now see the magic. So many things we have basically done. We have setup.py, we have requirement.txt. In requirement.txt we have this. Okay, so I'm going to basically open my terminal. Okay, so this command terminal was already there. Okay, now see the magic. Okay, once I probably do the pip install. Okay, right now my source just has this particular file and I don't have anything else, right? So quickly let's go ahead and write pip install minus r requirement.txt. So once I execute this, here you can see that I'm getting some error. Okay, fine. What is this error? It is saying that install requirement, get requirements, no file requirement.txt. Okay, no worries. I think I made this mistake. So it will be when I open this file requirements.txt. Okay, fine, not a worries. It should not give an error. See, I'm not editing the error part and all, so you should be able to see the errors also. Okay, so automatically see everything, all the installation will happen, but at the end you'll be able to see one very amazing thing. Okay, since there is in requirement.txt there is minus e dot, right? So that minus e dot is basically mapped to setup.py. That is an indication that is basically given that setup.py file is there, and automatically this entire package will get built. Okay, where I will have all this information like ML project, this, and so here still the build is happening. It will take probably some time. Okay, so let's wait for some time. So over here, installing collected packages. See, so everything is happening, installing collected packages, everything as such. Now see, successfully installed this is there. Now once I go and see this, so here you can see mlproject.egg-info. So this basically indicates that your package is basically getting installed. Okay, now you can probably use this packages anywhere if you probably deploy it in PyPy. But here if you go and see requirement.txt, you have this. See, minus e dot has gone, right? Sources.txt, what all things has got automatically considered, right? See, automatically it has been able to find out underscore init.py, right? Top level, I have source, right? Package info. This is the information that we have written in setup.py, right? Dependency link, everything is there. So this is the basic thing that we have done. We have done the entire setup. We have set up our requirement.txt, we have set up our setup.py. Now all I'll do is that inside this, I will start creating more and more folders. My logging, my exception will happen. Understand my main project is this, but the outline that I've actually created with requirements and setup.py, I've actually done that. And this is what we really need to learn in the first part. Again, the agenda, based on the agenda, we have done all these things. We have also setup.py, requirement.txt. The second thing is that we have also created a source folder and build the package, right? We build the package. So all these things is basically done, the agenda. And this was with respect to the first tutorial. Now going ahead, since we are still focusing on creating a generic project structure, later on we go ahead and create the generic project structure itself. Now quickly, what I will do, I will go ahead and add in the git, right? So git.add. So here you can probably see my git status. So what all things has got added, these 3 main files has got added. Git ignore is not going, so all those things are there. Git ignore is already added over there, so again I don't have to send it. So finally I will git commit -m. The second commit, or I can basically write setup.py, and requirement. Setup, I'll just write it down. So this is done. Now the next instance, what I have to do, I just have to write git push -u origin to main. Okay. So yes, this is entirely done. It has been pushed to the main branch. Now if you probably go and see this and reload it, here you'll be able to see all these particular folders and files are there. Perfect. So this was the basic project setup, GitHub setup that we have basically done, the project structure and all we'll be discussing in the second video. This videos will be this long, so you will be able to understand it. Okay. Let's just go step by step, try to understand. If you're not able to understand anything as such, what is setup.py? Go and search for it. Okay. So if I probably say setup.py, right? Python. What is the relationship between setup and py? See, setup.py is a Python script typically included with Python written libraries. Its objective is to ensure that program is installed correctly. With the aid of pip, we can use setup.py to install any module also, right? So what is the relationship between that? Just go and search for it. What is -e dot, right? Just search for it. And everything will be available with respect to Google, right? You'll get all the solutions with respect to Google. See, doc Python tutorials, everything is available. What all things are there? What all things are not there? What is setup.py? You can definitely search for it. So I hope you were able to understand this. In the next video, again, it will be for another 30 to 40 minutes. We'll start developing the project structure in the next video. Hello guys, so we are going to continue the discussion with respect to the end-to-end ML project implementation. In our previous session, we have already done many things over here. We have set up our setup.py file. You understood the purpose of this, right? To basically create the package. We have this requirement.txt file. So any packages that will be required, I'll probably be writing it over here. We have seen that how to probably create an environment and how to start. Everything we have actually done it till now. Now, in this video, we are going to focus on creating the entire project structure and then some of the common functionalities like logging, like exception handling, how to write that specific code, where you should specifically write, what should be a project structure, everything that we'll be doing in this specific session. Okay. So in the source folder, right now, I just have underscore init.py. Now guys, see, when I'm creating the project structure, I will just do it manually because I need to show everything for you from the scratch. Later on, this entire process can also be automated. I just need to write one code like template.py and automatically all the entire folder structure will be created, right? I just need to write some 10 to 15 lines of code. But right now I am showing you everything from scratch so that you understand the projects well, right? So in the source, because whatever project I'm implementing, everything will come inside this. In the source, we are going to create some very important folders. The first folder that we are going to create is something called as components, right? Now, what exactly the specific components are and what will basically come over here. We'll discuss about that. But before, as soon as we create a folder, the first thing that you really need to do is that create this file that is init__.py. So with respect to this particular file, why do we do this? Because components will be created as a package, and it can also be exported, like it can be imported to some other file location. That is the reason I'm writing this underscore init.py. Okay. Now these components are like all the modules that we are probably going to create, right? Like initially we will probably create a process called as data ingestion, right? Data ingestion basically means I'll be reading a data set from a database, or it can be from some other file locations, or it can be from different kind of databases also, right? So initially we need to read the database. So that database, reading the data from a specific database, we specifically say it as data ingestion. So data ingestion is a part of a module, right? When we are probably developing the entire project, right? So that can be our component. So let's say that I'm going to create a component over here, and the first component that we are probably going to create is something called as data underscore ingestion, right? And for this, I will just create my .py file, and this will basically have all the code that is something related to reading the data, right? So here I have my data ingestion. After reading the data, what we will be doing, we may probably do data validation, we may probably do data ingestion, data transformation, right? So over here, since I really want to make this project very precise, very easy for you, so that you'll be able to understand. So after ingesting the data, I will try to transform that particular data. So my next step that I'm actually going to do over here is something called as data underscore transformation. Okay, and this will be also my py file. So any code that is related to transformation, like over here we'll probably be writing code how to change the category features into numerical features, how to handle one-hot encoding, how to handle label encoding. There may be different features for that purpose, right? So all the code we will be writing over here, right? So I'm just going to rename this again. Trust me, I'm going to make your work very, very easy, so that tomorrow you solve any project, if you just follow this kind of structure, right? That will be more than sufficient. Okay. So this renaming file is basically taking some time. Let's see why it is taking some time. So data transformation. Okay, done. So these are the two steps. First, data ingestion, data transformation. Right? Data ingestion also, right? When we read the data, we'll divide the data set into train and test, right? And this is all for the training purpose, right? Training the model purpose. So in the data ingestion, I will also try to divide the particular data set into train and test, and then we'll also create a validation data. We'll create different folders. That all code will be writing in this data ingestion.py. Now after doing the data transformation, the next step that I will probably want to do is that I will basically say this as my model underscore trainer, right? So here I'm going to specifically train my model. So in this specific py file, right? So definitely model trainer will basically all the training code over here, how many different kinds of model I want to use. I will probably also call over here the confusion matrix if I'm probably solving a classification problem. If I'm solving a regression problem, I may see R2, R squared, adjusted R squared value. All those things will basically happen over here, right? And from here also, see, next one more step, I can basically write model pusher also, okay? But I'll not still make many files, because since this is just your first project, from the trainer itself, I'll try to push that particular model pickle file into the cloud also. That also I will probably show you, okay? So these components that you have seen till now, data ingestion, data transformation, model trainer, mainly this is specifically for the training purpose, right? So this is how I've actually created the folder structure, right? So this folder structure, we specifically say components. Components are nothing but modules that we are specifically going to use in the project. Now, after this, let's me do one more thing. I will create one more folder, and this folder will basically be having something called as pipeline. Because what kind of pipeline we really need to create, right? That also you really need to know, right? With respect to pipeline, two types of pipeline I'll decide. One is the training pipeline, and one is the prediction pipeline, right? So over here inside this pipeline, what I will do, I'll create a file, and this file will basically be written as train underscore pipeline.py. Okay, so this will basically have all the code for my training pipeline itself, and from this training pipeline, I will try to trigger or call all these components, right? Understand the structure of the project is super important to understand. If you get the basic skeleton, trust me, then you will automatically be able to understand where I have to create what kind of file, where I have to write what kind of code, right? So this becomes a modular programming code, a clean code, which will basically be acceptable in the industry standards, right? So one is the training pipeline, and the next file that I'm probably going to create is the predict underscore pipeline, right? For the prediction purpose, like let's say my model is basically created, and I want to predict for the new data, I'll basically write over here as predict underscore pipeline. Okay, now inside this pipeline, one more thing that I'm going to do, I'm also going to create one more file that is called as underscore init.py, right? So that I can import this, right? So all the files have been created. So for now, I will be creating these components and pipelines. Now the next thing that I'm going to do, since my entire project implementation will be happening inside this source, now I want to create three important files over here. One is definitely for logging. So here I will write logger.py. Okay. The next file that I'm actually going to create over here is for my exception. So exception.py for the exception handling purpose. And third one, which any functionalities that I'm probably writing in a common way, right? Which will be used in entire applications. So I'll basically say that as a utils.py. Let's say I want to read a data set from a database. I can probably create my Mongo client, like MongoDB client over here. So very much simple. You need to understand all these things, guys. See, if you're able to understand this project structure, trust me, no one can stop you in understanding the entire project. And that is the reason why I'm going step by step. And I hope you're loving it. If you're loving it, please do support it by sharing this video with everyone. Tell people about it. No, this kind of content will never get it anywhere. Okay. So all these things are done. Perfect. Now let's go ahead and probably write our exception handling code. Now, whenever you want to write anything with respect to exceptions, so just search for exception Python, right? And documentation you can basically search. So built-in exception, errors and exception. All this code is basically there, right? So with respect to exception, what I'm actually going to do for my case is that I am basically going to write my own custom exception. So first of all, I will going to import sys. Now sys, what exactly sys library is? Okay, what exactly sys is? Understand quickly. Okay, so let's talk about this sys library. See guys, there are many things that we specifically use in Python. Okay, and in order to use this, you need to understand some of the things. Yes, all the definition you'll not be able to get. So search for it. The sys module Python provides various functions and variables that are used to manipulate different parts of the Python runtime environment. So any exception that is basically getting controlled, the sys library will automatically have that information. Okay, so quickly let me do one thing over here. After importing sys, let's say if sys is not there, I can also try to put that into my requirement.txt. But I think by default sys will definitely be there. So here I'm going to create a definition of error underscore message underscore details. Okay, and here I'm going to give two parameters. So this will be my error message detail. Whenever an exception gets raised, I want to push this on my own custom message, right? So here I will give my error. Okay, this error, whatever message I'm getting, and the other parameter will be my error detail. And this error detail will basically be present inside this sys. Okay, what module we are basically imported. So I'm going to call this particular function in the case of this. And one more thing that you really need to understand: the return type of sys, right? It provides you like if I probably write error detail dot exe info. So let me write it down. So exe underscore info, right? So with respect to the exe underscore info, right? So this is basically talking about the execution info, and this will give you three important information. The first two information I'm not at all interested, right? But the last information will basically give me about exe underscore tb. Okay. So this information, from this information, we will be able to, this variable that is there, right? This info will probably give you all the information like on which file the exception has occurred, on which line number the exception has occurred. All those information will be probably given and will be stored in this particular variable right now from this exe underscore info, right? So this is the exception that I'm probably getting. I have all the details in which file, in which line I'm probably getting the exception. Now all I have to do is that I will probably create a variable which is called as error underscore message, and I will probably write any errors saying that error occurred in Python script. So in Python script name, and I will give the first location over here as 0. Okay, this is just like a placeholder. And after this, I can also give my line number. Okay, so I will probably go ahead and give my line number, and this will basically be my first placeholder. And after line number, I can also give my error message. What is the exact error message? And I will keep it this as 2. Okay, 2 is my placeholder. And then finally I write dot format. Okay, dot format. Let me just hide this so that you'll be able to see this. Dot format. And now we need to replace this 0 placeholder and all, right? So if I probably write dot format, I should basically be writing from here. Okay, so let me go ahead and write. So dot format. Okay, and remember guys, this will be common. Okay, it is not going to change again and again. Okay, so in dot format, the first thing that I'm going to give is file name. Okay, file name I have not executed it. So let's do one thing. I will create my variable file name, in which file name I'm probably getting this error. So this file name will be nothing but exec underscore tb. I've created a variable, and if I write dot tb underscore frame, there's a property inside this, and here another property will be that is called as fcode. And inside this, if you probably go ahead and write co underscore file name, right? So file this, we'll be able to get the file name over here, right? So see, inside this execution underscore info, right? You'll be having tb frame fcode, and then you'll probably find the file name. How I'm able to understand, how I'm able to get this in the exception handling documentation, it is already given, right? So if you probably search for custom exception handling in Python documentation. So if you probably search this, here you'll be able to see this. Somewhere it will be given. Okay. So how you can probably handle, how you can raise our own custom exception, everything is given. You just need to go ahead and read this and you'll be able to understand it. Okay. So again, I'm not going to go detailedly. I will just try to show you with the help of code. Okay. Perfect. So this is done over here. And now my first placeholder. Now first placeholder will basically have the line number. Now in order to get the line number, it is very much simple. I'll again use execution tab dot tb underscore line number. And the third parameter which is there, that is basically my error message, right? So that placeholder should also be coming. So for that, I will just write str of whatever error I'm actually able to get. Okay. And this error is nothing but this error, whatever I'm providing over here. So this is with respect to the error message detail. Now quickly what I will do, this whenever my error raises, I'm going to probably call this particular function, right? So here I'm going to create another class which is basically called as custom exception. Okay, custom exception, and here I'm going to give my exception. So this is my own custom exception class, and obviously I need to also give my div init, which is my constructor. Here I'll be giving myself error underscore message, whatever message I have for my error, comma error underscore detail. Again, this will be of my sys type, right? So here I go over here. Okay, see, since we are inheriting from the exception, so I will basically write super.init because we need to initialize the init, or we need to inherit the init function, right? And this will be underscore init, and this will probably give the error underscore message. Okay, so here we are basically using the error underscore message over here, and we are basically able to probably inherit the exception class with respect to that. Okay, now one more thing over here is that okay, here I have to return the error message. I just missed it out. So return error message. Perfect. Let's see whether this is a public variable or not. Yeah, this is fine. Perfect, fine. So over here you'll be able to see that I'm able to get my error message over here. This error, okay, this error message. Okay, fine. Super.init of error message. So this is done. Now what I will write, I will say self.error message. Self.error underscore message. Message is equal to this particular error message. I'll initialize with this error message, whatever is coming, right? And this is how we basically write in the modular programming way, right? And this error message, still we don't have anything, it should be coming from this, so we'll call this function. Okay, so we'll call this function with this particular error message, and then I'll give all the parameters that is required. First is the error message. I'll give over here, comma, I'll say error details is equal to, and this will basically get assigned to error detail. Okay, so these are my parameters that I'm giving, okay, in my custom exception. So whenever I raise this custom exception, first of all, it is inheriting the parent exception. Whatever error message is basically coming from this particular function, that particular error message will come over here, and we'll initialize it to the a variable, the class variable or custom exception variable, that is error message. And this error detail is basically been tracked by sys. Okay, and quickly I will also inherit one functionality in custom exception, that is strr underscore, and this will basically be myself. Okay, return self dot error message. So whenever I try to print it, I'll be getting all the error message over here. Okay, very simple guys. I think we have not done very difficult work over here. I've created a function over here which will probably give you a message, like how your message should look like inside your file with respect to your custom exception. And then we created our own custom exception class which is inheriting from exception. I've also overridden the init method right over here, and I've created an error message variable inside this. This is getting populated from this particular function. And finally, when we print this, right, when we raise the custom exception, in short, when we print it, it is going to print the error message itself. So this is with respect to the exception handling. Understand this will be common for the entire code. Now wherever you use try catch, and whenever inside the catch block you just raise custom exception, this kind of message will be coming that error occurred in Python script name so, line number so, and all other information. Perfect. So this was with respect to exception. Now we are going to use this everywhere wherever we require. Okay, and this is only for the one time. And similarly with respect to logger. So logger, again, you can check out the documentation with respect to the logger also. So first of all, what I'm going to do, I'm going to import logging. Now logger is for the purpose that any execution that probably happens, we should be able to log all those information, the execution, everything in some files, so that we'll be able to track if there is some errors, even the custom exception error. We will try to any exception that basically comes, we'll try to log that into the text file. And for that also we need to implement logger. So finally, I'm going to import OS, and then from datetime import datetime. Right. So yes, we have done this. Now quickly we will go ahead and create our log file. So how my log file should basically get created, that is what I'm basically writing. Over here, I'll take this fstring, and I have used a common notation or framework over here, very simple one, something like this, datetime.now. So my file name that will be created will be whatever datetime is basically coming, and further this will basically have month, day, year, hours, this .log file. Okay, so it will be a text file. In this naming convention, it will basically get created. Okay, and with respect to the logs path, because we really need to find out, we need to give a path for the log file also. So here I will write os.path.join, and here log file will definitely be used. Along with that, I will write os.getCW, correct working directory, and comma. So if I probably see with respect to joins, my file name should have logs in forward, and then this naming convention. So here I will write logs. So initially my file name will be done like this, and then finally I have my log file, right? So whatever logs will get created, it will be with respect to the current working directory. So here only logs folder will get created, and every file will start with logs along with this whatever file name is basically coming. Okay, so that is what we have actually done with respect to this. And then we will go ahead and we will just try to say make directories, and here I'm going to give my log path with exist underscore okay is equal to true. So this basically says that even though there is a file, even though there is a folder, keep on appending the files inside that whenever you want to create the file. Okay, so yes, these are some basic Python code which we have already seen, right? And right now we are doing this, right? And finally, if I go and see my log file path, okay, so this is the log file path. I will just say os.path.join. Okay, I will just use logs underscore path, comma log underscore file. Okay, so done. Now, whenever we really want to create the log, right, we really need to set, see, if you want to override this functionality of the login, right, we have to probably set this up in the basic config. So if you add log.basic config, so here you'll be able to see that inside this basic config, you will first of all give the file name where you want to basically save it. So here, if you go ahead and see for file name, this will basically give my log file path. Here I'm going to give my log file path with respect to the file name. Then the format, what format you want to specifically use. And with respect to the format also, guys, I will just copy the best practice that we usually use over here, and it will be inside this format. See, the timestamp, line number, name, level name, message, right? So this is how my entire message will get printed. Okay. And after this, I will say for which level. Suppose the next parameter is basically level, right? So if I write level is equal to logging.info, right? So in the case of info only, I'm going to print the specific messages, right? So done. This is with respect to the logging setup, okay? That basically means now wherever I use logging.info, input logging and logging.info, and probably I write out any print message, then it is going to use this kind of basic config, and it's going to create this file path. It is basically going to keep this particular format with respect to the message and all that we are going to get, okay? I'll show this, but right now, this is some generic thing that we need to do. One is exception handling, one is logger, and there is one more file with respect to utils.py. Now utils.py, whenever requirement is there, we will try to create those files, we try to create those functionalities. But exception and logger is definitely required. You can just check out this documentation with respect to the Python. With respect to logging, we really need to set up the basic config. With respect to creating custom exception handling, the new error message, whatever you want based on your requirement, you can basically get it. Now what I will do is that whenever we get an exception, I will take that exception, logging into the logger file, and use logging.info to put it inside the file, right? So such way we'll be able to get that particular folder also. Perfect. So this is perfect till now. We are able to get all these things. It's I think it'll be working fine. Absolutely. I can test this also, but I don't want to test it right now. But instead, let's see what all things we can basically do. Okay. So in this video, the entire project structure is there. I've kept less number of files, trust me guys. But if you do a very big project, still more files need to be created. In components, we need to add model evaluation, data validation was also added. But we are trying to just do it in a simpler way so that you'll be able to understand. So perfect till here, we have done it. Now in the next video, what I'm actually going to do is that I'm going to discuss about the problem statement that we're going to solve. And then we'll take the dataset, we'll perform the EDA, and we'll start coding. Data ingestion, data transformation, model trainer and all. Initially, I'll just coolly read the dataset, divide that into train and data, test dataset. Later on, what I'll do, I'll put this particular dataset into a MongoDB. And then from there, I'll try to read it. Just to give you an idea that how should we read the data from the databases itself. So yes, this was it. Now what, let me do one thing quickly. Okay, logger.info. Let's do one thing. Okay, I will write if underscore name underscore main underscore. Right. So logging.info. Logging has started. I'm just trying to check that everything is working fine or not. Okay, so let's go to terminal. So this is my new terminal. So I will just go to this terminal, which is there in my same working location. Make sure that you activate DNV, and then I will write python logger.py. Let's see whether it will work. No such file or directory. Okay, no worries, because logger is basically present over there inside your source. Okay, no worries. So python source logger.py. So it has got executed successfully, I guess. In order to see this, my logs folder has got created. The same way how that see this root info logging has started, right? The message has got printed over here, right? See over here, I've just written logging.info logging has started, right? Now what this is done, see, as soon as I write this, right, just to check whether everything is working fine or not. Over here you'll be able to see over here, right? My file name is basically with respect to the log file path, right? So over here you'll be able to see log folder is created, and inside this file is created, which is .log, right? Log file, right? So all the information is there, and then we are able to see the print message. After info, my message has got printed. Why? Because over here I've written level name, message, name, line number. So over here, first of all, the format is something like this, right? Ascending time. So this is my ascending time. Then 20 I've actually got, which is my line number. So line number is 20, where I've specifically used login info. And then you'll be able to see name, root name has come, info is there, and then finally message is there, right? I've used login.info. So this is how you can probably test it. You can similarly test the exception handling. Let's see with respect to exception handling if I'll be able to get it or not. So if underscore name, and let's go over here and write like this. I'll use a try catch block. So try is equal to 1 divided by 0. Okay, so obviously I'm going to get an exception. So this will be a catch block, except block. Is custom exception. Okay. So I will also go ahead and import the login. Okay, I'm just trying to check whether everything is working fine or not. Done. So this will be divide by 0 error. Let's see whether it will work or not. Or am I making some mistakes? Okay. So Python source exception.py. Return error message. There is an invalid syntax. So always make sure that you check it, because return error message. Oops. Okay, I can understand what is the problem. I'm not closed the bracket properly, so that is the reason it was giving red color. It's okay. So now let me just go and see this. Custom exception, missing error message and error details. Okay. If I want to call this, so here you can see that I'm not passing error message and error detail, and obviously this is a problem. Without passing that, how can we do it? So here I will write exception as e, and this e will be provided as my first parameter. Along with that, I'll provide sys, and sys I think I've imported on the top. Perfect. Now I think it should work. So here you can see the script init requires a super object but received a 0 division error. So guys, from the error that I see over here, underscore requires a super object. So let's see what is the problem. Okay, here I have to use brackets, which I've actually missed it. See guys, I'm not editing the errors, okay? I will tell you that whatever I'm getting, I'll just give it to you like that. Here we saw that error, now let's go ahead and execute it. So now here you can see that custom exception occurred in this division by row. So the custom exception has been recorded in the logging, and if you still have not uploaded this specifically in the logging file, but here you can basically see that as soon as I raise the custom exception, I'm able to see this error, which is basically saying divide by 0. With this all line number and all information is there, right? So perfect, this was it, you know. We'll see why this error has not been logged up, but we'll try to log this up probably in the upcoming video. But at least we are able to see the custom exception, right? So 0 division error, everything we are able to see this, right? Now all we have to do, just think over it, why it is not coming in the logging file, and tell me the solution. Okay, I have understood the solution, why it is not coming. Now it is up to you to find out. Okay, so please do it, just try it out and let me know in the comment section. But perfect, till here we have done it. We have created a project structure, we have created our exception logger and everything as such. Now what I will do is that I will again remove this files. I don't want this file as such. I will remove this files. I'll save this. I'll remove this also. I'll save it. And all I will be doing right now is that I will just try to publish this code. So if I say git status have so many files changes, so many files that got created. I will write git add dot, then I will clear the screen. I'll say git commit -m, and this will basically be my project structure. I will just write logging and exception, logging and exception. Perfect. Commit tos. This is committed, and then I will say git push -u from origin to main. Okay. So once I do this, all my git file will get committed. Perfect. So let me quickly open one of the file over here. Just a second. I'll just open my GitHub file and see whether my code has got updated or not. Okay. So let's go to my repositories. Let's see. So this is my ML project. Please make sure that you fork this repository, guys. And now if I go inside my source, you'll be able to see exception is done. Exception is available, right? So exception is available, logger is available, my entire project structure is available. Now all I have to do is that show you the dataset tomorrow and start writing the code with respect to ED and all. Perfect. Everything is done. So I hope you like this particular video. In this video, we have done so many things. We have created the project structure, and apart with that, we have also handled the exception handling and logger, right? So yes, guys, this was it from my side. I will see you all in the next video with the next tutorial where we'll talk about our dataset and our problem statements. And I'll keep it hidden right now. Please make sure that you do it everywhere, like with respect to all the implementation, and then you try to share it in the link and tag me, show your GitHub code. I will definitely have a look and probably put a comment on that. Uh, Hello guys, so we are going to continue the discussion with respect to the end-to-end ML project implementation. In our previous session, we have already done many things over here. We have set up our setup.py file. You understood the purpose of this, right? To basically create the package. We have this requirement.txt file. So any packages that will be required, I'll probably be writing it over here. We have seen that how to probably create an environment and how to start. Everything we have actually done it till now. Now, in this video, we are going to focus on creating the entire project structure and then some of the common functionalities like logging, like exception and handling, how to write that specific code, where you should specifically write, what should be a project structure, everything that we'll be doing in this specific session. Okay. So in the source folder right now, I just have __ init.py. Now guys, see, when I'm creating the project structure, I will just do it manually because I need to show everything for you from the scratch. Later on, this entire process can also be automated. I just need to write one code like template.py and automatically all the entire folder structure will be created, right? I just need to write some 10 to 15 lines of code. But right now I am showing you everything from scratch so that you understand the projects well, right? So in the source, because whatever project I'm implementing, everything will come inside this. In the source, we are going to create some very important folders. The first folder that we are going to create is something called as components, right? Now, what exactly the specific components are and what will basically come over here? We'll discuss about that. But before, as soon as we create a folder, the first thing that you really need to do is that create this file that is init__.py. So with respect to this particular file, why do we do this? Because components will be created as a package and it can also be exported, like it can be imported to some other file location. That is the reason I'm writing this __init.py. Okay. Now these components are like all the modules that we are probably going to create, right? Like initially we will probably create a process called as data ingestion, right? Data ingestion basically means I'll be reading a dataset from a database, or it can be from some other file locations, or it can be from different kind of databases also, right? So initially we need to read the database. So that database, reading the data from a specific database, we specifically say it as data ingestion. So data ingestion is a part of a module, right? When we are probably developing the entire project, right? So that can be our component. So let's say that I'm going to create a component over here, and the first component that we are probably going to create is something called as data_ingestion, right? And for this, I will just create my .py file, and this will basically have all the code that is something related to reading the data, right? So here I have my data ingestion. After reading the data, what we will be doing, we may probably do data validation, we may probably do data ingestion, data transformation, right? So over here, since I really want to make this project very precise, very easy for you so that you'll be able to understand. So after ingesting the data, I will try to transform that particular data. So my next step that I'm actually going to do over here is something called as data_transformation. Okay, and this will be also my py file. So any code that is related to transformation, like over here we'll probably be writing code how to change the category features into numerical features, how to handle one-hot encoding, how to handle label encoding. There may be different features for that purpose, right? So all the code we will be writing over here, right? So I'm just going to rename this again. Trust me, I'm going to make your work very, very easy so that tomorrow you solve any project if you just follow this kind of structure, right? That will be more than sufficient. Okay. So this renaming file is basically taking some time. Let's see why it is taking some time. So data transformation. Okay, done. So these are the two steps. First, data ingestion, data transformation. Now in data ingestion also, right? When we read the data, we'll divide the data set into train and test, right? And this is all for the training purpose, right? Training the model purpose. So in the data ingestion, I will also try to divide that particular data set into train and test, and then we'll also create a validation data. We'll create different folders. That all code will be writing in this data ingestion.py. Now after doing the data transformation, the next step that I will probably want to do is that I will basically say this as my model_trainer, right? So here I'm going to specifically train my model. So in this specific py file, right? So definitely model trainer will basically all the training code over here, how many different kinds of model I want to use. I will probably also call over here the confusion metrics if I'm probably solving a classification problem. If I'm solving a regression problem, I may see R2 R squared, adjusted R squared value. All those things will basically happen over here, right? And from here also, see next one more step I can basically write model pusher also. Okay, but I'll not still make many files because since this is just your first project, from the trainer itself I'll try to push that particular model pickle file into the cloud also. That also I will probably show you. Okay, so these components that you have seen till now, data ingestion, data transformation, model trainer, mainly this is specifically for the training purpose, right? So this is how I've actually created the folder structure, right? So this folder structure we specifically say components. Components are nothing but modules that we are specifically going to use in the project. Now after this, let's me do one more thing. I will create one more folder, and this folder will basically be having something called as pipeline. Because what kind of pipeline we really need to create, right? That also you really need to know, right? With respect to pipeline, two types of pipeline I'll decide. One is the training pipeline and one is the prediction pipeline, right? So over here inside this pipeline, what I will do, I'll create a file, and this file will basically be written as train_pipeline.py. Okay, so this will basically have all the code for my training pipeline itself, and from this training pipeline I will try to trigger or call all these components, right? Understand the structure of the project is super important to understand. If you get the basic skeleton, trust me, then you will automatically be able to understand where I have to create what kind of file, where I have to write what kind of code, right? So this becomes a modular programming code, a clean code, which will basically be acceptable in industry standards, right? So one is the training pipeline, and the next file that I'm probably going to create is the predict_pipeline. Right, for the prediction purpose. Like let's say my model is basically created. Now to predict for the new data, I'll basically write over here as predict_pipeline. Okay. Now inside this pipeline, one more thing that I'm going to do, I'm also going to create one more file that is called as _init.py. Right, so that I can import this. Right. So all the files have been created. So for now, I will be creating these components and pipelines. Now the next thing that I'm going to do, since my entire project implementation will be happening inside this source, now I want to create three important files over here. One is definitely for logging. So here I will write logger.py. Okay. The next file that I'm actually going to create over here is for my exception. So exception.py for the exception handling purpose. And third one, which any functionalities that I'm probably writing in a common way, right? Which will be used in entire applications. So I'll basically say that as a utils.py. Let's say I want to read a data set from a database. I can probably create my Mongo client, like MongoDB client over here. If I want to probably save my model into the cloud, I can write the code over here. And in the utils code, I will try to call it inside the components itself. So very much simple. You need to understand all these things, guys. See, if you're able to understand this project structure, trust me, no one can stop you in understanding the entire project. And that is the reason why I'm going step by step. And I hope you're loving it. If you're loving it, please do support it by sharing this video with everyone. Tell people about it. No, this kind of content will never get it anywhere. Okay. So all these things are done. Perfect. Now let's go and probably write our exception handling code. Now, whenever you want to write anything with respect to exceptions, so just search for exception Python, right? And documentation you can basically search. So built-in exception, errors and exception. All this code is basically there, right? So with respect to exception, what I'm actually going to do for my case is that I am basically going to write my own custom exception. So first of all, I will going to import sys. Now sys, what exactly sys library is? Okay, what exactly sys is? Understand quickly. Okay, so let's talk about the sys library. See guys, there are many things that we specifically use in Python. Okay, and in order to use this, you need to understand some of the things. Yes, all the definition you'll not be able to get. So search for it. The sys module Python provides various functions and variables that are used to manipulate different parts of the Python runtime environment. So any exception that is basically getting controlled, the sys library will automatically have that information. Okay, so quickly let me do one thing over here. After importing sys, let's say if sys is not there, I can also try to put that into my requirement.txt, but I think by default sys will definitely be there. So here I'm going to create a definition of error underscore message underscore details. Okay, and here I'm going to give two parameters. So this will be my error message detail. Whenever an exception gets raised, I want to push this on my my own custom message, right? So here I will give my error. Okay, this error, whatever message I'm getting, and the other parameter will be my error detail. And this error detail will basically be present inside the sys. Okay, what module we are basically imported. So I'm going to call this particular function in the case of this. And one more thing that you really need to understand: the return type of sys, right? It provides you like if I probably write error detail dot exe info. So let me write it out. So exe underscore info, right? So with respect to the exe underscore info, right? So this is basically talking about the execution info, and this will give you three important information. The first two information I'm not at all interested, right? But the last information will basically give me about exe underscore tb. Okay. So this information, from this information, we will be able to, this variable that is there, right? This info will probably give you all the information like on which file the exception has occurred, on which line number the exception has occurred. All those information will be probably given and will be stored in this particular variable right now from this exe underscore info, right? So this is the exception that I'm probably getting. I have all the details in which file, in which line I'm probably getting the exception. Now all I have to do is that I will probably create a variable which is called as error underscore message, and I will probably write any errors saying that error occurred in Python script. So in Python script name, and I will give the first location over here as 0. Okay, this is just like a placeholder. And after this, I can also give my line number. Okay, so I will probably go ahead and give my line number, and this will basically be my first placeholder. And after line number, I can also give my error message. What is the exact error message? And I will keep it this as 2. Okay, 2 is my placeholder. And then finally, I write dot format. Okay, dot format. Let me just hide this so that you'll be able to see this. Dot format. And now we need to replace this 0 placeholder and all, right? So if I probably write dot format, I should basically be writing from here. Okay, so let me go ahead and write. So dot format. Okay, and remember guys, this will be common. Okay, it is not going to change again and again. Okay, so in dot format, the first thing that I'm going to give is file name. Okay, file name I have not executed it. So let's do one thing. I will create my variable file name, in which file name I'm probably getting this error. So this file name will be nothing but exe underscore tb. I've created a variable, and if I write dot tb underscore frame, there's a property inside this, and here another property will be that is called as f code. And inside this, if you probably go ahead and write co underscore file name, right? So by this, we'll be able to get the file name over here, right? So see, inside this execution underscore info, right? You'll be having tb frame f code, and then you'll probably find the file name. How I'm able to understand how I'm able to get this in the exception handling documentation, it is already given, right? So if you probably search for custom exception handling in Python documentation. So if you probably search this, here you'll be able to see this. Somewhere it will be given. Okay. So how you can probably handle, how you can raise a own custom exception, everything is given. You just need to go ahead and read this, and you'll be able to understand it. Okay. So again, I'm not going to go detailedly. I will just try to show you with the help of code. Okay. Perfect. So this is done over here, and now my first placeholder. Now first placeholder will basically have the line number. Now in order to get the line number, it is very much simple. I'll again use execution tab dot tb underscore line number, and the third parameter which is there, that is basically my error message, right? So that placeholder should also be coming. So for that, I will just write str of whatever error I'm actually able to get. Okay, and this error is nothing but this error whatever I'm providing over here. So this is with respect to the error message detail. Now quickly, what I will do, this whenever my error raises, I'm going to probably call this particular function, right? So here I'm going to create another class which is basically called as custom exception. Okay, custom exception, and here I'm going to give my exception. So this is my own custom exception class, and obviously I need to also give my div init, which is my constructor. Here I'll be giving myself error underscore message, whatever message I have for my error, comma error underscore detail. Again, this will be of my sys type, right? So here I go over here. Okay, see, since we are inheriting from the exception, so I will basically write super.init because we need to initialize the init, or we need to inherit the init function, right? And this will be underscore init, and this will probably give the error underscore message. Okay, so here we are basically using the error underscore message over here, and we are basically able to probably inherit the exception class with respect to that. Okay, now one more thing over here is that okay, here I have to return the error message. I just missed it out. So return error message. Perfect. Let's see whether this is a public variable or not. Yeah, this is fine. Perfect, fine. So over here you'll be able to see that I'm able to get my error message over here. This error, okay, this error message. Okay, fine. Super.init of error message. So this is done. Now what I will write, I will say self.error message. Self.error underscore message. Message is equal to this particular error message I'll initialize with this error message, whatever is coming, right? And this is how we basically write in the modular programming way, right? And this error message, still we don't have anything, it should be coming from this, so we'll call this function. Okay, so we'll call this function with this particular error message, and then I'll give all the parameters that is required. First is the error message, I'll give over here, comma, I'll say error details is equal to, and this will basically get assigned to error detail. Okay, so these are my parameters that I'm giving, okay, in my custom exception. So whenever I raise this custom exception, first of all, it is inheriting the parent exception. Whatever error message is basically coming from this particular function, that particular error message will come over here, and we'll initialize it to the a variable, the class variable or custom exception variable, that is error message. And this error detail is basically been tracked by sys. Okay, and quickly I will also inherit one functionality in custom exception, that is strr underscore, and this will basically be my self. Okay, return self dot error message. So whenever I try to print it, I'll be getting all the error message over here. Okay, very simple, guys. I think we have not done very difficult work over here. I've created a function over here which will probably give you a message, like how your message should look like inside your file with respect to your custom exception. And then we created our own custom exception class, which is inheriting from exception. I've also overridden the init method right over here, and I've created an error message variable inside this. This is getting populated from this particular function. And finally, when we print this, right, when we raise the custom exception, in short, when we print it, it is going to print the error message itself. So this is with respect to the exception handling. Understand, this will be common for the entire code. Now, wherever you use try catch, and whenever inside the catch block you just raise custom exception, this kind of message will be coming that error occurred in Python script name so, line number so, and all other information. Perfect. So this was with respect to exception. Now we are going to use this everywhere wherever we require. Okay, and this is only for the one time. And similarly with respect to logger. So logger, again, you can check out the documentation with respect to the logger also. So first of all, what I'm going to do, I'm going to import logging. Now logger is for the purpose that any execution that probably happens, we should be able to log all those information, the execution, everything in some files, so that we'll be able to track if there is some errors, even the custom exception error. We will try to any exception that basically comes, we'll try to log that into the text file. And for that also we need to implement logger. So finally, I'm going to import OS, and then from datetime import datetime, right? So yes, we have done this. Now quickly we will go ahead and create our log file. So how my log file should basically get created, that is what I'm basically writing. Over here, I'll take this f string, and I have used a common notation or framework over here, very simple one, something like this, datetime.now. So my file name that will be created will be whatever datetime is basically coming, and further this will basically have month, day, year, hours, this .log file. Okay, so it will be a text file. In this naming convention, it will basically get created. Okay, and with respect to the logs path, because we really need to find out, we need to give a path for the log file also. So here I will write os.path.join, and here log file will definitely be used. Along with that, I will write os.getcw, correct working directory, and comma. So if I probably see with respect to joins, my file name should have logs in forward, and then this naming convention. So here I will write logs. So initially my file name will be done like this, and then finally I have my log file, right? So whatever logs will get created, it will be with respect to the current working directory. So here only logs folder will get created, and every file will start with logs along with this whatever file name is basically coming. Okay, so that is what we have actually done with respect to this. And then we will go ahead and we will just try to say make directories, and here I'm going to give my log path with exist underscore OK is equal to true. So this basically says that even though there is a file, even though there is a folder, keep on appending the files inside that whenever you want to create the file. Okay, so yes, these are some basic Python code which we have already seen, right? And right now we are doing this, right? And finally, if I go and see my log file path, okay, so this is the log file path. I will just say os.path.join. Okay, I will just use logs underscore path, comma, log underscore file. Okay, so done. Now, whenever we really want to create the log, right, we really need to set, see, if you want to override this functionality of the logging, right, we have to probably set this up in the basic config. So if you write log.basic config, so here you will be able to see that inside this basic config, you will first of all give the file name where you want to basically save it. So here, if you go ahead and see for file name, this will basically give my log file path. Here I'm going to give my log file path with respect to the file name. Then the format, what format you want to specifically use. And with respect to the format also, guys, I will just copy the best practice that we usually use over here, and it will be inside this format. See, the timestamp, line number, name, level name, message, right? So this is how my entire message will get printed. Okay, and after this, I will say for which level. Suppose the next parameter is basically level, right? So if I write level is equal to logging.info, right? So in the case of info only, I'm going to print the specific messages, right? So done. This is with respect to the logging setup, okay? That basically means now wherever I use logging.info, input logging and logging.info, and probably I write out any print message, then it is going to use this kind of basic config, and it is going to create this file path. It is basically going to keep this particular format with respect to the message and all that we are going to get, okay? I'll show this, but right now, this is some generic thing that we need to do. One is exception handling, one is logger, and there is one more file with respect to utils.py. Now utils.py, whenever requirement is there, we will try to create those files, we try to create those functionalities. But exception and logger is definitely required. You can just check out this documentation with respect to the Python. With respect to logging, we really need to set up the basic config. With respect to creating custom exception handling, the new error message, whatever you want based on your requirement, you can basically get it. Now what I will do is that whenever we get an exception, I will take that exception, logging into the logger file, and use logging.info to put it inside the file, right? So such a way we'll be able to get that particular folder also. Perfect. So this is perfect till now. We are able to get all these things. It's I think it'll be working fine. Absolutely. I can test this also, but I don't want to test it right now. But instead, let's see what all things we can basically do. Okay. So in this video, the entire project structure is there. I've kept less number of files, trust me guys. But if you do a very big project, still more files need to be created. In components, we need to add model evaluation, data validation was also added. But we are trying to just do it in a simpler way so that you'll be able to understand. So perfectly here we have done it. Now in the next video, what I'm actually going to do is that I'm going to discuss about the problem statement that we're going to solve, and then we'll take the dataset, we'll perform the EDA, and we'll start coding data ingestion, data transformation, model trainer, and all. Initially, I'll just coolly read the dataset, divide that into train and data, test dataset. Later on, what I'll do, I'll put this particular dataset into a MongoDB, and then from there I'll try to read it just to give you an idea that how should we read the data from the databases itself. So yes, this was it. Now what? Let me do one thing quickly. Okay, logger.info. Let's do one thing. Okay, I will write if underscore name underscore main underscore. Right. So logging.info. Logging has started. I'm just trying to check that everything is working fine or not. Okay, so let's go to terminal. So this is my new terminal. So I will just go to this terminal, which is there in my same working location. Make sure that you activate venv, and then I will write python logger.py. Let's see whether it will work. No such file or directory. Okay, no worries, because logger is basically present over there inside your source. Okay, no worries. So python source logger.py. So it has got executed successfully, I guess. in order to see this, my logs folder has got created. The same way how that see this root info logging has started, right? The message has got printed over here, right? See over here, I've just written logging.info logging has started, right? Now what this is done, see, as soon as I write this, right, just to check whether everything is working fine or not. Over here you'll be able to see over here, right? My file name is basically with respect to the log file path, right? So over here you'll be able to see log folder is created, and inside this file is created, which is .log, right? Log file, right? So all the information is there, and then we are able to see the print message. Info after info, my message has got printed. Why? Because over here I've written level name, message, name, line number. So over here, first of all, the format is something like this, right? Ascending time. So this is my ascending time. Then 20 I've actually got, which is my line number. So line number is 20, where I've specifically used login info. And then you'll be able to see name, root name has come, info is there, and then finally message is there, right? I've used login.info. So this is how you can probably test it. You can similarly test the exception handling. Let's see with respect to exception handling if I'll be able to get it or not. So if underscore name, and let's go over here and write like this. I'll use a try catch block. So try is equal to 1 divided by 0. Okay, so obviously I'm going to get an exception. So this will be a catch block, or sorry, except block. Is custom exception. Okay. So I will also go ahead and import the login. Okay, I'm just trying to check whether everything is working fine or not. Done. So this will be divide by 0 error. Let's see whether it will work or not, or am I making some mistakes. Okay. So Python source exception.py. Return error message. There is an invalid syntax. So always make sure that you check it, because return error message. Oops. Okay, I can understand what is the problem. I'm not close the bracket properly, so that is the reason it was giving red color. It's okay. So now let me just go and see this. Custom exception missing error message and error details. Okay. If I want to call this, so here you can see that I'm not passing error message and error detail, and obviously this is a problem. Without passing that, how can we do it? So here I will write exception as E, and this E will be provided as my first parameter. Along with that, I'll provide sys, and sys I think I've imported on the top. Perfect. Now I think it should work. So here you can see descriptor init requires a super object but received a 0 division error. So guys, from the error that I see over here, underscore requires a super object. So let's see what is the problem. Okay, here I have to use brackets, which I've actually missed it. See guys, I'm not editing the errors, okay? I will tell you that whatever error I'm getting, I'll just give it to you like that. Here we saw that error, now let's go ahead and execute it. So now here you can see that custom exception occurred in this division by row. So the custom exception has been recorded in the logging, and if you still have not uploaded this specifically in the logging file, but here you can basically see that as soon as I raise the custom exception, I'm able to see this error, which is basically saying divide by 0. With this all line number and all information is there, right? So perfect, this was it, you know. We'll see why this error has not been logged up, but we'll try to log this up probably in the upcoming video. But at least we are able to see the custom exception, right? So 0 division error, everything we are able to see this, right? Now all we have to do, just think over it, why it is not coming in the logging file, and tell me the solution. Okay, I have understood the solution, why it is not coming. It is up to you to find out. Okay, so please do it, just try it out and let me know in the comment section. But perfect, till here we have done it. We have created a project structure, we have created an exception logger and everything as such. Now what I will do is that I will again remove this files. I don't want this files as such. I will remove this files. I will save this. I'll remove this also. I'll save it. And all I will be doing right now is that I will just try to publish this code. So if I say git status, I have so many files changes, so many files that got created. I will write git add dot. Then I will clear the screen. I'll say git commit -m, and this will basically be my project structure. I will just write logging and exception. Logging and exception. Perfect. Commit tos. This is committed. And then I will say git push -u from origin to main. Okay. So once I do this, all my git file will get committed. Perfect. So let me quickly open one of the file over here. Just a second. I'll just open my GitHub file and see whether my code has got updated or not. Okay. So let's go to my repositories. Let's see. So this is my ML project. Please make sure that you fork this repository, guys. And now if I go inside my source, you'll be able to see exception is done. Exception is available, right? So exception is available, logger is available, my entire project structure is available. Now all I have to do is that show you the dataset tomorrow and start writing the code with respect to EDA. Perfect. Everything is done. So I hope you like this particular video. In this video, we have done so many things. We have created the project structure, and apart with that, we have also handled the exception handling and logger, right? So yes, guys, this was it from my side. I will see you all in the next video with the next tutorial where we'll talk about our dataset and our problem statements. And I'll keep it hidden right now. Please make sure that you do it everywhere, like with respect to all the implementation, and then you try to share it in the LinkedIn. Tag me, show your GitHub code. I will definitely have a look and probably put a comment on that. In our previous tutorial, we had actually implemented about exception handling logger for the entire project, right? And in the last example, one thing that I showed you, right, we were trying to raise an exception and it was not getting stored in the file over here, right? So what specifically, like I asked the solution for you, right? The simple reason was that I had to probably import the logger.py file over here, right? So inside this logger, right, I have to probably import. So if you probably go and see this logger, I have to go ahead and import this logging from here, right? So that is the reason I did not do it. And because of that, we are not getting the message saved. Now what I'll do, I'll quickly, first of all, show this. So I'll write from src.logger import logging. Okay, I'm just going to import this, and now you can see logging.info divide by 0 is there. Now if I probably go ahead and execute this python logger.py, sorry, exception python exception.py, so you'll be able to see, okay, just a second, python source exception.py. Now here you'll be able to see that division by error or division by 0, the error is basically coming. Now you need to see whether this is got saved in the log file or not. Now you can see the third log file is basically created, and here you basically have the entire error message going over here. Okay, just to start with, this was the main issue that we fixed. Now I hope everybody will be updating the code whenever they want to probably use logging. They have to import from source.logger. You have to import the logging part. Okay, now quickly let me go ahead and remove this because I don't require anyhow this whole things. Now what is the agenda of this specific session? The agenda of this session is that to talk about the project that we are going to implement. Now I was thinking, see, when you're developing an end-to-end project, right, the first priority thing that we really need to think about is that what kind of data set we should basically start with. Okay, so I gave a lot of thought, and since this is just our first project, and we will try to make this project better and better, and we'll go step by step. So I was thinking about the data set. Okay, so I hope first of all you like this message. If you like this message, please do make sure that you comment down. Now we are going to just focus on project. Let it be with respect to machine learning, NLP, and deep learning, and we'll try to implement very good things. I'll be creating a lot of documentation for you also, so that you will be able to understand. And trust me, any interview that you go, you will be able to crack it. Okay. Now, as I said, that I gave a lot of thought in probably just understanding like what project we should basically go ahead with. If you are a starter, if you just know about EDA, see, some prerequisite is required. You should know Python programming language. You should know modular coding. You should know how to perform EDA and all. Okay. Now, considering this, what I've done is I've taken a data set, and this entire project is about student performance indicator. Now, you may be thinking, Chris, this is just a simple project. There's a reason why I took this. See, understand. If I probably show you the data set of this project, okay. So this is the data set of this project. In this project, okay. If I close this, in this project, you will be finding features of every type. Categorical features, you'll find numerical features, you'll find NaN values, you'll find multiple things, right? And then we will try to see, to start with, how we can probably solve this, how we can perform the feature engineering. And till now, most of the time, we have learned everything in Jupyter Notebook, right? But that same Jupyter Notebook code, then we'll try to convert that into a modular code. That is how we are going to learn it, guys. Trust me, if you follow these strategies, tomorrow you get any kind of data set, any kind of project, you will be knowing that what exactly you need to do, okay? So for this, I have taken the project which is called as Student Performance Indicator. So initially, this is our project, and here I've added one notebook folder. Inside this, you have this data student.csv, and then I have given you these two files. One is EDA, okay? And the other one is about model training, okay? So let's go and see what exactly we are going to talk in the specific EDA and what all things we are basically going to do. Okay. And the best thing about this project is that I have given each and every understanding to you over here. You know, as I said, prerequisite is EDA, but I will just try to execute this and we'll try to see what all things we are basically going to do. Okay. Now with respect to EDA, now people will think, can we do EDA in this project in .py file? No, don't do that. Jupyter Notebook is the best way to basically perform the EDA and all. Whatever observation, see, something that is very much important. And whenever you perform EDA, right, observation is super important, right? And once you do the observation, you have to probably provide that observation to the stakeholder. And every step that you're probably doing in your project, for that there should be a reason. Okay. So in the student performance indicator, this is the entire lifecycle of machine learning project, understanding the project statement, data collection, data checks to perform, EDA, data pre-processing, model training, and choosing the best model. After that, we'll try to evaluate the model and push the model. That will also be the part of it. Now, what exactly is the problem statement? Just try to understand this, guys. This problem statement is very good, and I've taken this data set for purpose. As we go ahead and probably try to participate in some other, like implement some other project, right? At that point of time, we will try to put more complex data set. Now, if you get the idea about this particular data set, trust me, you'll get the idea about implementing everything. Okay. So problem statement is that this project understands how the student performance test score is affected by other variables such as gender, ethnicity, parental level of education, lunch, and test preparation course. So here you'll be able to see that. Okay. You have a lot of features. Okay, like gender, ethnicity, parental level of education, lunch, test preparation course, and many things you have. Okay. Now over here, what we are basically going to do is that we are just going to see how the student's performance is with respect to the test score, and based on these features, we'll try to predict the test score. Okay, and all these features, like some of the features are categorical features, some of the features are numerical features, that all will be seen. Okay, so that is the entire project information about it. This basically data set consists of 1,000 rows, 8 columns, so that we initially start with some basic things and then probably we gain, right? But again, at the end of the day, it is more about understanding how do we implement an end-to-end project. Okay, now to begin with, we'll be importing these libraries. Now here, as soon as I import, I will first of all select my Python kernel. Okay, so let me just go ahead and so this will be my Python environment. I've already made VENV Python 3.8, so you'll also be getting this option. Now you can see it is connecting to the kernel. I will just go ahead and install this IPy kernel. IPy kernel is basically required for implementing or executing any code in the Jupyter Notebook. Okay, and what is the folder structure that I've done? See, outside the source, right? I've made this notebook, then data is there, EDA is there, model training. So whatever analysis and whatever model training you'll do, right? You'll do it over here. Now in model training, what all techniques you have specifically used? What we are going to do over there, we are basically going to convert that into a model coding. That is what we're going to do. Now quickly, let's go ahead and see some EDA. Right now the installation is taking place, and this will probably take some amount of time. Okay, so till then, I hope you are able to understand the project. See guys, the way I really want to teach is that because once you are done with this project, you will be able to implement any Python project as such, and that is my promise. Okay, not Python only, but machine learning also. Okay, so yes, this has got executed now. So all these libraries are basically there, like matplotlib and all. It's okay. Let's see whether it is there in the requirement.csv or not. Pandas, NumPy, Seaborn. I can also write matplotlib. Okay, so these are all libraries. We'll try to put it over here. And every time when you're installing this pip install, right, don't try to put this because I don't want to build my package again. We'll build it at last. So try to comment this down whenever you try to install the package. Okay, like pip install -r requirement.txt. Perfect. Till here we are good. Now let me just go ahead and open the EDA. So this is basically my EDA. Now I will be reading the data set. I've written all the comments, so definitely you'll be able to see show top 5 records, what is the shape of the data set. So this is all simple. This is my data set information like gender, sex of students, this is there. And then you have something like math score, reading score, writing score. So what are the data checks to perform? First of all, we'll check missing values, then we'll check duplicate values. If duplicate values exist, we need to remove it. If there is missing values, with the help of feature engineering, we'll try to replace it. If there then we'll go ahead and check the data type, number of unique values of each column, statistics of the data set, and then we check various categories present in the different category columns. Okay, so here we are going to go ahead and check missing values. Right now we will be having 0 missing values. Trust me, if there is any missing values, you can use mean imputation. I've created an EDA playlist over there. Okay, but again, my main focus is to basically show you how to implement an end-to-end project. Okay, but as I said, this entire year I'm just going to focus on projects, MLOps, CI/CD. So I'll be taking more complex data set as we go ahead. Okay, now there is no missing value in the data set. This is the observation. Now this is the observation that I'm actually talking about, right? Every time you really need to write about the insights and observation. Then we'll go and see with respect to duplicates. Duplicates is not there. If duplicate was there, tell me what is the code to delete the duplicate elements. Okay, so this way we are able to find out whether duplicates is there or not. Like let's say if there are 5 to 6 duplicates. Okay, how to remove the duplicate? Just try to write down the code in the comment section, and then we will go ahead and see with respect to the info. Over here. Now you may be thinking, Krish, why you did not take a data set from some API and databases? Don't worry, I will do that. Okay, I'll show you by considering this data set or by considering any API data set how to do that. Okay, everything I'll be showing. But let's start with something. Let's gain your interest. Let's keep you motivated by starting some mid to intermediate level projects, and then we will go into complex one. Right? Then checking the number of values of each column. So df.unique. You'll be seeing that gender has 2, race ethnicity has 5, parental level of education has 6, lunch has 2. And then you have this math score, this with respect to data type as int. Okay. Then if you really want to quickly check the statistics of the data set, you can basically write df.describe. There are 3 numerical features. One is math score, reading score, and writing score. Okay. Now, from the above, the description of the numerical data, all means are very close to each other. So all this information you'll be able to see from this, right? And that is the insights that I've actually written. So my suggestion would be that please go through each and every point. You will be having one day completely, because once we complete this, right? Once we complete this, we will try to entirely convert this into a modular coding. Okay. Not EDA part, but at least the model training part. Inside the model training, what all things I'm specifically using. Okay. So here are about more exploring about the data. How many categories are there in gender? How many categories are there in race, ethnicity? See, guys, I've already created all this kind of videos. You can check out my EDA playlist. Okay. So once I execute it, race or ethnicity. So I think this will be race. Let me just see this. df dot head. So race underscore ethnicity, not all. So it is race underscore ethnicity. Now I think it will find. And then you have parental level of education. So some of the variables name is not there. It's okay. We'll make it. And then we have lunch. Lunch is fine. Then test preparation courses. Okay. So this will basically be my test preparation courses. So these are the changes. Race is also there. Okay. No worries. Race. Categories in race underscore ethnicity. Okay. Done. So here are all the features, all the category features, like what all values I specifically have. And then we have just written a condition to probably define our numerical and categorical features. So this is what we are getting printed. Okay. So see, in this particular thing, we are defining our numerical and categorical features. How we are doing that? Feature for feature in df.columns. Okay. If this df of feature.data type is not equal to object. Okay. If it is not equal to object, that basically means it becomes a numerical feature. Right. So easy it is. A generic statement. And similarly, feature for feature in df.columns, if df of feature.data type is equal to 0, right, or is equal to object, then that is basically a categorical feature. So this way we have done it. Over here, if I really want to find out how many unique number of categories are there, I've written df of gender.unique, right? So by that, I'll be able to see the name over here. And then it is a normal print statement. So here I will go ahead and execute it. Once I get my numerical and categorical features, all I'm doing, we are printing it. Okay. So this is basically this many number of numerical features are there, and this is all my numerical features, numerically with respect to the categorical feature. Now here we have 3 numerical features, and math score, reading score, writing score, and then we have 5 categorical features, that is gender, race, ethnicity, parental level of education, lunch, and test preparation course. Okay, everything is there. Now this is super important. This is the kind of feature engineering that we are performing. Adding columns for total score and average score. Okay. Now if you probably go and see df.head, let's see the first 2 records. Okay, df.head with respect to the 2 records. Now here you'll be able to see I have 3 different scores. One is math score, reading score, and writing score. Now what I will do is that I will try to do the summation of all these scores, and I will create one variable which is called as total score. This will basically be my output feature. Okay, and I can also make sure that I have one more output feature which is called as average. So based on this feature, now I can solve 2 problem statements. One is what is the total score, right? I can create a model to predict the total score, and then I can create another model to predict the average score. So that is what we are basically going to do. Okay. Now over here, what I'm doing, add columns for total score. So df of math plus df of reading score and writing score. I'm basically adding it up, right? So if I probably see, these all are math score, reading score, and writing score. Okay, and then for this total score, if I divide by 3, I will be getting my average score. Okay, that is what we are basically done. So I'll go ahead and execute it. Now here, if you go and see in the df.head, you have this, right, reading score, writing score, but here you can see now I'm having total score and average score. Very good. You have done this step, and now I can probably make this 2 as my dependent feature, and probably this all can be my independent feature. And if I don't want this particular feature also, this 3 features, I can remove it. But I'll just keep it just to find out more additional information about it. Okay. But if you perform feature selection later on, you can basically remove it. Feature selection I'll not perform now. We'll create a basic model, and then we'll try to improvise the model. Okay. Now, with respect to reading score, 100, what is the average? What is this? Everything. We are just going to compare it. So see this. It's all about simple. We're just trying to see the number of students with full marks in maths. So how many people have scored full marks in maths? That is 7. Number of students with full marks in writing. That is 14. How I've written the condition, df of writing score is equal to 100, and then we'll take out the average, dot count. That's it. Okay. And similarly with respect to reading score, writing score, if I really want to find out less than or equal to 20. Okay. So they have basically not done anything. Backbenchers. I have never been a backbencher, but I like backbenchers. Right? They are creative, but with respect to studies, they always try to get less marks. Okay. That is what I have observed. Okay. So here I have number of students with this 431, less than 4. Okay. So what are the insights that you're able to get from our values? You can see that we got students apart from the worst in maths, best performance in reading section, everything you can basically find out. And then if you want to go ahead and probably do more visualization, you can use histograms. So here also I've taken average with respect to this data frame. Here I've used hui as gender, right? Just to check how my average is with respect to gender. Okay. Now, common question that I can ask you: if you probably check out your college marks or school marks based on gender, who's going to perform well? Write down in the comment section whether male or female. I know the answer you know. Obviously, female usually perform well in the college times, right? So if you see this is my left hand side. You can see one graph. Okay, this is the average. But now if I try to see average with respect to gender, like male and female, so here you can see this blue color is basically female values, right? And the average score is basically increasing, right, with respect to the female. So this is what it is. Let's say with respect to total score also you want to check, you can basically check over here. So I will make a code, and instead of writing average, I will say total, right? I hope it is total only. Okay, total score, total space score. Okay, so this is total score, and the same thing I will copy it over here and paste it. Right, a very good EDA. Now with respect to total score also you can see that female are performing well. Okay, so male are usually not focused much on getting much more marks unless and until it is not IIT, JEE and some other things. But yeah, so the insight is that female students tend to perform well than male students. Okay, then here I've seen average with lunch. Then you can probably see with respect to female and male how it is getting performed with respect to lunch. All these graphs you can basically check it out. Okay, and then these are the insights that I've written. So all these things are there. Definitely go ahead and check it out. Okay, I've created some of the plots. Now this is EDA as suggested. You have to try it from here, and I will give you sufficient time to basically just go ahead and probably just execute this, understand the entire EDA about this entire project. Right, very good material that we have created over here as a team. My team was actually involved in creating this material. I told each and every minute detail things with respect to EDA. You have to write it down, and they have basically wrote it down. Okay, now let's go with respect to the model training. Okay, so here first of all I will just write std.csv. Okay. Now first over here I'm getting some issues with respect to sklearn. Okay. Now sklearn is not important. Now see in this particular file what we're going to do, we're going to train our model, and before training a model, how I'm going to handle the category features, how I'm going to handle the numerical features, everything will be available in this. How I'm performing, how I'm training multiple models, how I'm getting the results, what all model I'm going to use, everything will be here. Okay. So first of all, the major issue that I'm getting, right, if I probably execute this, I will get an error. Okay. Now what is the error that I'll get? So here also I have to probably go and connect to the V and V. Okay. So here you can see sklearn is not there. So guys, over here sklearn model is not there, right? So what I will do, I will just write pip install scikit-learn. I hope the library is same, scikit-learn, scikit-learn py. So here you have this one. So what I will do, I will take up this library. I'll open my VS Code, go to my requirement.txt, and give this particular file over here. Now I'll just comment it down. Okay. And I think Matplotlib is already installed, so I don't. Okay, let's go and make this. Now what I'm going to do, go to my terminal. Okay, already I have opened my terminal with respect to command prompt over here. And now see, I have commented this down because I don't want to build the package again and again. At the end, we'll try to build the package. So over here, what I will do, first of all, I will install -r requirements.txt. So once I install this, you'll be able to see this pandas, everything is getting installed. Okay, and I think we have installed it earlier also. So all the things are basically getting installed over here. Once this installation basically happens, now the scikit-learn installation will also happen, right? So once this is completed, then you probably go over here and execute this. So now you can see the installation is done. Now what I'm going to do, go ahead and execute this. So let me close this down. And now if I go ahead and execute it, let's see whether it will get executed or not. Or will I still get the error? Okay. So no module name cat boost. Okay, fine. So scikit-learn, at least we're not getting an error. So now the next thing is that we'll go ahead and install the cat boost. Okay. So here pip install, and I will go ahead and write cat boost. And this is how you have to write each and every library. Okay. So pip install cat boost. So we'll just go and see with respect to the package. So here is my cat boost library. So all I'll do, I'll go back again over here, go ahead and comment down in my requirement.txt. Okay. Now again, I'll not go ahead and install everything. What I will do here only, I will make a code, and here I will write pip install. Like this also you can do the installation, but one time you have to probably go ahead and write this. So let's see whether we'll get an error over here or whether it'll get installed or not. So here the installation is basically taking place. I don't know why we're getting this red color. Okay. So I think pip is not installed in this. Maybe it can be, it cannot be. Let's see. Okay. So let me do one thing. Let me interrupt this. So fine. Let me interrupt this. No need to execute it from here. So what I will do, I will again open the terminal. Okay. So see, these are the steps why I'm going very slowly and talking about it, because I want you all to follow in this way. Later on, I will also show you an automated way. Okay. So requirements.txt. So once executed, so here you'll be able to see cat boost will get installed. Okay. So cat boost is also done. So now if I go ahead and execute it, so now I don't think so. Okay. XGBoost is also there. Fine. No worries. I will again create my requirement.txt and go ahead and write XGBoost. Okay. And again, pip install requirement.txt. So XGBoost is also installed now. Okay. So all those things you have to do. The reason I'm showing you like this, I will not delete all these errors, guys. See, errors, whatever is coming, it's for your learning process. So now, finally, all the execution is done. We're good to go with respect to all the libraries that we require. See, sklearn.metrics is required. You have k-nearest neighbor, decision tree regressor, random forest, ADA boost, SVR, linear regression. Then since this is a regression problem, the total score is a continuous value, right? So it is a regression problem. So I've used almost all the libraries and let's try to see which is the best library. You can also use random forest, okay? Perfect. Could not install. I think it should get executed. Okay, perfect. It got executed. Now we'll go and read the student.csv file. It is basically present inside the notebook. Let's see this from where we are reading it. Okay, I'll copy this and paste it over here. Okay, done. So we have read it df.head. So what we are going to do over here is that, see, I can go ahead with math score, reading score, writing score, whatever things you want, right? Let's now see the two additional features that we have created. One was with respect to the total score and all, right? I can do that, or I can just directly use this math score and probably take this feature and my independent features and try to do the prediction for this. Okay. So that is what we are basically doing. What I will do is that I will take all these features, this as our independent feature, and we'll try to predict the math score. Now it is up to you, use total score or average or mean, whatever you want. But here in the code, I will be dropping maths underscore score with access. So this will basically be my independent feature. In my independent features, you probably go and see x.head. Okay, so these are all my features that I have, excluding math score, and then this y will basically be having my math score. Okay, perfect. So done. So if I probably create the code and see the y variable, so y is basically having this output feature. Now this is super important. Okay, super important. One is create column transformer with 3 types of transformers. Now see guys, you have numerical features. So for these numerical features, you have to probably do one hot encoding. First of all, just go ahead and probably just write x off. Okay. And just see, gender was 2, race ethnicity was 5, and we have already seen the ED also. Like how many are categorical features, how many unique categorical features were there. So let me just copy that code and again show it to you so that you'll be able to understand. Right? Yeah, this was the code. So here, if I try to go ahead and execute it, and see this, in gender, you have 2 categories. In race ethnicity, you have this many number of categories. In this, you have this many number of categories. In lunch, you have 2. And in test preparation course, you have this 2, none and completed. Okay. Now see, in this kind of way, because there are very less number of features, right? Very less number of features. Inside this, the categorical variables, right, has less number of categories also. So what we can do, we can basically perform one hot encoding. Now let's consider that there is another feature which has many categorical features. Then we can do target guided ordinal encoding, right? And I will also make sure that we'll try to use that, okay, as we go ahead. But we'll try to improve the model. First we'll create a basic model and then we'll try to improve it. Okay. So now I have my vibe, I have all these things. Now what I've done, I will create a pipeline. Now the pipeline is required because for numerical, I will try to do different not for numerical, basically, let's say for categorical features I have in my data set. So first of all, I need to perform one hot encoding for everything, right? Then let's say with respect to all the features, once it is getting converted into a numerical feature, what we'll do, we'll try to apply standardization, we can apply normalization. So this should be in a form of pipeline, one step by the other step. So here if you see, okay, so what I've done, first of all, I've taken my numerical features separately. So I've written x.select data type, exclude objects.column. So that basically becomes all my numerical features. And if I write x.select data types, include object.columns, then that basically becomes my categorical feature. Okay. And now what I've done from sklearn.preprocessing, import one hot encoder because I have to do that standard scalar. Okay. Now this two, when we combine this as a pipeline, right? So in short, what is basically happening in those two, right? The column transformation will basically happen. So the column transformer will combine these two together, one after the other. First, one hot encoder should happen, and then standard scalar should happen. So this all I think you're familiar with, right? So sklearn.preprocessing, import one hot encoder, standard scalar is there. From sklearn.compose, import column transformer is basically there. Okay. So what I did, I initialized standard scalar, I initialized one hot encoder. Now see, one by one I've combined this as a pipeline. So here you have column transformer. The first step in the list will be one hot encoder with this particular object, and for which kind of features it will be? For categorical features, right? For categorical features. And then I'm applying standard scalar for numeric by using this numeric transformer, and for which feature it will get applied? Only for the numeric features, right? So this way we are able to get this entire processor, right? And this processor will be used later to do any kind of fit or transform on any kind of data set. Okay. In short, this column transform is responsible for transforming your columns or your data points. Okay. So once I execute this is done. Okay. And now you can see I'm just doing unfit on the transform on X. So if I do this on X, and if I probably go and see my X value, here is it. I'm getting my entire array. And it is basically combined it. You can see if I write x.shape, you'll be able to see now I have 19 columns and 1000 records. Amazing, right? This is the power of this column transformer. Now see guys, it's not like basics is not important in data science. Basic is super important because all these things only we'll try to convert that into a model coding later on. In the next tutorial, you'll be seeing that. And you'll be quite impressed. At the end of the day, you'll be thinking, oh, it was so easy and we never thought how to probably prepare an end-to-end data science project, right? Perfect. Now the next step with respect to this is that we are going to do train template. Again, it's very much simple to create a train template. We use train template from sklearn dot preprocessing. So train template is not defined. Okay, no worries. So I will write from sklearn dot preprocessing, because here I'm going to train a model processing from sklearn dot preprocessing import. I hope so. There is train test split. Let's see whether it will work, or it is present in sklearn dot preprocessing. No, it is not present over there. So let me Google it. See, I'm also a human being. I also forget things. sklearn train test split. And Google is there. Don't worry about that. Okay, it is present in model selection. Now everything is coming in my mind. Okay. So here, instead of writing preprocessing, I will write model selection. Done. So done. Now I have 800 records in my training and 200 records in my test. Now what I've done next, create an evaluation matrix to give metrics about the model training. See, I will write all this code. All this code I will write again and again. Okay. When I'm doing modular coding, but right now I'm just trying to show you with respect to the EDA model training. Okay. So here in the evaluate modeling, we evaluate model, we're going to take mean absolute error, we're going to take mean squared error, and root mean squared error, R square, and we're going to return all these values. Fine. This function is there. Now this is super important. See, this is my model list, right? And then this is my R2 list. And then I'm basically going to do the fit, then I'm going to do the predict, and then I'm going to find out the evaluation of the model, like ME, RMSE and all. So see this, very simple. And then I'm going to append all those values over here. And then this is with respect to the model performance, right? And here is basically my R square. Now see guys, everything I'm going to do again. I'm going to write this code again for you when we're doing modular coding. But here, since you're very much familiar with Jupyter Notebook, since you're following my tutorials, you will get an idea about it once we do this in the form of this, right? Obviously, this is very much simple to understand. So here you can see output exceeds there, open the output data in the text editor, this is there, perfect, right? Now if I probably can try to see this, right, which is basically having the best R2 square, I'm basically displaying that, okay? So here you can see Ridge is basically having 88%, linear regression 88, cat boosting regression 85 and all. So I will probably go with linear regression because there is hardly any difference. So we go and see the accuracy of the model, then we predict it, done. Almost all the task is basically done. Okay, so these are all the tasks, and we have done the prediction. Okay, this is basically the predicted value and the difference that with respect to the actual value. So this is my actual predicted and difference. Okay, this is pretty much simple. See, now the reason I've shown you is that all these things we have done. Okay, we have done train test plate, we have done column transformer, we have probably gone ahead and created evaluation metrics, we have trained this model. Everything over here I've just executed and shown it to you. Okay, and then based on the R2 score, based on the ME score, MSE score, we have sorted all the models, right? This now same thing in the going tutorial. What we are going to do is that I'm going to basically write everything this in the modular programming way. We need to understand where this model training code will come, right? We need to understand where this evaluate model code training will come, because somewhere we'll be writing, right? Inside this source, we have created this utils file. Let me talk about this utils file. Here I'll probably create my evaluation method, technique, all the functions will be over here, right? In the model trainer, I will probably try to create all my training code that I've basically created over here. Finding the best model, I may write it in utils.py. Train test plate, I may write it in my utils.py. This kind of technique, I may write it somewhere, right? In data ingestion, I will be responsible in doing the train test plate. I did a train test plate over here. So where this train test plate will come as soon as you ingest the data. So we'll try to put this particular code over there. It's just like mapping properly which code needs to come where. But it is not like, see, if I'm saying train test plate, that basically means I'll be directly writing train test plate over here. No, nothing like that. I will create a function, a generic function in utils.py that will do train test plate. And this function will probably get called in the data ingestion. So this way, this is how we will try to map the entire modular coding. And finally, trust me, you'll be learning all these things. And this is all the mapping that I will be doing going forward. Right now, you'll be able to see, okay, I've done everything in the IDE, right? So I hope you like this particular video. If you like it, guys, see, again, it's a request. Share it with as many people as you can. This is important. If you share it, someone who's struggling to learn something, right, and they're not able to get some resources, please do make sure that you share them with them, right? It'll be very much important. Okay. So yes, this was it from my side. Just let me know in the comment section how the tutorial is going on. Before I go ahead and close this, I will be committing the code over here. So let me go ahead and write git add dot, and warnings LF will be replaced by this. Let's see. So this is my notebook, cat info. Okay, cat info and all are there. Okay, data is also there. It's okay. So what I will do over here is that I will just say git status. So what all things I have. So all these files have been created, right? I will just push this all the data set. Okay. So I will write git commit -m, and here we will be writing EDA and problem statement, right? So done. I will go ahead and execute it. Done. And finally, we'll go and git push -u origin to main. Done. Git push. Okay, sorry. -u to origin to main. So now you'll be able to see that yes, it's everything is pushed now. You'll be able to see in my GitHub repository all this particular code will be there. GitHub repository is already in the description. So yes, in this video we have discussed about our problem statement, we have discussed about EDM, we have probably also trained the model. Now going forward, we will be working completely on the modular coding part. Guys, we'll continue the project discussion with respect to end-to-end project implementation. In our previous part, we have seen like what is the problem statement with respect to the student performance. We're going to solve this one, and I'd also shown you about the EDA and model training part also. So model training also we had actually completed. Now see, all these things, right? Usually when you're starting data science, right, most of the time you will be working in Jupyter Notebook itself, right? But we need to probably convert this into model coding, convert that into a CI/CD pipeline, so that once it goes into the production, right, it should be continuously running, right, whenever we want. Now for this, in this video, we're going to basically start data ingestion, and this is where we are now going to start, focusing more on understanding how things will get implemented. Okay. So over here, you know that in the components, right, we had first of all created this data ingestion.py. Now this particular data ingestion will play a very important role. And for this to understand well, why it will play a very important role? Because see, most of the time when you're working as a data scientist, right, for any problem statement that you really want to solve, you require data. Now, in a team, when you're working in a team, when you're working in a bigger team, when you're working in a product-based companies, there you'll also be having a separate big data team. Okay, there specifically you'll be having a separate big data team. Now, in that big data team, they will be making sure that they will be collecting data from different sources and probably storing it in some databases, storing it in Hadoop, and storing it in different places itself, right? Probably it can be also stored in MongoDB, it can be stored in any kind of data source in short, right? But you as a data scientist will first of all try to read the data set from that particular data source itself, right? Now, these data sources can be various kinds, right? So first, initially, we will just start with the local data source over here. Then I will show you that how from MongoDB also we can extract it. That we'll do in the upcoming videos. First, we'll complete writing this data ingestion part, and we'll try to improvise this data ingestion part. Like what all best can be basically done. Okay. So let's go ahead and let's write this code. Again, the main aim is basically to read the data set from some specific data source. That data source can probably be created from big data team, or it can be created from the cloud team. They may be reading from the live stream data, and many more things, many more possibilities is there. Now, our aim is that we'll read that data, we'll split that data into train test, because that is the most important part, right? We need to split the data, and after that only data transformation will happen. See, after data ingestion, data transformation will happen. Right now it is completely empty. I'm not written any code over here. We will write the code line by line, and you can also practice along with me. So first of all, I will go ahead and import OS. Then I will go ahead and import sys. Okay. The reason why I'm importing this because we will be using our custom exception. And then over here I will write for exception, right? For exception, we need to import it from this source. Inside source, you have this exception which we had actually created this, and we really need to call this custom exception, right? So for that, what I will say from source.exception import custom exception, right? So this is what we are basically going to import. Along with this, we also require logging. So from src.logger, I'm going to import logging, right? So that we'll also be able to log in the data ingestion part. Okay. So today in this video, we're just going to discuss about this particular file itself. Okay. Perfect. This is done. Remove unused import, remove all used import. It's okay. Right now we'll just keep this. Okay. Now along with this, I will also be using pandas. So import pandas. There's a reason because again I need to work with data frame as PD. Okay. And then from sklearn model. Oops, what is coming up? As PD. Okay. I'm typing PD. This. Okay, import pandas as PD, and then after importing pandas, I will also be making sure that I will write from sklearn.model selection. I'll be using this to import the train test split. Okay, because I need to do the train test split. Now, along with this, I'm also going to use one more very important class, and this is probably in Python 3.9, I guess. So for here, I will say import data classes. Sorry, from data classes. Import data class. Okay, I will show you the use of this data class because why I'm specifically using everything will make sense once we probably start. Okay, it'll be amazing once we work with this data classes. Okay, and this is also a very cool way of using things. By creating this, basically you should create class variables in short. Now let's go ahead. Okay, now see in data ingestion, right? Whenever we are performing the data ingestion component, there should be some inputs that may be probably required by this data ingestion component, right? The input can be like where I have to probably save the training path or train data, where I have to probably save the test data, where I have to probably save the raw data, right? So those kind of input will basically be creating in another class, and this class I will try to mention it as data ingestion class. Okay, so data ingestion config. Now the reason why I'm making this data ingestion config, and I'll write over here as pass, because in my data ingestion component, any input that is required, right? Anything that I specifically require, I will probably give through this particular data ingestion config. So probably if you do data transformation also, you will probably go ahead and write data transformation config because there also you'll be requiring some kind of inputs, right? Output with respect to any data ingestion, that we'll try to see. The output can be anything. It can be a numpy, it can be a file saved in some folder, it can be multiple things. Now, if I want to use this data ingestion config, now see this. I will probably use a decorator which is called as data class. Okay. So this decorator is quite amazing. Okay. Because inside a class, to define the class variable, you basically use init, right? But if you try to use this data class, right, you will be able to directly define your class variable. Okay. So here, if I'm probably defining my class variable, so here I require train underscore data underscore path. This will be a str type, that is string type, and here I will write os dot and just give some path. Okay, os.join, os.path.join. Okay, and I will make sure that I will create an artifact folder so that I will be able to see my output. So this will be the path initially which we are giving to our data ingestion component, and data ingestion component output will save all the files in this path, like the train data. It will be saved in this path. Now the path will be basically I will create an artifact folder. Okay, so all the outputs will basically be stored inside the artifact folder, and this will basically be my file name, that is train.csv. Okay, so this is with respect to training data path, right? So this is the input that I'm giving. Later on, my data ingestion will save the training.csv file in this particular path. Then similarly, I will go ahead and copy over here, and I will save this test underscore data underscore path. Okay, test underscore data underscore path, and this will also be test.csv. And one more path, one more file that I really want to save over here. And for that, I also require the initial path, that is raw data path. So initially, how my raw data is, and I will try to save this in the form of raw.csv. Okay, some naming convention I basically used or something I've used over here. So let's go ahead and write data.csv. Now understand why this data ingestion config is called. See, I can probably create another folder over here like config entity, and then I can probably define this class over there. But I'm defining it over here. For the starters, it will be easy to understand. Okay, so these are the inputs that I'm giving to my data ingestion config. Sorry, data ingestion component. And now data ingestion component knows where to save the train path, test path, and data path because of this file path. Okay, so this is perfect. So I have first of all defined my data ingestion config. Now let's go ahead and start our class data ingestion. Okay, now this time, since we just only don't define variables. See, if you're only defining variables, then you can probably use data class. But if you have some other functions inside the class, I would suggest you try to go ahead with init, the constructor part itself. So I'll write def underscore init underscore, and here I will basically give my self parameter. Okay, and this is how classes are there. You can probably check my Python playlist if you want. Okay, so here I will write self.ingestion config. Okay, self.ingestion underscore config. Okay, I will create this variable which is called as ingestion underscore config, and this ingestion underscore config will consist of these three values because this is the input that I really need to initialize. So here I will write data ingestion config, and I will initialize this to this, right? So what will happen as soon as this will get executed when I call this particular class, this three path will get saved inside this particular class variable. Okay, basically inside this particular variable you'll have this sub variable itself, right, or sub object itself. Perfect. So this was the first step. Okay, now the second thing is that I will try to create my own function, and I will write it as definition initiate data ingestion. Okay, so this will be my function, and here I'm going to give myself parameter. Now what this initiate data ingestion will do? See, if your data is stored in some databases, I will write my code over here to read from the database. Okay, so if you want to also write the code to read in the database, so what I can do is that I can probably create my MongoDB client or my SQL client in utils function in utils.py, and I can read it. Okay, but here just to start with, and then I will try to simplify. I'll try to make it much more complex as we go ahead. Okay, but initially let's go and just read the dataset in a very easy way. So first of all, I will write logging.info, and I will say entered the data ingestion method or component. Okay, I will write like this. Okay, so here this is my logging.info that I'm actually doing. Okay, now let me go ahead and write my try block, because anytime my error will come, I will probably try to write in this way. So try pass, and I can write my except block also. Okay, except block. Okay, and this will also be pass. For right now, I'm just writing pass. Okay, now what will happen inside this try block? Now let's see this. Okay, first of all, let me just go ahead and read this dataset. So read underscore CSV. And inside my CSV dataset, I will give the path. Right now I'm reading it from CSV. See, here only you can probably read it from MongoDB, you can read it from anywhere that you want. But just as a starter, because I really want to first of all talk about those people, like those people who face problem who does not know about MongoDB and all, right? So initially we'll start with some basic, and then later on we'll convert this into MongoDB and all, right? So here I will go ahead and probably see this data. Okay, so over here you can see notebook slash data slash student.csv, right? So I'll give my path over here. So in order to get this path, just right click on this and copy in the copy relative path. So once you do that, you'll be able to get this. Okay, so this is my df. I'm reading the dataset over here, and I'll be able to see over here. Okay, now what I can do, I can basically write another log. Okay, so inside this I will say logging.info. Please make sure that you keep on writing the logs because it is important. Because anywhere the exception happens, right, we'll be able to understand which line the exception is basically happening. Okay, so I will say exported or read the dataset in the read the dataset as data frame. Okay, I can basically write this as data frame. Okay, now perfect. This is basically with respect to logging.info. Okay, now the next thing is that I already know the path of training data. Like my path will be artifacts and train.csv. This artifacts is basically a folder. So let's go ahead and create all these folders with the help of training data, test data path, raw data path. Okay, so for that, what we will be using os.make directories. Okay, now inside this I will write self.ingestion config. So this will be self.ingestion config. So inside ingestion config, we have the parameter which is called as train data path, right? So this is my train data path, and I will also give one more important statement over here as so this is my train data path. Let me just say it is basically ingestion underscore config. Okay, I will save this. I'm just seeing that the spelling is wrong, right? So self.ingestion ingestion config. Okay, now what I will do inside this make directories also, right? I have to combine the directory path name. So over here I will write one more bracket. Just see this. Okay, I will write one more bracket, and here I will say os.path.dir name. Okay, so what I'm doing, I'm basically getting the directory name over here with respect to the specific path, and here I will give another parameter which is like exist underscore okay is equal to true. So if it is already there, we'll keep that particular folder. We don't have to delete it and again create it. Okay, so this is what we are basically doing with respect to the os.makes directory. Now, a very important thing that I will try to do over here is that first of all, with respect to the raw data path also I can save it. Okay, so I also have the raw data path and I can probably save it in that specific location. Okay, so what I will do, I will say df.to underscore csv. Okay, and here I will write self. See, I'm going line by line. I'm just making you understand in a very easy way. Okay, and trust me, initially this project when it was developed, right, it was very complex. We broke it down completely so that you will be able to understand. I know there will be some people who will be saying, "This is all very easy and all." Don't consider it in that specific way. Okay, it will be tough. You'll be able to understand it, but once you are able to follow this, trust me, after any toughness in the project, you'll be able to get it. Okay, so first of all, what I'll do, I will take this raw data path and probably I'll write index is equal to false and header is equal to true, and I'll save the data in that specific path. Okay, in this path, raw data path. So raw data path is basically saved with the help of this. Now the next thing what I'm going to do over here, I will write logging.info and I'll make a message saying that okay, train test split initiated. Okay, initiated. So train test split is very simple. So here what I will do, I will just write train underscore set. Test underscore set. Okay, I'm creating train and test, and here I'm specifically using train test split, and this here I'm going to give as my df, and my test size will be 0.2 and some random state with respect to. Okay, so this will be my random underscore state is equal to 42. Okay, any random state you can probably give. Okay, once you get your training set and test set, now all I have to do is that again I will write train underscore set dot to csv to underscore csv, and now I will save this in the same artifact folder by using the same concept. Here I will just change the part from raw data path to train data path, right? So this is what we are going to do, and similarly for the test also we can basically do the same thing. So I have done the splitting and I'm actually saving it inside that artifact folder, right? So this will basically be my test underscore set. Okay, yes, this will be my test dot underscore data path. Okay, see guys, I'm writing line by line code so that you'll be able to understand very much clearly. Okay, so fine. Here I will go ahead and write one more comment. Okay, logging.info, and let me just go ahead and write this logging.info, and here you can basically just write it as ingestion of the data is completed. Okay, so usually in ingestion these things basically happen. Now here you can probably change the code and probably read it from MongoDB, from MySQL, it is up to you. Okay, that also we'll try to see this in this example only. We'll create a MongoDB from Atlas, we'll store it over there and then we'll do it. Okay, that probably will do it in the upcoming video, but let's understand this. Okay, because if you really want to learn something, right, learn from the basics, it will always be good. Okay, now finally these all things are done. Now what I'm going to do, I'm going to just return three important things now. Now here you'll be understanding what all things I'll be returning. First is I will write self.ingestion config, okay, dot train data path, okay, comma self dot ingestion underscore config dot test data path, because I will be requiring this information for my data transformation, right? So this two information, what I will do, I will just try to pass it so that my data transformation, which is my next step, will be able to just grab this information and take all these particular data points and start the process. And finally now in except, I will write it as exception as e, okay, and this will basically be raise custom exception raise custom exception with e comma sys. So once I do this, automatically the exception will be raised. See how simple we have just written the data ingestion component. We have read the data set, okay, from somewhere, okay. It can be anywhere. I'm saying just considering it somewhere, okay. It can be from UI, it can be from it can be from clipboard, it can be from APIs, anywhere, okay. So we are specifically reading the data set, and then we try to convert this into the raw data path. We converted that into CSV file. We did train test split. Then we saved the train file. We saved the test file, and then whatever things we are returning, we are basically returning the training data part and test data part to my next step, which is basically my data transformation. Okay. So this was the entire class, guys. Now quickly, I will do one thing. Very simple. I will just initiate this and run this. Okay. If underscore name is equal to underscore main underscore. Okay. So over here, what we can basically do is that I will just initiate this. Okay. So I will take data ingestion object. Okay. So obj is data ingestion. Okay. And let me write data ingestion, initiate data ingestion. Okay. So now once I execute this, right now no folder is there like artifact and all. See, no folder, artifact. Artifact folder will get created once I execute this. And my logs also, you can see only 3 files is there. Now 4th file will also get created. Okay. So quickly, let's go and open my terminal. Okay, I've just worked in today one file, right? So I'm already in my environment, venv. If you're not there, please make sure that you be there in the environment, then you'll be able to execute. Now what I'll write python src data ingestion underscore ingestion.py. So once I write this and execute it, can't open no such file and directory. Why? Let's see source components. Okay, it is inside source and components. Okay, so I will write components / this. So once I execute this, see logs is getting created. I will probably see whether the artifact will get created or not. Okay, this is what executed. Now here you go with respect to the artifact, right? So now this is your data.csv, your train.csv. So this is your train.csv, your test.csv, your data.csv. So all the files got created. The artifact folder is also created. That's amazing. In the logs file, you can see one extra log file. If you go and see this, enter the data ingestion method or component, write the data ingestion, data set as data frame, train test split, initiated ingestion. All the data is completed. So all these things has basically happened with respect to line number code. Also, you can see the data ingestion part, right? Now you can be anyhow, you can basically be creative and you can probably change only this line of code and convert it either by reading it from the API or either reading from the database. I suggest always try to read it from some kind of data source like MongoDB and all. How to do it, how to add those things, I will again give you the code also as we go ahead. I will give you the example separately with respect to MongoDB because I also need to show you how to set up MongoDB and all and what libraries will basically get required. But here you can see that I was able to do all these things. Right, my artifact folder is ready, my data train test, my logs files are basically getting created. That's amazing. Okay. So perfect. This was it. Now what we are going to do over here in the getting node, I will also add dot artifact. Okay, or artifacts, so that this not gets saved. Okay, perfect. So I've created the data ingestion. Now let's go ahead and add this to the GitHub so that you will be able to see the code. GitHub commit -m, and I'll give that a message like let's give the message like data ingestion, right? So data ingestion. Okay. So yeah, they're done. So over here created mode. I don't know why. So let's see get status. Okay. Your branch is origin by main push. Okay, by one commit. Perfect. So let me just see the git status. Okay, git status is done, right? So over here you'll be able to see that all the files got added. We have created a mode for this, and here this is my data ingestion. Okay, one changes is there. Perfect. Now what I'll do, I will write git push -u origin to main. Okay, done. So here you'll be able to see yeah, everything is getting updated. Great. Okay. Now quickly let me do one thing. Let me just go ahead and see my GitHub whether this is getting updated or not. I think it should get updated. If not, let's see in your repositories. So I'm just going to open it over here. ML project. Artifact is added. Okay, I had added in the getting node. I don't know why it came, but it's okay. We'll add the artifact. If I probably see in the source components, data ingestion. Perfect. The code is also available. So yes, try to refer this now. Now one task that I really want to give it to you. So in the data transformation, try to do someone. Okay, try to see how you're probably getting it or not. And let's see how many of you will be able to do the data transformation. The main aim of the data transformation is that take whatever inputs you're getting, whatever outputs you're getting it from here, and just try to probably read it over here. And then for category features, try to apply some kind of transformation. For numerical feature, what kind of transformation you need to apply. I will try to write the code for this in the next video. Till then, I hope you were able to understand. Now this is where be creative and try to think what all data source you can basically read. Okay. In this particular video, like we will be talking about data transformation. Already in our previous video, we had implemented data ingestion. Again, what was the main purpose of the data ingestion was that we probably read our data set from some kind of source, and then we did our train test split. So here was the entire code. We did our train test split, and we saved this inside one artifact folder, right, with respect to all the data set. So this was with respect to data ingestion. Now, if I probably go and see my train.csv and test.csv, I have all these particular data points. But one thing that you can probably observe over here is that, right, I have so many different kind of features, like categorical features, numerical features, and all. So with respect to categorical, numerical features, what kind of data transformation you need to do, and that is what we are going to discuss in the specific video, right? So here I have my data transformation. Now I'm going to write my entire code over here. The main purpose of the data transformation is basically to do feature engineering plus data cleaning. If I really want to change some of my data set, convert my categorical features into numerical features, I can definitely do it from here. Now let's go ahead and let's write this code. Again, guys, if you are not seeing this particular playlist, the entire playlist link will be given in the description. All I want from your side is that now less number of people are basically seeing it. So please make sure that you watch this entire series. It is quite important. You will learn any kind of projects once we do this implementation. It will become very easy for you. Okay. So let me go ahead and first of all, I will go ahead and import sys. So first I will be requiring this, and then from data class is I am going to import data class. The reason why I'm doing this, I'll let you know. Okay. Along with this, I will also be requiring numpy as np. So see, I'm focusing on basically doing data transformation. That basically means any data set that I have, I will probably be using all the transformation technique. If there is a categorical feature, if there is a numerical feature, if I want to handle missing values, everything will be handled over here. So here I have import numpy as np, and then we go ahead with the next step that I'm going to import pandas as pd. So pandas as pd, pd. Okay. So this is a problem, sometime when you start using too much of help from the VS Code itself, right? Then along with this, I'm going to import from sklearn.compose. I'm going to import column transformer. Now see why I'm importing this, because if you remember in my notebook file for the model training purpose, what all things we specifically did, right? If we go over here we use color transformer, you use one hot encoder, we use standard scaler. So all these things you're also going to use again in this data transformation technique one by one. So I'm going to import column transformer. This column transformer is basically used to create the pipeline, right? So first of all, I may be doing one hot encoding, I may be doing standard scaling. So if I really want to create in the form of pipeline, I can basically use this column transformer library, okay? And then let's say if I have some missing value, so for that I will be using sklearn.imputer, okay? So here you'll be able to see .impute, .impute. I'll be importing something called a simple imputer. And again, different imputation techniques you can basically do. Again, the main thing is that I'm just trying to show you some ways. All the other ways you can definitely explore in that, okay? Then what I will do, I will also make sure that I implement the pipeline. So for that, I will be importing the pipeline also, okay? So importing the pipeline, and finally from sklearn.preprocessing, since these two libraries will be super important, okay? Which libraries? That is import one hot encoder, and along with this we'll also be using standard scaler, okay? Standard scaler. Now just let me know why one hot encoder and standard scaler is used. Try to write in the description of this particular video. Now these are some of the libraries that I will be using in this specific file. Now coming to the next one, the first thing that I will be requiring is exception, right? So from exception, because I need to do the exception handling over here in data transformation also, right? So from source from exception, I'm going to import my custom exception. Along with this, I'm also going to import my logger, source.logger, okay? And I'm going to import my logging over here, and then yeah, I think this two will be fine. If there is anything more to be imported, I will probably go ahead and write the code later on, okay? Now as usual, in the data ingestion, right, we had also created a data ingestion config. Now this data ingestion config is just like providing all the input things that is required for this data ingestion component, okay? Now similarly for data transformation also, I will try to create that. So over here I will write class data transformation config, okay? Now this config, what it will give me any path that I will probably be requiring, any inputs I may probably require for my data transformation component itself, right? So here what I'm going to do, I will create my preprocessor. I'll talk about this, why I'm creating this. So this will be my preprocessor object file path, okay? So let's say that I want to probably create any models, right? And I want to probably save that into a pickle file. So for that I require any one kind of path, right? So I'll write os.path. Okay, I did not import os, so let me go ahead and import os. Okay, import os. I will be requiring this. Okay, perfect. Now here I will write os.path.join, and again I will try to get my artifact folder. Okay, and let's say if I'm creating any pipeline pickle file, I will name that as preprocessor not pickle file, right? Now see, I just created preprocessor pickle file. You can also create model file, but this is just an example to show you in data transformation config what exactly you want, okay? You basically just want to give the input to the data transformation component, okay? And now here I will again use data class. I hope everybody knows the feature of data class. Please do let me know in the comment section why data class is basically required, okay? Already I told in my previous video, but this is just to check your knowledge, because in an interview they may ask you. Now let me go ahead and write my data transformation. Okay, now with respect to this data transformation class, now this is the config, or this is the input that I will probably be giving over here. Now first, obviously as usual, I will be writing def underscore init underscore, and this will be with self, and here I'll be initializing self dot, okay, and I will write data transformation underscore config, right? This will be initialized to what? This will be initialized to this particular class over here, right? So in short, what will happen inside this data transformation config, I will be having this particular variable, okay? So that is the first parameter I will be probably requiring over here in the data transformation config, okay? Now what we'll do is that we'll write a new function inside this particular class, which is basically called as get transformer, get data transformer object, okay? So get data transformer underscore object, okay? And here I'm going to use the self, okay? So these are there. Over here, what I will be doing is that the reason I'm creating this function, okay? This is just to create all my pickle files, which will basically be responsible in doing converting your categorical features into numerical, or sorry, categorical into numerical if you want to probably perform standard scale and all, okay? So here I will write try, and this will basically be inside this try. I will, okay? So here I will go ahead and write try, and this will basically be pass, and again accept, and here also what we'll do, we'll just write it as pass. So I'm just going to write the code with respect to the try and catch block over here. Now, as usual, if I probably try to open the train.csv, you'll be able to see what are the numerical features and categorical features that I have, right? And obviously that I specifically performed in the EDA also, and I got the information about that, right? We understood that what all features were there. Again, I'm telling you guys, if you did not see the previous part, you really need to see it. Otherwise, you'll not be able to understand, okay? So over here, first of all, I will take all my numerical features. I have already made the distinction between the numerical features. So here will be my numerical features over here, okay? So this will basically be my numerical feature. In the numerical feature, I have write score and reading score, and probably in the categorical features, I have all the remaining features. So here, and go and use this categorical features over here. So this is nothing but gender, race, ethnicity, parental level of education, lunch, and test preparation course. Now, what we will do is that we will do two important things, okay? One is first of all create a pipeline. With respect to the pipeline, we also saw guys there are some missing values, okay? So we need to handle those missing values. So for that, if I probably try to create my numerical pipeline, okay, and this numerical pipeline I will initialize to pipeline, okay. Now see, the steps is super important, okay, and this is the most important thing with respect to this. So here I will be writing two steps, okay. The first step over here will be my imputer. Imputer basically means this will be responsible in handling my missing values. So imputer, and here I will be initializing my sample imputer, and the strategy, okay, will be used as medium, because there are some outliers which we also saw in the EDA, right? So in the EDA we also saw in some of the numerical features there were definitely a lot of outliers. So we are basically using medium, okay. So this is done with respect to the handling the missing values. Now after this, what we'll do, we'll also try to handle standard scalar. So for this, I will create another variable like scalar, okay. So just a second. So this will basically be scalar, and inside the scalar, I will just try to initialize standard scalar. Now what exactly is happening over here? We have created a pipeline which is doing two important things. One is handling the missing values with this particular strategy like medium, and the second one is basically doing the standard scaling, okay. And this pipeline needs to run on the training data set, okay, like fit underscore transform on the training data set, and we just do transform on the test data set. Now similarly, I will go and create my categorical pipeline, right? So this will be my categorical pipeline, and let's say if I get a numerical feature over here, sorry, in categorical pipeline, obviously what I will get, I will basically get all my categorical variables. So here I will just define it. So let's go ahead and probably define our categorical pipeline. Now inside this also, we need to handle multiple steps. Like let's say if there are missing values in categorical features, then how do we handle that? And for handling the categorical feature, converting into a numerical value, how should we basically handle that? You know, all those things we'll probably try to do. So inside this, what we are going to do, again, this was a pipeline. So let's see why this pipeline is not coming. Pipeline, okay, no worries. So here it is. Okay, this was the function over here. Okay, now fine. With respect to the pipeline, here I'm going to basically create my steps, and again my steps will basically be having multiple steps altogether. So here I will be writing steps. Okay, the first step again to handle the numerical feature, sorry, to handle the missing values. So here I will be creating imputer, and usually what we do, we basically use a simple imputer, and the strategy that we can probably use over here, strategy. Please make sure that you write the spelling well, otherwise strategy. Okay, strategy. Now this looks fine. Okay, strategy. Strategy will be nothing but it will be most underscore frequent. Okay, so that basically means I'm just trying to replace all the missing values with the help of mode. Okay, now this was with respect to the steps. The first step, I'm going to probably apply this in my pipeline. The second thing, obviously, I'm going to use my one hot encoder, and again here you can also use target guided encoder or whatever encoder you do, because in the EDA we have seen that there are very less number of categories in every categorical variable. So here we are just going to use one hot encoder and we're going to initialize it. Okay, and then coming to the third one, if I probably talk about the third one over here, I also have to do the standard scaling. Okay, and I think if you don't do also, it's fine, but let's go ahead and do the standard scaling so that I show you many things. Okay, over here. So done. This is all the techniques that we are going to perform in the categorical pipeline. Okay, the first thing first, what we are going to do over here is that we're going to apply the imputer pipeline, then one hot encoding, then scalar. Okay, so here missing values is getting handled for the categorical features, then one hot encoding is basically handled for the one hot encoder, and then you are basically doing it as scaling. Now I will also go ahead and write my logging. Okay, so logging.info, and here I can go and basically write categorical columns encoding. Okay, encoding completed. Right. So here I can write this logging info, and similarly I can copy this, and I can say logging.info, and here also I will talk about the numerical columns, and here I'll not say encoding, but at least standard scaling I will basically write. Okay, completed. Now here you can basically see all both of these things we have basically done. Now all we need to do is that combine this numerical pipeline with this categorical pipeline together. So for that only we will be using column transformer. So for this we'll be using preprocessor. Preprocessor will be my variable, and here I'm going to use column transformer, and this column transformer will be having the combination of two things. Okay, one is the numerical pipeline. Okay, numerical pipeline, and the second one is something called as numerical pipeline, comma numerical underscore columns. Okay, so here see what we are doing. This is what is the numerical pipeline that we are giving over here. Okay, and for what variables we are specifically doing this, we are doing it for the numerical columns. Okay, so inside this we first of all give our pipeline name, then what pipeline it is, and then our column. Similarly over here the next step will basically be my categorical pipeline, right? So this will be like cat underscore pipelines. This will basically be my name, and here I'm going to basically give my categorical pipeline, and then this will basically be my categorical columns. So comma categorical columns. So yes, both of them have been given inside this column transformer. Again, understand what all things we did. We created a numerical pipeline which is doing two tasks, right? That is imputer and scalar. Okay, that is handling the missing values and performing standard scalar. Then we have categorical pipeline that is performing imputer, one hot encoding, and standard scaling. And then we did the logging.info. Then we finally created. I'll not write this over here right now. Let me just go and give simple columns, right? Like this. I will just go and give this logging statement, right? Just to display our categorical and numerical feature. And then here I'm creating a column transformer, which is a combination of numerical pipeline and categorical pipeline. Okay. So all these things is done. And finally, what we do after this, we come outside and we return the preprocessor. Okay. Now once we return the preprocessor, that basically means we are returning this entire thing with respect to whatever things we have done over here. Now in the except block, what I can do, again, it is very much simple. I will write exception as E, and I will try to raise my custom exception, right? And this we have done it multiple times. So I'll go ahead and write raise custom exception with E, sys. Done. Perfect. So we have actually created the get data transformer object. The main aim of this particular definition of this particular function is to, I will also write the definition. This function is responsible for data transformation based on the different types of data. Okay. So perfect. I've done this. And this is very much good. We are going in a very good way. We are able to complete all these things and all. Okay. So finally, you can see get data transformer object. Now let's start our data transformation techniques. Okay. So this is where I will start my function. So this will be my another function, which is like definition, initiate. I will just write it as initiate data transformation. That basically means I'm starting my data transformation inside this function. Okay. And here again I'll be using self, and then I will give my train underscore path. Okay. Train underscore path, and this will basically be my test underscore path. So training path and test path. And you know from where you're getting this? You're getting this from the data ingestion, right? And done. Over here again I will be writing try, pass. Then I will go ahead and write accept, pass. Okay. As usual. Okay. Now fine, this is good. Now let's go and read our training data set. So I'll write train underscore df is nothing but since we have already imported pandas, so I will write pd.read underscore csv with my training path. Okay, then I can go ahead and write my test underscore df, which is basically pd.read underscore csv. Okay, so this will basically be my test path. Now here I can basically write my logging.info, so that you'll be able to log all the details, the train and test, read train and test data. I will just write like read train and test data completed. Done. So initially we'll go ahead and read this. Now the next step what we are going to basically do over here is that after this I will write another logging.info, and I'll write that obtaining pre-processing object. Okay, so done. This is done. With respect to this, I will be reading all my preprocessor object. So for that I will just write preprocessor. Now what is this preprocessor object? Whatever object I created on top, right? This one, this preprocessor. I'll try to call this. So this will be nothing but here I will write self.get transformer object, right? So here I will be getting this particular object over here. Perfect. Now I will go and create my target column just to make sure that my target column name. So this will be my target column name. My target column name is nothing but math underscore score. So if you see the data set over here, so this is my training data set. There is something called math underscore score. So this data set will be my target column. Okay. Numerical column, you basically know what is my numerical column. This is nothing but writing underscore and reading underscore. So I will copy the same thing for my numerical column. So this will be my target. This will be my numerical columns. And now what I will be doing is that you can basically check out with respect to continuous values, numerical values. Okay. Categorical features also you can make sure that you can basically write it in a way. Okay. Now this is fine. Perfect till here. Now what I'm going to do, I will say input underscore feature underscore train underscore df. Here I will write train underscore df dot drop. I'm just going to drop the columns. Which column that is? That is nothing but my target column name. Okay, from the input feature, and I will just write access is equal to 1. Now similarly, we want to do the same thing for the test data set also. So I will just copy this entirely and paste it over here, right? And now this input underscore feature underscore test underscore df, I will write like this over here. This is for my test data set. I will remove this, and this will be my test underscore df, and similarly this will be my test underscore df, and this will also be my test. So I'm also going to get the target column with respect to this with test df, and over here my independent features with respect to this. Now I will go ahead and write one more logging.info. After this, saying that applying the preprocessor object on training data frame and test data frame. But once I have my train and test data, all I will be doing, I will take this preprocessing object and I will do fit underscore transform over there, right? So I will go ahead and write preprocessor object dot. This will basically be fit underscore transform, right? So we will go ahead and write fit underscore transform on our training data set, right? So here I will be using input. Okay, some error. Okay, let me just see. Now obj. So this is what is my preprocessor object dot fit underscore transform. Okay, I will call this function, and here I will specifically give my input feature train underscore df. Okay, so here, oops, just a second. So this will basically be my input df train underscore df. Okay, let's see. I'm getting some error. What is the specific error? No, now it is fixed. Okay, I don't know. Sometimes the syntax issues, it shows up like that, right? So this will basically become my input feature train underscore array. Okay, so I'll save it in this particular variable. I have my pre-processing object. Pre-processing object is basically taken from here. Dot fit transform on this. Okay, now similarly with respect to my test data, what we are going to do is very much simple. For the test data test array, I'm just going to do apply transform. Okay, now let me know what is the differences between fit underscore transform and transform. It's simple interview question for you all. Try to write down in the comment section. Okay, it is up to you. So go ahead and write down in the comment section and let me know. Okay, now what is the next step? I will just try to convert this into np.c underscore. Okay, so just let me know what is the c underscore. Okay, this will be an interview question again for you. I'm just trying to take this input array, take my target value, and just have written np.c. Okay, so this is super important. There is a reason why I'm doing this. Okay, and just let me know why we are doing this. Okay, so for the training data and for the test data also I will try to do like this. So this will basically be my test underscore array, when I'm taking my test array and then probably converting my target also into an array and combining this. Okay, we are basically combining this in a way by using this np.c. Okay, you can let me know what exactly it is. Oh here. Okay, so finally I will go ahead and write my login.info. So I will go ahead and write my login.info saving preprocessed objects. This is fine. And now I will be returning these three variables. Okay, the returning that I'm going to return is basically my training array, test array, and data transformation config, whatever we have basically created, right? Our pickle file, right? Preprocessing object pickle file path. Okay, this is what we have basically used. Okay, so this is good till here. So guys, one final thing that I'm going to do over here you could see that we have created this pre-processing object, right? And you know that this can be converted into a pickle file. It needs to be converted into a pickle file. So for this, we have not converted anywhere, but we have taken the path, right? The path is basically given somewhere over here in the data transformation config, right? Like preprocessor pickle. So what we'll do, we'll go ahead and save this. We'll save this pickle file in the same location. So over here, to save it, I will just do it after this. So here I will just create a function which is called as save underscore object. Okay, and I will just give this file two parameters. One is file object or file path. Okay, there's two variables I'll give. I will write it as self dot data transformation config. So this will be the same thing, data transformation config. This entire thing I will be giving this. Okay, self.data transformation config dot pre-processing object file. This will be my first parameter with respect to the file path. Okay. In short, I'm having that entire file path like artifacts pre-processing pickle, right? So this is what is the file path over here, right? Something like this. So this will be my first path and the first parameter, and the second parameter will basically be my object. Okay. So this will be pre-processing underscore obj. Okay. So this is my object that I really want to save it now because this is the what I has a model with respect to all the transformation. Now where do we write this function? Save object. Now to make your work very much easier, I told you right, we are going to basically use utils, right? So utils is one place inside the source, right? So if you probably just go and minimize this source, inside this source you have something called as utils. And I told you that utils will have all the common things that we are going to probably trying to import or use, right? The common functionalities which the entire project can use. So here also I will write import OS. Okay. And here I will go ahead and write import sys for my exception handling. Import numpy as np. Import pandas as pd. Okay, so np import pandas as pd. Okay, oops, I hate this now. I'm going to stop this now. Import pandas as pd. Okay, and if I want to probably do train test split, I can also write it over here. See, the train test split initially in data ingestion was written over here. Instead, I could have written over here and called that particular function over here itself, right? So it is up to you. Okay, if you want to make your code very much cleaner, then we will do this. Now what I will do, I will just create this function called as save path. Okay, so okay, I will also make sure that from src.exception. Okay, import custom exception. Okay, now perfect. Now I have defined the save object function over here. This is taking the file path in obj. It will basically take the file path or it will make a directory like this. If it already exists, it is going to do it. Then we're going to open the file path in the write byte mode and we're going to do the dill.dump. Okay, so what is this dill? This is also another library which will actually help us to create the pickle file. Okay, right now dill is not there, so go ahead and import over here. So like dill. Okay, and I'm just going to the terminal. Okay, and probably install pip install -r requirement.txt. Just to make sure that dill is getting imported or installed. So yes, successfully installed dill. This is good. Now if I go and see import dill, this will be available. So this will be dill.jump. Dump. When we dump this will be saved in the specific file path. Okay. So in short, with the help of this code, what we are doing is that in the data transformation, we are saving this pickle name in the hard disk. Okay. Now in order to use this, all I will be doing again, I'll just import from source, or I can basically import something like this. Let me just write. I think it is inside the source itself, right? So okay, no worries. From source.utils import. From source.utils import save underscore object. Perfect. Now this save underscore object we can call it over here, and this is just used for saving the pickle file. Okay. Good. We have done it almost. Data transformation and data. So in data transformation, we are handling the categorical values, numerical values. We are creating this entire pickle file, doing everything. Okay. Next time we go into the data ingestion part. I had already written this code. Okay. Now what I will do, I will also import from here from sklearn. Sorry, from source. I'm going to from source dot data transformation. I think it is source from source dot components dot data transformation. I'm going to import data transformation, and along with this I will also import data transformation config. Okay, I'll import data transformation config just to check everything is working fine or not. Okay, and finally over here when I do object.initiate data ingestion, then I'll be returning two values. One is train data and test data. So here let me go ahead and write train underscore data comma test underscore data, and this will what I will be basically getting. Now after this all I will be doing is that I can create I can probably see in the data transformation, right? I can probably just call this data transformation, and with respect to data transformation, I can probably call this all the functions that I have. Okay, so here I will again go into my data ingestion, and let me go ahead and write data underscore transformation. This will be nothing but data transformation. Okay, once I initialize this, you'll be able to see that it will call this self.transformation function. Then what I'll do, I'll just call this initiate data transformation. So here if I write data underscore transformation dot initiate data transformation done, most of the execution will happen inside this data transformation. What we need to give our train data and our test data. Okay, and that is what we need to give. I'm just trying to see whether it will be running or not. I'll get some errors. Let's see what all errors will be getting. Fine, we are good. Now let's execute this code. Okay. So what is happening? We have combined data ingestion, and then after that we have combined data transformation. Okay. Oh, hope so it works. I've continuously written the code now. Now usually, see, when we are writing in the real world scenario, right, we will be facing some kind of issues. So here I will go ahead and write Python source data ingestion.py. Okay, I have to basically go ahead and write Python source components slash data ingestion.py. So the execution has started. Let's see whether this will get executed perfectly or not. At the end of the day, I should be able to see some pickle file over here. So now if I go and see, okay, pickle file is not get created. Let me see why it is not got created. So refresh. Great. Execution has happened successfully. Now let's see. Something is there. Let's see the logs. Ingestion of the data is completed. Okay, fine. After the ingestion of the data is completed, let's see in the data transformation. So guys, what I see from the logs, I'm not able to see the error. The reason is that because I did not write this except block. So what I will do over here, I will say exception as E, and here I will just raise my custom exception. Now I think we will at least be able to see the error, what error we are able to get. Okay, and here I'm going to give E comma sys. This is fine. Okay, now let me do one thing. Let me again execute this. Now I think you'll be able to see the error. See, the error is coming as occurred in this 86. Init got an unexpected argument strategy. Okay, fine. I understood what is the problem. So in the data transformation, you'll be seeing that this spelling is wrong, I guess. Strategy. Okay, it should be something like strategy. Which line that was? So this line was 42. Line number 42. Okay, so here also the spelling is correct. Simple imputer. And here I just have to use strategy. Okay, now I think it will work. So it is necessary that you have this custom exception raised, right? So now if I go ahead and read it, everything will work fine, but still I'm getting an error. Line number 101, center cannot center sparse matrix with mean is equal to false. Instead, C docstring. Okay, this is for 101 line. Let's see where it is. 101 line. Okay, no problem. I will go and see 101 line. See this kind of errors you'll be getting over here. So guys, I got to know the error, what exactly it was. Here I had written train_df. This will basically be test_df. Okay, so just have a look onto those kind of errors. Now I think it will work fine. It looks good. I have all my saved processing objects. This is my artifact, and the preprocessor.pickle file is created finally. So yes, it is not that simple. Always you'll be getting the error, but the main thing is that how you are able to fix the error. That skill set you should definitely try to find out. Okay, so great. We have done all this modification. We have saved all the file. Now what I'm going to do, I'm going to commit this code for you all so that you can use git add dot git commit -m. Okay. Here I'll just say data transformation is added. Data transformation done. Saved it, and then I can say git push -u origin to main. So once I do this, all my push will happen, and finally I'll be able to see in the GitHub link. So guys, this was it from my side. We did each and everything in an amazing way. We found out all the data transformation technique, everything as such. What are things we specifically did? We transformed our data set. We handled the categorical values. We handled the missing values. And here I've just shown you by writing line by line code so that you'll be able to. In a previous video, we have focused more on data transformation. In the data transformation, we saw all this, right? Simple imputer, how to handle the missing values, how to do standard scaling for categorical feature, how to handle the missing values, one hot encoder. So this all combination were made perfectly, and we did it, right? And then finally in the artifact folder, we could see this pickle file that getting created, right? Now it's time. We have completed data ingestion, we have completed data transformation. Now let's work on the model trainer. And as usual, I will write the code from starting. Now in this model trainer, what all things we are basically going to do? Okay, here we are going to train different models, and after training, we will try to see what accuracy we are getting, what R score we are getting. Now see, whenever we are solving a linear regression, any regression or classification problem, one thing that probably comes to your mind that what algorithm I should apply. You should definitely try each and every algorithm because you also don't know which algorithm will perform well. So tomorrow, if you go into the interview, someone asks you which is your favorite algorithm, you should just say that I don't have any favorite algorithm. You ask me any question, I'll be happy to answer that. Okay, then they'll only say select one algorithm and explain, right? So please always make sure that whenever you are training your model, try every model over there. Now quickly, what I will do, I am going to just import some of the important libraries as usual. So here are all the important libraries that I'm going to import. One is data class, OS census, obviously, and there's all algorithms we are going to try. Cat boost regressor. We're going to try all the ensemble techniques like ADA boost, gradient boost, random forest. Along with that, we're also going to try linear regression. Then we're going to basically import the metrics R2 score, k nearest neighbor, decision tree, XGBoost, whatever you want. Okay. So for XGBoost, what I will do, I will just write in the regression. Okay, here I've already written XGBoost, so no worries. And I think I've also imported over here. Okay. Now all these libraries has been imported. Now we are going to basically start the model training part. Okay. Now for the model training part, and one more thing I will probably import. I will say from src.utils. Utils part also I need to import because all the common functions I'll write over there. So if I import over there, let's see the util function. What all things I've created in the utils? I've created save object, right? So I'm going to probably import this save object. And if I want to create new, I'll probably go ahead and create it. Okay. So these are the libraries that we are probably starting with. Now, as usual, the first thing is that for every component, we really need to create a config file for that also, right? So every time, if you probably see with respect to data ingestion or data transformation, you will be able to see that initially I will be defining this kind of transformation config, and there I will be giving some path like of the pickle file, whatever input is basically required. So here also I'm going to do the same thing. No, don't cancel this. I'll probably go and do something over here. Here I will first of all create a data class. Okay, data class, and here I'm going to basically write class model trainer config, right? So this will basically give whatever input I require with respect to my model training. And here I'm going to create a variable which is called restraint model file path. So after probably creating my model, I will want to create that into a pickle file. So this will be my variable name, and here I will be writing os.path, and I will be joining over here with my artifacts folder, artifacts, and I will give my pickle file name as model.pickle. Okay, model.pickle. Okay, perfect. So this will be my model training config. Now the next thing that I'm actually going to do over here is that I will create another class, model trainer, which will be responsible for training my model. Okay, and inside this model trainer, first of all, I will define my init with self, and here the first thing that I will initialize is that I will say self dot model underscore trainer underscore config, and this config will get initialized to what? To my model trainer config, right? So model, I'll write it over here, model trainer config. Okay, so this will basically get initialized over here. So inside this variable, I will be able to get this particular path name. Okay, done. This is very much easy. We have done it. Now what I'm going to do quickly, I'll write another function which will say initiate my model training. Right. So we need to probably start model training. So here I will say initiate model trainer. Okay. Here the things that I'm going to give is first of all my training array. Okay. My test array, because this is the output of the data transformation. Right. So I'm going to just write test array, and then I will write preprocessor underscore path. Okay, done. These all are there with respect to this particular definition. Now what I'm going to do is I'm going to basically write try and catch block. So for this, let me go ahead and write try and then pass, accept, and then again I will write pass, right? And here I'm going to basically write my entire code. So let me just go ahead and probably write this. So first of all, I will start with logging. Some logging I will try to write logging info. Have I imported logger? Yeah, from source.logger, I've imported the logging part. So here I will say splitting training and test input data, right? Test input data. Okay. So first step that I'll be doing is that as soon as I get my train array and test array, which is coming from my data transformation. So if you probably go and see data transformation, what I'm returning the train and test array. And in this train and test array, the last feature that is added will be a target feature. So what I'm going to do over here, first of all, I'm just going to divide my training data set. So here I will say xtrain, ytrain, xtest, y underscore test. And this variable I will be initializing to a tuple. And inside this tuple, I will basically be having, train underscore array with colon, colon minus 1, right? So I'm just saying that take out the last column and feed everything or store everything in xtrain. Okay, and then from the train underscore array, I will be taking all the rows column minus 1, right? So then I will probably have that last data as my ytrain value, right? And similarly over here I will be having test underscore array with respect to all the columns, colon minus 1, okay, minus 1, and then finally test underscore array with respect to all the rows, colon or minus 1. Okay, so all these values are there with respect to my training and test data set. Perfect. So here we are good enough. Now what I'm going to do after I probably convert my data into train and test, all I will be doing, I will just create a dictionary of models. Okay, so these are the models that I'm going to try out with random forest regressor, decision tree, this, every model I'm going to try. Right now I'm not performing hyperparameter tuning. I want to give you as an assignment for hyperparameter tuning. Just try it out. If you're not able to do it, just try it out and tag me in LinkedIn somewhere. Just try to at least message in the LinkedIn for me and let me see your GitHub. And then if you also do that, I'll give you a huge shout out in my next video itself. Okay, so definitely do that. Right now I'm just taking basic models, and from all these models I'll basically try, and I will go ahead and see which model is performing well. Now let's go here. And the next thing that I'm going to basically do is that I will write model underscore report, okay, is equal to dictionary. I will create a dictionary and I will create a function which is called as evaluate underscore model. And inside this first variable, I will give my x underscore train. The second variable that I will probably give is nothing but y underscore train. And finally, I will give my models data. So let me go ahead and write models is equal to whatever models I've created over here. Okay, I've given x train and y train. So let me also try. Okay, what will be evaluate model? Evaluate model will be a function that I will create in the utils. Okay, so this evaluate model I will just try to copy paste for you all. Okay, if possible. Okay, here I will also give my let's give this. Okay, so this will be my x train. This will be my y underscore train. Then I also have my x underscore test, 4 variables, and finally I will also give my x underscore test and y underscore test. So these 2 values have been created, right? X underscore test and y underscore test. So 4 values. So why this is not accessed? Y underscore test, x underscore test. I'll write comma. Okay, fine. Let's see this. First of all, here I'm just going to write x underscore test variable, and I'll initialize to that, and this will basically be my y underscore test. Perfect. Is equal to this one. I hope everything will be working fine. And then finally I give my models is equal to models. Okay. I'll just write press enter. Now this evaluate model, what I'm going to do is that I'm going to just create a function inside my utils.py. Okay, so I will go ahead and just copy it over here. So now let's go ahead and see. I don't require this. Okay, let me just show you what all things are there. So here I will write x underscore train, y underscore train, x underscore test, y underscore test, comma models. Okay, so this is there. I'm giving all this data. I get all my data. Now what are we going to do? We are just going to go through each and every models. We'll say list.model.values of I. So basically I'm getting each and every model. I'll do the fit on my xtrain and ytrain, and then do the prediction on xtrain and do the prediction on xtest. I will go ahead and probably compute the R2 score. R2 score is very much simple, guys. As you all know what R2 score is used for. So first of all, I will import that from sklearn.metrics import R2 score, right? So this R2 score will be used over here to find out the prediction, and then I will get the R2 score for the test model, and I'll keep on appending on side this particular report, that is my dictionary values, right, with some keys, and this will be my test model score, and this will return this particular report. So this evaluate model will basically be having my entire reports of the model. So for that, I will go over here and import the evaluate models. Okay, done. So evaluate models is there. Now this will probably here I'll just create evaluate models, and here is my entire model report, which I'll be getting in the form of dictionary. Okay. Now once this is done, just let me know what the specific code is. I've written in the comment section also, don't worry. Now from this, I will try to get the best model score from the dictionary. For that, we're just going to sort this model report based on values. I'll get my best model score, and along with this, once I use this code, I will be getting my best model name, because the key is the model name, right? So whatever key is that will be the model name. So here you can basically see model report dot keys. First of all, this will get converted into list, and then I'm creating a nested list over here with respect to the report values, and whatever index is basically with respect to this best model score, I will get the best model name. Okay. So finally, once I take this best model name, all I will be doing over here is that I have to pick up that particular name from here. Okay, so for that I will just write something like this: models of best model name. I will be getting the best model. Okay, now here I will just write one condition. I'll say if best underscore model or underscore score, okay, is less than 0.6. Okay, I'll just put a threshold. If it is not better than at least 60%, then I can raise an exception, or I can raise a custom exception which says no best model found. Okay, no best model found. Okay, done. If I don't get any specific model, any best model less than 60, if all the models are less than 60, then I think we have to do something about it. Okay, now I will go ahead and probably write one logging also over here. So I'm doing the copy paste now, guys, because now it's more about just logging and doing it. But understand the process. Okay, we tried out with all this particular model, give our extra and extra y test data, and then we also give the entire models that you want to test. We got the entire report. We selected the best model, and here I'm saying that if the base model is the best model score is less than 0.6, then we are basically saying that no best model found. We are raising an exception over there. Okay, and finally let's go ahead and pre-processing underscore obj, and here I'm going to load this particular pickle file for the transformation, right? This preprocessor.pickle file, and we may probably use this particular file for doing the transformation or whatever things you basically require. And in this case, I think we don't require it. Also, if you don't want to load it, you can just keep that pickle file over there itself. Okay, but if you want to load it, you just try to load it for any purpose, for with respect to any new data that is basically coming. But here we will not do this. Okay, now the next thing that we are going to do over here is that I'm just going to save. I'm going to call this save object, and what we're going to do, we're going to save the model path. Okay, so here I will say file path is equal to self.model trainer config dot train model file path, and then I'm just going to give my object, which will basically be my best model, right? So this specific best model will be my pickle file that I really want to create. Okay, so this will basically get created as model.pickle file. So if I go and see in save object underscore this one obj object, so here it has my file path, it has the object, it is going to make the directory with respect to that particular file path, and it will just go ahead and dump it. Okay, so now I'm just dumping my best model with respect to this name model.pickle. Okay, so this will basically be the path, right? This model path is like artifact slash model.pickle. Okay, now if you really want to see the predicted output for the test data, so I can also write predicted best model dot predict, and here I'm going to basically say x underscore test, capital X underscore text, and then this will basically be my R2 score. I can also call over here just to see that how much accuracy I have, y test and y predicted, and finally I will return the R2 score. I will return all my R2 score. Now in the except, I can go ahead and write exception as E, and I can raise my custom exception with E, sys. Okay, done. I think we are very much good to go. I think everything will work fine. I am confident enough because now I practiced a lot of things. See, coding is all about having fun, you know. So if you are able to do it, now in order to test it, I will first of all write from src.components.model trainer import model trainer config, and then we have to also import model trainer, right? So done. I will import both of this, and now let's try. So all this is there already. Data transformation, I get my initiate transformation with respect to data transformation, right? What is the return type of data transformation? Let's see. So I will be getting these 3 values, right? So let me just save these 2 values at least, okay? Train array and test array, because this is what I'm going to give it to the forward, right? So here, what I'll say, train underscore array, comma, test underscore array, and last one I don't require also because I've already created the pickle file, right? So data transformation dot initiate config. Now I'll go to my next line, and first of all, I will go and write data model trainer, right? So model trainer is equal to model trainer, right? Model trainer. I will initialize this, and then I can call model trainer dot, what is the function name? Come on, what is the function name? That is initiate model trainer. Okay, I hope so. This should be coming. Initiate model trainer, and here I will just give my data set, that is train underscore array, test underscore array, test underscore array. Done. I think it is fine. Model trainer dot initiate model trainer. So why this error is coming? Let's see. And preprocessor path. Okay, preprocessor path also I need to give. Where is this preprocessor path coming from? Preprocessor path basically means this. Okay, fine. I think I don't require the preprocessor path because I'm not using it anyway, so I can remove this. No worries. Okay, done. I'm not using this. So model trainer data ingestion done. Now I will just go ahead and print this. Okay, so once I print this, this is basically going to give me my R2 score. Okay, great guys. I know whether you have understood or not, but I've tried my level best to teach. Okay, if you appreciate it, please do make sure you comment down, write something very good. Okay, now I will call this data ingestion. Let's see everything works fine. Otherwise, I have to keep on searching what went wrong. So now I've executed. Finger crossed, everything should work fine because the mapping of the code is perfect, right? So I should probably be getting the R2 score with respect to whatever data set we have. Okay, I got an error. I was anyhow expecting it. Evaluate models got an unexpected keyword argument x underscore test. So no worries. Evaluate model. So let's go and see evaluate model x underscore test. No worries. Done. Now I think it should work. I had written it in the small letter. Now let's see whether I get any error. Perfect. See this? I got, man. Successful. So happy I'm able to get this output. So I'll again execute and see all the logs are correct or not. So finally you can see R2 score I'm getting 87%. Great. The model.pickle file is created. If I go and see my logs, you can also see the logs. So all the logs are here. See, best found model on both interest testing and split. This has happened. So perfect, guys. We have got a pickle file. We got our preprocessor pickle file. The entire artifact folder is ready. The components is ready. Everything. Okay. Now from the next videos, I'll focus on showing you the deployment part. Again, I'll be using Dockers and all. Let's see how to like with the help of Dockers and all, how we'll be doing the deployment and how what I can also do. You know, this model now I can push it into the AWS cloud also. So that part also we'll try to see, which we also say it as model pusher. Okay. So that model pusher can also be created. But again, at the end of the day, very good. We have completed model trainer. We completed data ingestion. But I think I've tried to give you the best thing that is possible. And again, this was all possible of making this particular project. Again, thanks to my teammates in 9neuron. They've given this amazing way of writing this code. I told them try to give much more simpler, you know, much more simpler so that many people can actually understand and use it. So yes, this was it. Now the next thing that I can probably do is that just go ahead, git add dot. Let me do one thing. Okay, in the git ignore, no, I think in the previous git ignore, what did I add? So git ignore, there was artifacts dot artifacts spelling is right? Okay, it was a folder. Okay, no worries. Now if I go ahead and do git add dot, then I will go and see git status. So all these files have been added. Git ignore is also there, but now you can see this artifacts model.pickle file is there. Okay, perfect. I wanted my artifact to go right. I'll remove this. I don't want this to happen. Okay, so now I will write git add dot done. Then I'm going to basically clear it, clear the screen. Oops, and I'll say git commit -m data model trainer, right? Model trainer done. So I'm doing the git commit. And finally I'll get git push -u origin to main, right? One assignment that I told you, please try to perform some hyperparameter tuning. It is up to you, but I will definitely show you a technique of how to do it quickly. Okay, so done. I think the code is also updated. Let me open my GitHub. Let me just show you. So here is my GitHub. Your repositories. Okay, ML project. Now, if I probably go and see my source, my components, model trainer code is ready. This is so good. Now, in a simple way, I did it. Try to write the code for the hyperparameter tuning. Suggest me, share it in the LinkedIn. At least message me and show me a GitHub after doing that. Okay, and I'll give you a big shout. Hello guys, so we are going to continue the discussion with respect to the end-to-end machine learning project implementation. In this video, we're going to understand about how we can perform hyperparameter tuning considering different machine learning algorithms. So if you remember in our previous video, what we did is that we created this model trainer, right? Sorry, this is utility.py. Okay, we created this model trainer, and in the model trainer, we tried multiple algorithms, and then we selected the best model, and then we continued and saved the specific model. So if you've probably seen the artifact, I have my model.pl file. And so here are all my machine learning algorithms. Now what I can do, I can initialize all my parameters. So I will probably implement it and show it to you. So here, I'll just copy his code, okay? And you know what we can do is that, see, I'm just copying this over here, I'm pasting it over here with respect to this, right? So this becomes all my parameters, right? Now the best way is that instead of taking all these parameters and writing it over here, I can create an additional config file, YAML file, and then from that YAML file I can read it. But as I always suggest, first learn it in the baddest way and try to improve it as we go ahead, right? So here are all the parameters we are going to try. With decision tree, this is the criterion we are going to apply. Random forest, this number of estimators you can apply. You can probably apply all these things, right? Different parameters as you want. In gradient boosting, you have here basically apply different parameters, linear regression, k-nearest neighbor, everything is provided over here. Now in this evaluate model, right, what we need to do is that provide additional one more parameters with respect to this. So here we can create a variable which is called as params, and this param will basically given this parameter only, the same params only. Okay, so I will just write and copy paste it over here, and this will be my additional parameter that will be given. Now if I probably go to my evaluate model, so here I don't have that, so here I'm just going to write my param. Okay, the additional parameter that I'm probably getting. Okay, now as soon as I get it over here, now if you probably go and see his evaluate model code, so which is present in utils.py. Okay, so here you'll be able to see what is done. He's listed down all the params again. Okay, like how we listed down all the models. Okay, so here I'm just going to copy this line of code of getting all the params. Okay, so for inside the for loop only test. So here I'll just paste it. Now I have my all the parameters over here. This will be params. Okay, and then what we do, I take this particular parameter and apply grid.cv, right? You can also apply randomize CV as you want, right? So over here, I'll just go ahead and write grid.cv. So no need to write this code now. You don't need to write model.fit. So I'll comment it down. Okay, and grid.cv, obviously we have to import one more library which is called as sklearn.model-selection. So I will import this, paste it over here. Okay, paste it over here, and then we are using grid.cv. Then we did fit. After we did fit, all these parameters is not required. So in cross validation, I will give 3 just to start with 3 cross validation, and whatever are the default parameter with respect to all the other things, we'll try to provide that. Okay, so this is what we have done with grid.cv, and then after performing grid.cv, we just need to set this parameter. Okay, whatever model I'm basically getting, and then I will just try to do fit. Okay. So after selecting the best parameter, I'll just go ahead and write this one and use all the best parameters that is required, and then we'll do model fit, and then all the process will be same. See, just implemented more additional number of code of lines. Now we are properly good. Simple things, right? See, at the end of the day, if you know this much, you just need to keep on adding things. So here we have added the parameters. Here we have added the valid models with additional parameter that we are trying to give, and whatever best model I'll be getting, all the steps will be same, and I'll get my best model score. Again, a huge shout out to Ritesh Singh for giving this particular solution. I was expecting someone or the other one. A couple of people gave, but Ritesh Singh was having the best implemented solution. All I will do, I'll open my terminal. First of all, save this file. Okay, I'll open my terminal. Now inside this terminal, what I will do, I'll just close this. All I have to do, and please make sure that you are always in your VE environment. Okay. So guys, now finally we are going to run our code with respect to all the hyperparameter tuning setup. Okay. And again, I've done that setup in a data ingestion. If you remember all those things. If you have not seen my previous video, definitely watch the previous video. And now I'm just going to write Python, and I'll just try to run this src components this, and finally data ingestion.py. So my execution will probably start, and this is going to take some amount of time, okay, just for the execution. If you have a powerful laptop, trust me, it will happen fast. But since we are performing so many different kind of hyperparameter tuning, this will take time. It may take a couple of minutes, because if I probably seen the model trainer, this all trainings, right, is going to happen. So guys, so finally I executed this data ingestion file, and it took a couple of minutes to execute because we're performing hyperparameter tuning. The R square that we are probably able to get is somewhere around 87%, okay. And if you probably check out the logs and all, so here I'll just reload the logs. So inside this logs, you'll be able to see all the steps that I had actually taken, okay. Split data, this, save pre-processing object splitting, best model found on the training and data set. So finally everything is working fine. Now what I'm actually going to quickly do is that just make sure that I'll try to add it up, and so that I'll be able to give to you the git commit, right? So I'll write git commit -m, and here I'm just going to write hyperparameter training. Okay, so hyperparameter training is done, and here I'm just going to execute it. Done. Great. And finally, I'll just write git push -u origin to main. Okay. So yes, finally all the git commit is basically happened. I hope you like this particular video. I hope you like this particular implementation. This was about hyperparameter tuning. Now as we go ahead, we will try to implement the main thing, that is the prediction pipeline, right? So in the next video, this predict pipeline and train pipeline will try to complete. So guys, we are going to continue the discussion with respect to end-to-end machine learning project implementation. And in this video, we will be discussing about creating the prediction pipeline, right? So in our previous video, in our previous sections, what we have done is that we have trained our model, and with respect to that, artifacts have created. We have our 2 pickle file. One is this model.pickle, preprocessor.pickle. We completed the model trainer part. We did hyperparameter tuning. We got the best model. And then finally, now we need to implement the prediction pipeline. Understand why this prediction pipeline is important. Because this is the most important part, right? Now, I will try to create a web application, right? A simple web application, which will be interacting with this kind of pickle files, with respect to any input data that we give, okay? So let's say in our web application, we will be having a form where we'll be giving all our input data that is required for predicting the student performance, and then we'll just click on submit. Internally in the backend, we'll capture that data, and that data needs to probably interact with this preprocessor.pickle, model.pickle, and then we will try to see that whether we are able to get the prediction or not. So all these things is basically going to happen in this particular session. We are going to focus on the prediction pipeline, okay? So to begin with, what we are basically going to do is that first of all, I will go ahead and create our app.py, okay? So in this, we will be using specifically if I consider we will basically be using Flask app itself, right? We'll be considering using Flask. So first of all, I will go ahead and create my app.py file. Now, as soon as we create this app.py, remember the folder structure, what all things we did. Now this we will be making sure that we'll again follow the pipeline structure, the modular programming structure, and then we'll try to develop it. Now in the app.py, the first thing I'm going to import pickle because I may be requiring to load the pickle, load the data set itself. Over here also fine. If I don't want to do it, I can actually do it in the prediction pipeline also. But along with this, I will just go ahead and import Flask. So I'll write from Flask, import Flask. And then along with this, I will be also using request so that any post request I'll be able to capture through it. And along with this, I'll also be importing render template. Now, apart from that, I'm going to import numpy as np. Now see guys, all these things that we have learned, right? So easy it is, step by step if you actually follow things, right? Otherwise you will not be able to follow it. Trust me, because project is not just done in one day. It takes time, right? So finally I have my pandas also. Okay, again, that same problem is coming. Okay, so I will just write pd. Okay, import pandas as pd, and then I will go ahead and write from sklearn. Okay, I don't need to import sklearn. Also over here, so what I will do is that I will just say, okay, from sklearn, I will do pre-processing, and I'll import the standard scaler. The reason why I'm doing it, because I will try to use that particular pickle file. Okay, so I will go ahead and write standard scaler. If you remember guys, all these things, all these libraries needs to be written in the requirement.txt. So that is the reason I'm easily being able to import each and everything over here. Okay, now what we will go to do is that along with this, I also have to use this training pipeline. Now understand one very important thing. Inside this source right now, we have a file inside pipeline which is called as predict pipeline and training pipeline, right? So with respect to the predict pipeline, I'm going to probably see how we can do the prediction also, right? So first of all, the prediction part, I really need to create it. And then later on, we'll see that whether in this video it can be accommodated, otherwise I'll create a next video where we'll focus on creating a training pipeline. So in this pipeline, we'll focus on creating the prediction pipeline. Initially I told you we'll be creating the prediction pipeline. No. So let's focus on creating the prediction pipeline. Okay, so what I'm going to do, we'll go and start with app.py. Now here I've basically imported each and everything. Now I will go and create my app, and I'll just say, let me just go ahead and create this application name. Okay, so let's just write application. Okay, application is equal to, and I have to probably create a Flask app. So this will be my Flask app, and here I'll write underscore name. So here the Flask underscore name will basically give us the entry point where we need to execute it. Let me just go ahead and probably create this particular variable and assign it to app. Okay, because later on we need to create the route and all. So first of all, we'll just create a route for a home page. Okay, quickly, and here I will say app.route. And what we're going to basically do, just create a bracket just like a home page. And here I'm going to define my index. So if you don't know about Flask, you can definitely refer my playlist. I've explained everything related to Flask. There's a separate playlist over there in my YouTube channel. Just search for it. And then from here, I'm just going to do the return render template to index.html. Okay, so done. This is my index. Now the next thing that I'm actually going to do, let's test this whether this is working fine, and I hope it will be working fine. But before that, when we use this render index.html, it will just go and search for the template folder. And right now we don't have this template folder, so I will just go ahead and create my template folder. So it should be templates. Okay, please make sure that the naming convention is correct over here. Otherwise, you will be getting an error. And finally, I have my index.html. Now in index.html, I will just give some welcome to the homepage, something like this. Okay, to the homepage. Guys, understand I'm not that interested in probably creating the UI part and all. Okay, that was the work of the front-end engineer. But just to make it very much simple, I'm just writing all these things. Okay, so let's see this. Okay, perfect. Now this is done. I have my index.html. Now I'll go back to my app.py. Now the next thing that I'm going to write, I'll write app.route, and inside this we are going to make some predictions. So here I will write predict data. Okay, and the methods that it is going to support is basically my get, comma, post, right? So two methods is basically going to support as we usually write. And here I'm just going to write my predict definition as predict data point. Okay, so guys, remember the prerequisite is that you really need to know Flask about this. Now inside this predict underscore data point, I will be doing everything, probably getting my data and then probably doing the prediction, everything over here. Okay, so first of all I will write if my request, okay, if my request dot method is equal to, which method it may be basically post, right? So here I have to use double equal to, or if it is get, then what we need to do, if it is get, so if it is basically get, I will probably just do one very simple thing, that is return a render template, and I will return a default home page. Okay, so I'll say home.html, not index.html. Index.html is the home by default, and this will basically be my home.template, right? Home.html. Now what will be there in this home.html? The simple input data fields that we really need to provide to a model to do the prediction. Okay, so that will basically be there in this home.html. In the else part, I will basically say, otherwise instead of get, if it is not get, then it will be post, right? So here I will just say, right now I'll just write pass. Okay, because I'm going to probably write this entire thing over here, because in the post part, right, I have to probably capture the data, I have to do the standard scaling or feature scaling, and then I have to do the prediction. Okay, so to begin with, what I'm going to do inside my template folder, right, I'll create another file which will be like home.html, right? Now inside this home.html, I have already created one simple home.html. Okay, I'll just copy this entire HTML. That basically means it is just telling you to probably talk about all the fields that you have, right? So whatever fields you're selecting, like whatever inputs features that you have done, right, in drop down, I've just written that particular code in the HTML. Okay, not that very difficult. Just by seeing the output, you'll be able to understand it. For right now, this home.html is a simple HTML file which has all the data available over here. Okay, now two things that you need to do over here. One is the form action. Inside this form action, you'll just write URL underscore for, and you'll call the same data point, so same function that is present over here. See, predict underscore data point. So you'll be calling that same function over here, and the method will be post. So that is how when we do the post from that particular page, the request will come over here, and we'll be able to understand whether it is a get or a post. Okay. Now for the get, it is fine. Okay. Again, I'm telling you guys, this home.html is just a simple page, HTML page with all the fields. Okay. I don't have to worry about it because at the end of the day, this will be designed by the front end team. Okay. So just for practice sake, I'm giving you this. This is nothing but it is just having some fields. You can consider it in that way. Now in the app.py, what we are going to do in the else section, suppose if it is a post request. Now here we will start creating our data. Now for creating a data, I will first of all create my own custom class. Okay. Custom data. Now this is where your inside the source folder, right? We created a pipeline, and inside this predict pipeline was there, right? So that same function, that same class will actually be created over here. Okay, let me just show you how it will look like. Okay, so here in this predict pipeline, initially I will just import sys for my exception handling. Okay, and then I will write import pandas as pd. Import pandas as pd. Okay, then I'm going to probably go ahead and write from src dot exception. Okay, exception import custom exception. Okay, so all input, I'm importing the custom exception. This is good. Now from the next thing, I will just say from source.utils src.utils I'm also going to import one function which is called as load object, just to load our pickle file. Okay, so all these things I've imported it over here. Now the first class that I'm going to create for my prediction pipeline is like predict pipeline. Okay, this will basically be the name. The initial thing over here will be my init function. Right now in init function I don't want to initialize anything. Okay, so here I will just write self, and this will basically be pass. Okay, now by default empty constructor. Now the next thing that we are probably going to do over here is that this will basically be for my prediction pipeline. Now here I will create my class which is my custom data. Now understand what is the importance of this custom data class. The custom data class will be responsible in mapping all the inputs that we are giving in the HTML to the backend with this particular values. Okay, so here that is the reason I'm using this custom data. And here initially I will just write dev underscore init underscore. Now you know that what all features we are specifically going to use. So I'm just going to write all the features that will be used over here, right? So I'm going to say gender I require as my input feature, race, ethnicity, parental level, lunch, test preparation, reading score, writing score. So this reading score and writing score should also be an integer value. Okay, so this should also be an integer value. Okay, if I probably talk about this test preparation, it should be string. So let me go ahead and write string. And this lunch should also be string. Parental level, it's okay if you don't want to provide this value also, it's fine. Okay, but just for our sake, just to understand, we are giving all these things. Okay, so here I will just write comma. Now this definition int, I'm just writing it over here. Now all I'll be doing creating a variable by using self. Okay, so here I'll just press enter, and this will basically be my self. Okay, now what I'm doing over here, self.gender, gender, self.race, ethnicity, I'm just assigning all these values. Once we assign this, right, what will happen is that these values are basically coming from my web application, right? So if you go and see my home.html, see over here I've used gender, right? Same name will be getting mapped over there. Whatever value we select either male or female, that particular value will go ahead in that specific variable, right? Similarly, all the other things are available over here. Whatever group I'm selecting, these all values will be going over here. Okay, now this was with respect to let me close this predict pipeline. So all these things we are basically done. Now let me create one important function. Initially we have initialized this. Over here I will write definition get underscore data underscore as underscore frame. Okay, so what I'm doing is that as underscore data underscore frame. So I'm creating a function. Now what this function will do is that it will just return all my input in the form of a data frame, because we train our model in the form of a data frame, right? So what I will do over here is that I'll create a variable with try catch, and I'll create a dictionary, right? Something like this. Now see, now in this dictionary I have gender is equal to self.gender, then I have race ethnicity, which is nothing but self.ethnicity, parental level of education, self.this, self.dot, and then we are returning the pd.data frame as my data frame, right? So this in short, what is basically going to happen is that from my website, right, from my web application, whatever inputs I'm probably giving, that same inputs will get assigned, will get mapped with this particular value. Okay, all these things I could have also done in app.py, but since we are now learning completely end-to-end project in the modular way, so that is the reason we are using this specific predict underscore pipeline. Okay, so this particular method is basically done. We are very much good to go now. Now along with this, inside this predict pipeline, right, I will create one more function which is called as predict. Okay, so this predict will basically load my. So here I'm going to give my features, whatever features it is there. This predict is just like my model prediction pipe. What it is basically doing the prediction, right? So let's go ahead, and what I will be doing is that first of all, you know that how many pickle files I have, right? One is the preprocessor pickle file and one is the model.pickle file. So here I'm going to basically give my model path. So here will be my model path, and here I will write artifacts / model.pickle. Okay, and along with this I will just write preprocessor. Now this preprocessor is responsible in handling the categorical features, for doing the feature scaling, everything, right? So here I will just say preprocessor underscore path is equal to artifacts / preprocessor dot pickle, right? So here I have all these things, and then I will just load the model saying that model load underscore object. And right now I've not created this function. We'll create this function. See, load underscore object, and I'll just give my file path, and I'll say that file underscore path. Okay, with the model underscore path. Now what we are doing over here is that we are basically calling this load object function. Now this load object is nothing but it will just import the pickle, and probably it will just load the pickle file in short. Okay, so where you know where this should be created, right? It should basically be created where. So if I go inside my source, it should be created in the utils, right? So I have my component, I have my pipeline. Here is my utils.py, right? So I already have this utils.py. So quickly I will just go ahead and copy and paste it. So for doing that, I will just import. It's just a 3-liner function, guys. So here it is. So what this load object is basically doing? I think there's some indentation issue. No worries. Let me just copy it once again so that the indentation issue is not there. We'll start it from here and done, right? So here I've created my own definition of this load underscore object. What this is doing, it is just opening that file path in read byte mode, and it is loading the pickle file by using this DIL. So that is the reason we have imported this DIL. Okay, so that is what it is doing. So this load object is responsible in loading the pickle file. So that is the reason we have written in utils.py. The reason we have written in utils.py, so that this is a common functionality throughout the entire project. So now if I probably go into my predict.py pipeline, so the model path has been loaded over here, and we will also be able to probably load the preprocessor path also. So here I will again copy the entire code, the same code over here, and paste it with respect to this, and this will basically be my preprocessor. I can basically write preprocessor. Okay, preprocessor load object file model path will be preprocessor path. Okay, done. Now once we load this, now you know what we need to do first. We need to scale the data. So I will write data underscore scale is nothing but I will say preprocessor dot transform, right? And it will basically transform what? It will transform my features, right? So done. This is done. And after transforming the features, the next thing is that my model will just do the prediction. So I'll write model dot predict my data underscore scaled, right? So this will basically be my prediction, PREDS. Okay, and then we just need to return this prediction. Okay, so step by step we have done this. Along with this, I can probably include a try catch block. So quickly I will do that also. So I'll say try, so that if any exception is basically coming, we have to be really curious. We have to be really afraid of the exceptions, right? If exceptions are not coming, then something is wrong. Okay, so here is the thing, and then here I will go ahead and write my exception as E, and then I'm going to basically raise our custom exception, and here I'm going to write E, sys. Done. So exception, I've raised it. I've created a predict function. I have created the mapping variables mapping function, probably to get into the form of a data frame. Everything is done. Home.html app.py. Now in app.py, what I will do is that again here only I will be calling the custom data. The custom data, if I really want to call, first of all I need to import from src dot whether it is in the pipeline or component. So I will write pipeline dot inside the pipeline it is basically predict pipeline import. Okay, so here we are basically going to import the custom data. Okay, the another thing that we need to import over here is predict pipeline. Okay, so two things we need to import. So first of all, I'll try to make my custom data. Now inside the custom data is very much simple, guys. The same thing that we have probably done, right? We will try to just read this all the values, right? So here what I'm doing, I'm reading all the gender by using request.form.get. See, when we do the post, this request will have the entire information, right? So here we'll write request.form.get or gender, then I'll get the gender information, then I'll get the ethnicity, then I'll get the parental level, then I'll get the lunch, then test preparation course, then probably I'll get my writing score and reading score. So all these data points we will be getting over here. Okay, after we get the data points, now what we can basically do is that my prediction data point df is nothing but I will basically write data dot get data as data frames. I need to probably convert this entire data set into a data frame, and this function is basically present in my predict underscore data underscore pipeline. So here only what we are basically calling this. So this will basically return my entire data frame. So I got my data frame over here. The next thing over here is that you can also print and see how your prediction data frame looks like. And then what I'm going to do, I'm basically going to initialize my predict underscore pipeline. I'll go and create my predict underscore pipeline, and here I will define my predict pipeline, right? So I will initialize my predict pipeline, and this will then call dot. First of all, I'll just go ahead and hit my predict function. Now, once I call my predict function, here I will give my data frame. Now, as soon as I call the predict function, it will go to this function, right? It will go to which function? It will basically go to this function. And here, first of all, the transformation will happen, then the prediction will be happen, and I'll be getting all the predictions over here, right? So I'll go back to my app.py, and here this will basically be my results. Okay. So let's go ahead and return render underscore template, and here will be my home.html. I have to just return the output, right? So this will be results is equal to the results of 0, right? Because this will basically be in the list format, right? All the values will be returned over here. This is done. We are good to go with respect to this app.py. Now the next thing over here is that we need to read this value over here in my home.html. So here you'll be seeing I've created an h2 tag and I've written the prediction is this result value, right? So I'll just go and copy and paste it. Okay. So I finally got this results value over here. So the prediction will be output will be given over here, right? So yes, almost completed. Finally, I'll just run this app.py. In order to run it, I will just use this. Done. If underscore name is got underscore name, I'll just use app.run. Of course, it is this one. This is basically just going to map it with 127.0.1. Okay, with debug is equal to true. Done. So let's run this. I think this is my prediction pipeline created, guys. I know, right? So many things we did. We have an HTML page, everything, and all. So now it's time that we run this and see our 1 week of effort was successful or not. So I will just minimize this. I will open my terminal. Okay. So by default, my terminal, let's see, it should be inside my VNV environment. So let me just clear my screen. CLS. Okay. And now I'll go ahead and write Python app.py. So when this thing is getting executed, you'll be able to see this. Now I will just go and probably create a HTML, just let's call this. Okay, so I will write 127.0.1, and by default the port is 5000. So if I execute this with the home page, now everything is working fine. It is showing welcome to the home page. Now let's do one thing over here is that quickly, just a second. So finally you'll be able to see. Let's call this function /predict data. Okay. So for calling the /predict data, I will go over here. I will write /predict data. Now see how it looks like, right? So this is what I'm not done any decoration, but the main thing is that I need to give this field. Okay. So gender I'll give male, group A, bachelor degree, free, reduced, whatever, none. Score I will give something. Okay. Let's see. Some score I will be giving. Okay. Oops. Some score I will be giving. Completed. And then I will do the prediction. So once I predict it, now you can see the prediction is 65.625. So the math score that it is being able to predict is somewhere around 65.625, right? Isn't it good? We have done it right. So congratulations, guys. And see, over here, your data frame is also getting printed, right? So this was more about the prediction pipeline. Now there's some very good news for you all. I will be covering every different types of pipeline with respect to deployment and all, right? So here we have created the predict underscore pipeline, that is prediction pipeline. How to predict with respect to the data points whenever we give a new data points from a web app, how to do it. One additional thing you can also do is that you can also use Postman, right? So using Postman also you can do it. Just let's see how many of you can do this Postman work. You can probably create an API. Yes, I can also do this with Postman, give my post request in the form of one JSON format and probably do the prediction. So guys, finally we have developed our end-to-end project. Now what we are going to do is that we're going to deploy our project. Unless and until we don't deploy it, trust me, in the interviews, right, when you talk about the project, when you talk about CI/CD pipelines, when you talk about what are code pipelines, what are deployment techniques you have specifically used. So what I'm actually going to do is that going forward, we will be discussing about different deployment techniques. In this video, we're going to see how we can probably deploy our entire application into AWS Beanstalk, Elastic Beanstalk, and over there also I'll be using some code pipelines also. And again, first we'll go with the easiest one, and then we'll probably catch up the most difficult one, And I'm also going to make sure that I use multiple cloud platforms so that you get extensive knowledge regarding this. So let me go ahead and let me just see over here, first of all, what all configuration changes we really need to make. So already we have discussed about creating our prediction pipeline, everything is working fine, and deploy the code. Now here, if I probably talk about two important configuration we need to set up whenever we are working with Elastic Beanstalk, which is a kind of instance that will be provided to you where you can probably deploy your entire application. So that extension is that .eb extension. So I've created this over here. And inside this, I've created one Python config file. The Python config file is mainly to tell to the Elastic Beanstalk instance saying that what is the entry point of your application, right? That is the most important thing, that what is the entry point of your application. Now over here, by default, when I was searching in the Elastic Beanstalk documentation page, they had given this kind of configuration for that, right? So it was option setting AWS Elastic Beanstalk container that we're going to use is Python. This is specifically for containerized Python. If you're using Docker for that, there's a different process. Right now we are not into Docker. Dockers we'll discuss as we go ahead, right? Now here, and this is the most easiest technique of deployment, right? So over here you have WSGI path with application. Now this application should be your app.py name, okay? The entry point of the file, and inside this, that is the reason I updated the code to application, right? And it is compulsory that inside this python.config you give in this format only, that is application:application. But the problem over here is that I don't have an application.py file, right? So what I will do, the same application.py code, I will copy it and I will create a file over here just for my deployment purpose, which is application.py, right? And I will paste it over here, same thing, okay? So this is what we are doing, and I'll also be removing this debug is equal to true because while we are deploying, we have to always make sure that we remove that. Now these are just the two settings that is probably required to do the deployment, okay? Now how do you go ahead? So first of all, we'll go ahead and git commit this entire code. So let me quickly see this and write git commit dot, okay? So two things have been added. One is .eb extension and whatever file is present inside that, and one is application.py. So after this, what I will write git commit, okay, -m, and this will be deployment configuration that we are basically writing, okay? So deployment configuration, okay? So here it is. So your branch is up to date. Committing is done. Git commit file, untracked files. Okay, first of all, did I add it or not? Git commit. Okay, so let me just clear the screen. I think I have used git commit. So I'll add git add dot. Okay, and now if I probably see my git status, so these are the new files that are basically getting added. Now we will go ahead and do the git commit. So here I will write git commit -m, and this will basically be my deployment configuration, right? So this is the deployment configuration for AWS. Done. So this is done. Now the next thing that what I'm going to do, clear the screen. Okay, CLS, clear the screen. And one final thing that I really want to do about is that I'll try to push this code -u from origin to main. So once I push this code, you'll be seeing that my entire code will go over here. If I probably try to see my repositories, okay, and this is the ML project repositories, now you'll be able to see this extension file has got created. Okay, now this is just the requirement, and inside this I think a Python config has also been created. So yes, it has been completed. Now the next step what we'll do, we'll try to deploy this. Now please make sure that you follow this step by step. Now first of all, you need to have an AWS Amazon account, AWS console account, so that and obviously for this credit card is required. The first thing that you will be doing is that just go ahead and search for Elastic Beanstalk. Okay, so here you can see Elastic Beanstalk. It is nothing but it is run and manage web apps. So inside this I will just go and click on applications. These are the application that has been created. What I will do is that I will go ahead and create the application over here. So I will just go back and I'll create the application. Now let me just give you one example what exactly we are going to do, okay, with respect to the deployment. And I hope nobody has actually taught you with respect to writing also on the deployment part, okay? So with respect to this deployment, as I said, we will be using Elastic Beanstalk. Now this is my Elastic Beanstalk, okay? Elastic Beanstalk. Now what exactly this is just like a server or a cloud environment of some instance, right? Instance basically means this can be a Linux machine, right? And this will specifically be a Linux machine. Now here you can probably create an environment, you can deploy your code, okay? And this is basically present in the AWS, okay? The next thing that is there is basically your GitHub repository, right? Now my code is basically there in the GitHub repository, right? The only thing that is this Elastic Beanstalk requires is the configuration that is there, right? So configuration, you have actually set it up with that extension file and you have created that python.config file, right? So this too has been created over here. Now with respect to the deployment part, over here you already have the GitHub repository. In the GitHub repository, you have the code, right? And this configuration has already been made over here in the GitHub repository. Now, if I want to do the deployment, see over here requirement.txt, everything will be there. If I want to probably do the deployment from here to here, right? I have to definitely create something, right? My code should be able to go with respect to this. Any changes whenever in GitHub repository, it is happening, right? So this specific thing we basically talk about, in order to create this pipeline, right? We can use an amazing thing which is present in AWS itself, which is called as code pipeline. Now what this code pipeline is going to do is that whatever code is over here, it is going to basically commit or deploy it automatically as soon as you click a button inside this Elastic Beanstalk, which is just like a Linux machine, right? So in the GitHub repository, you have the code. Whenever there is any code changes, automatically one button will get created. Do you want to deploy this code? So once you probably click it, you will probably deploy the code in the AWS Beanstalk, Elastic Beanstalk, and then that deployment will get completed. So this pipeline that you see is basically it's a kind of a pipeline, and this pipeline we say it as continuous delivery pipeline. Okay, continuous delivery pipeline, right? Now this is a pipeline that we are also going to create it over here. So two things. First step, we will go ahead and create my Elastic Beanstalk instance, which can be a Linux machine. Here we'll also create an environment, right? And do the setup. Next thing that we are going to do is that we are going to basically create our code pipeline. Now through this code pipeline, we'll integrate with our GitHub repository, and then we will continue this deployment over here into the Elastic Beanstalk. So this is the process that we are basically going to follow. Now over here, first of all, we'll go ahead and create an application. Application name can be anything. I can basically write student performance, right? Student performance. Done. Oops, I'll just write student performance. So this is the application name that I'm going to create. Over here by default, you'll be getting a platform. Don't put any values in key value pair. So in the platform, I will go ahead and select Python. And here by default Python 3.8 is basically there, and obviously I've actually developed my entire application in Python 3.8. Okay. Now here you have two options. One is sample application, one is upload a code. In upload a code, you can probably upload a zip file from your local, or if there is a S3 bucket, you can probably put it. Okay. But right now I'll just go ahead with sample application because I need to integrate with my GitHub repository that is present over here, right? So I will go ahead and create the application now. As soon as I create the application, it will automatically create one environment also. See, creating an environment by default, environment is basically getting created, and it will probably take some time. Okay. So till this setup is done, see, now we have done this particular part, right? It is a Linux machine we got, and this particular machine is getting set up, and environment will also get created. Now we have to go and focus on creating a code pipeline and integrating with the GitHub repository. So for that, I will just open AWS again. Okay. And here I have to just search for something called as code pipeline. Now code pipeline is nothing but release software using continuous delivery. As I said, it is for continuous delivery. I'm still not focusing on continuous integration. That CI/CD pipeline we say, right? We are just right now focusing on CD pipelines. Later on, we'll go and see different techniques with respect to how to create your CI pipelines. The CD pipelines will automatically create a CI pipeline also. Okay. So I will go ahead and click on code pipelines. So code pipelines, once it opens, it looks something like this. Okay. And I will go and probably create a pipeline. Okay. Create a new pipeline. Now let me go ahead and probably write the pipeline name. So the pipeline name over here, I can basically give student performance. Okay. Same thing. And then over here you have advanced settings. Don't do anything for the advanced settings. Just go ahead and click new. Here you have a source provider. Now as I said, we want to integrate code pipeline in GitHub repository. Instead of this GitHub, some companies may be using GitLab. They may be using some other repositories like TFS and all, right? So here we need to integrate with that, right? It can be Amazon S3 also. But here I'm going to just write GitHub version 1. Okay. Now it will ask me to connect to the GitHub. So my local GitHub, whatever it is, I'll allow it to authorize. So I'll just go ahead and confirm it. Okay. And this is confirmed. Now after this, I will go and select my repository. Now what is my repository name over here? If you see ML project, right? So I will go ahead and write ML project. So this is just to connect with my GitHub, right? And branch will be main. Now this GitHub webhooks will be already there. We don't have to change this to code pipeline. Later on I'll also show you how we can do it AWS code pipeline. But here by default AWS code pipeline is only going on. Okay. Next we click on next over here. There is something called as build provider. Let's say you want to build your project before for creating artifacts and all, right? So for doing that, any steps. If you want to do that, you can probably use build provider. But over here, here you have two options. One is code build and Jenkins. Right now, I'm going to skip this stage. Later on, we'll also try to keep this. Okay. So here it says that your pipeline will not include a build stage. It's fine. Skip it. Now the deploy provider is super important. Now, what is this deploy provider? Where I want to deploy from my code pipelines, right? I want to deploy from my code pipelines to AWS Beanstalk, right? Now this is the step, right? I'm basically doing the configuration. Now this code pipeline is to deploy in the Elastic Beanstalk, right? So that is the reason we have selected this. What is the application name? Here we have created student performance. What is the environment with respect to that student performance environment? And the next, we'll just go and see whether this environment has got created or not. You need to wait till this entire environment is basically created. Okay. Now, just to understand, in the Elastic Beanstalk, if you've probably seen the application, your student performance is ready, and that is the reason now we can go ahead and deploy it. So once I click on next, now this is your entire pipeline setting. This diagram that I had drawn, right? It is basically talking about that same thing. Okay, over here you have your pipeline settings, you have your action provider. Action provider basically means where is your source, right? Adding the source. This is a pipeline setting with respect to all the default information about your Elastic Beanstalk. Then not Elastic Beanstalk, your pipeline name and all. And then finally here we have skipped this build action, but finally we are going to deploy this in AWS Beanstalk. That is what we are able to see. Now as soon as I click on create pipeline, this will probably take some time to get created. And once the pipeline is basically getting created, right? Now you'll be able to see that step by step everything. As I said, my GitHub will get connected to code pipeline. So that is where this is getting connected now. My code pipeline and GitHub will get connected, and then we'll try to deploy that in the AWS Beanstalk. So that is what this diagram actually says, right? You can probably see this diagram, right? And this is a very important diagram altogether. Now it shows that the deployment has failed. Let me go ahead and check what is the problem with the deployment. Okay. So guys, we were getting some error, but now I fixed that. Again, I saw the documentation page and all. That app.py file was there, right? I've deleted that file, and just by deleting that file, right, AWS Cloud they were actually able to deploy this, okay, in the Beanstalk. And I think the main reason is that, see, in the configuration, right, we have written application.py, but if they see app.py, probably they find some release problem. So please make sure that you delete the app.py and instead just keep application.py, which has the same code. Okay. Now you can see the deployment is done. I will just go to probably the link. So just click on this particular link, and here you go to the environment, and this is the URL that you will be able to see. So once I click this URL, now you're on the home page. You can see that my home page is running. And finally, I can just write predict data to just see that how everything is working. So guys, finally we have deployed our application into the AWS cloud, that is in Elastic Beanstalk. Again, you can probably do the prediction, you can probably use it. This is just one way of doing the deployment. Still, there are a lot of ways because we also need to discuss about the CI pipeline. We have completed about CD pipeline, right? The code pipeline itself. Now, probably if you go and see my GitHub, right, this entire build, what is basically happening, everything you'll be able to see it. Okay. So if I probably go and see in the repositories, right? If I go into the ML project, the same repository that I've given you. Okay. So here are all my files. Okay. And pull request is also there. You can see, okay, this pull request is fine. Issues is fine. Action, if I see with respect to action, okay, nothing has happened over here because since we have not again created the CI pipeline, we have just created the CD pipeline based on this configuration. Now, as soon as we create a CI pipeline, what will happen? You'll be able to see everything in this actions itself, right? As soon as I push it, and we'll be able to do the deployment. Now, let's say that I just make one simple changes, right? Let's say in this requirement.txt, I will just go ahead and add one simple library. The library can be, or I'm just adding one extra space, right? And I'm committing it, okay? Now, automatically, as soon as I commit it, now you see over here, it'll ask for the release chain. Now, see, again, that update it is being able to understand, right? The source with respect to the GitHub. Now, if I go ahead and do the release chain, the deployment will automatically happen. And over here, from the source, then again, the deployment will happen with respect to all the new code that has happened. Now, obviously, I've not added so huge changes where I've just added one extra blank. So, with respect to that changes only I'm deploying it. Again, now it is in the deployment phase and it'll get automatically deployed. So, I hope you understood how to do the deployment with respect to AWS Beanstalk. So, yes, this was it. I will see you all in the next video where we'll mostly discuss about CI/CD pipelines and all, right? Project over here, the entire project created. Now, additionally, what I need to do is that I need to create this Docker file. Okay, so Docker file I need to create over here, and this Docker file will play a very important role. Why Docker is required? Because like with the help of Docker, you'll be able to create containers irrespective of the OS that is specifically being used in the server. What we are going to do, first of all, we are going to include this Docker file. My entire project was built in 3.8, so I'm going to just mention 3.8 over here. But step by step, if you really need to understand what exactly we are doing, I'm basically saying that take a base image of Python 3.8 Slim Burster. So what will happen is that from the Docker Hub, it will bring up this Python 3.8 version of Linux machine. I'll not say Linux machine, Linux base image, so that it can be taken and can be done with respect to the deployment. It will not take machine. Okay, it will be taking a base image of a Linux environment. And we are creating a working directory called as app. Okay. Then the next step is basically copying this entire project into this app folder. Okay. The entire project into this app folder over here. And then the next step is a run command where we are updating all the packages after probably before doing the deployment in that specific server. It can be a Linux machine. Okay. And we will definitely use a Ubuntu machine over there. And then we will go ahead and do the installment of the entire requirement.txt. So once that installation takes place, this is the command that is used to run the file, that is app.py, Python 3 app.py, just specifying that we are working in Python 3 version, 3.8 version. And then the app.py is basically my file name which it will be running. It is the same project that we are actually done, student performance indicator, right? That same project. See this, guys. If you probably see over here, this is my model training, this is my student performance indicator. Everything is same. Now, additionally, what I'm doing in this video is that I'm going ahead and creating a Docker file. Okay. So here is my Docker desktop. Okay. It has been enabled. If I probably see in the images, you can see over here, I have created this Krishna 06 performance, student performance already, right? And this is the Docker that we have specifically created. Now, if I go and see, if I just clear the screen, I know, guys, this is a little bit difficult, but you really need to see this. Okay. Now here, if I probably go ahead and run Docker images, so here you'll be able to see I've already created this particular images, right? So this is building correctly, everything is happening correctly. I don't want to show you the step, otherwise it will just be a repeated step. Now, what we are going to do after we create this, the validating is happening, the building is happening with respect to my Docker. Now, the next step, what I will do, I will push this entire content into the GitHub. And then once I put into the GitHub, then we will go ahead with the deployment. So here, we probably see this. I've created a new repository called the AWS CI/CD project. And here you will be able to see my entire deployment, the commit that I've actually done with respect to the code. Okay. Now, before this commit, you really also need to understand one workflow that we have specifically created. So here is a main.yaml file. Now, please observe this workflow. Because of this workflow, only the entire deployment will happen. And this workflow has both CI/CD pipeline integrated. Okay. Observe this workflow. The name of this particular workflow is workflow only. Whenever any push is happening on the main branch, right? The readme.md file is ignored. Remaining all will be pushed into our deployment. First of all, the job that is going to happen, we will divide this. First is integration, then we push it into the ECI image, and then we have continuous deployment. These three steps are important, right, with respect to our deployment. When we say integration, in integration, this is nothing but continuous integration. In this integration, what we specifically do, it is saying that you need to run on the Ubuntu latest machine, and here it will check out the code, and I've just printed some linting repository, like eco code is there, some printing is happening. So what all things you can basically do in this integration section, you can run all the unit test cases to just see that if everything is running properly or not, right? So here we have just printed some eco command. This eco command is basically used in Linux machine. But along with this, if you really want to run any simple operation of testing all the unit test cases, you can probably do this. Okay, I will later on in my project, I will create some unit test cases, and we will try to run it in the integration environment, like in the continuous integration section. Okay, so this is my first task with respect to the job. Okay, so integration. After integration, what will happen after continuous integration? We need to build and push ECR image. Now, what is ECR image? Now, understand one thing, guys. When we create a Docker, okay, by default Docker, when we take the Docker image and push it into the Docker hub, then from that Docker hub, everybody will be publicly able to access, right, this particular Docker file. Now, if I probably show you my Docker hub, okay, I will log in and show you. See, I had actually created one Docker hub. Docker hub is just like you have all the Docker images. Whoever wants to put it over here, right? So based on that, like let's say if you have created a Docker image, you want people to use it, you can put it into a Docker hub, and this will be publicly available. Similarly, here you can see that I put this student performance app over here in the Docker hub, so that people can be able to access it. But when you're working for the companies, right? When you're working for the companies, this particular app, this particular Docker image will be private, okay? And in order to put the private Docker image, where do you put in AWS? In AWS, you specifically put that in the ECR repository, right? So AWS ECR, if I probably just go and search for AWS ECR, see what exactly is AWS ECR. AWS ECR is for build, deploy, and manages on AWS. If I see ECR, see it is fully managed Docker container to store, manage and deploy images. So whatever image is basically created over here, I will put it in the ECR repository, and from there the deployment will be done to the EC2 instance. This is how all the entire steps will go ahead. You know, so ECR is basically used to store private Docker images. So those Docker images will not be publicly available. You can still read about this more over here. Push container images to ECR without installing or scaling infrastructure, and pull images using any management tool. From this ECR, we can probably do the deployment in various instances. Like you can go ahead and do the deployment in EC2 instance and all and all and all. Okay, it has more functionality. See, access and distribute your image faster, reduce download times, and improve availability using a scalable, durable architecture. When I was working in my previous project, there also in Panasonic, I was specifically using this AWS ECR and AWS EC2 instance for doing any kind of deployment. Okay, now let's go ahead and let's see what is the next step after pushing it into the ECR. In the ECR again, first of all, you need to understand this command. It needs integration. That basically means unless and until integration part is not successful, we will not go ahead and push the entire Docker image into the ECR repository. And this is the part of continuous delivery. It will also run on Ubuntu latest. It will check out the code from the GitHub. It will install all the necessary libraries that is required to update the packages. Then it will configure the AWS credentials, whatever credential is. Now you may be thinking, Krish, how do we come to this particular credential? I will discuss about it. Don't worry. Okay, everything will be discussed with respect to the credentials, everything as such. Okay. Then I have this access key, AWS access key ID, AWS secret access key. These all are basically coming from the credentials only from the specific IAM user. Okay, I will also show you. Then we log in into the Amazon ECR, and when after logging it, we will build, tag, and push image to the ECR. Right? And for this again, you'll be requiring some output registry and ECR repository name. After that, you can probably go to the continuous deployment section. Here you can see that it will build and push the ECR image. Now this ECR image will probably run as a self-hosted app runner. I will show you that also. Then my steps are again same like checkout. Then again AWS credentials. It will log into the ECR, and then it will use this particular login ID, and then it will pull the latest image, and it will do the deployment in the EC2 instance. See, run Docker image to server users. And by using this command, we will try to run this particular Docker file, Docker image. And here you'll be also able to see this particular app name. Okay. Now you may be thinking, did I create this? No, it was already present in the marketplace of GitHub Actions, which will give you an option how to deploy from your GitHub to the ECR to AWS. Right? How do you get that? Just go to your GitHub. Okay. Go to GitHub Actions. Okay. And over here you have this workflow, right? So if you go ahead and click on new workflow, this is where you get an option. See, deploy to Amazon ECS, deploy container to Amazon ECS service powered by AWS Flagrate or Amazon EC2, right? You can probably click this and automatically you'll be getting the entire code. See, if I go ahead and configure it, you'll be getting this entire YAML file. See, this is my entire YAML file. All the steps, whatever it is doing, everything will be repeated over here. Right? Same thing. I did not do anything. I just copied the same thing and pasted it over there. Right? Now, after making all these changes, what we are going to do, and guys, let me know if you want a detailed video on GitHub Actions to explain each and every instruction over here. I will be happy to create a video on that. Okay. So now what we are going to do, we are going to just commit this entire code. I've already committed this code. So if you see in this particular repository, I'll be able to see the code. Okay. So this is my entire code with my GitHub workflow. Now let's go step by step. Okay. Now first step, I will just open my notebook. So Docker build has been checked. Okay. And then second step is that what did we do in the second step with respect to this? If you remember, in the second step, we set up our GitHub workflow. Okay. Again, understand from GitHub to ECR repository, then to EC2 instance. Okay. So this is my second step. my third step, if I probably talk about, in the third step, what we are going to do now, I'm going to create my IAM user in AWS, right? So here I'm just going to go ahead and create IAM user. So first of all, I will require IAM user. So I will just go and see. So I will go and click on users. This is my company's AWS account. So I have the entire control, so I can change it whenever I want. Okay. So I have already created this Krish Nayak IAM user. Okay. If I want to delete it, I can also delete it, and probably I will try to create it again. Okay. So I'll go ahead and write Krish Nayak. Okay. Now, why do we require this IAM, right? It is nothing but identity and access management. This is super important to understand what we can basically do with the IAM over here. Now, let's say that I am an admin, right? And I want some people to work in my team, right? And my entire company's all the deployment usually happen in AWS. So being admin, I cannot just give the entire admin access to everyone, right? So what we do is that for the people who are working in some specific cloud service, like in AWS, I'm probably going to use ECR and I'm going to probably use EC2 instance. So I will try to only give the services for this too, right? So the users will be able to get the permission and they'll be able to work over here, right? So what I'm actually going to do, I'll just go ahead and add the user. Right now I'm the admin and I will say Krish Nayak, okay? So Krish Nayak I'm giving, okay? And over here you'll be able to see, I'll go and click on next, okay? Now in which team it basically belongs, which user groups it basically belongs, okay? All the things will be there. Or copy all group membership, attach members, manage policies and inline thing, whether you want that, or add group to users or add policies directly. So I will search for Amazon ECR. Let's see whether I get anything as such. Nothing is there. Okay, I will clear the filter. Now let me go ahead and search Amazon EC2 container. Okay, I think in this we will be able to find something. So here you can see Amazon EC2 container registry full access. So please go ahead and select this. Okay, and attach this. Okay, so this one I'm going to attach. The next thing that I'm probably going to attach is Amazon EC2 full access. So here you'll be able to see container registry I require because I'm going to do my I'm going to push my Docker image over here, and AWS EC2 full access. Okay, so this too I will go ahead and clear the filters. Okay, so this too has been added. I will go and click on next, and now here is my permission summary. See, I have all these things. I have permissions that has been given over here. Okay, with respect to this particular permissions I have, and I can create this particular username. Okay, now I will go ahead and create the user. After creating the user, you'll be able to see Krish Nayak over here. Okay, and if you probably see one more thing, there will be something called as security credentials, and this security credential will give you the sign-in link, everything as such. But there will be one very important thing that you will be able to get. Okay, over here, one is called as credentials, like what kind of credential you want with respect to the access key, right? So I will go ahead and create the access key. I will write command line interface. Okay, because I'm going to use this with respect to the command line interface only, and I will go and click on next. No need to write any tag value. I will go ahead and create the access key. Now this access key will be super important because this access key only I'm going to use it. Okay, so I'm going to download this over here and keep the CSV file handy so that whenever the access key is required, I'll try to put this. Okay, so this step is done. Okay, I will go and click on done. So my user is already created. I am user Krish Nayak. Okay, now coming to the next step. Now in the next step, what all things we really need to do? Okay, I will go and search for ECR. Okay, see Elastic Container Registry. Now I'll go to the Elastic Container Registry and I will create a new repository. So create a new repository like this. Now the visibility setting will be private. Here I can probably write anything that I want. So in this case, I will go ahead and write student performance. So this will basically be my ECR URL name. Okay, and then I don't think so we need to put anything over here, but it will be private. Okay, it should not be public. So just for the private deployment. So I will go ahead and create it, and let's go ahead and create this. So this is my deployment done. Let's see. So this is my student performance. I will copy this URL over here. This URL will be super important, and I'll paste it over here. Okay, I will paste it over here. Okay, now this URL will also be used somewhere, which I'll be telling you in some time. Now once the ECR repository is created, now we will go to the EC2 instance, and I will create my virtual server in the cloud. And we'll try to integrate this with the ECR also. Let's see how we'll be doing. Okay. So here, first of all, I will go and click on launch instance. So we'll go and create one launch instance. Let's go over here and select my web server name. So my web server over here can be student performance. I can just write student performance. Okay. Student performance. So next step, I will select out of all these things, we will go ahead and select Ubuntu. Okay. And in Ubuntu, it will be 64. Now, which tier can we use? Okay. So at least my application is a little bit, so I will just go ahead and use this T2 medium. Okay. There will be some charges. So once you probably test it, please make sure that you delete this. Okay. Do you require a key pair login? So here I will be using the previous key pair, whatever is present. Okay. I'll say sample EC2. Then create a security group. Nothing is required. I will just tick this, allow HTTPS traffic and allow HTTP traffic. And after we do this, this is the configuration storage. I can also increase it based on my things. Okay. And remaining all are fine, I guess. And then we will try to launch this instance. Okay. So I will go ahead and create or click on this launch instance. Okay. So it will create all these groups and it will probably launch everything. Now, if I go and click on the instances, so this is my student performance instance. Okay, it is still in the pending stage. It is going to take some amount of time. So once it is done, once it is completed, we just need to reload this, and then I will talk about like what has to be done with respect to the next step. Okay, so yes, it is running. I will go ahead and click on this instance ID. Now here on the top, you will be able to see something called as connect to instance. Okay, so connect to instance, we will go ahead and do it. Okay, now it will probably ask you to EC2 connect. Username is Ubuntu. You can also connect to session manager, SSH client, EC2 serial console, right? So guys, now to connect to the EC2 instance, I will just go ahead and click on connect over here. Now once we do this, it will get connected and command prompt will get displayed in front of me, and here I need to do the setup. And just like I've got my server in front of me with respect to this particular command prompt, I can probably do anything that I want, like installation and all. So I will clear the screen first of all. Okay. Now it is very much important, guys. Whenever you first of all create an EC2 instance, you also need to install some packages for Docker. Okay. And before that, some packages also we need to install over here. I'll show you. So here I will give all these packages in the GitHub repository only what all things you need to do for a Docker setup. First of all, I will go ahead and execute sudo apt-get. Please make sure that you go ahead and Google it. Okay. Then you'll be able to understand everything. So with the help of sudo apt-update, what will happen is that your entire packages will be installed and it will be indexed properly. Okay. So once I do this, it will probably take some time. Based on the time, it will happen. Okay. So done. This is done. Then the next thing is that we will go ahead and also do apt-get upgrade. So just right click it and paste it over here and just press enter. So this is also done over here. I will go ahead and click on yes. And there are some 4 to 5 commands, nothing, no logic as such, no such mathematics as such as well. You're just setting up our Linux server. That's it. Okay. Now this is done. The next step over here is that this is super important. What we are doing is that we are trying to install all the necessary packages that is required specifically with respect to a Docker in the Linux machine. So there for that also 3 different commands are there. First is this one. I've executed it, and then we will go and write sudo sh get docker.sh just to make sure that all the admin access is provided with respect to this. So here the execution is basically happening. All the necessary things will get uploaded. Okay. No need to think so much. If you find difficulty with respect to any command, just go and Google search it. Okay. So yes, this will be done in some time. Let's see how much time, and then I will go and just make sure that I like sudo user mode so that I don't have to use sudo at every point of time. Okay. So this will probably take some time. Let's see how much time it will take. Done. I will paste it over here. Okay. And done. Right. So sudo mode is done, or user mode, so that I don't have to use sudo, and I'll create a new group called as Docker. Okay. And just paste it. Okay. Now this is almost done. Everything is basically completed with respect to this. Now the most important thing that we really need to do is that, see, whenever we commit in the GitHub repository, right, automatically that deployment should happen in the EC2 instance. Okay. So just in order to check whether Docker is running or not, I'll just go and click on Docker. I'll just write the command Docker and I can see everything over here. Right. This is perfect. See, our main name is sent from the GitHub ECR repository. My Docker image will go, and from the Docker image will get installed in this EC2 instance. Only that much is the entire thing that is required. Okay. Now over here, what we are going to do again. Please be patient with respect to this. Understand step by step. Commands and all, you'll be able to understand it. Now in this GitHub, right, over here, if I go to settings, in the setting, you'll have something called as action, and here you'll be having runners. Now you need to understand what is the main importance of this specific runner. Okay, this runner is not a simple thing, right? Whenever you do any kind of code commit inside this, automatically this runner should be able to get triggered and do the deployment process. Okay, so what we're going to do, we're just going to create the new runner over here. I will go and select Linux. Now once I do this, all I will be doing is that I just need to execute this line of code over there. Okay, and automatically my runner will start getting created. Okay, so now see this. Okay, I will go step by step. Okay, I'll go step by step completely. First of all, I need to execute this command. Okay, where I will be executing again in my EC2 instance. So yeah, I will go and paste it over here. First of all, let me clear the screen. All the command will be shown to you guys. Don't worry. Okay, I will write it in the GitHub repository so that you can go step by step. So I will paste this. The first command where we'll be creating this action runner. Then the next command. What is the next command over here? I will go and probably download the latest runner package. Okay, and this is how you have to do. Even in production, we do this specific thing. So it has downloaded the latest. It has downloaded the latest runner package, and then we will go ahead and probably run this for this Linux. I don't know for what purpose it is used, but again, it is basically used for the. Okay, I think we have run this, right? Yeah, if I see over here, yeah, same thing. We have run on the we have run for the packages to get the latest packages over there. Okay, then coming to the next thing, we need to validate the hash. So I will go ahead and paste it again and just execute it. Done. The execution is done over here with respect to this. And then when we go to the next step, in the next step again, we have something like this. So echo validate the hash, and then now we are going to extract the runner. Okay. So step by step, whatever is written over there, we are just going to do that. Okay. So this is also done. Okay. Then again, I'm going to go over here. Then we are going to configure this. I will go and copy and paste this. Okay. Well, now you can see the self-hosted runner registration is coming. So guys, over here you can see that it is asking enter the name of the runner group to add this runner to. Right now I don't want any runner group, so I will just press enter. Whatever will be the default, it will be taken. But here, please make sure that you give the name called as self-hosted for your app runner name. Okay. Again, understand what is the main name of the app runner. Any changes that come in the GitHub action or GitHub, it will automatically push the deployment. So here, what I'm actually going to do, I'm just going to write self-hosted. Once you write over here and once you press enter, then this will be the name of the runner. Okay. Enter additional labels, any labels you specifically want. So I probably don't want anything, so we will go ahead and press enter to skip. So runner has been successfully added. Enter the name of the work folder. So I don't have anything as such. Work folder I don't want to create. So this is done. Now as soon as I probably go ahead and see this, right, and if I just go and see this particular command, okay, something like this. I think the previous one I've already executed it. So we'll go back again over here. What is the last command that we executed? Yeah, this is the command that we executed. Now here, what I'm going to do, finally, I'm just going to paste this the next command, and we're going to just click on run. Now once this run happens, you can see it is now connected to GitHub, and it is listening for jobs. Listening for jobs basically means any push that is basically happening. Now if I go ahead and probably see in the actions, in the settings, if I go ahead and see whether there is any runner created, you can see that there is a self-hosted runner created. This is also called as the app runner, and this is in idle state, the green signal state. That basically means it is waiting for any commit to come. If any commits are basically coming, it will go ahead and push it into the EC2 instance, right? So this is the most important thing that we have done. We have set up our self-hosted runner also step by step. You need to focus on step by step. What we did in the first, we created Docker, we created then our workflow file, right? Then we went and created our ECR repository. Then we did all the necessary things that we required, right? Before that, we also created our IAM user, right? Then we went and created our EC2 instance, and similarly we went ahead, right? Now this is now in the idle state. Now the next step is that I will again go back to the settings, and I need to add some secret keys, right? So if I go ahead and click on action, I will go and add the secret key over here that is required. Right now I'll delete all these things because now my secret key will definitely change, and this I just use this for the previous example. Okay, so I will delete this. Okay, so quickly let's delete it. Okay, everything, and we need to add these 5 keys, right? What are 5 keys? First key is that AWS access key ID. Okay, AWS access key ID, what it will be present over here. So if you probably open this CSV file which we download, right? So here you will be able to see that inside the CSV file. Okay, if I expand this, here you have AWS access key, AWS access key and AWS secret key, right? So I will go ahead and copy this, and I will put it over here. So this will be my first secret. I will go ahead and add it. Okay. Now in my next one, what I will do, new key, secret key, I will go and select my AWS secret access key. So there will be another key value pair. And again, if I go over here, so this is my another one. Okay. And here I will be pasting it. Okay. So this will be my AWS secret access key. Okay. Now 2 keys has been added. The third key that I'm basically going to create is AWS region. Okay. Step by step, just name this particular key and create it. If you want to see in which instance we are running, so if you go over here, you are basically running in the North Virginia US East 1. Okay. So US East 1, I'm just going to add this over here, US-East-1. Okay. Done. I'm just going to create this secret. Now the next secret that I'm going to basically create after this 3 has already been created. That is AWS ECR login URI. And if you remember, what is this ECR login URI? This entire URL that we had actually kept or copied, right? So this is what we are basically going to do. I'll go and create my add secret. 4 keys has been added. Now the 5th key is basically our app name, which we specifically have in our Docker. Okay, so here I will just go ahead and write ECR repository name. Okay, and whatever is the ECR repository name that you specifically have. In our case, what is the ECR repository name? So if you probably go and see in your GitHub, right, or over here you can see that I've used a name called as ML test. Okay, so this is my ML test, and that is what I'm going to use over here. Okay, ECR repository name. So done. These are the 5 important keys that we need to add one by one. And once this is added, the next is that we just do the deployment. Right? So guys, now just to test, what I will do, I will just update the README file and see what I will do. Okay, I will just update the README file. AWS deployment. Okay, now see, as soon as I commit these changes, now what will happen? See, as soon as I commit these changes, go to the action page. Okay, and wait for some time. Okay, so right now I've committed it. Okay, so over here, if you probably go and see my README, AWS deployment has happened. Instead of README, also I can probably update any one of this file. Okay, let's go ahead and make sure that edit this part. Or let's see in the GitHub action whether anything has happened. Right now, still nothing has happened. Right now, what I will do is that let's see in my settings once whether my runner is idle or not. It is idle. So what I will do, I will just make a small code change. What code change should I make? I will just make a space. I will just edit this and make a extra line. Okay, I'm just simply adding something. Okay, update app.py. Now see this action. See, as soon as a little bit change in my code went, right, now already this is basically now going to get started, right? And the first step is continuous integration. Now see in continuous integration, what happened? Checkout code, right? The checkout code of this happened in lint code. It is basically just showing this lint repository, but we can run unit use test cases, which I will show you later on. Then you can see post checkout code and then completed the job. This was with respect to unit integration, right? Now with respect to continuous delivery, you can see install utilities, AWS ECR login, tag this, verifying everything from Python 3.78, everything copy command is basically happening. All the packages are getting updated, and this is how quickly things are happening now, right? And yeah, everything is working fine, I guess. Let's see after the deployment whether we'll be able to get an error. Okay, then post login to Amazon CR. Then we also configure the AWS credential. Everything is automatically running. I did not have to do much right over here. See, just one setup, and this is how in a production gate deployment it will happen, right? If you know this step by step, just follow things, right? And automatically you'll be able to understand things, right? So here it is. So done. Let's see. It'll take some time, okay? And we'll wait till then. What I will do, I will just update all these things, right? Docker setup in EC2, commands to be executed. Okay, I will just write like this, okay? And I will also give after this, Docker setup in EC2 executed. Then I will also write after this what you need to do. You need to configure EC2 as self-hosted learner, okay? Configure EC2 as self-hosted runner. So I'll just go ahead, and I've already shown you this particular step, so please make sure that you follow the video. The next one will be set up GitHub secrets, right? What are secrets you need to create? You need to create all this secrets, right? Which I've already mentioned, right? So all these things we are going to update in our README file till then, okay? And if we are updating README file, I think it will not trigger that, okay? So if you go to my repositories, CI/CD projects, deployment is happening in the backend anyhow, and this will be my README, and I will edit this and I'll paste it over here. Okay, done. So these are all the steps. I will commit the changes so that you can refer it whenever you want. So let's see how the deployment is going on. Login is also completed. Configure AWS condition. Post login, this will happen, and it will take time. So we'll wait for some time till this thing happens, and once this thing happens, we'll go ahead and test our entire application. So guys, we got an error over here in the build and tag, and I understood what is the mistake that I specifically made. So I'm just going to open my GitHub again, okay, and we'll do the setting of one of the things which I will again show you over here. So I'll go to CI/CD project, and let's go to the setting one. Inside the setting again, you will be having the secret and variables. We'll go and click this. Now with respect to the ECR repository name, okay, now this is super important, and probably you really need to understand this because over here, previously what I had given is that I've given the entire link, okay. But if I probably say with respect to this login URI and ECR repository name, so I'll just go and click this, okay. Inside this, right, the repository name, I have to probably give the student performance, okay. So this one was I had to give, but I think I gave something else, the entire link. So I'll update the secret. The another secret which was with respect to this AWS ECR login URI. Now here also what I'm actually going to do is that update with only this much URL, okay, not with the entire URL over here. So I will just go and copy this. So finally I will update this particular secret. Now what we can do again, I will go to my action and let's rerun this workflow, okay. So I will just rerun this workflow. And I'll just say that rerun all the jobs, okay, no worries. So I will just go ahead and rerun all the jobs, and then we'll try to see now if it is working fine or not. Continuous integration will happen quickly, but we'll say with respect to the continuous delivery, which was failed last time, okay. So quickly, let's see how much time it is going to probably take, and we're going to basically do this entire continuous delivery and deployment with respect to that, okay. So just let's wait, and this time I don't think so we'll be getting this error, okay. Now here only you could see, right, because of that, right, the matching was not happening. It created the Docker image, but it was not able to push it into the ECR repository. Then I understood that, okay, because of that, the problem may be occurring. So now the continuous delivery will be happening, and now here you can see login and build, it is happening. So we'll wait for some time and see whether the entire build will happen or not. So let's just wait, okay. So finally, guys, you can see all the deployment has happened. We were getting an error, and this was the previous error that we got. And again, because of the changes that we specifically did in the secret keys, we were able to fix it, right? So finally, I have my update app.py over here. Now let's go and see whether everything is working fine. In the continuous deployment, I have completed the job. The job has got completed. Now I'll go to my EC2 instance. So let's go to the EC2 instance. I'll just go and search for EC2, and we will go ahead and select our instance. Okay, our instance was 1. This is running the instance. So here I'll go inside this instance ID. I will open this address. Okay, now when I open this specific address, initially you'll be able to see that I'll be getting this error. Okay, but what you have to do, one more step, which I probably missed to talk about. You go to the security. Inside the security, just go and see the security groups, okay? And just go and click on edit in one row. So here you need to add this last one, okay? Last one. So here you need to add custom TCP 8080 because I've given a port of 8080 in my GitHub. So if you probably go and see over here with the GitHub in the code in the app.py, I've given 8080, okay? So 8080, you can see the port number is given as 8080. So that is the reason we need to mention it over here also in the EC2 instance with respect to this 8080. Okay, make sure that you select custom TCP, and this needs to be selected, right? So that it can be used everywhere. Now what I'm going to do, I'm just going to use this port number 8080 and just execute it. So still, I think there's an error. Let's see. So let me go back over here, and this will be my EC2 instance. This one, I will copy this. I will execute this and write 8080. So now here you can basically see my homepage is running. And finally, if I do /predict data, this is what I'll be getting. Okay, I can select mail, groups, and I think it'll work. And most of the end-to-end projects deployment is specifically done in this way by using the app runner. Okay, so please make sure that you follow this step properly. And finally, you can see the prediction is 44.875. So this is working absolutely fine. This is a deployment technique that we specifically use. One was very important with respect to ECR. Why? Dockers privately, if you really want to put it, Docker images, if you want to put in AWS, you have to use ECR repository. And from there, you want to pull and deploy it in the EC2 instance, you have to probably use AWS EC2 instance itself. And this will be super important because all the steps that we have done, you can explain in the interview why you specifically went with this. If you really want to scale up, right, further we can also add load balancer. And through this way, we can definitely do a lot of things with respect to this. So yes, this was the video about deployment techniques. I hope you like this. If you like it, please do make sure that you hit like button. And as we go ahead, I'll also be discussing about various ways. We'll also be discussing about GitHub Actions with Azure and many more, right? But after you do this, the next thing that you probably need to do is that just close this EC2 instance, or you can go to GitHub Action also, and whatever is your app runner, right? You can delete it or make it in the idle state. Remove runner. I'll just remove it because I don't want to this. So I'll force remove this runner, and then I will also make sure that my EC2 instance, I will just try to close this up. So when I go to my EC2 instance, I will also try to stop it because I don't want this. Okay, so action instance state, I will just say terminate instance, so that I don't want any charges to happen more. Okay, this is done. And similarly with respect to ECR also, what I will do, I'll go and select the ECR repositories, and I'll try to delete that repository. Not required because I just wanted to test it. So I will go ahead and delete it. So here I'll just try delete. So none of the charges happens, and I guess you have also seen my secret access key and everything as such. So I'm also going to go to my IAM user, and I'll just delete my user group. Okay, I'll just delete my user so that you don't check what I'm actually doing. Okay, so users here I have Krish Nayak, and we will go ahead and delete this. Confirm release a user name. Okay, KRISHNAYK. Done. So that none of the additional charges will happen. So yes, this was it from my side. I hope you like this particular video. I will see you all in the next video. Now, initially, the first step will be that I will convert my web application or whatever application I've actually created into a Docker image. Okay. Now, once it is getting converted to a Docker image, this Docker image is super important. See, this Docker image will be deployed in the server that we are going to use, right? In AWS, it was EC2, and right now we are going to use Azure Web App. In AWS, first of all, this Docker image, right, which is currently a private image because it is not a public image. You're not putting it in Docker Hub, right? We are putting it in. I don't want to make this public because this application is what I have actually developed for my purpose, right? So I don't want to make it public, right? And in companies also, whenever you develop an application, that will be private. It will not be public. Now, when this Docker image is basically it is created as a private image, and this private image will then get deployed into. Then I said that this Docker image will get deployed into something called as container registry, and this container registry is the Azure's one, okay? Like in AWS, we have ECR, right? ECR. And there also we, if you really want to upload the Docker image in AWS, we use ECR, right? Similarly in Azure, what do we use? We use Azure Container Registry. Now, once we upload this particular Docker image over here, then the next thing is that what we have to do, we have to create an Azure web app. And this web app will be just like my server, okay? Like how we have an EC2 instance. And then this container registry will be pulled over here and it will be installed over here, okay? So this is the entire funda or mechanism that I'm going to use for the Azure deployment. So we'll go step by step and we'll understand how things are done in this case. So first of all, just go to your Microsoft Azure, okay? Then here we will go ahead and write my Azure, or I will just search for container registry, okay? So container registries, okay? So I will go and click on this container registry. I will go ahead and create my new container registry. So here you can see Project Neuron is by default. You can select whatever you want. Here there will be options like pay as you all go and different services and subscriptions will be here. Then we will go to the resource group. Now in this resource group, what all things we need to add? I will create a new resource group, something like test Docker Krish. Okay, I'm just writing my name so that it will be easy for me to test it later on. Okay, so this is what is my resource group I've created and the same instance detail registry name I'm going to make. So test Docker Krish. Understand one thing is that this registry name will be holding the your entire Docker image, okay? And here I'm going to select Central US because it is near over here with respect to Central US. Then I will go to next. Over here you can see connectivity public, whatever is the default, we'll keep it. We'll also go ahead and do review and create. Now see, this entire thing will get created over here. And let me go ahead and create it. So I'm creating a container registry wherein all my Docker image that I'm actually going to create for my local, I will put it over here. Okay. So this is done. So this is probably going to take some time again, but understand inside this registry only I'm going to put my Docker image. So once this step is completed, let's see how much time it will take. The next thing after this is that I will also go ahead and create my Azure web app, but it will be with respect to container. Okay. Because now I'm not directly doing the deployment from web app. Okay. So here it is. So I will just go to my resource. Okay. Test Docker resource. So test Docker Krish is there. Here you'll be also able to find one very important thing that is called as access keys. Okay. So please make sure that for this access keys you keep this admin user enabled. Okay, this is your login server. So here you can see this will be my login server. I'll just copy this and keep it handy because I will be requiring it. Okay, and these are the steps for container registry and Docker setup and all will do. Now here, once I enable it, I will be using this password also. This password will be super important, guys. So let me keep this password because I need to give the authentication when I push my Docker image to this particular Docker repository. So sorry, container registry itself. Okay, now this is done. The step is done. We are very much good to go. Now I'll go to the overview and these all things have been completed. Now the next thing is that I will go ahead and search for Azure Web Container. Okay, so let me just go to home and let me just search for web app for containers. I think web app for containers will be there somewhere. If it is not there, we can find it out through different. Okay, not worries. I will just go ahead and create a new resource, and here I will just go and create web app. Okay, so this is my web app that I'm going to create. Again, over here, I will go and just search for this test Docker Krish. Okay, resource group with the same name already exists. It's okay. I will just go and select some different resource. Okay, let's say ML project. Here, I will just go and write test Docker Krish. Okay, this will be my website name, but I'm going to use a Docker container now. So this will be my Docker container. Here, instead of writing East US, I will just select Central US because it is near. And then I have all these values shared by default or whatever things is default. I'll just keep it like that. Okay, and we'll go ahead and go and select the next Docker over here. Inside this Docker, you have single container and Docker compose, right? So I'll go ahead and select single container. The image will be Azure Container Repository. I will go and select my registry, that is test Docker image. Okay, and I will go ahead and select my images. Right now, image is not there, right? So this is the main thing, image is not there. Now, in order to make sure that my image is not there, I have to build my image. Okay. Now, in order to build the image, what I will do, I will build it from my specific repository over here. Okay. So here I have updated the README file, what all commands you really need to write and what all things you basically need to do. Okay. So just go ahead and open the terminal. So here I will go ahead and click the terminal. Okay. So this is my terminal. And just to build the Docker, right, you really need to have Docker desktop. Okay. So if I probably show you Docker desktop, here is what is my Docker desktop available. Okay. And you can see I've already created a Docker which is called as test Docker Azure IO student performance. Okay. Now this particular Docker I will be using it, but I'll just try to show you how to create this Docker. How to set up a Docker desktop and all. I've created a dedicated Docker video where you can basically check it out. Okay. Now the next thing what I'm actually going to do over here is that in order to check whether everything is working fine and you can probably see whether Docker is working or not, you just need to write this particular command. Okay. So here you can basically see in order to test Docker. Okay. And what is the command? I will just show you. First step, okay, if you see over here in the README file, I've given all the steps. This is how we build the Docker. Docker build -t test docker.azurecr.io, right? So this URL, you know that this is the URL of my container registry, right? And this is where I've actually selected this. That is the reason I saved it, right? Test Docker Krish does this, okay? Now what will happen? This will get built in this particular name, and always make sure that you follow this name format, like your application name latest dot, okay? So I will just go ahead and copy and paste it like this over here, okay? Now instead of writing test Docker, ML test, I will just write my Docker, my application name. Let's say I will write student performance 1, okay? So student performance 1 with respect to this particular thing, I have this, okay? And this will be latest column, okay? Once I press enter, my entire Docker image will get created and it is going to take some amount of time with respect to this, okay? Now, once I do this will probably take some time. You just have to wait for things to happen, okay? Don't be in a hurry because this application is somewhere around 1.5 GB. So obviously not 1.5 GB, the Docker image that will get created will be somewhere around 1.5 GB. So we just need to wait till this entire Docker image is created, right? How to build a Docker image, you have to use Docker build -t. And the reason that I'm writing like this test Docker Krish.azure.cr.io, because see, whenever you want to create a Docker image and whenever you want to upload it in some kind of repositories or registries, right? Not repository, registry. You need to follow a naming format. First, whatever is the registry name, and then your application name, latest dot, okay? So I will just go ahead and open the terminal. So here application name, okay, and then this is basically your latest saying that this is the latest version, and from the current directory, from here it will start creating this particular entire Docker. Okay, so now here you can see that pip install is working, and we are going to install all the requirements. So this is how the entire image is basically getting created. Okay, and then what we'll do, we'll take this particular image, and then we will do the deployment by using these two commands. First of all, you need to log in into the registry, and then we need to push it into the registry. That's it. Okay, so that is what we are going to do. Till then, let this run, and we'll have a look after this. Okay, so guys, finally the Docker has been built. I will also show you it in the Docker desktop. So here you can basically see this is my Docker application or Docker image that has got imported. It is in the name of that has got created. It is in the name of student performance 1. Now what we need to do is that take that Docker image and push it inside this text docker krish.azure.cr.io. Why? Because this is my container registry. Now in order to do this, all you have to do is just write docker login, okay, and just use this entire URL, whatever URL you have over here, okay. And please, this should be with respect to your name. So as soon as you enter this, it will ask for the username and password. So go ahead, click username. Right now, I've used some existing credentials, so I think it is not going to work because the existing part I had actually deleted it. Okay. So guys, here you can see that it is not being able to log in and it is saying unauthorized authentication. So I'll go ahead and write my username again. So I will write test docker krish, the same name. I'll press enter. And the password, I hope everybody remembers what is the password that I copied it over here. So here is my entire password. I will paste it over here. For pasting, just right click and press enter, guys. That's it. Now here you'll be able to see that entire push mechanism will happen with respect to the entire repository. Now here you can see login succeeded, right? Now the next thing what we're going to do, I'm just going to push this with this name over here, right? And remember, what is this name that you could see over there? It was nothing but students, right? By mistake, I wrote students. So let's see over here. So it is nothing but, let's see over here, student performance 1. Okay. So I will go ahead and write it the same name. Okay. Student performance 1. I'm very lazy. I'm not renaming it because again, it will take much time. Now this push will basically go. And now this entire thing, the entire Docker image is getting pushed into the container registry. Okay. Which we can then later verify by just reloading this. Okay. So I'll just search for this one. Let's go over here, home. Okay. And here, once it gets logged in, I'll just go and search for the container registry. Inside this, you will be able to see that entire Docker image once it comes. Okay. So just wait till this entire that registry gets created. Sorry, not the Docker image gets pushed over here in this specific container registry. Okay. And again, this is also going to take some time because it is 1.5 GB, right? Around 1.51 GB. So again, we'll wait. Again, it'll be I think 4 to 5 minutes it will take. But in short, what all things we did, the naming convention, always remember it should be like this. Okay. .io, then your application name, then latest, then dot. Okay. This naming convention just is saying that where your container registry URL is or what your container registry URL is. So that is the reason I had actually copied it over here and kept it over here for my reference purpose. So let's wait and let's see that how much time it is going to probably take. Okay. So here you can see things are getting pushed layer by layer. It is getting passed. When we combine totally, then it should be 1.515 GB. Okay. So just wait for some time. Okay. So guys, finally here you can see my entire Docker image has been pushed to the to this container registries. So if I probably go and check inside my container registry and see the repositories, here you'll be able to see my file, I guess, the Docker image file. So if I click this is my entire information about the Docker image file itself with the latest tag. Now the next thing that I'm actually going to do over here is that create my web app. So let's go ahead and create my web app. For creating my web app, I'll just go and create a resource. I will create it over here. Okay. I will just go and select test Docker. Let's say test Docker krish. And after selecting this, I will also keep the name as student performance. So student performance. Okay. Check. Okay. Student performance check. Over here, I'm going to use my Docker containers. I'll go and select this. I will go and select my central US because that is very much near to India, I guess. Okay. Not central India, central US because I have to also access the other services. Now, the next option is that I will go ahead and select my Docker. So image, I will go and start with Azure Container Registry. My test Docker will be selected. And now here you'll be able to see that automatically the student performance will be shown. Okay. And then with respect to the networking, let's see what we can do. So this is on. We'll keep it like this. Monitoring is also no. Tags, no. Fine. Review create. Okay. So here you'll be able to see not enabled setup after application. Okay. So I will just go ahead and the continuous deployment is not enabled yet. So we'll just try to create this entire thing in the same resource group. Okay. And let's see what we will be able to get. Okay. So yeah, this is working absolutely fine. The deployment is actually happening. Let's see till then over here inside my resource group, I should be able to see all these things. So this is my resource group and you should try to see over here. So here you go. So let's search for test Docker krish. Here only you'll be able to see that web app, once the deployment happens. So this deployment will take some amount of time, not a worries to worry about anything as such. So once this deployment takes, now I can just go and click to, go to the resources and here you'll be able to see this. And similarly, if I reload this over here, so this is my container registry. Okay. And inside this only we should be able to see our web app. Let's see. Okay. The web app is over here. Okay. Now, one thing I will do with respect to the deployment center over here. Let's see. I will just load this. Okay. In deployment center. Let this get loaded. And then we are going to do some changes with respect to the setting. But let's reload this also in our GitHub action. If any changes that happen, we'll be able to see this. Okay, no changes. And the actions also still, nothing has been set up. Now what we need to do, integrate this entire code in the form of continuous deployment, right? That is what is remaining. So I will go over here. Let's see. Okay. It's getting time, like a lot of time it is taking to just to get reloaded. Let's see. And quickly we'll try to do this and we'll complete it. But at the end of the day, you just need to know about the deployment techniques. This is what is specifically used in the production environment. Okay. So again, let me go ahead and reload this. This is my test Docker. So here you can see student performance app, right? And if I probably go and see with respect to this, here you have this monitoring log capabilities, different things you specifically have, right? And let's see why this deployment slot is not opening. I'll go and click on deployment center once again. For unnecessary reason, sometimes it will take time. I don't know why. Okay, but let's see. So now it has been deploying these things. Now this all options you'll be finding. See, container registry, set up your app to pull the container image from a registry. And over here you can see that continuous deployment is off. So I will keep it to on. Okay, just to make sure that this thing is there. And then I will also go ahead with respect to the GitHub action. The GitHub action will deploy and manage your container app automatically with GitHub action. So I will go ahead and select my organization. And again, you can change the account from here. I'll select Krishna906. This is my GitHub. And from here, if you remember what is my project name, student performance Azure deployment. Okay, so I will go ahead and select student performance Azure deployment done. The select branch will be main or master, depends what branch you're working on. Azure Container Project Neuron, admin credentials there. The registry is basically this one. See, now what is going to happen is that from my GitHub, right, every time the build will happen with respect to the Docker image, it will go and replace in this particular registry. Okay, that it will put the entire Docker image in this registry, and the image name is also given, and then we'll also have this tag. Okay, and now all these things are done. I will just go and save this. Now see the magic over here. Okay, as soon as this gets saved, what will happen? See, saving container configuration and all is there, right? and see the magic now. Okay, this page will get entirely reloaded. So if I go ahead and reload it, automatically GitHub Workflows is coming and GitHub Action is running, right? So I'll just to make sure that I'll cancel this. For the first time, I don't know why 2 times it is running because I also checked previously. But let's focus on this because I cancelled one. So now my entire build has started. See, set up Docker build box, log into repositories, push container image to registry. Automatically the push is basically happening. For the first time I did it manually, but after that I think we did not have to worry about anything as such, right? So automatically the deployment is basically happening, and I also even got a mail about this deployment that is going to happen, right? So now after this build and push container image to registry is just like having your private Docker image. You don't want to make it public, right? So this will probably take time again building, because understand the entire build will happen, the Docker image will get created, it will get pushed, multiple things will happen, and whenever we make any changes, now this will automatically run. When this is automatically running, everything is getting fetched in that. Okay, so this is how it will work out, and again it will take a little bit more amount of time to push even the container image to the registry because it is somewhere around 1.5 GB, right? Exporting to the image, exporting layers. So just let us wait till some time and then we will continue. Thank you. So finally, guys, congratulations, we have done the deployment. You can see this complete job deployed completely, right? And over here, this is my URL. I will just go ahead and click this. It'll probably take some time, again, a couple of minutes, and then automatically this website will run. Okay. So in short, what we have actually done is that finally we have done a deployment. Automatically, any changes right now will probably go with respect to this particular repository. Automatically, all the deployment will get triggered and it will go to the Azure. Okay. So this was the entire steps. First couple of minutes, it'll take some time just to load the page. Okay. So we have done so many different things. We have used container registry. Understand, container registry is used to store the Docker image, right? Container registry. And then we are also using AWS, right? AWS, in that we had ECR repository, right? ECR to AWS EC2 instance, and here container registry to specifically we are exporting it to the Azure Web App, right? So these are the 2 different things that we specifically did. Now again, this will take some time to load. Let's see whether it'll get loaded or not. But I hope you were able to understand this, guys. There are many steps that we basically use just to explore this. You have to probably see all the documentation. You need to explore properly and then come to a conclusion. Okay. So here it is. Let's see over here also. So this is my web app over here. Okay. I can also click this if you want. I can click this default domain, or I can also go ahead with something like browse over here, and automatically that thing will get opened. Okay. Otherwise, I can also go copy this and paste it over here. For the first time, it will take 2 minutes. Okay. It is going to take anyhow 2 minutes. That is what I've seen earlier also. But I think this is fine enough to work through it, and we will be able to get the output. Okay. So comment down in the comment section how it was. I'm just waiting till this gets loaded, but I hope you're able to understand these things properly. You are able to understand the techniques with respect to the deployment. So see over here, finally we have got it. Now I'm going to write /predict data, and here you can basically select the gender. Here you can go and select this, and then we will go ahead and probably select this, predict the math score. So here I'm actually able to get 46.935. Great, guys. This was it. I hope you were able to understand this entire video. After doing everything, guys, please make sure that you delete the repository because I don't want you all to make sure that any charges happen by mistakenly. Okay, so I'll just go ahead and delete this particular resource group because I don't require it. So here it is. I will go ahead and delete it. So this will get deleted so that every services will get stopped. So whatever password you have seen, everything you have seen will not be able to do anything as such because all the services will get stopped in some time. Okay? Anyway, so finally, we are going to start our amazing end-to-end data science project on this cybersecurity problem. So here you can see I have just created one folder in E Drive, Udemy Final, inside that one more folder, which is nothing but network security. And from this specific folder, I am going to start my project. Now from here, I'm going to use my VS Code ID. Okay, so in order to get the VS Code ID, all I can actually do is just right click over here, and I'm getting this open with VS Code over here, right? And many people, I think you don't have the specific option when you do the right click. So what I will do, I'll just go from my command prompt. So let me just go ahead and open my command prompt. Okay, so this is my command prompt. If you're in Linux, you can open your terminal. If you're in Mac, you can open your terminal. What I will do is that I will just go to that specific drive, okay, in Udemy Final Network Security, and in this particular drive, I will go ahead and open my VS Code. So in order to open the VS Code, you just need to go ahead and write code dot. Okay, so once you write this and once you press enter, then you'll be able to see that hey, my VS Code will get opened. Okay, and it looks something like this. And I have really created a lot of projects, so you will be seeing so many things over here. I've been working parallelly in 5 to 6 projects. So now let's go ahead and talk about this network security. As I said, in this video we will be focusing on 2 important things. That is how to create your environment. Okay, and in this again we're going to use Anaconda because just with the help of Anaconda you can completely manage your environments much more efficiently. So first of all, what I will do, I'll just go over here, and if I want, I can also go ahead and open my terminal because I need to start working with my environment, right? So if you see over here terminal, so here you can see you have an option which is called as terminal. Now inside this terminal, you have a lot of different options like you have PowerShell, you have Git Bash, you have command prompt. I also work with NVIDIA projects, so over here you'll be able to see NVIDIA Workbench WSL. But in short, there's all are like default extensions that is available in my VS Code. For most of you, you may be able to see Git Bash, PowerShell, command prompt, even JavaScript debug terminal if you install VS Code over here. Okay, so all this information you will be able to specifically see it. Okay, and if you're specifically working with Mac, okay, so you may also have another terminal which is just like ZSH. Okay, but anyhow, we will try to make it as common as possible. So first of all, let's open Git Bash. Now inside this Git Bash, you will be able to see that this is like a default terminal in Linux environments, right? Linux operating system. Either you can use this if you are specifically working with Windows, so you can also use command prompt. I would suggest don't use PowerShell because PowerShell is just like giving a feeling of Git Bash in your Windows environment. So I will not use PowerShell. Either of these 2 things you can specifically use, and we'll try to see probably if I just go ahead and create my new environment from here also, I'll be using the same command. Okay, so first of all, let me just go ahead and write conda create, or let me do one thing. Instead of using bash, I will just go ahead and use command. First of all, by default, I am actually into the development environment. So first of all, let me just go ahead and deactivate this environment because I will not be using this. So let me just go ahead and write conda deactivate, and after I do conda deactivate, you'll be able to see that I'm outside my development environment. So guys, now what we will do is that we will go ahead and create our new environment, and here we are going to use conda command. And I hope you must be familiar with Anaconda. As I said, Anaconda is one of the most amazing open source tool which will actually help you to manage your projects, your packages in a much more efficient way. So what we will do is that let's go ahead and first of all create our environment. So for this again, you can probably use bash or you can use cmd command. So here we are going to go ahead and write a command conda create -p my environment name, okay, the version that I'm going to specifically use. So let's say if I want to probably use 3.10, I will go ahead and use this particular environment, okay. And again, the entire project can be developed with respect to different Python environment, but we always need to make sure that which all libraries and packages we are making use of it. Like we really need to make sure that it is compatible to at least Python 3.10. So let's go ahead and press enter. So after you go ahead and press enter, here you'll be able to see that my environment is getting created. This is going to take some amount of time. So here you can see the environment. I will just go ahead and click on yes. Why? So that will ask for the further installation things, and all the installation will specifically happen. Now here you can see this venv folder will be available, and here the installation is specifically taking place. Now before we go ahead, we also need to make sure that we create some of the files and let the environment get created. But before that, I will just go ahead and create my requirement.txt. In this particular txt file, I will be writing all the libraries that I'm actually going to use. So whatever libraries I want to really use, it will get installed as soon as I go ahead and write pip install -r requirement.txt. Okay. Along with this, some of the important file that I'm actually going to use is something like .getignore. Okay. .getignore will be super useful because when we are committing all this particular code to the GitHub, which will be our repository for this particular project, we don't want this venv folder also to go there. So what I can do is that I can go ahead and provide all my information of all the folders which need not be committed. So here I'm going to go ahead and write .venv. Okay. So .venv is, sorry, I should just go ahead and write venv folder. So this will basically be my venv folder, and I'm just saying, hey, when I probably go ahead and commit in my GitHub repository, this folder should not be taken. Okay. Along with this, quickly, what I'm actually going to do is that I'm also going to create more folders. So one more is simple README file that I really want to go ahead and create it so that I can provide all the information on the specific file. So right now I've just installed the, I've just created a new environment, and we are just making sure that we go ahead and create one specific project folder for project structure. Okay. So README getignore requirement.txt will be specifically required. Along with this, what I will do is that I'll also go ahead and create one more folder. I'll just go ahead and write github.github/workflows. Okay. The reason I'm going to write this, I'm going to probably create this particular folder. It is very much simple because at the end of the day, we will also be focusing on deployments, and for that we are specifically going to use GitHub Actions. So .github/workflows, and let me just go ahead and create my YAML file. So this will basically be my YAML file, which will be available over here. Right now, this YAML file is completely empty. And here later on we will go ahead and insert some more information in this particular YAML file. Okay. So since it is empty right now, it is just not allowing us to even see it, but we'll have a look onto that as we go ahead. Okay. But what I've done is that I've created two folders. Inside that one YAML file is also there. Okay. Otherwise, let me do one thing. Let me just remove this for now, and let me do like this. Okay. .github/workflows. Okay. I'll create these two folders, and inside this I will create one main.yaml file. Okay. So here now you'll be able to see, let's see this particular path, it is inside the workflows. Okay. Main.yaml. Okay. So you don't write along this location. Inside in this particular folder, I will just go ahead and create this particular file. Okay. Now once this is done, this is basically to write our GitHub action so that we will proceed with the deployment and all. Okay. Now once this is done, requirement.txt is also there. Okay. The next thing what we are going to do is that I'll just go ahead and prepare a simple project structure, okay, which will be important for everyone. Okay. So let's go ahead and create a simple project structure. So first of all, I will just go ahead and use one folder which is like network. Let's say I will go ahead and write network_data. Okay. And this network_data will be available over here. Inside this, I will go ahead and upload my dataset. I'll talk more about the dataset as we go ahead. Now, I will also go ahead and create one more folder outside this. Please make sure that where I'm actually specifically creating this folder, we can also automate the entire structure of creating the folder in the project structure, but I don't want to do that because if you're learning it for the first time, if you're developing a project, it's very much necessary to just understand the folder structures itself, right? And this project structure that I'm specifically using, this will be most generally used in companies based on the best practices that is specifically used. I'm actually going to create that. Then after creating this network_data, I will also go ahead and create one more folder, which will be my notebooks, where I will specifically go ahead and create my notebooks. Okay. Now, let me just go ahead and create one more folder like network. I'll just go ahead and probably name this as network security. Okay. And this network security will be there. And inside this network security, what I am actually going to do is that I'm going to create my entire project structure, right? And before I go ahead and start creating this, we will specifically follow a proper structure inside this network security because this will be our main project package. Okay. So inside this network security, what all things are basically going to come. So let me just go ahead and write one by one folder structures as we specifically go ahead and see this. Okay. So first of all, I'm just going to go ahead and create my components. Okay. The next folder that I'm actually going to create is nothing but constant. Okay. So here you'll be able to see, let me do one thing. Okay. It has basically created, let me delete this. Okay. And let me create a folder over here and let me just go ahead and write network security. Okay. Now inside this, I will just first of all create a file which is called as init__.py because I need to consider this entire folder as a package, right? And that is the reason we specifically use this _init__.py. Now along with this, what I am actually going to do is that here I will go ahead and create one folder which is called as components. Okay. Along with the components, I will create one more folder, and it should be in the same level of this network security, like constants. Okay. This constants will be nothing but any constants that I'm actually specifically defining. It will be going over here. Then again, I will go ahead and create my another folder like entity. Okay. Now after I probably create entity, what I'm actually going to do, since we need to also apply logging and exception handling, so two more folders will be created. So logging will be here and exception handling will be here. So I will go ahead and create exception. Okay. The reason of creating this folder is just to consider this like a package. Now right, we basically go ahead and import pandas as PD, right? Just consider that pandas is one of the folder, and whatever inbuilt function is present inside pandas, right? So we basically go ahead and write pd.dataframe. So dataframe will be another folder. Inside dataframe there will be another package. So we are specifically following that particular folder structure. Okay. So we have created components, we have created constant, we have created entity, exception, logging, entity, exception, logging. Exception will be for exception handling, logging will be for logging handling and all, right? Now similarly in the same folder structure, what I'm actually going to do, I'm also going to create one folder which will be pipeline. Okay. So here your training pipeline, your batch prediction pipeline, everything will be created over here. Along with this, I will also go ahead and create one more folder which is like utils. So util folder will be like any generic code that you specifically want to apply for the entire project. You can basically go ahead and create in this utils folder. Okay. And already you have this _init.py. Now one more folder that I am actually going to create over here is nothing but cloud. Okay. This cloud will be super beneficial if I really want to write any information related to the cloud or any functionality related to the cloud. Okay. So this is my entire folder structure where I have included cloud components. I have probably written about constant, entity, exception handling, logging, pipeline, utils. Okay. So this is just a folder structure. Now in all these files, right? All these folders we will try to go ahead and create our py file. That will be see step by step as we go ahead. Okay. So this was about our network security, and here you will be able to see that this network security folder has been created, and this will be my entire package name as we go ahead. Okay. Now, along with this, I also require a Docker file because I really need to create the Docker image for all these files. So there will be a Docker file over here. Along with this Docker file, you have this requirement.txt, which is basically completed. I'm also going to go ahead and create my setup.py file. This setup.py file, I will be writing some code which will be packaging this entire content itself. And anytime, any end-to-end projects that you specifically create, it is very much compulsory to go ahead and create a setup.py file, because there you'll be writing some generic information about the entire project and all, right? Like version, who's the author, and many more things. So overall, this was the most important thing. Right now, I've not created any .py file, so this is just a generic project structure. When here I have the .github workflows, I have my data folder, I have my entire project folder, I have my notebooks, I have my VNV environment, everything is over here, right? Now, the best thing is that now, since I've also installed all the requirements and libraries, I've also created my new environment. Now it's time that we close all these things and activate our new environment. So in order to activate it, I will just go ahead and write conda activate VNV. Okay. Either you can. So once we have activated the environment, now what I will do is that let's go ahead and show you some of the basic libraries that I'm actually going to use. One, we are going to use something called as python.env. This is specifically used to call our environment variables. I will talk about the importance of environment variables. But before that, let me also go ahead and create my .env file. Okay. Now I have this .env file. Inside this, if I really want to use any environment variables, let's say like it may be API key, it may be something like username or password, anything I can specifically write in this, and with the help of python.env, I'll try to call it. Along with this, I will take some basic libraries. Let's go ahead and write it down. Pandas, NumPy. These are some of the basic libraries. Let me go ahead and write PyMongo. PyMongo, I'll specifically be using the data ingestion. So right now, let me just go ahead and close this. Okay. Now here, I'll just keep it like this. Okay. And now, if I really want to go ahead and do any installation from this requirement.txt, I can go ahead and write pip install -r requirement.txt. Okay. One thing, please make sure that you save all the information. Right. Do Control S. Right. So here you also have something like save. There should be an option like autosave, right? So just go ahead and click on it so that whenever you write any code, it should be autosaved. So once I go ahead and write pip install -requirement.txt, then automatically all these libraries will get installed. But I will do this in my next video, where we will, just in this video, we are focused more on understanding about how to probably go ahead and create each and everything as a project folder structure. As you know, I've also created this .gitignore. I will also go ahead and write .env file, so that this should also not get committed, because this will have some crucial information with respect to the project details, like API key, or it can be an some username or password, some information it may be over here, right? So right now I've not installed anything as such. This is just a generic project structure that I've actually focused on. Now in the next video, I will go ahead and set up our GitHub, and then we will try to commit all this entire folder structure inside the GitHub, so that as and when I probably go ahead and discuss about the entire project module by module when we are developing, everything will be committed in the GitHub itself. So I hope you like this particular video. I'll see you in the next video. Thank you. So guys, now we are going to go ahead and set up our GitHub repository. Now, this is a one-time setup. Later on, we can go ahead and just commit it from our VS Code itself. So what I'm actually going to do, first of all, I'm going to go to our repositories. So let me go to github.com and click on your repositories. And it is basically like you need to go ahead and select on new. Go ahead and write your own repository name. Let's say this repository is like security, let's see, what is the project name that I've actually given? This is network security, no worries. So we'll go ahead and write it down, network security. Okay, and this will be my project name. I'll keep it as private because I don't want to share it with anyone, but you will definitely get the code. Along with this, I will not go ahead and select any gitignore or any license file. I can do directly from my GitHub repository itself. So let me just go ahead and click on repository, create repository. Now once you go ahead and click on create repository, here you will be able to see all these particular commands. Now, since you already have the knowledge of Git and GitHub, so first of all, you need to probably go ahead and write Git init. So once you create the repository, what I'm actually going to do is that I'm going to go ahead and open my terminal. So inside this, I'll go ahead and select my command prompt. I am already in my VNV environment over here. So the first step is basically to initialize. So let me just go ahead and initialize this Git init. And I think you can also see the command over here, right? Step by step it is showing us. So Git init. So I will quickly go ahead and write over here as Git init. Okay. So now here you can actually see that it has initialized an empty repository, right? Empty Git repository in this specific location. Okay. The next step from this particular repository shows that here you need to add some files. And here I don't need to probably go ahead and create a README file because it is very simple. I have created so many files over here, right? I have README file, I have all this folder structure, everything as such. Now, see, the most amazing thing is this, right? Once you initialize this as a Git repository, everything you can see over here, it's green color. Over here also you're able to see something in green color. Here you are able to see something in this orange color and all, right? This everything has some different meanings, right? And here also you can see notebook folder is there, but still this is empty, so it's not considering it, right? So empty folder is not considered. Why these two files or folders are not getting as a green color? Because it is very simple. Because we have created a .gitignore file and it is ignoring these two folders, right? So this two folders is also ignored. What about notebooks? Because still I have not created any file inside this, so it is not considering them. But remaining all, you'll be able to see that it is basically green, right? So it is what Git is doing is that it is tracking all these specific files. Okay. Now what I'm actually going to do is that before I go ahead, and please make sure that you don't need to send VNV and ENV folder, right? So make sure that you have all these files in the gitignore. Step by step, you'll see that, right? And I'm doing that itself. You just have to follow me how probably to work in a specific project. This is the best way. If I go ahead and probably upload the entire VNV to the GitHub repository, anyhow you're going to get an error because this size will be huge. Okay. Now the next thing what I'm actually going to do is that I'm going to add everything in my local repository, right? So I'll just go ahead and add git add dot. Okay. So here you can see this file will have its original line ending. Okay, it's saying something related to data.csv. No worries, no need to worry about that. But here you can see that every files will be specifically added. And here also you can see this network data. It has got changed into something like A. A basically means after tracking, now this file is added to my local repository, local remote repository, and it is ready to be committed. Okay. So here you can see that similarly here git add readme.md file is also done. But we have all, if I'm writing git add dot, that basically means it is going to take all the files and it is probably going to store it in the local repository itself. Then we're going to commit it. For this, we're going to write our first message git commit -m. So quickly, let me just go ahead and write it over here. So here now it's time to commit it. So I'll go to write git commit -m. This is my, or I will just go ahead and write this is my project structure, right? So let me just go ahead and write this project structure. Okay, project structure setup is done. Okay, so once I will do this, I'll press enter. Now here you can see all this files has been added. Gitignore is added, Docker file is added, phishing.data.csv is added, network security init_py is added. But here also you can see inside network security, or not all the folders are added because these are empty folders, right? So what you can actually do quickly is that you can create a _init.py file. I'll do that in the next step. But right now, first of all, let's commit it. Okay, so once you have added this for the committing phase, now these all are created in added in the commit mode. Then I'm going to create a branch which is like git branch -m main. So I'll go ahead and create my main branch. So I'll just copy and paste it over here. Let's press enter. Okay, so git branch -m main. So the same step over here. Then we are going to add the remote repository repository. So we need to add something like this: git remote add origin with whatever this repository, the git URL for my repository is this one, right? So what I'm doing is that the remote where I need to push it, right? I need to push the code. That repository link we are trying to add it over here, so that it has the reference where we really need to commit our code. Okay. So once we go over here, I'll paste it over here. This is done, and finally we go ahead and push this. So if I write git push minus u from origin, origin is our origin from where it is going, where it needs to go to our main branch, which we have added this specific data, right? This URL, right? So this URL is my location or destination where I really need to push my entire git, my code itself, right? So once I go ahead and write git push minus u origin to main, now everything is committed. Okay, and here you'll be able to see that if I reload this, my entire code will be available over here. And if I go inside network security, only underscore init.py is there, right? Now what I will do quickly, I will go ahead and again do one more step. I will quickly create all the folders, or sorry, all the files inside this network security. So inside cloud, I'm going to create a file which is like underscore init underscore .py, and you know what is the importance of this file, because this will be considered as a package itself, right? Inside the components also, I will go ahead and create the same file underscore init underscore .py. See, as soon as I created the file, right, automatically this u sign is coming. U basically means untracked. Okay, and here also I have my underscore init underscore .py. Okay, now this will also become green color. This is fine. Now here also I'm going to create. So this is my components. This is my cloud. Now let me just go ahead and create a file over here. Underscore init underscore .py. Okay. And here also in the exception, I will go ahead and create my underscore init underscore. Why this is being done? Because I can probably import any code that I write as a package in any folder as I want, right? You'll be seeing that. I will be showing you step by step, which will be amazing. Okay. Underscore init.py. Okay. So this is my logging and this is my pipeline. Underscore init underscore .py. Perfect. Pipeline is also ready. So many files is created. So I'll just close this up so that I will be able to see everything over here, right? And finally, pipeline also I created. Now I will go ahead and create my utils. In utils also, I will go ahead and create the same file, underscore init.py. Perfect. So everything is ready. Now I will give you a task. Okay. First of all, pause the video. So many untracked files are there. Go ahead and commit in the same GitHub repository. Okay. How do we do that now? Okay. So for this, I will first of all clear my screen. I'll go ahead and write git add dot. Okay. So after adding git, that basically means all the file will be in this added mode now. See A, and all are there, right? Then what we do, we commit it. So git commit -m with some message. I'll give my message. I'll go ahead and say packages created. Okay. And I'll go ahead and press enter. I'll go ahead and clear my screen. And finally, I'll go ahead and push -u origin to main, which we set it as a remote repository in the initials. That same URL is just going to go ahead and push it. Okay. So now this is pushed. Perfect. Now let me just go ahead and reload this. Okay. So now if I go inside my network security, all the folders are here. Right. Perfect. So this is the best thing, you know. And if you have done till here, congratulations, because you have done an amazing work. Okay. Because you have already everything set up over here. Right. Now this was about my GitHub repository. That setting up the GitHub repository. Now any code, any project that you specifically create, you can follow this particular structure, because in companies you also use this particular structure. But there are more to this. We will be adding more number of files as we go ahead. That we are going to see as we go ahead. Right. One more very important thing is that because later in the stages we'll also be doing deployment. So that is the reason you'll be seeing that many of the files in workflows and some more files will also be getting created outside this entire network security project itself. Okay, so that we'll discuss as we go ahead. Right now, nothing is there in the README file. Let me do one thing quickly. Let me open my README file and update some information that is good to have, right? So here, I will go ahead and do this. I'll say, hey, this is my network security project. Involves for phishing data. Okay, some information I'm just going to write. Now you know that my README file is updated. Quickly go ahead and add this. Get add dot. Right, when I'm writing add dot, it is just adding all. It is probably checking all the files which are modified or which has been added or which is not untracked, something like that, which is untracked. Right, it will just go ahead and add all those files. If I just go ahead and write get add that specific file name, then it will be in the add mode. Right, but I'm just going to do this, and this will be my commit -m. Okay, and this is my updated README file. Okay, and then I will go ahead and git push -u origin to main. Okay, and let's push this. Perfectos. Okay, so yes, this was about the GitHub repository setup. Now in the next video, we are going to go ahead and create our entire project. We'll go step by step, and we will work on all these things that we have written, like cloud, components, constant, entity, exception, logging, pipeline, and many more things. So yes, this was it from my side. I hope you like this particular video. I'll see you all in the next video. Thank you. Take care. Hello guys, so we are going to continue the discussion with respect to our end-to-end project. In this video, we are going to set up our setup.py file. Along with that, we are also going to set up our requirement.txt files. Okay. Now, why is the setup.py file really important? Because for any project that you probably develop, you really need to have the setup.py because it is an essential part of packaging and distributing Python projects. It is used by setup tools to define the configuration of your project, such as its metadata dependency and more. So these are some of the basic information that we really need to have. If you could probably go to PyPy and if you see any libraries, any open source projects available over there will be some information about that particular project, such as metadata, dependencies, which version that are, and many more things, right? So we will go ahead and set up this entire thing. And what we're also going to do is that we're also going to install some of the libraries that are there in the requirement.txt and how it is basically done. We'll go ahead and have a look into that. Okay. So first of all, what we are going to do is that over here, I will go ahead and write from setup tools. I'm going to import two important things. One is find packages, comma setup. Okay. I'll talk about this, what exactly this find packages is. This function, what it is going to do is that it's going to scan through all these folders, and whenever there is an underscore init file, right, it is going to consider that particular folder as a package. So what it is going to do over here in network security, you can see there's an underscore init__.py file. So it is going to consider this network security as a package. Inside this package, there may be multiple packages. So it will just go and scan through this entire folders, and whenever they find out this, the parent folder will exactly become a package itself. So that is how it is basically getting identified. Okay. And I'll also talk about this setup because this setup is responsible to provide all the information regarding the projects over here. Okay. That we will go ahead and see. Okay. Then I'm also going to go ahead and import from typing import list. Okay. And here we are specifically going to go ahead and write definition get_requirements. Right. So what we really need to do is that whenever we are creating the entire Python package or my Python project package, it is also necessary to install all the requirements, all the packages that are available inside the requirements, right? All the libraries that we are going to use. So I'm going to create a function which is like get_requirements, and this is going to give you in the form of list, and all the list will be in the form of string format. I'm just trying to typecast it, and let me give you some definition that we're going to probably write it down over here. Okay, it is always necessary. It is always a good idea to probably write down the definition. I'll say this function will return list of requirements. Okay, so this is the information that I have. Now I'm going to open my try block. Okay, now what we're going to do is that inside this try block, I know that I have to read my requirement.txt, right? So let's go ahead and open it. So I'll write from with open requirements. So this with open my requirements.txt file. Okay, and I will try to read this in my read mode, and I will create a variable as file. Okay, and after creating this, what I'm actually going to do is that I'm going to read line from the files, right? So here I'll write a comment. I'll write read lines from the file, and quickly let's go ahead and write lines is equal to file dot read lines, right? So I'm just going to go ahead and read these lines, and then we're going to process each line. Okay, so for line and lines, okay, for lines and lines, what we are basically going to do now is that I'm going to create my requirement variable. Okay, and I'm going to make sure that I remove any empty spaces from every line that I'm actually getting. So for that, I'll just go ahead and write line.strip. Okay, so this way we are specifically writing this, and what I'm actually going to do is that I'm going to ignore the empty lines, and I'm also going to ignore one very important thing, that is nothing but minus e dot. Okay, I'll talk about the importance of minus e dot and what will basically happen. See, in requirement.txt, after installing this all the repositories, also I have to probably write this one at the last. Okay, why I will tell you just in some time. Okay, just wait for some time, and I will explain you why specifically we are going to use that. Okay, now after we write this, and then I'm going to basically ignore the empty lines in this, and here I'm going to basically say if requirement and requirement is not equal to the same dash e dot, right? I'm saying that hey, I should not probably consider this. Okay, I should not probably consider this. Remaining all the packages that are present in the requirement.txt, I need to install it, right? So that is the reason I've written this specific conditions. Okay, so I'm just ignoring empty lines and minus e dot. Okay, if my requirement, you can just say that if my requirements and requirement is not equal to this, what I'm actually going to do, I'm going to basically take my requirement underscore list. Let me create a variable is equal to, and this requirement underscore list, I will try to initialize it somewhere over here before I write try block, and this should be my LST or LIST. It should be a list of string because that is what I'm actually going to return over here, right? I'm basically going to return the same thing over here. So this should be appending whatever requirements specifically come over here, right? So if any of this condition matches, like let's say if there is some requirements that is there is some line that I've actually got, and if it contains this particular value, I'm saying don't add this. Okay, sorry, don't add this because that's the reason I'm writing not equal to this one, right? If it's not equal to this, then only I'm going to add in this particular list, and I'm going to get all the packages that I've actually written in my requirement.txt file. Okay, so this is my try block. Here I'm going to write my except block. Except block will be nothing but file not found error. Okay, obviously if I'm not getting the requirement.txt file, that basically means I'm going to get a file not found error. I'm just going to go ahead and print over here saying that hey, my requirements.txt file not found. Okay, so here I'm going to basically go ahead and write this. Okay, perfect. And after this, after the try catch block, I'm just going to go ahead and return my requirement list. So that basically means this function is nothing but what we are basically doing in this function. We are reading the requirement.txt file, and out of this, we're not taking this particular value, you know. And why this value will be important, I'll just talk in some time because this is responsible in even triggering the setup.py file, you know, automatically building all the entire packages. So that is the shortest definition that we can specifically use. Okay. Now after this, let's go ahead and let me do one thing. Let me just go ahead and print this get requirement so that we can test it out. Okay. So let's run this in the terminal. So I will go ahead and tell this I have to be in the same folder over here. You can see that I'm in the network security folder in the same environment, right? I have to be in the VNV environment. Otherwise, it will not work. Okay. Now if I go ahead and just write Python setup.py, if I just execute this, okay, so here you'll be able to see that it is able to display all the libraries that are over here, and that is what we're printing. We're printing the requirement underscore list. Okay, so python.env pandas numpy, that is present in the requirements.txt file, and it is displaying. But we are not going to stop over here because our main aim is just not to print this requirement.txt, but instead to set up our metadata, right? So in order to set up our metadata, so I will go ahead and write setup name should be my project name, that is nothing but network security, okay, and then my version will be nothing but it will be equal to 0.0.1. Okay, let's say that I'm going to put this particular version, and later on we can probably change the version. The author will be nothing but Krish Nayak. This is my name. You can write your name. Okay, and there's some more other things like author underscore email. Let's say that I'm going to probably go ahead and write support some email ID. I'm going to write krishnayak06@gmail.com. Okay, this will basically be my email, and after that I'm also going to go ahead and see what all packages are there because that is what your setup actually requires. So in order to do that, I will just go ahead and execute something called as find packages, which will be responsible in searching all the packages, right? And that is what we have inputted on the top, right? And there is also one thing which is called as install underscore requires. Okay, and then I will just go ahead and write my get requirements over here. Okay, Now over here, you can clearly see that I've written the setup. Now this get requirement, see install requires when the package is basically getting built, it's going to make sure that it installs all the libraries, right? So this is why your install underscore requires is required. Okay. So this is the basic information about setting the file over here for the setup.py. Now in my requirement.txt, let me just go ahead and write some more, like pymongo. I'll go ahead and write certify. I'll talk about why certify is required. It is also a very important library. Okay. And let's say that I may be requiring some more libraries over here. I'll just save it like this also. So finally, guys, you can probably see from here is that after I have set up, I've written this entire code of setup.py file. In the requirement.txt, I have -e dot, right? E dot over here. Now you really need to understand what this -e dot does. Okay. See, this setup.py file, it is responsible of entirely packaging and distributing your entire Python project. It is also defining the configuration of your project such as metadata, dependencies, and more. Okay. Now if I open my terminal, okay, now see the magic. Okay, this will be the most amazing thing, and then you'll be able to understand what does -e dot actually do. So if I go ahead and write pip install -r requirement.txt, okay. So if I really want to go ahead and install any libraries, so I just need to go ahead and write pip install -r requirement.txt. So what this is basically going to do, it is going to take all these specific libraries and it's going to install it, right? But when it comes to -e dot, what it is going to do, this -e dot is nothing but in the same thing. It is going to refer to the setup.py file, right? And when it goes to the setup.py file, it is going to execute this entire code where it is going to set up the entire Python project as a package, right? But it is also going to do one more thing in this requirement underscore list, right? Underscore list. It is not going to consider -e dot. See, so that basically means this -e dot is nothing but it is referring to the setup.py file. Okay. Now let's go ahead and do this installation. Now see, one very important thing that you need to remember: all the installation should specifically happen in your VNV environment. So please make sure that you activate the VNV environment before going ahead. Now I'm going to write pip install -r requirement.txt. Now let's execute it. And right now, here if you see the Python project folder over here, nothing you'll not be able to see some additional files. But as soon as I execute this, let's see this. What is basically happening? So I have just written pip install -r requirement.txt. Now you can see over here. See what is the first thing that has basically happened? Preparing metadata setup.py, collecting python.env from requirement.txt, collecting pandas, collecting numpy, collecting pymongo and all the basic libraries, right? And then you are probably building this entire package for the distribution, right? You can see installing collected packages, all the packages will get specifically installed. So in short, what is basically happening when I wrote pip install -r requirement.txt, it is basically seeing that hey, -e dot is present. Now let's go ahead and build our package from setup.py. Now in the setup.py, when we are executing this entire code, we will be getting all the packages. We will get from all the requirements that is required from the requirement.txt, right? So here you can see everything is basically happening. Here some deprecation issues is coming. No worries, we don't need to worry about it. It is just a warning. Running setup.py develop for network security successfully installed network security. Now if I just go ahead and show you this, see this. There's so many packages that you'll be able to see, right? And this is the entire packages that is basically getting created. Okay, this is what is the package that is basically getting created. Okay, so here if you go ahead and see dependency link list, there is something called as package info. The same package info is over here. I've written metadata version, network security version is over here. Who's the author? What is the required packages? Every information is there. Requirement.txt has this particular packages. Source underscore txt has this all packages, right? All these packages are there. Then top level txt is nothing but my network security itself, right? And these are all the packages that you can see automatically it was able to detect, right? And this is the most amazing thing about this, right? So initially, it is not necessary that you need to all the time keep this -e dot. This you can actually add at the last. Okay, so when your complete project is ready and you want to create a final package, at that time you can probably put this. But this is just to give you an idea, and this is usually used when you are trying to deploy the packages into some cloud or into some as a PyPy package. You want to deploy all those information that are required. Right now, I'm just going to comment it out so that I don't require this. And let's go ahead and let's proceed with this. And this time, if I just go ahead and let me just go ahead and delete this because I don't require it. Now, if I go ahead and just execute pip install -requirement.txt, now my packages will not be installed. And now here you can see that nothing has been updated. But if you uncomment this, automatically the setup.py file will get triggered and your entire package for this particular project will be created. As said, please do this step at the last, which I will again show it to you. Okay. So till here, I hope everybody's clear. I have updated two files, one is setup.py and requirement.txt. Now let me quickly go ahead and add this. So I'm just going to go ahead and add over here git add dot. Okay. Now after adding the file, what I'm going to do is that I'll go ahead and commit it. So git commit -m setup.py file ready. Okay. I'll just go ahead and do this. Then finally it shows two file changes and you know that we have changed setup.py and requirement.txt. And finally I'm going to git push -u from origin to my main branch, right? And here you can see the push is done, right? So finally I've also pushed it inside my GitHub repository and both this file should be updated. Now what we are going to do is that in the next video, we're going to set up our logging and exception, which is really important. Without logging and exception, you won't be able to debug your applications. So logging and exception is compulsory. Now in the next video, we'll focus on doing that, right? So I hope you like this particular video. I will see you all in the next video. Thank you. Hello guys, so we're going to continue the discussion with respect to our end-to-end project. Already in our previous video, we have done this entire setup.py file. We have written the code. Now we're going to focus on creating our logging pipeline. So first of all, we'll go ahead and set up our logging pipeline and then we'll go ahead with the exception pipeline. So inside this logging pipeline, already my _init_.py file is there. So this will also be created as a package. So here I'm actually going to create a file which is like logger.py. Now after I create a logger.py file, I am just going to go ahead and copy some important information over here with respect to the code. So first of all, I'm going to go ahead and import logging, and here I'm going to probably go ahead and give my logging configuration, and this is really important because with respect to every execution of our modules, it is always necessary that we try to log some information so that if there is an error that comes, we will be able to debug it very much in a very easy way, right? Then we're going to import OS, and then from datetime, I'm going to import datetime. Okay, so this will also be imported. Okay, then I'm going to go ahead and create my log file format. So let's say my log file format will be, I'll be using a f string over here, and this will basically use like datetime.now. Okay, datetime.now, and here I will be using some timestamp like kind of thing, str f of time, and some time format. Let's say the first one will be nothing but with respect to my month, my day, year. Okay, so this will basically be the format that we're going to use it, and I'm going to use underscore in between so that you'll be able to see in that same way, right, how your file should basically look like. So %m, %d, %y, and let's say I'm also going to use %h underscore hour, then it should be coming with minutes, and then I will also go ahead and write my seconds. Okay, and this will be my log file. That will be the name that I'm actually going to use for this entire log file, and this will basically be present inside. Sorry, this bracket should be inside over here. So that will be my log file that I'm going to probably create. So this will basically be my entire log file name. Okay, and with respect to the log file name, I will also go ahead and create some log path where it should probably create the logs. So here I'm going to write os.path.join, and here I'm going to write os.get cwd get current working directory, and then I'm going to basically go ahead and execute. I'll create a folder called as logs, and this logs folder also you'll be able to see it once I probably execute this. You will be able to see that logs folder also getting created, right? And then I will also go ahead and mention my log file. Okay, so this is the logs path that I'm actually going to create, and then I'll go ahead and write os.make directory okay, make dirs, okay, and this will basically create my the log directory itself, and I'll say, hey, exist. If it exists, then not create it again. Okay, so that's the reason we say it as exist underscore OK is equal to true. And then finally, I will go ahead and create one more variable like log underscore file underscore path, and here I'm going to define my os.path.join. And finally, you'll be able to see that I'll give my logs path along with my log file, right? So this will basically be my total path that you'll be able to see, right? Once with the logs path and what file I really want to create. This file will be basically getting the recent date time format, and that will be the name that will be present in this particular file itself, right? And finally, if you know some basic idea of logging, if you've learned this in Python, we basically go ahead and set up our basic configuration. File name will be nothing but it will be log file. Then we keep a format of ASA time, line number. We provide this information, right? This basic information is required with respect to the line number. Then we have this name, level name, and message. Okay, so these all are my basic information, and here the level that we're going to basically say is that login.info. I can also set this up to login.error. It can be different information, but since my login.info, all the information I specifically want, I'm keeping it as login.info itself, right? So perfect. This is about my login details. Now what I can actually do is that I can import this log.py file, and I can call, with respect to this logging itself, right, to log any details that I really want. If I just go ahead and write login.info with the kind of message that I really want, it will be able to log each and everything, right? So this is the basic logging fundamentals, and here is the entire configuration that I've set up in this particular file, right? Now coming to the next one, that is called as exception. So here also I will go ahead and set up my exception.py. So let's go ahead and do this, because whenever we face any exception, we should be able to create our own custom exception to handle it. Okay. So for that, I will be writing this particular code. Please focus on this code. So here what I'm doing is that I'm creating a class which is called as network security exception. Here is my init method where we are taking two values like error message and error details, which is coming from system. So that is the reason we have imported system over here, and we are taking three information. This two information is not required. The third information, which talks about our execution underscore tb, which gives our entire execution details, the error details. So that is the reason we are writing error underscore details dot exe underscore info. This error details is basically coming as a sys parameter, right? It is a type of sys, basically from the system itself, right? Then my line number will be available inside this particular variable. So I'm using this line number. Even my file name will be available inside this particular variable. exe underscore tb.frame dot f underscore code co underscore file underscore name. So these are some basic information that you should definitely know related to exception, and these are the internal details with respect to exception that you really have. So this class will basically raise our custom exception, right? Then we are also overriding one functionality that is underscore str, just saying that hey, error occurred in this Python script, line number and error message, right? And format, I'm just going to use my file name, line number, and whatever error message that we're facing, right? So let's try this out and let's see whether it is working or not. Now, I also want to make sure that I probably do some kind of loggings over here, right? So loggings is also required, right? So what I'm actually going to do is that I'm going to go ahead and write from network security. I'll import the logging part. So see, logging is basically present over here, right? So if I say from network security dot logging, I'm going to import logger, right? So here I'll go ahead and write network security dot. If I go ahead and see logging, if I go ahead and write logging is my folder, right? I'm going to import logger, right? So logger is over here. I'll also go ahead and write this particular try catch block, right? So I also want to check whether logging is working. We're just testing to check both logging and exception should work, right? So here, if underscore name is equal to underscore main, try this. Okay, so here I will say logger dot info. Let's see what is the function inside this. So if I say logger, so this is my entire logger.py file, right? Now, if I really want to use the logs, how do I write it down? So I can just go ahead and write logger dot and see which function is basically available over here, right? So if I go ahead and say logging, see, because logging is one variable over here, right? Logging, right? So logger dot logging and dot. If I go ahead and write my info, right? Info, and here I will say, I'll just give some message, enter the try block. Okay, let's see whether this log will be created or not. But the kind of operation that I'm trying is nothing but 1 divided by 0, and you know that this is, if you just have a basic idea about what is division by 0 error, right? We will definitely face error over here, and this is the prerequisite that is required, at least some information about Python programming language, right? So 1 divided by 0 is nothing but it is giving you an exception over here, and with respect to this particular exception, here you'll be able to see that it is a division by 0 error. Okay, so here you can see this will be not printed. This will not be printed obviously, and here I can say that this information will definitely not be printed because an exception is basically getting handled over here. We are raising an exception, we're catching this exception, and we are raising it with the network security exception, right? So guys, now the code that I've actually written, let's go ahead and check for logging and exception handling whether it is working fine or not. Okay, so I'm just going to go ahead and open my terminal. Let me do one thing. Let me open my own command prompt. Always make sure that you have to be in the VNV environment. Now, just to check exception handling, I have to make sure that I have to run this file, right? Exception.py. Now, this exception.py is in which folder? It is nothing but inside the exception folder, right? So what we are basically going to do is that first of all, I will go ahead and go to my network security folder, right? So if you go ahead and see logging exception is inside this network security folder, right? So I will say, hey, cd network security, right? I'm going to go inside this particular folder, and then I'll go ahead inside my exception folder. After going inside my exception folder, I will go ahead and write Python exception.py, right? Now this is the first issue. Okay, I've got an issue and it's showing, hey, I'm getting an error in line 18. Okay, so exception is basically coming in line 18. What is that? Okay, in this particular line, in my logger.logging.info only, I'm getting an exception. Even it did not go to this particular line. See, as soon as I got error in this line, you can see over here, I'm getting type error over here, and it shows this exception message. Error occurred in Python script so and so, line number 18, and error message is int object is not callable. Okay. Now let's understand what is the mistake that we have done. Okay. Now I'm not going to edit this part because this is really important, right? So I made one mistake. Instead of writing capital info, I have to write small info. Now this should be running fine. Okay. Now I fix this exception. Okay. But what about the next exception? So here initially we got this exception. It came outside of this, and it was caught by our network security exception class that we defined. And this is our own custom exception that we have defined, right? Now let's go ahead and run this. Okay. If I go ahead and run Python exception.py, now you can see that I'm getting a division 0 by error. Now with respect to this division 0 by error, I can see that error occurred in this particular file name, and all the things is basically there, and it is nothing but it is also displaying the error message. How this is getting displayed? Because we have written a custom function over here, right? So that to display whenever we get an exception, how the message needs to be displayed, right? Now this is fine. That basically means my exception is basically getting handled. It is also raising. It is also displaying the proper message. But still, we did not find out whether this logging info has been put up in form of some file. So here you can see in our exception folder, there is one logs file. Now inside this logs file, you'll be able to see, hey, this is the information over here, enter try block, and that is what we were trying to display over here, right? Now the thing is that the logs folder has created inside this exception folder. Why? Because we are executing the code inside the exception folder, right? We were trying to run this exception.py. And here you can see that this is the log file that is getting created. So both the functionality is working. It is not necessary that we always need to run the file inside the exception block. When we create our final project, we will be running the file outside this particular block, right? My training pipeline should get initiated from outside this project, and then it should probably go inside that. And wherever we are calling exception handling and logging, we can basically use that. Okay. So right now everything is working fine. What I'm actually going to do is that since this logs folder is no required, because when we work for the entire project, it will be created in the outside location. Okay. But here we have tested both the logging and exception is working absolutely fine. Okay, so this was our exception handling, everything as such. I will remove this code because we will not be running this particular code. If you want to run it, you can just go ahead and just write this particular code. Okay, so I'll just keep this and make sure that I'll commit this so that you can go ahead and check it out. Okay, now quickly I will do cd dot. I'll go back to my main parent folder and then let me just go ahead and commit this. Git add dot git commit -m exception handling and logging completed. Okay, then finally Python git push -u from origin to main. So here you can see that that push has basically happened, right? Now I can go ahead and check up in my GitHub. I think it should be there, and it will be definitely there. That is the reason it is showing me successful. So I hope you like this particular video. Here in this video, we have discussed about both logging and exception. The kind of code that I've written, I've also explained you with respect to exception. This is the generic code that we basically write, right, with respect to the configuration, and it looks absolutely fine. And this is my normal exception. Remember how to probably import this and how to probably use this entire logging in short, right? So this was it from my side. I will see you in the next video. So guys, we're going to continue the discussion with respect to our project. Now this is a generic project architecture that you will probably see, for implementing this entire project, and this many number of modules we are going to go ahead and develop as we go ahead. Now the best idea about implementing this particular project is to develop the modules step by step. Okay. Now over here you will be able to see that fine, we are creating a module. So here you can see that there is something like MongoDB database. So this is the database from where we will start our data ingestion step, right? Now over here our data will be initially present, right? And then we go to data validation component, then we go to data transformation component, then model trainer, model evaluation, and then we finally push our model to the cloud, right? So the cloud, it can be AWS, it can be Azure, right? It can be different clouds, right? Now, before we even go ahead and understand how we can implement it with the help, like how we can implement the data ingestion part, it is really important that you need to understand how the data will be coming into this MongoDB database, right? As a data scientist, most of you, you will be working in any of the specific components and you'll be developing a project. But you really also need to understand how my initial data will be specifically coming to the MongoDB database. And that is the reason you really need to understand something called as ETL pipeline, which is really important for you all to understand, right? So what exactly is ETL pipeline? Okay. Now, in order to make you understand about ETL pipeline, the full form of ETL pipeline is nothing but extract, transform, and load. Okay, so this three components actually make up an entire ETL pipeline. And since I'm discussing with respect to this particular project architecture, before our data enters into the Mongo database, right, MongoDB database, as a data engineer, you really need to create a ETL pipeline also. And specifically in a data science project, there will be many people who will be working. Now, in order to explain you about ETL pipeline, there are three important things that you really need to know. First is about source. The second thing is about destination. Now, between the source and destination, something is happening. What is happening? A step which is basically called as transformation. Transformation. Now, in our project, you will be seeing that we have created one folder where we'll be specifically putting our CSV file. So that is our data set. Now in this particular problem statement, my data set is present in my local folder, okay, in my local machine itself, right? And from this local machine, I will pick up this particular data set. I will do some basic pre-processing, whatever is required, basic pre-processing. And this basic pre-processing involves cleaning raw data. Okay, it will be involving cleaning raw data, some of the basic cleaning process and transformation process. If I also want to convert this data into some other format like JSON or anything, I will be specifically doing in this particular process that is called as transformation. Then when we go to the next step, right? So from the source, we take up this particular data, we'll be doing some kind of transformation techniques, and then after doing that, we will save this in some destination. Now you really need to understand what exactly is the source. Now in our case, since we are developing this particular project, our source will be our local, right? From our local, we will be reading our CSV file. We'll be doing some kind of transformation, we'll be doing some basic pre-processing, and after that we'll try to convert this into JSON, and then we will save into some destination database. Now in this scenario, my destination database is nothing but it is MongoDB. And this MongoDB, here you can see, right, my MongoDB database, it is present over here. So that is the reason I told that before this, how my data is basically getting inserted into the MongoDB database. You really need to understand this. Now why this ETL pipeline is so important? Because see, in a real world project, whenever you work in any companies, this data will be coming from various sources. It will not just be one source. In my example, I'm just taking it from the local database or local source itself. But if I probably consider a real world scenario, my data may be coming from APIs, it may be coming from some S3 buckets, right? It may be coming from some paid APIs. It may be coming from some other source itself. So there may be multiple sources, right? So it may be coming from there, right? And in our project, you need to combine all this particular data, right? And when we combine all this data, we do some transformation technique. And let's say my main aim is basically to convert this into JSON and store it in some database itself. Now my database may be MongoDB over here. If you're working in AWS, it can be AWS DynamoDB. It can be various databases like MySQL, right? It can be Amazon S3 buckets also, right? It can be different data sources. Now in our example, I'm obviously picking up the data set as a CSV file for my local and doing some basic transformation and storing it in the MongoDB. But in a real world scenario, you may be having different data sources itself where you initially take this. And that is the reason we say this as extract. See, this step of extracting from the source, right? So this basically becomes extract. This is nothing but transform, and this is nothing but loading into our database like MongoDB or any other databases that we are specifically using. Again, to repeat guys, this process is entirely done by the data engineering team, but I'm explaining you this entire concept, right? Now what we are going to do is that in our next video, in the upcoming video, we are going to implement this entire ETL, where we'll be reading this data set, we'll perform some transformation, and finally we'll convert this into JSON and load it into our MongoDB database. Now this MongoDB that we're going to create, it will be in Atlas Cloud. So here you'll get an idea like how to probably go ahead and upload this entire data set into the MongoDB itself, right? So this small pipeline I'll try to create in the next video, but again, to just give you an idea, this entire sources may be different, right? It depends on the use cases that you're probably working with, okay? And some more sources if I really want to add, there may be some internal database within the company, there may be like multiple databases maybe there, and we need to combine all those data sets. That is required to solve this particular problem statement, right? This particular problem statement or the network security problem statement that we are working on, right? So I hope you got an idea with respect to the ETL pipeline, and that is the step before we insert our data into the MongoDB database, and then after we do that, we can actually go ahead and start our data ingestion, data validation, data transformation, and other steps. So I hope you like this particular video. I will see you in the next video where we'll implement this basic ETL pipeline where we will perform all the steps. So yes, this was it. I'll see you in the next video. Hello guys, so we're going to continue the discussion with respect to our end-to-end project. As I said that before our data gets into the MongoDB database, what we really need to do is that we need to create a small basic ETL pipeline, and this ETL pipeline, what it should do is that in my local dataset, which is available, right? And the dataset that we are specifically talking about is this fishing data.csv, which has so many number of records, okay, over here. If you probably go ahead and see this entire dataset, it is somewhere around, I don't know, like it's a huge dataset, right? If you probably go ahead and see there are more than 11,000 records, okay? Now, inside this dataset, you also have so many number of features. And the main aim of this particular data is that we need to create a machine learning model, let me just zoom in, right? We need to create some machine learning model wherein whenever I get this specific dataset from a specific website, I need to probably do a prediction whether the website is fake or whether it is a malicious website or not a malicious website, right? So that is our entire problem statement. Now, this particular dataset is basically present in my local machine in the same folder that is network_data, right? So if you don't have this particular file, I would suggest first of all download the file and probably upload it inside this particular folder, network_data. Now, we will try to create an ETL pipeline wherein we will read that particular dataset, we will do some kind of transformation, and then we will convert into a JSON, and finally after converting into a JSON, we'll insert the entire database data in my MongoDB database itself, right? And right now the MongoDB database that I'm going to use, it will be in, I think everybody has heard about this MongoDB Atlas. Specifically, MongoDB will be in cloud, and Atlas actually provides some free account to create your MongoDB database and use them for some number of requests. So for our project, I think the free account will be more than sufficient to start with. So in this video, what I'm going to do is that first of all, we'll go ahead and set up our MongoDB Atlas account, okay? So let's go over here, let's go to the browser. So first of all, just go and search for MongoDB Atlas, okay? So once you search for this MongoDB Atlas, you'll be getting this first link. Click on this, okay? And I think for the first time, it will tell you to create an account, okay? So first, what you can do is that you can click on Start Free. So once you click on this, you can go ahead and sign up with Google. Once you go ahead and sign up with Google, here you will be having an option to sign up with any of your Gmail account that you have. So I will just go ahead, and right now I think in my previous account it has been logged in. So I'll just log out over here, and let me again click on Sign Up, okay? Now this time I'm going to sign up with Google, okay? And let's take one of the email ID which I have never created an account before. So I'll go ahead and click on Continue, okay? So once I go ahead and click on Continue, here you can see please acknowledge the following terms and conditions to finish the account. So I will just go ahead and click on Submit, okay? So once I go ahead and click on Submit, you will be able to see that I will be getting a new account itself over here. Use your account and deploy a cloud database with MongoDB Atlas, contact support, anything by default it's showing me. You can provide some of the important information over here. It is up to you, whatever things you want to put, just go ahead and put it. So let's say I want to work with Python. I want to just select any information I'm just trying to select, okay? So I'll go ahead and click on Finish. Now fine. Once you go over here, it will first of all tell you to deploy a cluster. Now here you have different options. One is the M10, one is serverless, one is M0. I'll go ahead and select for M0 because here you'll be getting a storage of 512 MB RAM. The RAM will be shared and it is for free, okay? Let the name be cluster 0, it's fine. I've selected AWS by default. I will just go ahead and click the create the deployment. So once you create the deployment, so by default, you will be able to see that you'll be getting something like this, okay? Connect to cluster 0. Now for the first time, you need to go ahead and create your database user. Let's say that I've created one of the database user, which was given by default over here. You can also go ahead and create another user later on, but it's okay. Now after this, just go ahead and click on choose a connection method. Select your first option that is called as drivers. Here I'm going to probably say I want Python 3.6 or later. And first important installation that you really need to do is this one, right? PyMongo. So this shows all the steps, what you really need to do over here, right? And you can also go ahead and click on this one, view MongoDB driver installation, which I will not be requiring, but you can just go ahead and see this, okay? Now here, let me do one thing. Let me go ahead and take this entire PyMongo over here. Let me update this in my requirement.txt file, okay? So now I will go ahead and create, I'm already there in my requirement.txt. I will go ahead and update my package over here, PyMongo, SRV, and I will also go ahead and install PyMongo, okay? So both of them I can specifically use, okay? It is not necessary to import it, but I am just doing this so that, if any dependency is missing, that can also be installed, okay? Now, once this is done, I will click on Done, okay? So once we do this, here you can see that if I click on database right now, it's still trying to create. I think it is getting created. Okay, so we'll just wait for this clusters to get created. I think once the cluster is created, see your cluster is being created, it'll take some amount of time. So let us wait till the cluster is getting created because after that, I really need to talk about some of the very important steps. Okay, what you really need to follow. Okay, so let's wait for some time and then let's wait till this cluster is created. And for you also, it may take some amount of time. Okay, amazing. Now my cluster is basically getting created over here. I will click on connect again. I will go to driver. I will select 3.6 or later. Now I can go ahead and see my view full code sample, right? Just to check whether my connection is working or not. And for this, I really require PyMongo. Okay, PyMongo is a library which will actually help you to connect with the MongoDB itself, right? So this is my entire code, and it is telling you to probably upload my password over here, right? Like whatever is the DB_password, and this is my entire MongoDB connection, right? With cluster 0, all the information. So I'll copy this entire data, okay? And what I will do, I will go back to my code. I will create a file. Let's say the file name that I really want to create over here, since I need to push all my data over there in my MongoDB database. So I will say, hey, push_data.py, okay? Now here I'm going to copy and paste this entire code. Now the next thing is that we need to update this DB_password. Okay, this is really important. And as I said, I have to already install PyMongo. And if you remember in my requirement.txt, I have imported PyMongo already. I've installed this, okay? And here also you can see this SRV is equal to 3.6. So I will remove this. So PyMongo is already installed from my requirement.txt. Now instead of this password, I need to upload the password that I had created over here. Now where do I see the password? Let's see this, okay? So if I go ahead and click on, so let me just hide this because I don't require it. If you go ahead and click on quick start, here you will be able to see username and password. Right now, Crochet Technologies there. I'll just go ahead and edit this password, okay? Now just to show you the password, what I'm writing, I'll go ahead and write admin@123. Okay, so this is my password. The password contains special characters which will be URL encoded, or let me just go ahead and make it much more simpler. Capital ADMIN123. I'll go ahead and update the password. The password has got updated. Now I'll go back to my code. I will paste my password over here, okay? Password over here. Now this code that you'll be able to see is that we're just trying to check whether there is a successful connection with respect to the MongoDB or not. And for this, we basically create a Mongo client for this URI, right? This URI is nothing but the connection of my MongoDB database, okay? And the remaining code is basically just checking whether you're able to ping the database or not, okay? So what I will do, I will go ahead and open my terminal and let's check this, whether it is going to work fine or not. So I'm in my cmd command prompt, okay? I'm in my network security over here. Now what I'm going to do, I'll just go ahead and write Python test, push_data. push underscore data.py. Okay, so once I execute this, here you'll be able to see that ping your deployment is successfully connected to the MongoDB. So this is perfect. That basically means with the help of this connection that you have, right, I'm able to connect to my MongoDB database. So this is my main details, and this all details should not be hard coded in our file. So what we really need to do, we really need to create our .env file. Now inside our .env file, what we are basically going to do is that we are going to use a key, that is MongoDB URL. Let's say I will create a MongoDB URL key, and I will save my password over here. So I'll go ahead and write equal to, and then if I go back to my push data, I will be taking this entire string and I will be putting it over there so that I'll be able to connect to my MongoDB database. Okay. So once this is done, this is my MongoDB URL, everything is ready, and I'm good to go with respect to this. Now, in my next step, after probably doing the entire MongoDB connection and all, testing it is working absolutely fine, and I hope everybody knows how to get this particular code, right? So let me just remove this code and create one more file. So I'll say test underscore MongoDB.py. Okay, so here I'll keep that particular code so that you can actually refer it on the later stages. But please make sure that you write your own password over here, right? So here, what I will do, I will just go ahead and write my password. You can update it over here, right? So this will basically be my details of the password over here. Based on your password, you can basically write here your user name details or whatever user you have created, it will be there. Okay. Now this was about the test MongoDB, and it's working absolutely fine. Now in my next video, what I'm actually going to do is that whatever code of reading the data set, converting it into a JSON, and uploading it into the MongoDB, that code will be written in my next video, where I will be completing this ETL pipeline altogether after writing the code over here with respect to push underscore data. So I hope you like this particular video. This was it. Right now I'm not committing it. Once I write all the code with respect to push underscore data, then I will try to commit the code, right? So yes, I'll see you in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to our end-to-end project. And if you remember, in our previous video, we have already set up our MongoDB Atlas Cloud. And then now what we're going to do is that we're going to implement this ETL pipeline wherein we will read the dataset from our source. We will try to convert this into JSON, and then we will push it into the MongoDB. Okay, so all the steps will specifically happen over here, and we have already created a file which is called as push underscore data.py. So here we are going to write our entire code. So how do we go ahead and write it down? Okay, so first of all, we are going to import OS. I will also import OS. Then we'll go ahead and import sys. And apart from this, we'll go ahead and import JSON. Okay, then from from .env, I'm going to import load underscore .env, right? So the load underscore .env will be specifically used so that I can call all these environment variables, and I require this environment variable MongoDB URL so that I know where I really need to push the data, right? So that's the reason I'm actually importing load underscore .env. Now what I can actually do is that I can just go ahead and initialize this, and let me do one thing. Let me quickly go ahead and create my variable MongoDB URL, okay? And inside this particular variable, right, I am going to just write os.get env, okay? That basically means get the environment variable, and my variable name is nothing but it. You can actually find the environment variable from this MongoDB URL itself, right? So here I'm going to go ahead and paste it out. Once I get this, I can go ahead and print my MongoDB URL. Okay, so let's test this, whether we are able to probably pull the environment variable or not. Okay, so for this, again, I will go ahead and open my terminal. I will go into the same terminal which I was specifically working before. And please make sure that you keep this autosave option so that the file gets continuously updated as soon as you write the code. Right now, I'm going to just go ahead and write Python push underscore data.py. If I execute it here, you can see now I'm printing the entire environment variable, which is absolutely fine. And the password is also admin123, which I have actually created for my MongoDB, right? MongoDB cluster. Now this is perfect. Till here, we are good to go. Now what we are going to basically do is that we are going to import two more libraries. Import certify. I've already told you before I have installed in the requirement.txt, I also return a library which is called as certify, right? And what exactly the certify is, I will try to explain you. But before that, we'll go ahead and write certify.where, okay? And I will explain you both the line of the code, okay? Now understand one thing. If I probably talk about certify, right? The certify is a Python package that provides a set of root certificates. Okay, it is commonly used by Python libraries that needs to probably make a secure HTTP connection. And right now I'm also trying to make a HTTP connection, let's say, to my MongoDB database, and I'll be using some of the libraries like request and all, right? So this is just to ensure that they trust only this certificates verified by the trusted certified authorities, right? So whenever we are trying to communicate with the MongoDB, if this library has been imported, it knows that it is a valid request that is probably being made. Okay, and if I talk about this particular line, right? So certify.where, so this line retrieves the path to the bundle of CA certificates provided by certify and store it in the variable CA. So CA, if I probably talk about what exactly CA is, okay, certificate authorities, okay, and these are nothing but the trusted certificate authorities, and this is usually done, for SSL or TLS connections to verify that the server you're connecting to has a trusted certificate ensured, right? So this much knowledge is more than sufficient for you to probably understand this, okay? And we will be using the certificate for further requests and all that we'll see as we go ahead, okay? Now perfect, this is done. Now what I'm actually going to do along with this, since I'm also going to read my dataset from my source itself, right? And the source is nothing but inside this particular folder network underscore data, phishing data.csv. I need to read this, right? So what I'm actually going to do, I'm going to import pandas pd, okay? And then I'm going to import numpy as np, okay? Import pymongo, okay? Now, since I also need to implement logging and exception, so what I will do, where is logging and exception file? If you probably see, it is inside this network security logging folder. Inside this logger.py file is there, similarly exception.py file is there. So in order to access those files, I also need to import both those packages, right? So here I'll go ahead and write from network security.exception, and here I'm going to basically go ahead and import network security exception, right? This was one of my exception. Then the other one, what I will do is that I'll go ahead and write from network security.logging.logger, and from this I'm going to basically go ahead and import my logging, or let me just go ahead and see what that variable is, logging. Okay, I'm going to go ahead and import this. So this is with respect to my exception handling and logging, so that I will also make sure to save all these kind of files. Okay, now I'm going to go ahead and create my class, which is nothing but network data extract. Let me just go ahead and write like this. This will basically be my ETL pipeline, which will be responsible for doing all those things what I've actually discussed. Now here, first of all, I'm going to go ahead and create my init function. We'll try to make this as much as modular, because there's always a good idea in companies to probably show your modular coding so that they get an idea about it. Then I have my try block. I will just go ahead and write pass over here. Okay, and let me just go ahead and write my except block. So if an exception happens, okay, I am just going to catch that exception E, and I'm going to basically raise my network security exception, the same exception which I have actually called. And inside this, I'll give my e, sys, which we have basically imported from import sys. Okay, so perfect. Till here, this is my init function. I'm not written much because I did not have to initialize anything inside this try block. So I just kept it as open. Okay, now our main aim is basically to read all this data, convert this into a JSON file. Okay, so for that also I will go ahead and create my function. So I'll write definition csv underscore to underscore JSON underscore converter. Okay, and here I'm going to basically go ahead and write self, comma file, self comma file path, right? Because I really need to know the file path itself, right? Without the file path, I don't know from where I need to read the data set, and that information is basically given by the file underscore path. And again, I'll go ahead and write my try and catch block. So here I'll go ahead and write try, and here I'll go ahead and catch the exception as E, and let's go ahead and raise my exception. So this will be a common thing that we are going to specifically use, right? Everywhere. So here is my network security exception, and here also I'm going to give my E comma sys. Okay. Let's say what happens if the file path is not found. The file path is invalid, so that can also raise an exception, right? So here we have this. Now what I'm actually going to do over here is that I will go ahead and read my data set. So I will say, hey, data is equal to pd.read underscore csv, which is my specific data set, and here I'm going to basically go ahead and give my file path. Okay. Now once I read the data set, because I need to read it from this particular folder, so this file path needs to be set over there. That I will be setting it in the later stages. But if I just go ahead and open this file, by default there will be an index that will be applied over here, right? So we need to drop that entire index because we don't require the index itself, since we are trying to load this inside our MongoDB database. Okay. So what I will do is that I'll just go ahead and write data.reset underscore index, and here I'm going to go ahead and write drop is equal to true. Okay. Drop is equal to true, and here I'm going to basically go ahead and use in place is equal to true. Perfect. So this is my reset index, and I'm also going to make sure that that happens on the same variable that is data, right? Then finally I'll go ahead and convert this into records. Now this is really important for you all to understand. Okay. Now what exactly this specific record says. Now understand. Let's say that I have a data set. Okay. I have a data set. In this data set, I have features like A, B, C. Okay. And let's say here there are some values like 100, 120, 14. Now this is my data set for a specific row. Now how do I insert this data in the form of JSON inside our MongoDB? That is really important to understand. So in this scenario, what we do is that we convert every record in a form of JSON, in a form of list of JSON. So this will be a list of JSON. Okay. And for every record, there will be a JSON. And we will, since we have multiple records over here, right? And to be precise, I think we have more than 11,000 records. So what we'll do is that we'll convert every record in the form of this key, like A colon. So A colon value for the first record is 100, and B will be equal to 120, and C will be equal to 140. Now this way, we're trying to form this into a form of key value pairs, and whenever we try to convert into JSON, it should be in the form of key value pairs. And MongoDB also supports well this kind of data. So we are basically going to convert our data in this format and try to save it into MongoDB. Okay. So how do we convert in this particular format when we have something in this particular data frame format? So that is what I'm actually going to show you. So here, what I will do, I will first of all go ahead and take this data. I'll make a transpose of this, okay, and then finally convert this into JSON so that I get that same format. Okay. And after doing that, what I will do is that I'll take this entire data and I will convert this into values. Okay. So that it looks in the form of arrays of JSON. So I will just go ahead and write dot values. And finally, after converting this, what we will do is that we'll convert this into JSON. JSON loads. Okay. JSON loads. So just a second. JSON loads. So JSON loads for this particular value dot values. Yeah, perfect. And then I will finally convert this into a list. Okay, so I will just go ahead and write in this format. So this will basically be a list of JSON arrays, right? And that will be my records. Okay, and finally I will go ahead and return the records. Okay, all the records that I'm actually getting. So this function is nothing but my CV to JSON converter. Here I'm giving my file path. I'm reading that particular file. I'm resetting the index. I'm converting into a list of JSON as I showed in my notebook, right? Now I will go ahead and data function insert data data to MongoDB. Okay. Now here also I require two important things. One is self, which records I need to push it, and then I will have my database. And usually in MongoDB, what we do is that we have to probably go ahead and create our database and collection also. So collection is just like a table, like how we have in table in SQL, right? Similarly, here you'll be having something called as collection, and this will be any collection name. I'll show you how we can also try to put the collection name. Now I'll go ahead and write try block. Okay. Now inside this try block, first of all, I'll assign the database that I want. So I'll go ahead and write self.database. I'm going to create my variables over here. So self.database is equal to database. Okay. Then even see, you can also define all this variables, class variables over here also, right? But you can just see that during runtime, I'm trying to just write down inside this particular function because I remembered it over here. You can also write this over here. So when you initialize this network data extract, you can probably pass all this information over there itself. But it's okay. We'll give it over here. Cell.collection is equal to collection. Cell.records is equal to records. Okay. And then finally, I will also go ahead and write cell.mongo client, because we also need to create a client so that we will be able to connect it to our MongoDB. Now this Mongo client needs to be initialized with PyMongo. So PyMongo is the library that is used along with Python to basically for all the Python programming language to connect to the MongoDB. So PyMongo.mongo client, so there will be something like Mongo time, and here I can give my MongoDB URL, right? So let me do one thing. Let me go ahead and give my MongoDB URL. Perfect. So this is that, and we have set this entire thing. Now along with this, so what I will be doing is that I will also be using some important things because I need to assign this particular value. So first of all, I'll go ahead and write self.database is equal to self.mongo client or self.database. So we are going to assign on this particular Mongo client what database we are using. Then self.collection, I have to probably assign with this what collection we are using inside the database. Okay, so these are my two additional codes that I will be writing. And then in order to insert, I will again go ahead and write self.collection.insert underscore many, and here I will go ahead and write self.records. Okay, so self.records will be finally added over here, and finally after adding it, I can just go ahead and return something like length of self.records. Perfect. Done. So this is done. Now I can go ahead and create an except block, exception as E, and here I'm going to raise network security exception. Okay, and here we're going to basically write E comma sys. Okay, like let's say that if I face any issues with respect to the MongoDB client or anything on MongoDB URL, I should be able to get an exception over here. Okay, so this is done. Most of my functionality, insert data MongoDB, CSV to JSON converter, everything is done. Now what I'm actually going to do is that I come outside this particular class. Okay, so here I will start my execution of the ETL pipeline. So I'll go ahead and write if name is equal to underscore main underscore. Okay, so first of all, I'm just going to give my file path. So let's go ahead and set up my file path. My file path will be nothing but whatever file path I have over here, right? So let's take this relative path. Copy relative path. Let's paste it over here. Whatever will be my path itself, right? Then I will just go ahead and write my database. I will say, hey, Krish AI. Okay, this will basically be my database, and here I will go ahead and write my collection. My collection variable will be nothing but it will be my network data. Okay, so this is my collection. Now what I need to do is that first of all initialize this particular class, right? So I will go ahead and initialize it over here, and while we are initializing it, I will just go ahead and create my network obj object. Because I need to use the functions inside that, and then I will just go ahead and write network obj.csv to JSON converter. I will give it over here. So first parameter is the self I don't need to give up, but I really need to give the file path. So here I will give the file path, which is nothing but equal to the file path, right? So once I have the file path over here, the next thing is that I will be able to see number of records is equal to network obj dot because once I convert that into JSON, I should be able to network obj dot, I think, push. What is the function name? Let's see the function name. Insert data MongoDB, right? So here I'm just going to go ahead and copy paste this. Okay, insert data MongoDB. Inside this insert data MongoDB, I am going to give my records, the records that I'm actually going to get, and this records is nothing but this will be the return type over here. Okay, and this records, once I give it, along with this, I really need to give my database, and the second thing that I really need to give is my collection. Okay, so all this information is there. Perfect. Number of records is gone. Now I can also go ahead and print the number of records. Okay, done. So this is what we are printing. I can also go ahead and print the records to just see it, but let's see. I'll just go ahead and print this entire records. See, the return type over here is record. So let's go ahead and print it. Print the records. Okay, so you will be able to see the records over here. So okay, perfect. So this is my ETL pipeline. Now let's go ahead and execute this particular code. So here I will just go ahead and write Python again from the same parent folder. I'll go ahead and write push data.py. Once I execute it, I think it should work now. So this is my entire MongoDB URL. Now here you can see everything is getting displayed. That basically means I've converted this into a JSON, and now it is pushing. All the information will get pushed. It finally should display this. It should display the number of records. So see, 11,055 records. So let's go ahead and also check whether our data has been inserted into our clusters or not. So cluster 0 is there. If I go ahead and click on collections, so here you can see retrieving list of this. So here is my Clutch AI network data. Okay, and here are all my data that is available, which is amazing. We can see all the data itself, right? Which is good enough, right? So all this data has been inserted. We are good to go. This is just a basic ETL pipeline. Understand the real work of the pipeline, specifically ETL pipeline is done by the database engineers or data engineers itself, who will be managing the data from various sources, manipulating, doing some transformation, storing it in some kind of database. Now, after this, the main step is that we really need to start with our data ingestion, right? So if you remember whatever things we specifically discussed over here, right, with respect to various components like data ingestion, data validation, data transformation, model training, and model evaluation, that is what now we are going to look ahead as we go ahead in the next video. So I hope you like this particular video. This was it from my side. And one last thing that I really want to do over here is that just let's go ahead and commit this particular code. Okay, so quickly I'll go ahead and write git add dot so that I'll also be able to show you git commit. Okay, -m. See, again, there are extensions in VS Code also for GitHub commits, but I always like the command prompt. It gives me a sense of satisfaction that I'm doing something very amazing. So I'll just go ahead and write over here with respect to the commit. So let's go ahead and write over here. I'll say ETL pipeline completed. Okay, I'll go ahead and write like this, and then finally I'll clear the screen. I'll go write git push -u origin to main. Okay, so once the push is done, I'll go back over here. Now let's see this network security and let's see whether our file is there or not. Test MongoDB is there, push data is there, everything is there. Our code is also there, right? This is good enough. We're good to go with respect to this. Yeah, this was it from my side. I'll see you in the next video where we'll start our data ingestion component. Okay, so I'll see you in the next video. Thank you. Hello, so we are going to continue the discussion with respect to our end-to-end project. Already in our previous video, I have shown you how we can create a basic ETL pipeline where we specifically created MongoDB Atlas. We took our data set from any source, like in my example, in this particular project example, we took it from local. We did some type of transformation, converted that into JSON, and we loaded in the destination, that is MongoDB Atlas. Now, once your data is in the MongoDB, we really need to implement this data ingestion component. Now, if you see in this data ingestion component, there are three main important things. One is the data ingestion config, then this is the data ingestion component, and the third one is something called as data ingestion artifact. Now, we're going to take this section and we are going to deep dive more into it and understand the architecture. Now, what exactly is the data ingestion? See, already our data is already present in our MongoDB, right? So MongoDB is over here. Now, in the data ingestion, what we do is that we specifically read this entire data so that this data can be used for our training model itself, right? So first of all, over here, the thing that you actually require is nothing but data ingestion config. Now, what exactly is this data ingestion config? This data ingestion config is nothing but these are the information. These are some basic information where my data set needs to get stored. There are many steps that we specifically perform once we while we're doing feature engineering. Like we really need to convert our data set into train and test. We need to use the training data for our training the model, right? And all those kind of things. So all basic information like which should be my data ingestion directory, which should be my training file path, testing file path. This kind of information we can actually store it in data ingestion config. So first of all, we're going to go ahead and probably work on the data ingestion config. Once we work on this, we have all these details. Then what we're going to do is that we're going to probably create another function, another important file classes, right? Where we will be reading from this MongoDB. Now, this MongoDB will specifically be looking for the database that is Clutch AI and all the other information that we have with respect to the collection name and all, right? So through this, what it will happen is that we will be reading the data from this particular MongoDB itself, right? So once we read this data, then we will be taking all the specific information, that is the data ingestion config information, where we will be converting this and we'll be taking this entire information and we'll convert this into a data ingestion artifact. Now, data ingestion artifact is nothing but it is the output of the data ingestion config. Now, when we see the data ingestion artifact there, we will be having a feature store. Okay, I'm just naming it as feature store so that you get a clear understanding of this, right? So inside this data ingestion artifact, I will be getting the raw file, raw data that I'm actually extracting from the MongoDB or pulling the data from the MongoDB. And along with this, we also need to do a train test split, right? So inside this data ingestion artifact, what we are going to do is that we'll create an ingested folder and there also we'll do our train and test, right? We'll do the splitting of the particular data so that you'll also be able to see the data. Now, again, this data can also be stored in MongoDB in a separate collection, but just for here purpose, I will be showing you this feature store can be in any cloud, it can be in any database as such, right? So once we do this specific thing, then we perform. Once we take this particular data, we will be dropping the unnecessary columns. We'll be splitting the data as train and test, and finally we'll be giving all this particular information to either convert this into train and test data and raw.csv. Since once I'm exporting all the data from the MongoDB, obviously this needs to get converted into a raw.csv file, right? Because this will be this is just saying that hey, this is my entire data that is coming from MongoDB, and this will be specifically used for the training purpose. Then after we get that data, what we're going to do, we're going to do some type of feature engineering. Okay, we'll see what kind of feature engineering we'll do, and finally we'll split this data into train and test. Once we split this data into train and test, then what we're going to do is that we're going to give it to the data ingestion artifact, wherein it will store the file in the form of train.csv and test.csv. So this is the generic architecture of the data ingestion. Now it's time that we start working on understanding that how this data ingestion can be implemented with the help of Python programming language. So I will first of all go into my network security security, and I will go into my components, and inside my components, I will first of all go ahead and create my file that is called as data_ingestion.py, right? So in this particular file, I'll start writing my code. Along with this, you'll be seeing something like constant, you'll be seeing something like pipeline and all. I will be also defining some constants, okay? That we're going to see in the next video how we're going to proceed with this particular development. But we are just going to follow this architecture and implement the entire data ingestion part. Okay. So yes, this was it from my side. I hope you like this particular video. I will see you in the next video. Hello guys, so finally we are going to go ahead and implement this data ingestion part module. Now as suggested, I have already told in my previous video, in data ingestion there are three main components. One is the data ingestion config, one is the data ingestion component, and one is the data ingestion artifact. Now since first of all we are starting with this specific flow, here I need to go ahead and set up my data ingestion config. Now that basically means I need to go ahead and set up my ingestion directory, where should be my future stored file path, this specific location, and then where should be my training file path, testing file path, train test split ratio, how much it should be, and what should be my collection. So all this information I need to probably write it somewhere down over here, okay? And that is what I am actually going to see, like where we can go ahead and define this, okay? So first of all, what we really need to do is that we will go ahead inside this entity folder, okay? Now inside this entity folder, this entity is for some specific purpose, right? Here I'm going to go ahead and create one file which is called as artifact, okay? Or let me just go ahead and write this something like config_entity, okay? Since we are working with my config entity, right? So this will be my config entity.py. Now inside this config entity.py, first of all, what I'm actually going to do is that I will just go ahead and write something like this. So here all my configuration details will be specifically over here. So I will first of all import from datetime. I will be importing datetime. Now see this will be quite amazing because we're just going to follow this, right? I need to provide all this path from where I will be providing basically in the configuration file. So that is the reason I have this data ingestion config, right? So let me go ahead and open my VS Code again. So first of all, I will be going ahead importing from datetime, import datetime, and then I am going to import OS. Then along with this, what I will be doing is that I also have something called as constants over here, right? Now this constant, okay, is really, really important because here I'm going to specifically define all the parameters like file path, what should be the exact file path, and many more things. See, I am showing you in a structure which matters in the industry. Our code should be really modular. It should be like very, very much loosely coupled so that anybody who comes in your team should be able to code. So let's say in my constant folder, I'm going to create one more folder, and I know that it is nothing but I will name this particular folder called as training pipeline. Okay. Now inside this training pipeline, you can also go ahead and create one init file. So I will go ahead and write init file, just considering that it is a package. Now inside this init file, what I will do is that I will go ahead and define some of the important things. Now what I will define, I'll show you. So first of all, I'll go ahead and write import OS. Then I'm going to go ahead and define import sys. These are the generic package. Then I will go ahead and write import numpy as np, and then finally I'll go ahead and import pandas as pd. Okay, so see the file structure, right? Now these are my basic information, right? Now you really need to understand is that in the data ingestion, what all information I really need to write. So let's consider this. I'll go ahead and define this as my data ingestion over here, and this is nothing but this is my constant variable names, right? I have to probably talk about what should be my database, what should be my directory name, what should be my feature store directory, what should be my ingested directory, what should be my train test split ratio. And if you probably go ahead and see in this diagram, these are the same information, right? This should be some hard-coded value, right? Because it should know from where to probably take the data, from where to probably do the train test. After we are specifically doing the train test split, where we need to save it, all those kind of information you can hard code it over here, and that is the reason we have created this constant file, right? Now over here, if you remember, I will just go ahead and open my I'll go ahead and open my MongoDB. So let's go ahead and open my MongoDB Atlas. Okay. Now once I go ahead and open my MongoDB Atlas, I hope you know that I will click on start free and automatically it should log in because I think I had logged in. So I'll go ahead and sign in over here, and let me go ahead and do the sign in with respect to Google. And please use the same account which I've actually shown you in the previous video how to create clusters. And inside that we have also created about our database and collections, right? So over here you'll be able to see that okay, I will be able to get my collections. And once this clusters gets opened, you can probably go to current IP address not added. You will not be able to connect the data from this address. Okay, it's okay. So I'll go ahead and click on browse data. So it'll just go ahead and see this. This is my name, right? This is my Krish AI name. Okay. So I will go ahead and quickly do one thing. Okay. And one more very important thing is that if you click on this network access, right, it shows the current IP address not updated. You'll not be able to connect to the database from this IP address. What I will do, I will make sure that I will go ahead and add something. Okay. I'll add this current IP address. Okay. So it will show, okay, I'll just go ahead and this IP address. So this is just for our HTTP request. I'll just go ahead and confirm it. Okay. So once this will add, you'll only be able to connect to your clusters from the following list of IP address, right? So this is nothing but this is the generic IP address that we're going to specifically use for any kind of request. Okay. So now this is also active. Okay. Now the next thing what I'm actually going to do, I'll go over here. I'll click on overview. Okay. Understand 0.0.0 is nothing but we are going to make sure that from any HTTP request that specifically comes, that happens. Okay. Now I'll go ahead and click on browse collections. Okay. Now inside this collections, you can see my database name, that is Krish AI, and the collection name is network data. So what I'm actually going to do is that I'll go over here, and here my collection name is same, right? So network data, and this should be Krish AI. So I'll go ahead and write Krish AI. Okay. Then my data ingestion directory, it should be nothing but data ingestion, and my feature store directory should be nothing but feature store. My ingestion directory should be ingested, and my train test should be float. Okay. So these are my basic constant informations that I specifically require. Okay. And along with this, what I will also be doing is that I will be defining some common constant variables also. Okay. And this common constant variables, like what my train file should be in the name and all, right? So defining common constant variables for training pipeline, my target column in this specific data set. See, so if I open my data set over here, which we are going to probably read it from the MongoDB, the target column is result, and remaining all are my independent features. So that is the reason if you go ahead and see underscore init.py, which is inside constants inside training folder, my target column is result, my pipeline name will be network security, my artifact directory will be nothing but artifacts, my file name is nothing but network data.csv, or I can also go ahead and write something like phishing data, right? So that is the name over here, phishing data.csv. Let me just go ahead and update this. So phishing data.csv, and my train file name should be train.csv, and my test file name should be test.csv. So all these informations are specifically put up over here, right? So this are my constant information. Now I'll go back again to my config entity. Now I'm going to update my data ingestion config, right? So for here, what I will do is that I'll quickly first of all go ahead and write from network. See, I've already defined my, if you remember, I've already defined my constants. My constants are nothing but it is present inside this constant folder, training pipeline, right? So and this is nothing but it is inside network security, right? So what I'm actually going to do, I'll go ahead and write from network security dot constant import what is my training pipeline, right? So I am specifically importing my training pipeline folder over here, and inside this, whatever is the pipeline name that I've actually created, I can go ahead and use it. So let me go ahead and do like something like this: print training pipeline dot what is my pipeline name, just to see that everything is working fine. And print training pipeline dot artifact directory, right? So this all are my config entity, and you can probably print this. You can directly run this particular file and you can see whether everything is working fine. But as said, I am going to create a class. I'm going to create a class, and this class will specifically have my data ingestion config. data ingestion config. Okay, so this is my data ingestion config. I will go ahead and define this. Let me go ahead and create my init function. Now inside this init function, I'll give myself, comma, I'll give my training pipeline config. Okay, so this will be my basic generic information, the common generic information, and this training pipeline config will be of some another class. I'll create that class also over here, because here we are also going to create our training pipeline config. Okay, so this will be the class that we are going to basically use. That is nothing but training pipeline config. Okay, so this will be there. I will again go ahead and create my init function. You'll just understand this why we are specifically using this, right? So I will be using my timestamp is equal to nothing but datetime.now. Okay, so I'm going to probably provide, whenever I talk about training pipeline config, you need to have this basic information. What are those information? So I will be having this information where I will be knowing my timestamp, I'll be knowing about my pipeline name, okay, I'll be knowing about my artifact directory name, and I'll be also knowing about the artifact directory itself, right? Now here you need to really understand this, where this information of pipeline name and artifact directory is specifically coming from. This underscore init.py, right? This is my pipeline name, this is my artifact directory, right? And that is all the information that I'm getting it over here. If I talk about artifact directory, which will be again, another variable inside this class, it is nothing but we are assigning it to self.artifact name along with the timestamp. We're just joining both the path. And self.timestamp will be this. The reason why I'm doing this, because this generic information I specifically want it from my training pipeline folder itself, right? Where I've actually created this. Okay, this is fine. Now you need to understand this. Whenever I create my data ingestion config, obviously for the data ingestion config, I need this particular details also. I need to have my pipeline name, I need to have my artifact directory, because here also it requires that, right? Because here also you can see where is my data ingestion artifact folder, it is feature store ingested. I need to know that. Okay, and that is the reason I've also hard coded it over there. Okay, now see this. Okay, now this training pipeline config that I'm actually going to get is from my training pipeline config itself, which we have created over here, right? So all these details will be specifically coming from this particular class. Okay, now inside my data ingestion config, I will go ahead and write self.data ingestion directory. Okay, and this should be my string type, which is nothing but os.path.join. Okay, so I'm probably joining this entire thing. Okay, self.data ingestion directory. See, because if I go over here, first I need to know the data ingestion directory. How do I create my data ingestion directory? I'm just saying that, hey, go and use this os.path.join, and from this particular join, what we really need to join, right? You need to understand this, right? What we really need to join, right? Two important things. One, I will take this training pipeline config dot. Okay, I will go ahead and use my artifact directory, right? So this artifact directory from where I'm actually getting from this training pipeline config itself, and that is what I have got over here, right? When I'm combining artifact underscore name and timestamp from the root folder, right? So I will be having this artifact directory, and what we do along with this particular path, I need to save this data ingestion file over here, right? So I need to know my data ingestion directory, right? So I'll just go ahead and write training pipeline dot data ingestion directory name, right? So once I'm writing this, what is basically happening inside this? Where is my data ingestion directory name? It is nothing but this data ingestion which we have hard coded, right? So what we are specifically doing in the data ingestion config is that we are initializing our data ingestion directory to this particular value, and these values are specifically coming from this constant variable. The training pipeline values are specifically coming from here where we have created this, right? But this data is basically getting read from the same constant file, right? Which is present inside the constant folder and all. This we are just hard coding it. See, the thing is that you can also directly hard code it over here, but we will try to follow the best practices that are specifically used in companies. Okay, so this we have done it. Then similarly, if you probably see, I need feature store file path, I need training file path, I need test file path. Okay, so and I also need to know the train test split ratio, right? And you know that all these values I've already defined it over here, right? What should be my train test split? What should be my ingested directory? I just need to probably read it from here and assign as a variable over here. So considering this, what I will do is that I'll copy and paste some of the code, which is commonly similar, right? Like how we create a data ingestion directory. Similarly, we'll go ahead and write self.feature store file path. And feature store file path is nothing but we're going to just write os.path.join. Here we're going to use the data ingestion directory again. Then we are going to combine that from training pipeline. I'll be getting my data ingestion feature store directory name. Okay. And if you see one more, what file name it should be, right? So that will basically save my file, right? So this training pipeline and dot file name is nothing but what is my file name over here? It is nothing but test.csv. Sorry, this is nothing but fishing data.csv. So to save this particular file in that particular format, right? And this will be my entire path. First of all, the folder will be data ingestion. Then inside that feature store, right? This particular value, what you're basically getting, training pipeline dot data ingestion feature store. It is nothing but it is feature underscore store. Then inside that particular folder, I will be getting this particular information with respect to the file name. Similarly, if I go ahead and see with respect to the training file path, I should know the training file path again, ingestion directory. Inside that, the data ingestion directory, because we'll follow this pattern. See, ingestion directory, data ingestion directory. Inside that, I'll be having my training test.csv file, right? So I need to probably set up that particular path for my training file path. So here you can see I'm using training pipeline dot training file name. The file name is nothing but you can see over here what is my file name, training file name. So if you go ahead and see, it is nothing but train.csv and it is nothing but test.csv, right? So this config.entity is just to get all the basic configuration information which we were discussing over here, right? So similarly, what I will do after this, I will also get my training file path, and for getting the training file path, I need to combine with my data ingestion directory, and you can probably get a train file name, right? And you just need to follow this, right? If I probably go inside over here, this is my data ingestion directory. Inside that ingested folder will be the train and test name will be there. I'm getting this name from my constant folder, right? And similarly, I'll be getting my testing file path. At the end, you'll be able to see everything will be same, but here we are going to use test.file name. Okay. Then coming to the train test split ratio, you know from where you can probably get it is if you go ahead and write training underscore pipeline dot data ingestion train test split ratio. It is nothing but over here. This value is nothing but 0.2. It is just going to read that. And finally, your collection name, you're getting a data ingestion collection name. If you know your data ingestion collection name, it is nothing but network data, and you can also get the information about the database from training pipeline data ingestion database name. Okay, so all these things are specifically done with respect to our config entity. Okay, that basically means if I probably consider this part, data ingestion config, we have initialized it and it is ready. Right, we have all the values, hard-coded values in the constant variable, and we are reading that. Right now, the next thing will be that we need to implement this data ingestion component. Now, this data ingestion component, what it is going to do, it is going to read from the MongoDB, and after reading from the MongoDB, we need to perform train test split. And we need to save all the files. First, we need to save this fishing data.csv in one feature store folder, and then we need to save this train test data inside my ingested folder. That is what we're going to do in the next video. So I hope you like this. Now, in the next video, I am going to just minimize this, and I will just start working on this data ingestion folder. So yes, this was it from my side. I hope you like this particular video. I will see you in the next video. Hello, so we are going to continue the discussion with respect to our end-to-end project. Already in our previous video, I have shown you how we can create a basic ETL pipeline where we specifically created MongoDB Atlas. We took our dataset from any source. Like in my example, in this particular project example, we took it from local. We did some type of transformation, converted that into JSON, and we loaded in the destination that is MongoDB Atlas. Now, once your data is in the MongoDB, we really need to implement this data ingestion component. Now, if you see in this data ingestion component, there are three main important things. One is the data ingestion config, then this is the data ingestion component, and the third one is something called as data ingestion artifact. Now, we're going to take this section and we are going to deep dive more into it and understand the architecture. Now, what exactly is the data ingestion? See, already our data is already present in our MongoDB, right? So MongoDB is over here. Now, in the data ingestion, what we do is that we specifically read this entire data so that this data can be used for our training model itself, right? So first of all, over here, the thing that you actually require is nothing but data ingestion config. Now, what exactly is this data ingestion config? This data ingestion config is nothing but these are the information, these are some basic information where my data set needs to get stored. There are many steps that we specifically perform once we are, while we are doing feature engineering. Like we really need to convert our data set into train and test. We need to use the training data for our training the model, right? And all those kind of things. So all basic information, like which should be my data ingestion directory, which should be my training file path, testing file path. This kind of information we can actually store it in data ingestion config. So first of all, we're going to go ahead and probably work on the data ingestion config. Once we work on this, we have all these details. Then what we're going to do is that we're going to probably create another function, another important file classes, right? Where we will be reading from this MongoDB. Now, this MongoDB will specifically be looking for the database that is Push AI and all the other information that we have with respect to the collection name and all, right? So through this, so what will happen is that we will be reading the data from this particular MongoDB itself, right? So once we read this data, then we will be taking all the specific information, that is the data ingestion config information, where we need to store the train test file, where we need to probably store the raw file, So we will be converting this and we'll be taking this entire information and we'll convert this into a data ingestion artifact. Now, data ingestion artifact is nothing but it is the output of the data ingestion config. Now, when we see the data ingestion artifact there, we will be having a feature store. Okay, I'm just naming it as feature store so that you get a clear understanding of this, right? So inside this data ingestion artifact, I will be getting the raw file, raw data that I'm actually extracting from the MongoDB or pulling the data from the MongoDB. And along with this, we also need to do a train test split, right? So inside this data ingestion artifact, what we are going to do is that we'll create an ingested folder and there also we'll do our train and test, right? We'll do the splitting of the particular data so that you'll also be able to see the data. Now, again, this data can also be stored in MongoDB in a separate collection, but just for here purpose, I will be showing you this feature store can be in any cloud, it can be in any database as such, right? So once we do this specific thing, then we perform, once we take this particular data, we will be, dropping the unnecessary columns, we'll be splitting the data as train and test. And finally, we'll be giving all this particular information to either convert this into train and test data and raw.csv. Since once I'm exporting all the data from the MongoDB, obviously this needs to get converted into a raw.csv file, right? Because this will be this is just saying that, hey, this is my entire data that is coming from MongoDB, and this will be specifically used for the training purpose. Then after we get that data, what we're going to do some type of feature engineering. Okay, we'll see what kind of feature engineering we'll do, and finally we'll split this data into train and test. Once we split this data into train and test, then what we're going to do is that we're going to give it to the data ingestion artifact, wherein it will store the file in the form of train.csv and test.csv. So this is the generic architecture of the data ingestion. Now it's time that we start working on understanding that how this data ingestion can be implemented with the help of Python programming language. So I will first of all go into my network security and I will go into my components, and inside my components I will first of all go ahead and create my file that is called as data_ingestion.py, right? So in this particular file I'll start writing my code. Along with this, you'll be seeing something like constant, you'll be seeing something like pipeline and all. I will be also defining some constants, okay? That we're going to see in the next video how we're going to proceed with this particular development. But we are just going to follow this architecture and implement the entire data ingestion part. Okay, so yes, this was it from my side. I hope you like this particular video. I will see you in the next video. Right? So similarly, what I will do after this, I will also get my training file path. And for getting the training file path, I need to combine with my data ingestion directory, and you can probably get a train file name, right? And you just need to follow this, right? If I probably go inside over here, this is my data ingestion directory. Inside that ingested folder will be the train and test name will be there. I'm getting this name from my constant folder, right? And similarly, I'll be getting my testing file path. At the end, you'll be able to see everything will be same, but here we're going to use test.file name. Okay. Then coming to the train test split ratio, from where you can probably get it is if you go ahead and write training_pipeline.data ingestion train test split ratio. It is nothing but over here. This value is nothing but 0.2. It is just going to read that. And finally, your collection name, you're getting a data ingestion collection name. If you know your data ingestion collection name, it is nothing but network data. And you can also get the information about a database from training pipeline.data ingestion database name. Okay. So all these things are specifically done with respect to our config entity. Okay. That basically means if I probably consider this part, data ingestion config, we have initialized it and it is ready, right? We have all the values, hard-coded values in the constant variable, and we are reading that, right? Now, the next thing will be that we need to implement this data ingestion component. Now, this data ingestion component, what it is going to do, it is going to read from the MongoDB. And after reading from the MongoDB, we need to perform train test split. And we need to save all the files. First, we need to save this phishing data.csv in one feature store folder. And then we need to save this train test data inside my ingestion folder. That is what we're going to do in the next video. So I hope you like this. Now, in the next video, I am going to just minimize this. And I will just start working on this data ingestion folder. So yes, this was it from my side. I hope you like this particular video. I will see you in the next video. Hello guys, so we're going to continue the discussion with respect to our data ingestion. Now, let me just reiterate what all things we have actually done. We have implemented this data ingestion config wherein we defined all our constants, like what all information we wanted, like data ingestion directory, feature store file path, train test split ratio, and collection name. Now, once we go into the initiate data ingestion, right, we really need to write this particular code, right? Initiating data ingestion basically means, first of all, the first step will be over here to read the data. I'll go and write over here. This is my first step. Read the data from the MongoDB, right? The second step will be to probably create this feature store. And the third step will be to probably split the data train and test and finally save it in the ingested folder, right? We have all the specific details from here, right? We already have that. Now, when we say initiate data ingestion, so from this place, we are going to implement our data ingestion component, okay? So again, what I will do is that I will go ahead and write this particular function, initiate data ingestion. So let me go ahead and open my code. Now, first of all, let me do one thing over here is that I need to go ahead and import some of the important libraries over here. So first of all, exception library, right? So from network security dot exception, right? From network security dot exception dot exception. Okay, so if you probably go ahead and see this, right? If you see network security is this folder, exception is this folder, inside this exception.py is there, right? And inside this, we need to import this network security exception, right? So here we are just going to go ahead and write this. So let me close this quickly. Let me close this, right? So here, from here, we need to import the network security exception. Okay, so I'll go ahead and paste it. So this will be my exception, the custom exception that we have specifically written. We're going to import the same thing. Now, similarly, we will go ahead and write from network security dot logging dot logger. Okay, and from this we're going to import logging, right? So this is the logging. For the logging purpose, we have actually created this entire py file. Okay, now here we need to also go ahead and call the configuration or config file for the data ingestion config, right? Configuration of the data ingestion config. Okay, so step by step I'll write each line of code and I'll show it to you so that you understand the entire flow. So from network security, you know how to probably go ahead and call it. So I have my entity, along with the entity I have my config underscore entity, and then I'll go ahead and import my data ingestion config. Okay, then this data ingestion config is the same class that we just created in our previous video, right? Now let me just go ahead and import some more things like import OS, import sys, and these are some of the basic libraries that we're going to use. Import PyMongo, import typing from list, and this is my sklearn. Now sklearn specifically we're going to use for probably doing our train test plate, and I hope everybody must be familiar with machine learning and how to probably go ahead and create a train test plate. Now for this sklearn, what we really need to do is that we need to go ahead and import one library. For that we need to go ahead and install that library in our requirement.txt, right? So what I will do, I'll just go ahead and open my terminal. Now inside my terminal, I'll just close this, or let me just go ahead and open my terminal over here. Let me open my command prompt, okay? And still we are in the VM environment. You really need to understand, you really need to be in the VM environment and do the installation. So finally I'll go ahead and write pip install -r requirement.txt. And this requirement.txt will be responsible in installing the scikit-learn, that package that we have written. Okay, now here you can see PyMongo is also getting installed. Then you have scikit-learn, everything is basically getting installed, right? So let this installation basically happen, and then once this installation happens, we are just going to go ahead and continue our entire data ingestion part itself, right? So perfect. I think we are in the VNV environment itself, right? So network security VNV environment, perfect. Okay, so this is done. Now what I'm actually going to do is that I'm just going to go ahead and continue with respect to data ingestion. As I already said, once we are probably writing this data ingestion, we need to import some of the libraries over here. Now after we import all the specific libraries, the next thing is that we will go ahead. See, our first step is probably to read from the MongoDB database, right? So what I will do, I will go ahead and write from .env. I'm going to just go ahead and import load_.env, and here I have my load_.env over here, and this will basically, I'll go ahead and read my MongoDB URL, right? So mongo_db_URL. This MongoDB URL is going to come from the environment variable that we have created over here, right? If you go ahead and see my environment variable .env, and this is the MongoDB URL I really need to read, right? So what I'm actually going to do is that I'll go to my data ingestion. Here I will just go ahead and write os.getEnv. Now inside this env, I need to go ahead and paste the same key, that is MongoDB URL, right? So inside my data ingestion, I'm just going to go ahead and paste this. Now I have my MongoDB URL. Now it's time that we go ahead and start reading from this MongoDB URL. So first of all, I will go ahead and create my class, since we are going to make this completely modular. So this will be my data ingestion. After creating this data ingestion, what I'm actually going to do is that I'll go ahead and create my init function. So definition init, and I need to initialize some of the variables over here. So I will go ahead and write self, and you know that if I really want to initiate data ingestion, it should know all the configuration details from the data ingestion config, right? So here we are going to create a variable which is called as data ingestion config, and this is basically going to get assigned with the data ingestion config, right? And if you remember, we have already imported this data ingestion config over here, right? So this will be this particular type, right? Now inside this init, I'll go ahead and write my try catch block. So this will be my try pass. Let's go ahead and write my except. And here I'm just going to write exception as E, and from here we can probably raise any network security custom exception, right? So we're going to raise this, and here I'm going to provide my sys. Okay, sys is basically getting defined over there. Now inside this init function, init method, we really need to initialize the entire data ingestion config from this data ingestion config class, right? So here we'll go ahead and write self.data ingestion config, and here we are going to create an object of, or we're just going to assign this data ingestion config over here, right? So once we assign this, that basically means in this variable we will be having the access of almost each and everything that we have created inside this data ingestion config class. Okay, so this is the first thing that we really require. Okay, now let's go ahead and define our function. So first of all, we need to define a function wherein we initiate. See, according to this particular architecture, we need to initiate the data ingestion config. Okay, I got the MongoDB URL, so I'll go ahead and create a function inside my class which is called as initiate data ingestion. So now let me go ahead and create a function initiate data ingestion. Okay, after I probably go ahead and initiate it, I will just go ahead and write myself. Okay, then I will go ahead and create my try. So try, I'll just write pass except. Okay, so inside my except, I'm just going to go ahead and write exception as E. So this is common thing that we really need to write for any function that we are basically writing, right? So here I'll go ahead and raise my network security exception. Perfect. Now what I'm actually going to do, I'll just remove this particular pass over here. Okay. Now when we are initiating the data ingestion config, first of all, I need to get the data frame, right? Now this data frame, from where we will be getting it, we need to read it from our MongoDB itself, right? So for this, I will create a function. Okay, and that particular function will be nothing but, let me just go ahead and write it over here. So this will basically be my function definition export underscore collection as underscore data frame. Okay, so this is nothing but we are just trying to say that, hey, from the MongoDB collection, I need to probably export it as a data frame itself. So I'm going to read all these things from my MongoDB, right? So here we are basically going to read it from the MongoDB itself. Again, over here, as usual, I will go ahead and write this try catch block. Okay, so quickly let's go ahead and write this try catch block because I may face any kind of issues over here, right? So that is the reason I'm going to write this. Now I'm going to specify my database name. What is my database name? In order to get my database name, I can go ahead and initialize with self.dataingestion.config. And if you remember, inside this data ingestion config, which is probably present in my entity folder. So if you probably see data ingestion config, inside this, where is my database name? It is basically there in database underscore name. So data ingestion config dot database underscore name, we can probably get that particular data. So here you will be seeing I will be having something like database underscore name. Okay, so this is my database underscore name, and the next thing that I really want in order to connect to our MongoDB, it is nothing but collection underscore name. And here I'm going to use self.data ingestion config dot collection underscore name. Okay, so I have my collection name over here, I have my database name over here, and then I have self.mongo underscore client. So if I go ahead and write self.mongo underscore client, okay, I'm going to probably go ahead and create my Mongo client itself. Within this particular function, I will go ahead and write pymongo.mongo client, and I hope everybody knows how to call this, right? So pymongo.mongo client. So I will just go ahead and define this Mongo client, and for this Mongo client, I need to import it also, right? So if I probably we'll see whether I've imported PyMongo or not. So PyMongo is there, so I'm just going to go ahead and use this py.mongo client, which will be actually helpful for creating my client itself. And here we're going to use the MongoDB URL. Okay, so once this is done, then I'm going to probably go ahead and create my collection. My collection is nothing but self.mongo client. Oops, what happened? Let's see. Okay, so it should be data ingestion.collection name. Okay, that's fine. Now let me quickly go ahead and call this specific information. So I'll write collection is equal to, okay, self.mongo client, okay, of database. And I hope I've already shown you how to probably work with MongoDB, right? So here I will be having my database name, okay, and here I will be showing to get about collection name. See, again, you need to have a good amount of knowledge with respect to MongoDB because you should at least know how to read the data. We are not querying anything as such. We're just writing a basic query, just like reading the entire documents that are present in the MongoDB. Okay. So once we do this, finally we get all this collection information. What we can do is that we can convert this into our data frame. So I will go ahead and write. Let's see whether we have imported pandas. I think we have not imported pandas. So let me quickly write import pandas as PD. Okay. So I will be requiring this pandas library. So if I go ahead and write PD dot data frame, and here I'll be writing list. Inside the list, I will be writing collection dot find. Okay. So once we basically go ahead and write this, we will be getting the entire data, and this we will convert this into a data, and this will be like converting or typecasting into a data frame itself. So here I will be getting my DF, right? Now, one very important thing that you should know: whenever we try to read any data from the MongoDB, by default there will be one column that will be added. That is nothing but underscore ID. So here I will just go ahead and write one condition where I'll say, hey, if underscore ID, okay, if underscore ID in df.columns, if it is present in df.columns, what I'm actually going to do is that I will, or I'll just say df.columns dot to underscore list, so that we can actually check whether this particular value is present or not. Okay. So if this is present, okay, we will just go ahead and drop it. So I'll go ahead and write df.drop of columns is equal to underscore ID. Okay. So this we are going to drop it, and here I'm going to write access is equal to 1. Okay. Now, perfect. Till here we are good enough. So finally, I'll go ahead and write df.replace, and let's say that I have some kind of data like NA and all. So we will try to replace this NA to something like np.nan, so that it basically takes a value of numpy, right? And then here I'm going to probably go ahead and write in place is equal to true. Okay. So finally, after this, I'm just going to return the df. Okay. So so this is what is basically there. Why we have written this particular function is just to read the data. Okay. So here I'll just go ahead and read data from MongoDB. Okay. So, and this particular function we will try to call inside my initiate data injection, right? Because after this, calling this, we will be able to get this, and I'll write self dot, okay, self dot export collection as data frame. Once we call this particular function here, you will be able to see that, okay, so this is a function. I'll use this function over here. I will be able to get the data frame itself. So what we have implemented over here is nothing but initiate data injection, the first step of reading the MongoDB, where I put my database name and collection name. So everything has basically been implemented. So till here is good to go, right? Now the next thing is that if you probably see the architecture, right? I need to perform this step, export data to feature store. When I say export data to feature store, that basically inside this feature store folder, I need to have some CSV file, okay? And this CSV file is the entire data to just make sure that we have the original data that we have read it from the MongoDB. It's not always a good idea to always read from MongoDB with respect to data. Once we read it, we keep that chunk of data probably in the local so that we train it with our machine learning model. So for this, what I'm actually going to do, since I need to store that in feature store, I will create another function, okay? And this time, my function that I'm actually going to create is something like this, okay? So just focus on this function because this is really important. This is nothing but export data to feature store. So here I'm going to give my data frame, whatever data frame I get from this, right? Export collection as data frame, right? So whatever I get from here, right? I'm going to probably get that information. Oh, okay. Then here you can see, first of all, I need to get the feature store file path. Why? Because this will be my feature store file path. Where is my feature store file path? It is already available in the constant. So here inside my data injection config, I have the feature store file path. Then I will go and create that particular folder, right? So feature store file path, and I'll go ahead and create that folder. We'll be using os.min directories. And finally, I'll convert my entire data frame into CSV, which will be storing in my feature store file path itself, right? And then we will also be making sure that we have index is equal to false and header is equal to true, and then we'll return the data frame, right? So this is my second step, right? So here again in the architecture, export data to feature store basically means we are going to take our entire data, which is in the form of data frame, we're going to convert that into a CSV file and store it in feature store. And we're getting this information from our data injection config. Okay. So that will be my second step. So in the second step, again, I will quickly go ahead and write something like this, right? I will go ahead and write data frame is equal to, again, I will go ahead and write self dot export data into feature store. Once I do this, here I need to give my data frame, right? So this is what the function is expecting. Okay? So this is my second step. Now the third step is really important. The third step, I will drop the columns if it is required, and then we'll do split, train, and test, and then it is going to save it inside this ingested folder. So for that, I'm going to create another function, which is nothing but it is called as, and this is really important, and I hope you should be familiar with train, test, split, right? So here is my third function. Okay, so let me do one thing. Okay, so this is my third function. Okay, so let me just go ahead and minimize one together, right? So this is my export data frame into feature store. Now this is my this one and initiate data injection. So let's see this function. Okay, it is nothing but split data as train test split. So here I'm taking self data frame pd.data frame. We will be using this train test split. Now understand one thing: train test split is nothing but it is available in the sklearn library. That is from sklearn model selection. We're going to import train test split. You know, for a train test split, what all values we require? Okay, we require the data frame, we require the test size. This we are getting from the data injection config and train test split ratio, right? If you remember, here we have defined that, right? Train test split ratio, which we are reading it from the training pipeline, right? So these values are basically there. Then we're going to write some logs, perform train test split on data frame, exit train test split. Then we're going to create a directory path because we need to save it inside the train file path, right? So here I'm again getting this particular information from my data injection config. I'm making a directory. I'm writing login.info, and finally I'm converting this into I'm saving that particular train set into CSV and test set to CSV with my name of training file path and testing path. And finally, you'll be able to see that I'm writing login.info, exported train and test file, right? So everything is working perfectly fine. So this is my final function. Now what I will do is that inside this, I will go ahead and write my third step, and I hope you should be familiar with this. Many people may have done that because at least you need to have some knowledge with respect to how this one, right? So here I'm going to split the data as train test split, and here I'm going to give my data frame, right? So data frame will be given over here. Okay? So this is perfect. Till here everything is working fine. Now if I go back to my architecture, here you can see I've implemented this entire data injection. So everything I'll be able to get till train test CSV everything, right? Now finally will be this data injection artifact. Now this is really important for you to understand what exactly is data injection artifact. What do you think the output of data injection component should be? See, at the end of the day, in the data injection, my final goal will basically to take the data set and convert that into train test split, right? So I have my train data, I have my test data. So what we can do is that we can probably create another class like how we have created for data injection, okay? And in that, I will just go ahead and say, hey, what all output I specifically want, that's it. What all output I want from the data injection component, what all output I want from the data validation component, right? So what I will do, I'll go back to this and I'll go to my entity, okay? Now how we have a config entity, similarly, we will be having something called as artifact entity. So let me go ahead and write this artifact entity .py. Okay. Now inside this artifact entity, first of all, I'm just going to import from data class as data class. Okay. Sorry, from data class import data class. Okay. So I'm just going to import this specific class. Oh, sorry, it should be data classes. Just a second. data classes, I'm going to import data class. Okay. Now data classes, so let's say why this will be basically used. With the help of data class, it just acts like a decorator, which probably creates a variable for an empty class. Okay. Let's say in my class I don't have any functions. I just need to have some variables defined, a class variables defined. I can basically use this. Now with respect to the data ingestion, right? The output of the data ingestion, I will call it as data ingestion artifact. Okay. So I can go ahead and define this data class like data ingestion artifact, and the output of the data ingestion component should be that I should be getting my train file path and test file path. Okay. So this two information will be more than sufficient. Now after this data ingestion, what I am going to probably do over here is that, see, after we do that split, after we do this particular split as train test, the final aim will basically to get the output of the data component, the data ingestion component, right? The output of the data ingestion component should be my train file path and test file path, and that is what we have actually created over here, train file path and test file path. So for this, what I will do is that the output I will go ahead and write something like this, okay? And please do check this, okay? So here, first of all, let me go ahead and import, like I will use this itself from network.entity.artifact entity. I'm going to just import my data ingestion artifact. This is the output of the data ingestion component, okay? Now, when I go ahead and create this artifact, so let's go ahead and create this data ingestion artifact, okay, as a variable artifact. It will be nothing but it will be self dot data ingestion config dot, okay? First of all, let me go ahead and initialize data ingestion artifact, and inside this I will give my train file path. My train file path, you know that where exactly it is, right? How do you get your train file path? You can probably write something like the self dot data ingestion config dot train test split ratio. This is fine. Let me just go ahead and see where is my train path and all. Okay, so here I can go ahead and write like this: self dot data ingestion config dot training file path, right? So this will basically be my train file path, right? And I have to probably initialize all these values inside my data ingestion config, right? The second parameter after this that we really need to create, you know the second parameter what exactly it is my test file path, right? So here I'll go and write self dot data ingestion config dot test file path, right? So both this is been defined, and as you know, inside this I have this particular data ingestion config, I have this two parameter which we need to initialize, right? And that is what we have initialized it over here. Perfect. Now over here, what we are going to do is that once we get this specific artifact, we are going to return this data ingestion config, right? So data ingestion artifact. That's it. So this is my final output of my data ingestion component, right? So first of all, this is my step to read from the MongoDB, then save it, then create train test split and save it in the right kind of folder and all, right? This looks good, and everything is probably working fine. Now I've written the code. I don't know whether it will work fine or not, but let's go ahead and test this, okay? So quickly, in order to test it, I will go ahead and create one main.py, and please make sure that you create it in the parent folder, in the outside folder, right? So from here we will trigger each and everything, right? Now the first thing first, so what I'm going to import is that I will go ahead and write from network security, okay, dot component, okay, components dot data ingestion, okay. I'm going to just go ahead and import what is the class in the data ingestion. It is nothing but it is data ingestion itself, right? So I'm just going to import this, okay. So this is the first thing that we really need to go ahead and import to just test whether data ingestion is working absolutely fine or not, okay. Now what I will do along with this, let's do one thing, okay. I will also go ahead and import my security exception and login also, okay. So this too has been imported. Now I'm just going to go ahead and write if underscore main or let me just go ahead and open my exception handling, because there I had already written a code, okay. So I'll just copy and paste this to just see whether everything is working fine or not. That's it. That is my main name, okay. So here I'm going to basically use logger, okay. Login.info is over here. Let me remove this code, okay. So here I'll say enter, will initiate our data ingestion, okay, from here, okay. So in order to initiate the data ingestion, I will just go ahead and write data ingestion is equal to data ingestion over here. So once we initialize this, as you all know, see, when we are calling this data ingestion, right, you should know that when we're initializing it, here we need to also pass data ingestion config, right? Now this data ingestion config, where exactly it is present inside my entity, inside my config entity, right? So over here it is basically present. So we also need to go ahead and import this, right? So in order to import it, what I will do is that I'll quickly go to my main.py file again. Let's go over here and let me do one thing. I will go ahead and write from network security dot components dot constant, or is it constant or is it something else? Let's see. So here we have our entity, right? So inside our components, no, not inside our components, outside our components, it should be entity components. Sorry, not should not be components. From network security dot entity, okay, dot inside my entity, I have my config entity. I'm just going to go ahead and import my data ingestion config, right? Now this data ingestion config, also we need to go ahead and initialize it over here. And oops, just a second. We will go ahead and initialize the data ingestion config over here. This config will be my data ingestion config itself, right? And this variable, we need to pass it over here, right? And if I go ahead and see in my config entity, config entity in my data ingestion config, once we're initializing this, it should also be getting this entire training pipeline config, right? I'll just show you one way of running this. Now this training pipeline config, again, we need to import this in our main.py. So here I will just go ahead and copy this again, and I will initialize it over here, and this will basically be my training pipeline config. Now, if I go to my training pipeline config, see this, if I just go ahead and press this, I need to provide my timestamp, that is, and timestamp is also by default provided. So that's it, I need to just initialize my training pipeline config. So quickly, let's go ahead and write my training pipeline config over here, and we will just go ahead and initialize this. So once I get this training pipeline config, I will copy this, I will provide it over here, I will initialize it over here, and this is my data ingestion config that I really need to do, okay? Then we can go ahead and write login.info, and I'll say, hey, let's go ahead and initiate the data ingestion, okay? So every module you can run something like this, which will be great enough, Now inside my data ingestion, so what I will do, I'll just go ahead and open my data ingestion.py, I'll just call this function. Which function we really need to call? It is nothing but my initiate data ingestion config, right? So finally, if I just go over here, close the requirement.txt, go to my main.py file, I'll just go ahead and call this, okay? And you know that. What is the return type of this initiate data ingestion config, right? Oh, okay, one more thing, I need to probably use this data ingestion. Okay. Dot initiate data ingestion config, okay? And what is the return type of this? If I remove this, what is the return type of this? It is nothing but data ingestion artifact. So this should be my artifact, which should be returning over here. And then after this, I can go ahead and print my data ingestion artifact, okay? Just to test it out. So this will probably talk about the entire flow. Let me check it out again, whether everything is working absolutely fine or not. So finally, guys, let's go ahead and run this particular code and check whether our data ingestion pipeline is working fine or not. So I'll open my command prompt quickly. I will just go ahead and write Python, and I'll call this main.py file. Now I hope everything should work fine. Network security artifacts. I think we should be getting the train and test file path, right? So this is my data ingestion, train and test file path. Everything looks good, and this is my artifact, right? So this is my folder that has got created. Let's see every folder files and all are created. Now, first of all, we need to see the logs. So log is over here. Let me open this particular log, and let me go ahead and minimize this. Okay. So it looks perfect. It's working absolutely fine. See, initiated data ingestion, perform train test, split on data frame, exited split test, exporting train test, exported train test file. Perfect. This looks good enough. And if I probably see the time, it is nothing but 10:06. Yes, it's absolutely perfect. Now here you can also see the artifact, right? So in the artifact, if you see, I have the feature store, my entire fishing data.csv, and ingested, I have my train and test CSV. And train and test is basically done in the ratio of 80:20, right? So this my artifacts folder is basically created. And if you remember this feature store from this particular architecture, if you see over here, this is what is my feature store. I've written raw.csv, but the name I've given as fishing data. And here inside my ingested folder, I can see train and test, right? So here you have this. So this looks absolutely fine. We have completed our data ingestion. Yes, this project looks difficult, but trust me, the best way we can probably go ahead and write this. This is what is specifically used in industry standards, right? Now quickly, what I'm actually going to do is that let me do one thing. This artifacts is usually created. We'll try to create it in the later stage for our next phase, right? So like train test split everything, because this will be running in the form of pipeline, right? So I will delete this artifacts, and I don't even also want to upload the logs, okay? But I will just go ahead and push all this particular data, because this artifact will just be a temporary variable, right? A temporary folder, so that we train our pipeline. So first of all, we'll go ahead and commit all our code. So git add dot, then I'm going to write git commit -m, and here I'm going to go ahead and write data ingestion component completed, component, okay? And then I'm just going to go ahead and push it, right? So I think everything works fine. Get push -u from origin to main, right? So once we push it, we're good to go, right? Perfect. Let me open my GitHub again, and let's check whether everything is working fine or not. So this is my repository, and I have created a lot of repositories. You can definitely check it out. So here is my network security, it is in private mode, and here is my everything. So inside my network security, I'll just go and see my component, data ingestion is ready, all the code is ready. If I also go ahead and see my entity, so my files are ready, artifact entity and the config entity, right? Now in the next video, we are going to go ahead and talk about this data validation component. So I hope you like this particular video. This was it from my side. I'll see you in the next video. Hello guys, so we are going to continue the discussion with respect to our end-to-end project. Already in our previous video, we have seen about data ingestion. Now in this video, we are going to discuss about our data wallet validation module. Okay. Now in the data ingestion module, already we saw that we have implemented data ingestion config, and from MongoDB, we have basically read the entire data with the help of our data ingestion component, and finally we convert that into a data ingestion artifact. Now my next step is specifically with respect to the data validation component, right? Now here you can actually see the input to this data validation component is nothing but whatever data ingestion artifact is basically created from the data ingestion component, that is only passed as an input, right? And similarly in the data validation component also, what we are really going to do is that we are going to probably create a data validation config so that we'll have all the necessary path information, and then after we complete this data validation component, we specifically get the data validation artifacts itself, right, as the output. Now if I go back over here and if I probably see this is the entire architecture of the data validation, let me give you an idea like what exactly we are basically going to do in the data validation. Here you'll be able to see that whenever we read some data from the MongoDB, right, the most important thing is that my data schema should not be changed, right? If my data schema basically means, if let's say if I have 10 features in my data set, this 10 features should always be there, because if this 10 features are not there, or if this one of the features is of any other data type, then we will not be able to train our model properly, right? Along with that, we also need to check like how, let's say in one of this particular feature, my data is following this kind of distribution, a normal distribution. Now, what may happen is that after some point of time, this data may change its feature to this kind of distribution. So this change of the data is specifically called as data drift, okay? And this is really important because if there is a data drift, we cannot use that same data probably to train our model, because there is a huge difference between this particular data and this data. This data we have specifically used for our model training, right? Model training, our model is basically trained. But what if as time goes ahead, and my data distribution completely changes? So this is a big issue. So what we should do is that we should probably go ahead and create something called as data drift report, okay? And this data drift report, I will show you how you can probably go ahead and create it. This will just give an idea to talk about or to tell the developers, hey, whatever data is basically coming, that distribution is completely getting changed. Not only that, we'll also go ahead and check whether each and every features that we are specifically getting during the training the model is same data type with respect to the new data types that we are basically getting, or new data that we are getting, right? So this kind of check is basically data validation. First important information over here, I'm going to write, our data set should have the same schema. When we are saying same schema, that basically means same number of columns, same number of features, right? And the distribution should also be the same, right? Second thing that you'll be able to see that we'll also be checking something called as data drift. Data drift is just to check whether the distribution of the data is same or not when we compare it with training the data that we have used for training our model, and the new data that we are specifically getting. Third thing, some checks that we are specifically going to do is nothing like validate number of columns. Okay. There is also something called as whether numerical column exists or not, numerical column exists or not, and many more checks. Okay, so let's go ahead and this will be the entire flow of the architecture. So here, first of all, you have this data validation config. Initially, you have all this necessary information. See, so this is my basic information that I require in my data validation config, right? So similarly, in this module also, we'll first of all define our config. Now let's talk about what all folders we basically require. We require data validation directory, we require valid data direction, we require invalid data direction. Directory, not direction, it's directory. Then we have valid train file path. Then we have invalid train file path. Let's say that if my train file that I'm actually getting, if it is not having the same number of columns, we are just going to go ahead and put in the invalid train file path in that particular directory. We're just going to put that particular file. Then you have invalid test file path, then drift data report file path. We'll talk about more as we go ahead. So initially, inside this data validation config, we will define all this particular path. Then when we go to the next step, we are basically going to initiate the data validation. Now to initiate the data validation from the data ingestion artifact from the ingested folder, we are going to read the train and test.csv, right? And you know that this data ingestion artifact is given as an input to the data validation, right? So here this is given as an input where I have a folder called as ingested, and I have train.csv and test.csv. And remember, this pipeline of data validation should run after data ingestion. Okay. Then you have this next step, validate number of columns. So first of all, we're going to probably go ahead and check for train data whether I have the same number of columns, and for the test data whether I have the same number of columns, right? So we're going to validate this. So we are going to probably create a function which will probably work in this way, right? Then it will probably going to give me some status like false or true. If it is false, columns are missing in training data. If the status is false over here for the test status, then we can basically say the columns are missing in the test data frame. Okay. Then one more check we are going to do after this is that is numerical column exist or not. We're just checking whether the numerical column exists or not with respect to our training data and test data. And here also we'll be getting some kind of status. And after we get this particular status, what will specifically happen is that we'll go to this validation status stage. And if we are basically going to check this validation state, and we're just going to find out whether it is true or false. If it is false, we are going to get a validation error. We will raise this kind of error. Otherwise, we will go ahead with the next step, that is detect data set drift, okay, to check whether the distribution of the data is changing or not. Then finally, we go to this drift status. So once we go ahead and apply this particular function that is detect data set drift, here we are going to check the distribution, okay. And how to do this? There is a mathematical way. Okay, as we are going to focus more on the coding part, so we'll go ahead and apply and we'll compare the previous data set which we have trained with the model and the new data set that we're going to get. Okay, so we're going to go ahead and check this data set drift, and then we're going to get the drift status. If it is false, that basically means the data is almost similar, the distribution is almost similar. So from here, what we're going to do is that we're going to generate this report.yaml file. Along with this, we are going to return our validation status, valid train file path, test file path, invalid file path, train test file path, then drift report file path. So all this information will be shared. Okay, and this report.yaml will be shared inside the artifact folder where we'll be creating a folder called as data validation. Now, the architecture that I have actually followed over here is based on the most common end-to-end projects that is probably developed in the entire industry. But you can just imagine how many number of steps are specifically involved. Okay. Now, what I'm actually going to do is that I will go to my code over here. Let me close each and everything. Okay. Now, as usual, you know that if you probably go ahead and see my network security. Okay, so let me just close all these things. Now, in my network security, you will be able to see that if I go to entity, right, there's something called as config entity. Now, in the config entity, what we are basically going to do is that we're going to define our all the things over here, right? We have to make sure that we have our data validation config over here. So first of all, we'll go ahead and define a data validation config over here. So for that, I will go to my network security. Inside this, I will go to my entity, and inside this entity, I will go to my config_entity.py. Now for data validation config, what I'm actually going to do, I will also go ahead and open my constant here, my training file, okay, and I'll just go ahead and click my init.py, okay. So because here also I have to probably go ahead and define all my constants, okay. So in order to define the constants over here, as I said, go to this training underscore pipeline underscore init, and we like how we have updated all the details with respect to data ingestion. Similarly, what we really need to do is that we need to do the same thing over here, right? So whatever data validation related things will be present over here, that all things we really need to update it, okay. So the same methodology, like how we probably performed everything, should be same. Otherwise, you will not be able to, like, this is the valid flow that you really need to go ahead and implement all the things, okay. So as said, again, go to my constant folder, go to the training underscore pipeline, go to the init.py, okay, and as you all know, all the information is basically written over here. So let's go ahead and write our other information here itself. So first of all, I will just copy and paste some of the variables that I'm going to use, okay. So this is my data validation things that I require, and again, I'm seeing the same architecture. So first of all, I require a data validation directory, valid data directory, and valid data directory. So considering this, I have this, right? So data validation directory name will be nothing but data underscore validation. Then this validation directory will be validated. This will be invalid. Here I'm going to create my data drift report, and my report file name should be report.yaml, okay. Then after I probably update this, I'm just going to close it. And I'm going to go back to my config entity. Okay, so in this config entity, and if you remember, where is your config entity? Inside this particular entity. So all the normal configuration information, I'm going to basically go ahead and write it over here. Okay, so let's go ahead and update this, like how we have updated for the data ingestion. We will create another class for data validation. Okay, and as I said, the process is almost same, no difference at all, right? So I will go ahead and create my class, and this is my data validation. Okay, so here you can see now. Let me just go ahead and quickly minimize this training pipeline config and this. Now inside my data validation, here also I'm going to give my training pipeline config. First of all, I'm going to combine my data validation directory, and for this, I will be getting my artifact directory. Then inside my artifact directory, this will be my data validation directory name, which I have already defined in my training pipeline init file, right? Then similarly, I require valid data directory, invalid data directory, file train file path, test file path. Then you have all this information, right? This is good enough, right? And similarly, if I go ahead and see with respect to the report file path, I require my data validation directory. Inside that, I will be having my drift report directory, and then my file name. So and everywhere we are using this os.path so that we get the full path, okay? So if you see over here, first of all, an artifact folder will be getting created, and all these files will get basically created, okay? And this is what it is, and you can see it is almost similar to data ingestion, right? It is almost similar to data ingestion, the same technique of code where I have defined all the constants over there. If I see with respect to, I'll just show you we'll discuss about this first three, and later on you can probably understand for all these things, okay? So if I see data validation directory, you know that we have defined the data validation directory in training file underscore name, right, dot name. So if I go ahead and click on F12, automatically this information is basically getting picked up, right? So I have my data validation getting over here populated, right? And this training pipeline underscore config.artifact directory, so this is basically present inside my training pipeline itself, training pipeline config itself, right? So if I go ahead and click on F12, so here you can see that I'm getting this artifact name and timestamp, right? So this will basically be my artifact folder name itself, right? So all this information is already there, and that is what we are basically doing with the data validation config. Okay. Now the next thing is that I will go back to my file. I will just minimize all these things, and now my next component that I'm actually going to create is data validation. So I'll go to my component folder, create something like data validation.py. Okay. Now inside my data validation.py, if you remember, what are the steps? First of all, we will initiate the data validation, wherein we'll read from the path that is given by the data ingestion artifact, right? The train and test.csv. That information we are already getting in the data ingestion, right? So over here we go, and first of all, what I will do is that I'll go back to my code. I'll go to my components inside this, and as I said, the data validation is basically over here. We will go ahead and import some of the URLs. Okay. Now the first, some of the libraries. So first thing that we are specifically going to import over here is nothing but from network security dot entity dot artifact underscore entity. Okay. So right now I've not defined artifact underscore entity because that will be my output, and in the artifact underscore entity also I require this many number of information: validation status, validation train file path, this. Okay. So we will first of all define this class in the later stages. Okay. But what I will do, I will quickly go over here in the down, and let me do one thing. Okay. I will go ahead and write my one information, okay, from here, right? My input to the data validation will be coming from data ingestion artifact, right? This is what we are going to get it, right? Then the next thing is that I also need to make sure that I need to call my data validation class from this config underscore entity, right? So here I'm going to write from network security, network security dot entity dot config entity. I'm just going to go ahead and import my data validation config, right? So this is the initial information that I specifically want. Along with this, I will go ahead and copy and paste my exception, and this should be logging. Okay. So we are going to import the exception and logging so that we can specifically use it. As you all know, for the data drift, right, we are going to use a library from SciPy, and I'll show you how to do that in practical terms. One is KS2SAMP. This will basically check 2 samples of data to find out whether there is a data drift or not. Then I have this pandas, OS, and sys. Okay. All this information is basically there, and these are the basic libraries that I require. One more thing that I really want to create, right? And if you remember in the artifact entity also, I need this basic information, right? The output of that particular data validation config. And if you remember, the output is nothing but I need to provide all this validation status, train file path, test file path, and everything, right? So what we will basically do is that we will go ahead and create one more data class inside this, and that will basically be my data validation artifact. Okay. Now to get this, as you all know, data artifact underscore entity is basically present inside our entity folder. So we will continue that. And here inside this particular class, inside this particular PY file, we are just going to write all the information. So as usual, I'll just copy and paste to data class. I'll be having this validation status is equal to boolean value. This will be string. 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 Right? All this particular path, and this is the information that I really need to return from the data validation stage, right? So here I will just go ahead and import one more. That is nothing but data validation artifact. Okay. So this is the overall thing. Now, one final thing that we also need to worry about is that, see, when I talk about one very important thing over here is that how to validate the number of columns and all, right? We need to validate number of columns. We need to probably check whether the numerical columns exist or not. So for this, we need to define some kind of schema, right? And that schema will be something like, I will probably define a schema path, okay? And based on that particular schema path, we'll just try to compare like how many fields are there or not, okay? And that schema path where it needs to be created, again, what we can basically do is that like how, if I go to the code, right? If you see in the training pipeline, right? So here inside the constant, here we have this training pipeline, right? like how we have this entire data validation directory information and all. Here, what we are basically going to do is that we are going to probably give our entire schema file path over here, right? Now, the schema file path will be really important because let's say that I'm going to provide a schema file path over here. Let me see this, and this will also be in the generic information. So this is my schema file path. Here I'm saying, hey, there'll be a folder called as data underscore schema, and inside that there'll be nothing but there will be something called as schema.yaml. Okay, and inside this folder, I will be having my entire schema YAML file, right? And for this, what I will do, I will go back to my network security. I will create this particular folder. Let's say this will be my data underscore schema. Okay, data underscore schema. Inside this, I will be having my schema.yaml file. Okay, now this schema.yaml file is really important because here we're going to just define our schema itself. Now, to define our schema, we'll be writing something like this. See, now let's talk about like why this schema.yaml file is basically created. Now, understand one thing, guys. If you probably go ahead and see my data set inside my network data, like this phishing.data, we need to see, when I say we need to compare the schema, we need to basically see that how many number of columns are there, how many number of numerical columns are there and all, right? Through this, we will be able to validate this entire data itself, right? So that is the reason we have created this schema.yaml. It will be in the form of this key value pairs. So here I have columns and here I'm writing all my input features. And again, this you really need to do in the manual way. So that is the reason I've just copied and pasted it for you so that you can probably see. So here you will be seeing that I will be having all the feature name. Yes, you can also automate it with the help of programming language. But here the main idea is basically to talk about this particular schema. You know, we need to compare whether we are getting all the data in the schema or not, right? And in every problem statement that we work in data science, right, with respect to our data set, that is specifically coming after the ETL pipeline, we need to have a fixed schema, right? So here I have this having IP address. It should be of int64. I've written all these things over here, right? This is with the feature name and your column name, right? Then the numerical columns have basically taken all the numerical columns over here, like how many number of numerical columns are present, right? So this two information. Now what we are going to do in the data validation is that we are going to read that particular schema, right? And this is really important. We need to read all the schema and then we will go ahead and compare that particular schema itself, right? So comparison is very much important. The comparison will be done with respect to this entire schema itself, right? And if the comparison is basically successful, you will be able to see that. We will just go ahead and say that. And if you see this particular graph, it will say the training status is true. That basically means it indicates, hey, your columns are not missing in the data in the data frame. Even your columns are not missing in the test data frame, right? So all this information we will go ahead and probably do this particular check. Okay. Now for this, what I'm actually going to do is that first of all, let me go back to my code. Okay. So here is my data validation. I'll go ahead and import one more thing. That is network security.constant.training pipeline import schema file path. And we are going to specifically use this. Okay. Before I go ahead, I want to go ahead and create my data validation class also. And in the next video, we will go ahead and take care of the further things. Okay. So here, what I've done is that I've created a class called as data validation. This will basically be my init file. And you know that the input to this data validation is nothing but data ingestion artifact. So I've created a variable which is of data ingestion artifact. And my output is nothing but data validation config. Okay. Now, data ingestion artifact, I'm going to initialize it over here. Data validation config, I'm going to initialize over here. Now, this is really, really important. That is nothing but what is this read.yaml file? Because we need to read the schema YAML file, right? Initially, right? And for that, we need to create one kind of function, right? And that function will be nothing but read underscore YAML file. Now, in order to create this, just imagine, just see this project structure. Where do you think you should probably write your code of reading, right? That is really important for you to understand. Where should we go ahead and write our code, right? And this is where you need to think, right? And I've already told you that there will be a util folder where I will go ahead and create my main underscore utils, okay? And inside this util folder, I will just go ahead and write my code, whatever code is basically required, okay? And here, I will go ahead and write init underscore.py. And inside this particular folder, I will also go ahead and create one more file that is nothing but utils.py. Now, inside this utils.py, I'm going to go ahead and write my code, all the generic code that I'm actually going to basically use, okay? So the function that we are going to specifically write, and before that, I'll go ahead and do some import YAML network security .logging, okay, .logger, import dill, okay? And we'll see like whether this dill, I will talk about more, you know, why we basically require it, but right now I'm just putting it, and I'll also update this in my requirement.txt. This will be specifically useful for pickling off files, you know, and I'll talk more about it, right? Right now, let's comment this. I also have something like YAML, so I'm going to import YAML over here, and in my requirement.txt, I will go ahead and import something like PyYAML, okay? PyYAML, okay? And we will also go ahead and install all these requirements, okay? I'll just open my terminal. Let me do one thing. Let me just go ahead and open it, and I will just go ahead and pip install -r requirement.txt, okay? Now this is the setup. I'm showing you all step by step. Later on, it is the same flow, like how we are specifically working on it, right? So here YAML has been imported. Now what we are going to do is that we're going to create our own function. Which function we are going to create as defined over here? If you see in the data validation, this read YAML file, right? Read YAML file is nothing but reading the YAML file and probably returning those entire information. So for this, I will go ahead and copy paste this particular function. Here we'll define a read YAML file where I'll give my file path and it should return the values in the form of dictionary. The reason is very simple, because we are reading it from the schema. It is already there in the form of if you probably go ahead and see, it is already there in the form of key value pairs, right? So in this key value pairs, once we are reading, we'll return this in the form of dictionary. Okay. So if you again go back to my utils.py, we are just opening that file in read byte mode and we are loading it. And for that, we'll use this YAML.safe. Okay. Perfect. Now in the data validation, since we're going to use this read.yaml file, what I will do, I will go ahead and write from network security.utils.main utils import read, okay, main utils it should be main utils, and then inside main utils, I think inside main utils there should be utils.py. Okay, so .utils import read YAML file. Okay, done. So this is the basic init method, and this initial information that you are basically doing, what we are initializing as soon as we initialize this data validation component, right? It is very simple. For the data validation component, what all things you basically require? One is the data validation config, which should be your initial thing. Your input is nothing but data ingestion artifact. You require data validation config, right? So if you go ahead and see like how many parameters it is taking in the init function, it is nothing but data ingestion artifact and data validation config. Okay. Now yeah, this was it. Now we'll continue this in the next video, otherwise it will become a very long video. But step by step, I hope you are able to understand what things we are specifically doing. And by default, I'm showing you this structure also so that you also become familiar with all these things as we go ahead. So yeah, this was it from my side. In the next video, I'm going to continue with respect to the data validation. Thank you. Hello guys, so we're going to continue discussion with respect to our data validation. Already so many things we did in the part 1 of this particular video. Now let me just go ahead and again reiterate what we're going to do is that we are first of all going to initiate the data validation. We have already read the data validation config. We already have that particular value over here in the data validation config itself, see in this particular variable. Now we're going to initiate it. So in order to initiate it, let's go ahead and create a function inside this class. So I will go ahead and write definition initiate underscore data underscore validation. Okay. Now in order to initiate this data validation, first of all I'm going to give an input which will be of self and always return the return type, right? The return type of the entire data